the silence of the star-filled night. Every moment, every sight, every feeling, it's all wonder. But look closer. Beneath that wonder, the anatomy of life, the patterns of thought, the pulse of our veins, all of it is connected. All of it is science. The iron in our blood, the calcium in our bones, the carbon that forms us, forged in dying stars billions of years ago. We are the universe, looking back at itself, trying to understand, trying to feel, trying to know, and yet in this vast, expanding cosmos, we are so insignificant. A speck of dust, a fleeting moment, a brief flicker of consciousness in an ocean of time. And maybe that is what makes us so powerful, that in all the significance, we still question, we still wonder, we still seek meaning. Science is not just knowledge, it is curiosity that refuses to stay silent. It is a courage to ask why and the humility to accept how little we know. And when we follow our curiosity, not just with our minds, but with our open heart, we don't just understand the world, we begin to fall in love with it. And today, we are not just here to learn science, we are here to experience it. Seeking the blessings of Lord Sri Krishna and Mukhya under the divine guidance of His Holiness Sri Sri Vibhudesha Tirtha Swami Ji, Founder President, His Holiness Sri Sri Vishwapriya Tirtha Swami Ji, Former President, His Holiness Sri Sri Ishapriya Tirtha Swami Ji, President, Udupi Sri Adamarumata Education Council, Bengaluru. Today, as we gather here for the momentous occasion of National Symposium on Science and Technology and Scientist Meet 2026, organized by Science Association under the guidance of Internal Quality Assurance Cell of Poornaprajna College, Autonomous, Udupi. I am Neha, Master of Ceremony of today's program, and I feel truly honored to stand before a gathering of teachers, thinkers, and learners, all united by our shared love for science and eager to hear from distinguished scientists. May I now request Dr. Karamachandra Kishore Sir, Convener, Science Association, to gracefully escort the dignitaries onto the dais. Every quest for truth begins with a moment of humility. Let us invoke the divine presence to grant us clarity of mind and purity of purpose. I invite Nayana from 1st BCA to lead us in the prayer. I request everyone to kindly raise and join your heart in reverence.
वन्दिता शेषवन्द्योरुवृन्दारकं चन्दनाचर्चितोद्धारपीनांसकम् इन्दिराचञ्चलपाङ्गने राजितं मन्दरोद्धारिवृत्तोद्भुजा भोगिनं प्रीणयामो वासुदेवम् देवतामण्डलाखण्डमण्डलं प्रीणयामो वासुदेवं सृष्टिसंहारलीलाविलासततं पुष्टषड्गुण्यसद्विग्रहोल्लासिनं दुष्टनिःशेष्यसंहारकर्मोद्यत हृष्टपुष्टानुतिष्ठप्रजासंश्रयं प्रीणयामो वासुदेवम् देवतामण्डलाखण्डमण्डलं प्रीणयामो वासुदेवं प्रीणयामो वासुदेवं प्रीणयामो वासुदेवम् त्वमेव माता च पिता त्वमेव त्वमेव बन्धुश्च सखा त्वमेव त्वमेव विद्या द्रविणं त्वमेव त्वमेव सर्वं मम देवदेव। ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते। ॐ शान्ति शान्ति शान्तिः।
Thank you, Nayana, for that serene and soulful start. To formally welcome this distinguished gathering and to set a tone for the day, I now invite Dr. Karamachandra Kishore S., convener of Science Association, to deliver the welcome address.
Seeking the blessings of Lord Sri Krishna and Mukhya Prana, seeking the blessings of Param Pujya Sri Vibhudesha Tirtha Swami Ji, founder president of Udupi Sri Adamarmat Education Council, seeking the blessings of Param Pujya Sri Vishwapriya Tirtha Swami Ji, former president of Udupi Sri Adamarmat Education Council, seeking the blessings of Param Pujya Sri Ishapriya Tirtha Swami Ji, the president of Udupi Sri Adamarmat Education Council. Nobel laureate Richard Feynman said, "I would rather have questions that can't be answered than the answer that can't be questioned." The above statement signifies the importance of questioning, reasoning, and critical thinking. Good morning to one and all. I, Dr. Karamchand Kishore, convener of Science Association, stand before you. It's my proud privilege to warmly welcome you all to the National Symposium on Science and Technology and Scientist Meet 2026. Today marks a significant occasion as we gather here to share knowledge, exchange ideas, and inspire innovation in our respective field. I extend my heartfelt greeting to all the distinguished guests, respected speakers, and all the enthusiastic participants. Your presence makes this event truly special and meaningful. I hope this symposium serves as a platform for insightful discussion, valuable learning, and fruitful collaboration. Let us make the most of this opportunity and contribute to its success. Today, for this inaugural ceremony of the National Symposium on Science and Technology and Scientist Meet 2026, we have Professor Vidyadiraj N.S., Professor of Theoretical Science Unit, Jawaharlal Nehru Center for Advanced Scientific Research, Bengaluru, as our chief guest. I, on behalf of Poornaprajna College, Autonomous Udupi, extend my warm welcome to Professor Vidyadiraj sir. A warm welcome you to sir. It is my great honor and privilege to warmly welcome our respected principal, Dr. Ramuel sir, in his absence, who is the backbone of our institution, whose vision and leadership inspires every activity in this college, and whose leadership and support have instrumental in organizing and inspiring this national symposium. I welcome him in his absence. I extend my warm welcome to Dr. Vijayalakshmi C. Bhatt, member of Academic Council of Poornaprajna College, Autonomous Udupi, and HOD of Botany. I welcome you, ma'am. I extend my warm welcome to CM Manjunath sir, Director of Academics and Training, USAMEC Bengaluru. A warm welcome you to sir. I extend my warm welcome to Dr. Lakshmisha Rao, Co-Coordinator IQAC of Poornaprajna College. I extend a warm welcome to the principal and teaching staff members of Alevuru Public School. Welcome you all. I extend my warm welcome to Dr. Amrita A.S., Assistant Professor of PPISR Bengaluru. Welcome you, ma'am. I extend my warm welcome to Dr. Shivakumar K.I., Assistant Professor, PPISR Bengaluru. Welcome you, sir. I extend my warm welcome to Dr. Somyaji sir, Coordinator, PG Department of Commerce. Welcome you, sir. I extend my warm welcome to all the accompanying teaching staff members of the neighboring college. A warm welcome to you all. As Albert Einstein once said, the important thing is not to stop questioning. With that spirit, I warmly welcome all the curious minds here today, our student participants. I extend my warm welcome to all the student participants of Poornaprajna College and student participants and students from diverse institutions from the neighboring colleges and school. Welcome you all. We are honored by your presence and enthusiastic participation. Today, we are privileged to have among us a very special guest whose vision and dedication have shaped the very foundation of the institution. I would like to extend a heartfelt welcome to all our former principal. Their unwavering commitment, exemplary leadership, and tireless effort have not only guided this institution through challenging times, but also laid the groundwork for the growth and achievements that we celebrate today. Their vision continues to inspire both faculty and students alike. As we gather here to discuss and deliberate on the National Symposium, we are reminded that it is their foundational work of our former principal that allowed such vibrant academic and intellectual engagement to flourish. We stand on the shoulder of their dedication, and it is their spirit of excellence that motivates us to aim higher. Under their leadership, we witness significant growth and innovation and academic excellence. On behalf of Poornaprajna College Autonomous Udupi, I extend our deepest gratitude to our former principals for being here today. Your presence is a source of inspiration, and we are honored to have you join us. We look forward for your guidance, insight, and continued blessing throughout this symposium. I warmly welcome you all. I extend my warm welcome to all the members of the print media, broadcast media, digital and online media. Welcome you all. I extend my warm welcome to the technical team, Mr. Jagdish, photographer, Mr. Krishna sir. It's my duty to welcome all the eminent dignitaries in their absence who will later join us for the program. I extend my warm welcome to Parama Puja Sri Ishapriya Tirtha Swami Ji, President of Udupi Sri Adamarmat Education Council in his absence, who is going to later join us in the program. I extend my warm welcome to all the scientists, Padma Shri Dr. Prahalad Ramarao, former Director of DRDL Bengaluru, Dr. B.R. Guruprasad, Director of Jawaharlal Nehru Planetarium Bengaluru, Dr. Vinay K. Pattar, Science Communicator at JNCASR Bengaluru, in their absence, who will later join us in the program. I extend my warm welcome to Dr. A.P. Bhatt, Honorary Secretary, Udupi Sri Adamarmat Education Council, Bengaluru, Dr. G.S. Chandrasekhar Sir, Honorary Secretary, Poornaprajna College Managing Committee, Dr. P.S. Aital, Director, Poornaprajna Institute of Management and Academic Advisor, Poornaprajna Group of Institution. I extend my warm welcome to Dr. N.A. Madhyastha Sir, former Principal, Poornaprajna College, Udupi, in his absence. So all these eminent persons are later going to join us in the program. On this outset, I would like to thank the management, Udupi Sri Adamarmat Education Council, Bengaluru, for giving me an opportunity to speak. Thank you all, and once again, a warm welcome to everyone present here.
Thank you, sir, and a warm welcome to you too. A blossoming flower is a nature's own scientific masterpiece and the purest symbol of gratitude. Now, I request Dr. Mahesh Bhatt, sir, Head of the Department of Chemistry, to florally welcome all the dignitaries on the dais. I also request Mrs. Pratibha C. Acharya ma'am, Head of Department of Physics, to florally welcome Dr. Shivakumar and Dr. Amrita ma'am from PPISR, Bengaluru. Light is the universal language of awakening. It dispels the shadows of unknown and ignites the spark of innovation. To officially inaugurate National Symposium on Science and Technology and Scientist Meet 2026, I invite our chief guest, Professor Vidyadhiraja NS, and all our dignitaries on the dais to kindly step forward and light the ceremonial lamp.
participants. Good morning to one and all. It is both an honor and privilege to stand before you today as the convener of Science Association to brief you about the National Symposium on Science and Technology and Scientist Meet 2026. This National Symposium and Scientist Meet 2026 represents not just an event, but a powerful convergence of ideas, innovation, intellect, and brilliance. It is an honor for Poornaprajna College, Autonomous Udupi, that we are hosting eminent scientists of our country. We are immensely proud to host internationally renowned scientists whose groundbreaking contribution have shaped the course of modern science in India. Among them are the distinguished recipient of prestigious Padma Shri Award, Dr. Prahalada Ramarao, Chief Architect of Akash Surface-to-Air Missile System, during which he worked together with Dr. APJ Abdul Kalam, former President of India, who is famously known as the Missile Man of India. Dr. Prahalada Ramarao played a vital role in development of Agni, Prithvi, Nag, and BrahMos missile. All these missiles are the pivotal component of our Indian defense system. The award of Padma Shri, the fourth highest Indian civilian award, is an acknowledgement of excellence, dedication, and service of Dr. Prahalada Ramarao to the nation. We are equally honored to have eminent scientists like Professor Vidyadhiraja NS, Professor Jawaharlal Nehru Center for Advanced Scientific Research, Bengaluru, Dr. B.R. Guruprasad, former Indian space scientist at ISRO, Dr. Vinayaka K. Pattar, science communicator at GNCASR Bangalore, as our esteemed resource person for the scientist meet. These eminent scientists come from diverse fields, each bringing with them a wealth of knowledge, experience, and vision. These are individuals who have devoted their life to pursuing the boundaries of discovery, solving complex challenges, and advancing humanity through science. Their presence here is a source of inspiration to all of us. Today's inaugural session is followed by a talk and experimental demonstration by Professor Vidyadhirajan NS, Professor at JNCASR Bengaluru. We are eagerly waiting for your talk and experimental demonstration, sir. At 1:30 p.m., we have a talk by Dr. B.R. Guruprasad, former space scientist who worked at ISRO for 37 years, contributing to over 25 national satellite missions. Presently, he is the director of Jawaharlal Nehru Planetarium, Bengaluru, who will be speaking about astronomy and India's space achievements. From 2:30 to 4:30 p.m. is the scientist and student interaction. It is a time when great minds meet young dreams. It is a dialogue, a collaboration, a shared journey towards discovery. When an eminent scientist engages with the student, something extraordinary happens. It is not merely a transfer of knowledge, it is a spark that can light a lifelong passion, shape a career, or even change the course of human progress. At 4:30 p.m. is the felicitation to all the eminent scientists and felicitation to Dr. N.A. Madhyastha, former principal and head of the Department of Zoology, Poornaprajna College, for his contribution towards malacological research of the Western Ghats and his pioneering efforts in environmental conservation. By Parama Pujya Shri Ishapriya Tirtha Swami Ji, President of Udupi Shri Adamarmat Education Council, Bengaluru. So the objective of this symposium goes far beyond presentation and discussion. It is about creating a shared platform where knowledge meets curiosity, where experience meets fresh perspective, and where challenges meet solutions. This gathering serves three vital purposes. First, it fosters collaboration. No significant scientific breakthrough has ever been achieved in isolation. By bringing together experts, researchers, and young minds from diverse disciplines, we encourage the exchange of ideas that can spark innovation and lead to groundbreaking discoveries. Second, it promotes knowledge sharing. Science is not static. It evolves through dialogue, debate, and dissemination. This symposium provides an opportunity to question assumptions and learn from eminent scientists of our country, thereby strengthening the collective intellectual foundation. Third, and perhaps most importantly, it inspires the next generation of students. For students and young researchers, this is more than an academic event. It is a glimpse into the future they can shape. Interacting with accomplished scientists ignites ambition, builds confidence, and nurtures the spirit of inquiry. At its core, this scientific meet is a celebration of human curiosity and relentless pursuit of understanding. It reminds us that science is not just about theory and experiments, it's about solving real problems, improving lives, and building a sustainable future. As we move forward in this symposium, let us engage openly, think critically, and collaborate meaningfully. Let us not just exchange ideas, but also challenge and refine them, because the true success of this gathering will not be measured by the sessions we attend, but the impact we create afterwards. Together, let us turn knowledge into action, ideas into innovation, and discussion into lasting change. Thank you, and I wish you all truly inspiring and enriching symposium. Thank you, one and all.
Thank you, sir. Today, we are immensely privileged to have with us our chief guest, Professor Vidyadhiraja N.S. sir, Professor at Jawaharlal Nehru Center for Advanced Scientific Research with us today, to introduce a man whose works delves into the profound mysteries of a quantum many-body theory. I warmly invite Ms. Anusha ma'am, lecturer, Department of Mathematics, to give us a deeper insight into his remarkable journey.
A very good morning to one and all present here. It's my immense pleasure to introduce today's chief guest, Professor Vidyadhiraja N.S., an eminent physicist and academician known for his outstanding contributions to theoretical physics and scientific research. He is currently serving as Professor of Theoretical Sciences Unit at Jawaharlal Nehru Center for Advanced Scientific Research, Bengaluru, one of India's premier research institutions. His academic journey reflects excellence and dedication. He completed his MSc Physics from IIT Kanpur, followed by PhD in Physics from the Indian Institute of Science, Bengaluru. He then pursued postdoctoral research at the University of Oxford, United Kingdom. Professor's research interests lie in quantum condensed matter physics, strongly correlated electronic systems, quantum many-body theory, and computational physics. His work has significantly contributed to understanding complex physical phenomena in modern materials and quantum systems. He has published numerous research papers in reputed international journals and has guided several PhD and MS students, shaping the next generation of researchers and scientists. Sir has also worked as visiting professor at internationally renowned institutions. He is a life member of Indian Physics Association and a member of the American Physical Society, demonstrating his active involvement in the global scientific community. Apart from his academic and research and achievements, he has contributed significantly to scientific outreach programs, delivering lectures and interacting with students, teachers, and young researchers across the country. His commitment to promoting science and research continues to inspire many aspiring scientists. With such an impressive academic background, remarkable research contributions, and dedication to teaching and outreach, we are truly honored to have him with us today. Without further delay, let us warmly welcome Professor Vidyadhiraja N.S. and invite him to deliver his talk. Over to you, sir.
Good morning, everyone, and I would like to thank the organizers for inviting me here for this very prestigious occasion. And the title of my lecture is Quantum Physics to Quantum Technologies. So it sounds like a heavy title, but let me tell you, I am going to tell you a story. Okay? In fact, there will be multiple stories in this one lecture. right? So this is not going to be a heavy physics lecture where I'm going to write down equations, derive all of those things. This meeting is all about opening doors to new worlds. Okay? So there are many different worlds that I will make you aware of, which you may not be aware of at this stage, but I would encourage you to explore those new worlds as you go forward. Okay? And what you're seeing here on the screen, okay, this is a primary example of a phenomenon called quantum entanglement. Okay? And on this side, what you're seeing is the most powerful supercomputer that we are building today. It's called a quantum computer. Okay? So how quantum entanglement leads to a quantum computer or quantum technology, right? So that is going to be one of the stories of today's meeting, but there'll be many such stories. Okay? So let's begin with the first story, okay, of physics itself, right? So the first story of physics starts way beyond, thousands of years ago. Okay? Even in India, there were lots of physics discoveries, including in astronomy, architecture, engineering. There were lots of such discoveries. Okay? So what I'll do is, because my topic is quantum physics, I am going to divide the time into two parts, before 1900 and after 1900. Okay? So what you're seeing here is before 1900, right? So in before 1900, I'm not sure if the people at the back can read this, but what is written here is laws of motion, gravitation, astrophysics, calculus, classical mechanics, fluid mechanics, electromagnetism, chaos theory, thermodynamics, and so on. All of this was quite in an advanced way discovered before 1900. Okay? Now, what happened after 1900, right? So after 1900, some very interesting things happened, okay? And those interesting things are like this. You see at the top, there is relativity, okay? So that was one very new thing that happened. And the other new thing which we are going to focus on today is quantum physics. So that's what happened after 1900. In fact, in 1900 itself, there was a scientist called Max Planck. He postulated that the light that we are seeing, right, that light is not a continuous object. It is made up of packets of energy called photons. Okay? He did not know whether it is true or not. He just postulated, he assumed that, because he wanted to explain some physics phenomenon called black body radiation. So he assumed that light is not a continuous object. It is made up of packets of energy, and using that he explained it. But that was kind of a birth of quantum mechanics, okay, or quantum physics. So we want to know what exactly is quantum physics, but before knowing quantum physics, let's find out what is the essence of classical physics, okay? So whatever you're seeing here before 1900 is what I will call classical physics, okay? And whatever happens after 1900, of course classical physics is there in that, but the major discovery was of quantum physics, okay? So let's just figure out what classical physics is, okay? So classical physics is mostly, okay, there are many other things also, but classical physics is mostly about Newton's laws of motion, gravitation, and Maxwell's theory of electromagnetism. If you combine these three different frameworks, you can actually explain a lot of phenomena. What do you see on the screen? A cricket match, right? A bowler bowling a ball, a cricket ball, and a batsman hitting the ball, and a fielder catching the ball, right? The trajectory of the ball, all the way from throwing the ball to hitting the ball to catching the ball, everything can be explained using Newton's laws, okay? The way we are filming all of this, right? Electromagnetism plays a very important role. Why does the ball fall down? Why does the ball follow a parabolic trajectory? It's gravitation. Okay? So this is a very interesting application of all the three different frameworks that I told you. Then what do you see here? There is some construction happening. So there is a lot of civil engineering involved, there's a lot of mechanical engineering involved. All of this is again developed using those basic laws that I told you. Okay? So somebody has asked a question that we will be addressing later. please note here that we are talking about the transition from science, basic science, all the way to technology. Okay? So the basic science involved in this technology, in this construction technology, is the Newton's law of gravitation, then Newton's laws of motion, and also the electromagnetism. Okay? Then what do you see here? Robotics, right? Again, robotics is also an application of these three frameworks. Now what do you see? The launch of a rocket, right? How much fuel should you have? What should be the escape velocity? How do you control the motion of a rocket, of a satellite? Okay? All of that can be derived from these three frameworks, right? So those three frameworks that I talked to you about, they are extremely powerful frameworks, and they form the foundation of classical physics. Okay? Remember, classical physics is about Newton's laws of motion, electromagnetism, and gravitation, right? So these three basically are the pillars of classical physics. Okay? But if you ask the question, is classical physics sufficient to explain everything? Okay? The answer is a big no, right? So these are the equations of classical physics. So most of you have read this in your school. This is about Newton's laws of motion. This is gravitation, and then there is electromagnetism. Okay? Electromagnetism, most people might not have studied, but these are the equations. Okay? So it turns out that classical physics, even though it is so powerful, it cannot explain everything. Okay? And how many things can it not explain? It turns out it cannot even explain our basic existence. Okay? It cannot explain the stability of an atom. An atom is a very small object. Okay? How small an object is an atom? I can take a meter, okay, 1 meter, and divide it into 1,000 pieces. I get 1 millimeter. Then 1 meter, okay? 1 meter I divide it into 1,000 pieces, I get 1 millimeter. So that 1 millimeter I divide it into another 1,000 pieces, I get 1 micron. Our hair is usually about 40 to 50 microns thick. Okay? Then you take that 1 micron, divide it again into 1,000 pieces, that gives you 1 nanometer. That nanometer, you divide it into 10 more pieces, that gives you the size of a hydrogen atom. That's how small an atom is. Okay? Now, take that atom, okay? Inside that, there is an electron and there is a nucleus, right? Isn't that right? One hydrogen atom has one nucleus, which has one proton and one electron, okay? It turns out the nucleus is 10,000 times smaller than the atom. And the electron is basically around that nucleus. It's going around, not in an orbit. It's not like a planetary model, okay? It's a very interesting model called the orbital model, okay? It's in some orbital. It has some probability of being in different places at some point of time, okay? So the point is, electron is negatively charged and the nucleus is positively charged. So after some time, the electron should basically fall into the nucleus. And if it actually does that, you know how small our universe will be? I am right now around 1.6, 1.7 meters, okay? I will become 1 lakh times smaller if that electron falls into the nucleus and the atom collapses. So it turns out classical physics cannot explain the stability of an atom. If classical physics cannot explain that, there is something missing in classical physics, okay? There is something really important, which is important for my existence here. Otherwise, I would be this small, you would not even be able to see me, okay? So that is one of the most biggest failures of classical physics. But that is not the only one. There are many others. It turns out that if you take hydrogen, hydrogen absorbs light at certain frequencies only, okay? Which frequencies are those? How do you explain that? Classical physics cannot explain it, okay? Then if you take black body radiation, this is a special kind of radiation which has a special intensity as a function of wavelength shape, okay? That is again something that classical physics cannot explain. Now, if you take heat capacity of solids, how much heat do you need to give a solid in order to raise its temperature by 1 degree Celsius? If you look at its temperature dependence, classical physics cannot explain it, okay? So like this, there are many, many different phenomena. Chemical bonding, for example. All of chemistry is based on chemical bonding. If I take water, water is a life-giving substance, right? Water is made of 2 hydrogens and 1 oxygen, H2O. The bond between oxygen and hydrogen is actually something that classical physics cannot explain. Why should a neutral oxygen atom and a neutral hydrogen atom, why should they come together to bond with each other? There is no reason within classical physics that water should form. Okay? The reason water forms is because there is something new physics that is happening inside this hydrogen, H2O molecule. Okay? That new physics is what we are going to discuss in this lecture. Okay? All right. Then photoelectric effect. This was an effect which Einstein explained, and he got the Nobel Prize for explaining this effect. Okay? Semiconductors. All of today's technology, including the mic that I'm holding, including the slide changer, including the laptops, phones, everything is based on silicon technology. Inside your phones, inside your laptops, there is a chip, there is a microprocessor. That microprocessor is made out of an element called silicon. Okay? And silicon is a semiconductor. It's neither a metal nor an insulator. But the existence of a semiconductor is itself something that classical physics cannot explain. You cannot use Newton's laws of motion, Maxwell's equations of electromagnetism to explain the existence of a semiconductor. You need new physics for that. Okay? Then electrical conductivity of metals and also magnetism. Every magnet that you know of cannot be explained by classical physics. Okay? Magnetism itself is something that needs new physics. Right? So all of these phenomena and hundreds of more such phenomena are there which cannot be explained by classical physics. So what do you need? What came up after this is a new subject. Okay? That new subject is called quantum physics. That quantum physics subject explained all of these phenomena, but it also gave rise to very, very interesting questions. You will see today that the physics that I'm going to tell you will appear almost magical. Okay? In fact, at the very end, we will also have a small demonstration, and that will also seem like magic to you. Okay? So let's just wait for that, and before that, I will explain to you what is quantum physics. Okay? All right. So what is this new physics that we are discussing, which explains all of those phenomena? Right? So what is the essence of that? I'm not going to tell you the equations of this. In fact, if you want to study quantum physics, there is a whole 1 semester course that you have to study. Okay? But here we are only going to discuss the concepts, purely the concepts of quantum physics, and we will discuss the consequences also. What does quantum physics lead to? Okay? Is quantum physics being used? Is it only taught in textbooks? Is there any technology that comes out of it? Those are the questions that we will discuss today. Okay? All right. So what is the essence of quantum physics? The first essence of quantum physics is a very interesting principle called the wave-particle duality. What do I mean by that? Okay? See, what you are seeing here is basically something called interference. So what is happening? Some waves are coming, okay, and they are hitting a screen. In the screen, there are 2 holes. Okay? You see there is a hole here, there is a hole here. Right? So when these waves go through those holes, what happens? You get spherical wavelets. These spherical wavelets, they interfere with each other. What does interference mean? When a maximum of a wave meets the maximum of the other wave, you get a bigger maximum. But when a maximum meets a minimum, they both cancel each other. Okay? So what do you get at the screen? You get bright fringes and dark fringes. That is called an interference pattern. This is characteristic of waves. Remember this, because I'm going to talk about this again. Okay? This is wave interference. Right? Now let's see what are particles. Right? Okay. So this is what I would call particle-like behavior. So when I take a billiard ball and hit it with other balls, or I take a marble, for example, or I take a cricket ball, all of this is characteristic of particle-like behavior. What do I mean by that? A particle is present in one place at one point of time. It can be given a trajectory. It can go along a certain path, right? Like a cricket ball. A cricket ball, when a batsman hits the cricket ball, it goes along a certain trajectory, right? But waves are not like that. Waves are present everywhere at the same point of time. Okay? If you have seen a pond, right? In a pond, if you throw a stone, then waves are produced. But those waves are not in one place. Like a cricket ball is in one place at any point of time. Waves are there everywhere. Okay? So waves are something called, they are delocalized. They are not localized in one place. Waves are delocalized. But particles are localized. They have a specific trajectory. Okay? So these two things, waves and particles, are normally two very different objects. But what happens in quantum physics is that they come together. Every quantum object, every electron turns out to have wave and particle duality, which means they can behave as waves and also as particles, depending on what measurement you make. Okay? So it turns out there was a person called Louis de Broglie, and when he was 23 years, okay, 29 years, when he was 23 years old, he wrote his PhD thesis. His PhD thesis was very, very small, I think around 30 odd pages. Okay? And the most important contribution he made was this equation. Okay? In this equation, there is a constant here. You see this h, okay, in the numerator? That h is a constant. It's a universal constant called the Planck's constant, right? But more importantly, this lambda here, this symbol that you're seeing, okay, this symbol that you're seeing here, this symbol, okay, and this symbol, these are the two very important things. This is wavelength. So this is a wave property. This is momentum, and momentum is a particle property. So this equation relates waves and particles, and it says every electron, every proton, or every subatomic particle is a wave and a particle at the same time. How can something be a wave and a particle at the same time? Right? It's a very mysterious concept. Okay? And it leads to dramatic consequences. We will see that later. Right? So this wave-particle duality is not just a theoretical construct. It has been experimentally also verified. Okay? How was it experimentally verified? There was an experiment called the Davison-Germer experiment. Okay? And I'll show you a visual of that. Right? And then there was another experiment called the electron diffraction experiment. See, diffraction is also a pure wave phenomenon. Right? So it turns out electrons can show wave-like behavior. Electrons, we usually think of them as particles, as marbles. But electrons can show wave-like behavior. Okay? And in 1927, it was demonstrated that electrons behave like waves using the phenomenon of diffraction. Okay? So this is classical interference. That is, if I take water waves, okay, these are water waves, then these water waves form an interference pattern. Okay? And so this is again showing you the same thing, right? When water waves come in, what happens? Notice the screen. Okay? Notice the screen, what happens? You will get bright and dark fringes, right? So those bright and dark fringes are characteristic of an interference pattern, right? But what you see here is different. You are seeing one electron come at a time, right? Almost like a marble. But what is happening at the end of it on the screen, you see an interference pattern. So particles coming in, but showing wave-like behavior, okay? So this is another cartoon of that. So basically what is happening here is that you think of a single electron gun. Okay? This electron gun is shooting electrons. And electrons, we usually think of them as particles. Right? So when particles are coming out, they should just hit the screen at one point. But what they're doing is something extremely interesting. What they're doing is these electrons are behaving like waves. And collectively, not just one electron, collectively they are forming an interference pattern. It's a mind-boggling phenomenon. To explain this, many different physicists have tried. right? And now we have an explanation, but it is in terms of concepts that are completely different from classical concepts. Okay? So wave particle duality is one very fundamental concept of quantum physics. Okay? All right. Now, what is the equation that is most important in quantum physics? Right? See, in the classical physics, the equations I showed you, the Newton's law of gravitation, F is equal to G m1 m2 by r squared. I also showed you Maxwell's equations. I also showed you Newton's laws, right? So it turns out quantum physics does not replace Maxwell's equations. They remain as it is. Quantum physics does not replace gravitation. That remains as it is. Only the Newton's laws are replaced. Okay? Newton's laws fail completely. So Newton's laws have to be replaced. But what is that equation that replaces Newton's law? That is called the Schrodinger's equation. Okay? So the Schrodinger's equation looks something like this. Don't worry too much about the mathematics of it. That is not very important for this talk. Okay? And if I write this equation in full detail for a very simple system, which is the hydrogen atom. The hydrogen atom is one of the most simplest systems because it has only one proton and one neutron. That's it. Okay? So that equation looks like this. It's a complicated equation. Okay? But you will be interested to know that all of you have actually used the solution of this equation. Even though many of you may not have seen this equation, all of you have used the solution of this equation. Does anybody know where you have used the solution of this equation? If I show you, you will know. Okay? Have you not used the orbitals in chemistry? 1s, 2s, 2px, 2py, right? That is actually the solution of hydrogen atom, Schrodinger's equation. So even though you did not know the equation itself, you have used the solution. Okay? And these orbitals, they come out of the solution of the Schrodinger's equation. So all of chemistry, when you fill those electrons in those orbitals, up, down, you are actually doing quantum physics. Okay? It's a solution of this equation. Fine? All right. Now I'll show you something, a second concept in quantum physics called quantum tunneling. Okay? And this quantum tunneling is again a very, very mysterious concept, right? But it has a lot of uses also. I'll show you that as well. All right. So what is, first of all, non-quantum tunneling, right? What is classical tunneling? Let's look at that. This is a tunnel, right? I'm sure many of you have traveled by buses and trains. You would have gone through tunnels, right? So this is a tunnel, right? Why is it a tunnel? What you have to do is, let's say I'm constructing a road and I find a mountain. Then I have two options. One is I make the road go on the mountain, go all the way around the mountain and then cross the mountain. My second option is I make a hole through the mountain. I make a tunnel through the mountain, right? But to make a tunnel, what do I have to do? I have to break the mountain. I have to use dynamite. I have to use many construction equipment to actually break that tunnel, right? That is classical tunneling. Quantum tunneling is not like that. Okay? Let me show you one more visual. This is classical tunneling. That when you have to tunnel, you have to break that wall and you have to go through it. Okay? So this is classical tunneling, right? But quantum tunneling is like this. This is a classical ball. Whenever it hits the wall, it comes back, right? That's what a classical ball would do. Now what does a quantum ball do? This is a quantum ball. That's what it does. You see what it did? It just went through the wall. Did not bounce. Sometimes it bounced. Sometimes it just went through the wall, but without breaking the wall. It did not break the wall. When you have to make a tunnel to go through the mountain, you have to break the mountain to make that tunnel. A quantum particle does not break the wall and just tunnels through it. Now you may be thinking the quantum particle is so small, right? Because it is so small, maybe the wall also has atoms and there is space between the atoms, so the electron is basically just going through the wall. Okay? But I can make an invisible wall for the electron. How can I make an invisible wall? I will use an electric field. Once I have an electric field, there is no atoms. It's just a continuous electric field. Now what can the electron do? Right? But it still tunnels through that electric field. Okay? This is quantum tunneling, where an electron, even though it does not have enough energy to break that wall, it can go through the wall sometimes. There is a probability that the electron will tunnel through this wall, but without breaking the wall. Remember this, quantum tunneling is not about breaking the wall, it is about going through the wall even though you don't have enough energy. The wall remains intact. Okay? So this is quantum tunneling. All right? So I have shown you some concepts, right? I will show you more concepts later, right? But quantum technology is all about going from science to applications, right? Now, what does science mean and what do applications mean? I will come to that also later. All right? So let's just discuss the context. What is science, right? So science is this. Now, many of you may not be able to read this, so let me just read this. Science is a methodical way of gaining knowledge on a particular subject through observation and experiments. This is what we mostly read at the BSc level. We do science, Bachelor of Science, right? And science is all about observation, experiments, theories, and working in the lab, working with pen and paper, solving equations, and all of this, right? This is all science, okay? Now, what does science do, right? Science can take you all the way from basic science, fundamentals, to technology, right? So what is technology? Technology is the practical application of scientific knowledge for various purposes. So when you take basic science and when you start applying it to solve problems of real life, how do I construct a building? How do I design an aeroplane wing? How do I make a computer? How do I make a more powerful processor? How do I make memory in which you can store your songs and videos, right? How do I do all that? That requires the application of basic science, okay? The application of basic science creates technology, right? That is one of the themes of this talk. I'm going to show you some very exotic concepts, which are concepts in quantum physics, and how those concepts have led to technologies which are again miraculous technologies, okay? All right. So that's the journey that we are going to do, okay? This is the journey, quantum physics to quantum technologies, but this journey involves a lot of other disciplines. This is not an isolated journey. There are a lot of stops, right? And these stops have different names, right? Let's see what those names are. Condensed matter physics. Then you will need material science. Then you will need electronics engineering. You will need information theory. And you will also need computer architecture, right? So if you want to go from quantum physics to quantum technologies, you have to bring in and you have to make a convergence of all these different disciplines. It's a very interdisciplinary journey, okay? And it's always a story that whenever you want to take science to applications, it is not a linear journey, right? It involves a lot of other disciplines which you have to bring in order to solve real world problems, okay? All right. So I have told you about some concepts. I have told you about wave-particle duality. I have also told you about quantum tunneling, okay? Now, you may think that these are interesting concepts, but why would they be useful, okay? What do I have to do with wave-particle duality? What do I have to do with quantum tunneling? Maybe it is happening at the atomic scale. Maybe it is happening at the subatomic scale. What do I have to do with that, okay? And you will be it will be interesting for you to note that every one of you today is actually using quantum technologies, okay? What are these quantum technologies that you are using? I will call this quantum 1.0, okay? And quantum 1.0 is based on quantization and tunneling, right? All right, let me show you. Does any of you know what this machine is? You may not have seen it, okay? And I am giving you one hint. That hint is actually written here. The first word in the title is a hint to the name of that machine. Can anyone guess that? Does anyone know a machine which has tunneling in its name? Exactly. So it's a scanning, tunneling microscope. Now most of you would have seen a microscope in the biology labs, right? It's an optical microscope, okay? But this microscope is not an optical microscope. It's a scanning, tunneling microscope. It actually uses the tunneling of electrons inside different material to probe the structure of that material, okay? And when it probes the structure, it goes deep beyond and it gives you resolution of the order of angstroms. Angstroms is 10 to the power minus 10 meter, the scale of atoms. So it can show you materials on the scale of atoms, okay? What are the kind of pictures it takes, right? These are the kind of pictures it takes, okay? The colors are false. The colors are not true colors, okay? But the images are true. These images are actual images of atoms on a surface, how atoms are arranged, okay? And these are beautiful things here. You know, these patterns that you are seeing, these kind of patterns, they are called quantum corals, okay? And you can produce these kind of quantum corals by introducing certain defects, okay? So these are all images which are taken by such a microscope, scanning tunneling microscope. So it's an extremely useful concept. It's an extremely useful machine which most modern industries are now using, because most modern industries are working at the atomic scale now, right? So they are actually using this machine heavily. Then now I'm going to show you another machine, okay? I would never wish that you see this machine in person, okay? Except if you are a doctor or if you are working in a hospital, right? But as a patient, I would never wish you to see this machine, but it's a very interesting machine. It's called an MRI machine, magnetic resonance imaging machine, okay? Now, many of you might have seen an X-ray, right? When you take an X-ray, what happens is, X-ray hits me, inside me there is a skeleton. The soft tissue allows the X-rays to go through, but the bone, the skeleton, does not allow. So what happens? On the screen, I get a shadow, okay? That shadow tells me what my skeleton is looking like. But sometimes it can also figure out the soft tissue. For example, if I have congestion in my lungs, right? Then I will see that as some darkish patterns, okay? But this MRI machine goes beyond that. It actually gives you a full image of the soft tissue, right? This MRI machine gives you an image of the soft tissue. For example, if I have a brain tumor, then X-rays will not be able to tell me that. I will need to get an MRI done to find out if there is a soft tumor in my brain, okay? So these are the kind of images that you get. But you know how an MRI machine works, okay? It's based on two quantum principles. One principle is nuclear magnetic resonance, which I'm not going to explain here, but that is the name of the principle. The second principle that we are actually going to see in action later is something called superconductivity, okay? Now that superconductivity turns out that you see this round shape here, okay? Inside that round shape, there are actually wires made out of this material called a superconductor. They are not wires made of copper. The reason is that these wires, there is a current that passes through them, okay? That current produces a magnetic field. Remember an electromagnet? All of you must have seen an electromagnet, right? How do you make an electromagnet? You take a nail, you take copper wire and you wind it around it, okay? Then what happens? You can actually attract pieces of nail to that, or you can safety pins, for example, okay? So passing a current through a wire makes it into a magnet, okay? But the kind of magnetic field you need to image your brain is not just a small magnetic field, okay? The kind of magnetic field you need looks like that. It can actually attract a chair from far and then suck it inside. It's a huge magnetic field of the order of 3 to 6 Teslas, right? It's around 10,000 times more than the Earth's magnetic field, okay? That kind of an electromagnet you cannot make using copper wires. You have to use a quantum object. And that quantum object is actually in the fifth phase of matter called the Bose-Einstein condensate. Have all of you heard of the fifth phase of matter? Bose-Einstein condensate? How many of you have heard? Please raise your hands. You've all heard of solid liquid gas, right? You have all heard of plasma. How many of you have heard of the fifth phase, Bose-Einstein condensate? No? So I'm going to show you that fifth phase today here in this hall. You are going to see that fifth phase of matter, okay? But that fifth phase of matter is sitting inside that cylinder. And that is what is creating that huge magnetic field which is sucking that chair in. And in Mumbai, there was an accident because of such huge magnetic field. An attendant was carrying a cylinder. He did not know that the machine was on. Remember, a cylinder is made out of metal. Whenever a patient is sent into the MRI room, they are told, remove all metallic objects from your body. Okay? But this boy did not know that the MRI machine was on. And what happened? The MRI machine sucked in the cylinder. That poor attendant got stuck between the cylinder and the machine. And there was a death. The boy died. Okay? That's the kind of magnetic field this produces. Right? But to produce that, you need the fifth phase of matter. And that is what we will see. And this is a direct application of quantum physics. So remember, I told you about quantum tunneling. I told you about wave-particle duality. Now we are seeing an application of those concepts. Okay? The same concepts. Right? So it is not a useless thing. Right? All right. Now, what am I showing here? This. Can you all see the ceiling? What is happening on the ceiling? What am I shining here? It's a laser. Right? A laser also happens to be a pure quantum object. Right? So inside a laser, what is happening? Okay? Inside a laser, what is happening is, laser in fact is actually not a word. It's an acronym. It stands for light amplification, LA. LASER, right? Light amplification by, does anybody know it? Stimulated emission of radiation. Okay? So you're actually stimulating photons to come out by other photons. Okay? And inside every, for example, this pointer also has a laser inside it. That laser has two mirrors. Okay? But inside, between those two mirrors, there might be a material which is the lasing material. That lasing material has energies which are quantized. They are quantum energy levels. Okay? And that is what you are seeing here. These quantum energy levels, what happens is a photon comes in, excites the atom, and then to de-excite it, for the de-excitation of that atom, another photon comes in. Okay? So it's a stimulated emission, not a spontaneous emission. Okay? So this is again, every laser that we know of is a quantum object. It requires quantization of energy levels. Now you may think this is the only application of lasers, maybe a laser pointer. Okay? And this is what your boring lecturers use for giving boring talks. But that's not true. Okay? Lasers have thousands of applications. Right? They have applications in health sciences. Lasers have application in engineering technology. And these days you may hear of Star Wars. You can use lasers to bring down drones and aeroplanes and satellites also. Okay? If you have high-powered lasers, you can do that. Right? Lasers are used for metal cutting. They are used in engineering. They are used in metrology, reprography, environmental chemical analysis, manufacturing and process control, weapon systems, dentistry, surgical, ophthalmology. They have thousands of applications. And every one of those applications means that you are using quantum physics. Okay? So quantum physics, and this is all quantum 1.0. I have not even come to quantum 2.0, which is where we are living right now. Quantum 2.0 is happening right now, and that's what I'm going to tell you. What is quantum 2.0 bringing? Okay? Now, before going to quantum 2.0, I want to show you the magical application of quantum physics. Okay? Now, this is Vande Bharat Express. Okay? And this Vande Bharat Express is standing on 2 tracks, and you can see here the wheels, right? All of you can make out the wheels in the train? Can all of you see that? The train has wheels, right? Now I want you to imagine, and you can also see on the screen, a train which looks like this. What is the difference between the previous screen and the new screen? There are no wheels, right? And if I just remove the wheels from your car, what will happen? The car will just sit on the ground. Will the car be floating? No, right? But this train seems to be floating. It's not falling down, even though I have removed the wheels. Okay? Now, can this train be a reality, or is it just fantasy? What do you think? Is it real, or is it just a dream? It is real. Okay? And this is a superconducting magnetic levitation train. It's called SC Maglev. Okay? And we are going to see a small prototype version of that today here. Right? But Japan has actually made it. China has also made it. And this is what it looks like. Okay? You can see the speeds. It has crossed 670 kilometers per hour. Okay? But if you see, this is the bottom of that train. The first visual is the bottom of that train, where it is showing that there are no wheels and it is actually floating on tracks. Right? It has no wheels and it is floating. Right? There is a space. Okay? But it is not like a hovercraft. You know, a hovercraft also floats. But what does a hovercraft do? It actually pushes air. And it makes an air cushion, right? On that air cushion, it is floating. Here, it is not like that. There are no fans. Okay, there is no air being pushed. It's a fifth phase of matter that is actually playing the role here. Okay, and through a phenomenon called Meissner effect. That is a pure quantum effect. So this train is also based on quantum physics, right? It's an application of quantum physics to technology. Okay? We will come to this, right? Later on we will come to this. So what I wanted to tell you was, quantum is all around us, even today, right? We are using quantum technologies. We are using lasers, we are using phones, we are using mobiles. In fact, we are also using something that you may not know uses quantum technology. I'll tell you that. This is a light emitting diode, lasers, and we are also using the GPS. Do you know that GPS actually uses quantum technology? So what is GPS, first of all? Can any of you tell me what is GPS? All of you have used GPS at some point in your phones. If you want to go somewhere, you just put in the destination. It tells you the full route to how to go there, right? And as you keep going, it keeps changing the route also. It might optimize the route as well. How does it do all that? Does anybody know this? So GPS stands for Global Positioning System, correct? This Global Positioning System is actually a system of 30 satellites, around 30 plus satellites, all controlled by the US, okay? These 30 plus satellites, at any point of time, there will be 4 satellites which can actually pinpoint the position, any position on the entire Earth. So they are spread out like that. The 30 satellites are spread out in such a way that at any point of time, 4 given satellites can triangulate a position on Earth, any point on Earth, okay? But that is not sufficient. Every one of those satellites is carrying a clock. And that clock is so precise that it does not lose even 1 second in millions of years. You know, most of our clocks, we have to reset it, okay? Most of your mobile phones, they are reset according to some network clock. But if you are wearing a watch, or if you have a clock which is hanging in your home, sometimes you have to reset it. Okay, it loses 5 minutes, it gains 5 minutes. The clocks that we are discussing here, which is placed inside those satellites, is an atomic clock. It does not lose even a second in millions of years, which means in 1 year, it may lose 1 microsecond or even less in 1 year. Okay? If that atomic clock was not present in the satellite, what would happen? Do you know? If I have put a GPS to go to Udupi, I may land up in Mangalore if I don't have that atomic clock. If that kind of precision was not there, the spatial resolution will be completely off. Okay? So the atomic clock presence is extremely, extremely important, and the atomic clock is again a pure quantum object. Okay? It's an application of quantum physics to technology, right? All right? And this is the MRI machine. So the message is, quantum physics may seem new to you because you may not have studied it, but you are using quantum technologies all the time. There are lots of quantum technologies that we are using today. But that is not all. You are in the middle of a revolution. Truly speaking, today is the time, if you get into quantum physics, there are lots of new things which are coming up, which can actually lead to potentially disruptive technologies. I will just give you a glimpse of that. Okay? So what I'm going to tell you is, quantum 2.0 is just happening. You are in the middle of that. Quantum 1.0 is over. You cannot participate in that. Okay? The technology is mature. You are not, you will probably, modify something, optimize something, but the revolution is over. It's all about fine-tuning and optimization. But quantum 2.0 is right now here. You can all participate in it. If you study quantum physics, you can be one of the pioneers of quantum technology 2.0. Okay? So what is quantum 2.0? It's based on two new concepts which were already known in the beginning of quantum physics, but they were not used for technology as effectively as we are doing it today. Those two concepts, I have not told you yet, I'm going to tell you that now. Those two concepts are called superposition and entanglement. Okay? So let's see what these concepts are. All right? And this quantum 2.0 is going to lead to a lot of new technologies, okay, in communication, in measurement and sensing, and also in computation. Okay? So let me just give you a glimpse of that, and then I will tell you what those concepts are. So in communication, it turns out that you may have heard of hacking the communication, eavesdropping. If somebody is talking on a phone, there are people who can hack into that communication and pick up your OTPs or pick up your secrets, right? You can eavesdrop into a communication. But using quantum mechanics or using quantum physics, you can create extremely secure quantum communication. Okay? And how many of you know that we do a secure communication? How many of you have used SSH, secure protocols? When you write your website, some of the websites will say HTTP with an S at the end. Have you seen that? HTTPS, right? Just a plain HTTP is not a secure website. HTTPS is a secure website. Okay? But that security protocol is based on a mathematical function called the trapdoor function. A trapdoor is like a baglo which opens one way easily, but it does not open the other way very easily. Okay? You can go one way very easily, but not the other way very easily. One simple example. If I give you two numbers to multiply, no matter how large those numbers are, maybe they are 10 digits each, okay? You will multiply them very easily within a fraction of a second using a calculator, okay? But now if I tell you that I will give you a 20-digit number, that 20-digit number has two factors. Both those factors are prime numbers. And I ask you, which are those two prime numbers, which when multiplied gives me that 20-digit number? So what am I giving you? I am giving you a 20-digit number. That 20-digit number has two factors. Both of them are prime numbers. And now I ask you, which are those two prime numbers? So you have to do prime number factorization. Okay? So multiplying those two, if I had given you the prime numbers, is very easy, fraction of a second. But going back from that 20-digit number to the two 10-digit numbers will take you the most powerful supercomputers today and a time which is equal to the age of the universe to solve that problem. It's an impossible problem to solve today. This is known as a trapdoor function, where going one way, which is the multiplication, is fraction of a second. But going the other way, taking that 20-digit number and coming back to two 10-digit prime numbers is an impossible problem. Okay? This trapdoor function is currently the basis of all secure protocol today. Prime number factorization. Okay? Because you cannot factorize large prime numbers, we cannot hack into today's encrypted communication. But a quantum computer is coming, and these quantum computers can do this prime number factorization in polynomial time. Okay? That's the power of a quantum computer, right? It's more powerful than all classical computers put together, right? All right, so in terms of technology, there are these technologies which are coming, right? A quantum computer, I don't have enough time to tell you what the quantum computer is, right? It's based on new technology, but it's extremely, extremely powerful, okay? And India also has a mission based on quantum computing called the National Quantum Mission. And this National Quantum Mission is all about building quantum 2.0, not about quantum 1.0. Quantum 1.0 is over. But you can take part in quantum 2.0, okay? So it's based on this new technology called quantum bits. Sorry, I had the slides for superposition and entanglement, but I think I missed that somewhere. But anyway, let me tell you what is superposition and entanglement, okay, without going into the slides. So superposition is an interesting concept in quantum physics. So imagine that I am here for a talk. You can all see me, right? But suddenly, the president of my institution calls me for a meeting. What will happen? I will have to catch a bus and go, or I'll have to take a train and go, right? But when I go there, I'm not here. So I can be only in one place at a time. I can either be in Bangalore or in Udupi, right? But a superposition, if I were a quantum particle, and if I could do superposition, I could be in Bangalore and in Udupi both at the same time. That's what superposition is. In superposition, a quantum particle can be in multiple states at the same time. Okay? Think of a coin. When you toss a coin, it's either a head or a tail. Okay? But if I take a coin, place it vertically and rotate it, then it is both head and tail at the same time. Okay? Unless you take a snapshot. Right? So superposition is about being in multiple states at the same time. Okay? So that is quantum superposition. Second thing is, I told you about quantum entanglement. Now this quantum entanglement is again very mysterious phenomenon. In fact, the founders of quantum physics, one of the founders, which was Albert Einstein, did not even believe in this concept called entanglement. He made a very famous statement which amounts to saying that God does not play dice with the world. Okay? Why he said that is because if you see, when you study quantum physics, you will see that quantum physics is actually based on probabilities. So what do we mean by probabilities? See, when you solve Newton's laws, when you solve the parabola, you've all studied projectile trajectories. Okay, when you study projectiles, you know what is the x and the y of the projectile at every point of time. Okay, that is a deterministic trajectory. That is not probabilistic. But when an electron moves, it moves in a probabilistic way. Okay, and that is what quantum physics predicts. But Einstein did not even believe that, right? And Einstein was a complete opposer of this concept called entanglement. Now, what does entanglement mean? Let me tell you. Imagine that I have two balls, okay? One is a red ball and one is a green ball, okay? Now, what I will do is, I will take those two balls and place them in two boxes, right? And those two boxes, I will move them around very rapidly, so you will not know in which box the red ball is there, in which box the green ball is there. Now what I'm going to do is, I'm going to take those two boxes kilometers apart, very far from each other, okay? And now I will ask one of the guys over that side to open that box, right? Let's say I call him up and I say, which color did you find? That person says, I found a red ball. What should be the color of the ball in the other box? Obviously, green, right? All right. This is classical entanglement. This is not quantum entanglement, okay? Now imagine I have again two balls, but those two balls are in a superposition state. every ball is being red and green at the same time. Okay, I had a visual for it, sorry, that has got missed somehow. But imagine that the ball or the coin was in a head state and a tail state both at the same time. Okay, so I can create a coin which is rotating, right? And I will rotate the coin and place it in both the boxes. But the coin is rotated in a very special way. If I take a snapshot of both the coins, I will find always if this is head, the other one will be tail. If this is tail, the other one will be head. So I am rotating it in a very special way. Okay? Now I take those two boxes and I take them kilometers apart. If this coin was entangled, something special will happen. What I will do is, the two coins are rotating, remember, right? The one box which goes to this side, I will ask that person to open the box and stop the coin, right? That person will tell me, okay, I have stopped it and I can see the head there. What should happen to the other box? The other box should stay as it is, right? The coin will keep on rotating. If the coin keeps on rotating, then it's in a superposition state. But this is not what happens in entanglement. If the two coins were quantum entangled, the other rotating coin will also stop instantaneously as soon as the other coin stops. And there is no connection between them. There is no wire, there is no light, there is no electromagnetic wave which is telling this coin that the other coin has stopped. Okay? That is quantum entanglement. That the state of that coin, whenever it is determined completely, this coin also collapses to another state. And if this coin is found to be head, that coin will found to be a tail. If this coin was stopped at a tail, that coin will stop at a head. Okay? And this communication is not real communication at all. It's instantaneous, it surpasses the speed of light. Okay? And Einstein, that is why he thought that quantum entanglement violates relativity. In fact, many of you may have heard of a paradox called the Schrodinger's cat paradox. Okay? That Schrodinger's cat paradox is also based on this concept called quantum entanglement. I don't have time to go into it, but that's the concept which is actually controlling this paradox called the Schrodinger's cat paradox. Okay? Now, how much time do I have? What's the time now? 11:30? Okay. All right. So, what we will do now is, I will just show you one visual. This was 1950s. Okay? One of the first computers that was built. And this computer, occupied a very large space, space like your lab. Maybe your physics lab or chemistry lab. But the power of this computer, which was made in 1950s, was just 5 kilohertz. 5,000 operations per second. Even your calculator is 1 million times faster than this now. Okay? So even calculators are more powerful, and calculator you can actually hold in your hand. Okay? But this was 1950s, and today what we have is this. Right? We are using laptops today, and laptops are million to trillion times faster, right, than the old machines. But how much time did it take? It took almost 70 years, from 1950 to 2026, right? Almost 76 years. So, today's quantum computer, it looks like this. This is today's quantum computer, okay? And the quantum computer is actually sitting way below here, just at the bottom. This entire setup here is a dilution refrigerator which cools that quantum computer to millikelvin temperatures. A millikelvin is an extremely, extremely cold temperature. Okay? Millikelvin is extremely close to absolute zero. Nowhere on Earth and nowhere in the universe you will naturally find such temperatures. They have to be engineered, right? So that is the temperature you need to keep this quantum computer alive, to make it work. Okay? But that is today, right? And this dilution refrigerator is like huge, it's like a chandelier, right? But the quantum computer is sitting at the bottom, and today's quantum computer has roughly about 127 to 150 qubits. Now what does it mean? How does it compare to today's computers? On today's classical computers, on a single 1 inch by 1 inch wafer, you may have billions of transistors. Billions, right? 10 to the power 9 transistors on a single wafer. But here we are seeing a quantum computer with just 127 qubits. Okay? But it turns out, if all of those 127 qubits were operating and they were all logical qubits, that computer would be more powerful than all the computers put today. Okay? Turns out that today's quantum computer is not so powerful because all of those 127 qubits are not logical qubits. They are something called physical qubits, but you guys are needed to take those 127 qubits from physical to being logical. If you study quantum physics and if you study qubit technology, you can contribute to making that qubit a physical to a logical qubit. And once you make a physical qubit to a logical qubit, it becomes powerful. Okay? So that is what is needed now, right? So we don't know. We don't know what the future is, but it appears that in about 10 to 20 years, we will be having these kind of very powerful quantum computers. Okay? And they will be able to solve problems in medicine, they will be able to solve problems in energy, environment, many other problems, which are today unsolvable on classical computers. Okay? So these quantum computers offer promise to solve those unsolvable problems. All right? Okay. So this is an interdisciplinary journey. Okay? It just continues. There are lots of different disciplines that have to come together in order to create this quantum computer. Okay? So now what I'm doing is, this first part of the talk is over. Right? I have just given you a glimpse of quantum physics and how it leads to quantum technologies. Right? So, and I told you that you are using quantum technology today, but there are many new quantum technologies that are yet to come. Okay? So now I'm going to give you a glimpse of that fifth phase of matter, right? Which is a superconductor, right? This name superconductor, you can break it into two parts, a super and a conductor. Conductor is something that you know about. You know about semiconductor, you know about insulator and a metal, right? A metal is a good conductor of electricity. A semiconductor is not so good, and an insulator is not at all. It does not conduct electricity at all. Okay? So if I go with the same progression, a superconductor is something that conducts electricity really well. Now how well, you can ask. Okay? Now how well, when we ask, we have to characterize the electrical conductivity of a system by some property. That property all of you have studied, it is called resistance. Have all of you studied the Ohm's law? V equal to IR, right? V is the voltage, I is current, R is resistance. That R, which is the resistance, tells you that when electrons are flowing through a material, how much resistance do they suffer? If they suffer less resistance, it's a good conductor. If they suffer more resistance, it's a bad conductor. Okay? We are talking about a material where the resistance is 0. There is no resistance at all. Okay? And that no resistance material is a superconductor. Okay? So this superconductor has a very peculiar property. So what I'm drawing here is a graph, okay? And this graph shows you, this is resistance and this is temperature. Okay? So what you are seeing is, if I go on decreasing temperature, the resistance comes down, but at some point you see a sharp drop. Okay? That sharp drop denotes a transition temperature. It's transitioning from a normal system, from a normal phase of matter to the fifth phase of matter. Because what happens is, below this temperature, it's going into a new phase of matter. Now this is not something new for you. See, when you take water and you keep it at normal temperature, it's a liquid. But if you put it in a fridge, which is at much lower temperature, it can become ice, right? So you see a phase transition going from a liquid to a solid, okay? So a phase transition So phase transition is something very natural for all of us. In fact, we have to boil water for cooking. Okay? But when we boil water, what happens? Water, liquid water gets converted to steam. So that is a phase transition. Okay? This material, this superconductor material, also undergoes a phase transition. But you will not see on the surface. On the surface, that material will look exactly as it is. But inside that material, something magical is happening. Something quantum is happening. Okay? That fifth phase of matter is born inside that material. Okay? And today we know hundreds and even thousands of superconductors. Superconductors are not isolated. Okay? We know thousands of them. Unfortunately, all of those superconductors that we know of, they have to be cooled down to very, very low temperatures. Okay? And how low temperatures do we have to cool them down to? At least up to liquid nitrogen temperature. Okay? How many of you know what is the temperature of liquid nitrogen? Anyone? Huh? Yes. I want to know from the students. Anyone? Is it, can I make air has 77% nitrogen, okay? Can I make air into a liquid at minus 10 degrees Celsius, minus 40 degrees Celsius, minus 100 degrees Celsius? What is the temperature I need to go down to make air a liquid? Minus 196, excellent. So minus 196 degrees Celsius, okay? What is the coldest place on earth? What is the coldest place on earth in degrees Celsius? Okay, what is the temperature at the coldest place on earth? It's roughly about minus 70 to minus 80 degrees Celsius. Okay? Liquid nitrogen is far, far, far colder than that. There is no place on earth today where air can become a liquid. Okay? We have to create liquid air using special techniques, right? But we have liquid air with us today. So we will use that, and we will cool this material called a superconductor. And the superconductor that I am going to use is sitting here somewhere. Let me see where it is sitting. Yes, it is sitting here. You see this material. I will show you that material, okay? It's called yttrium barium copper oxide, right? YbCO. It will look completely unremarkable. It will look like a stone, kind of a black stone, okay? But that unremarkable looking stone has something very, very special going on inside it, right? It turns out that when this material goes into the fifth phase of matter, the electrons inside that superconductor do something really remarkable. Which charge do electrons have? Do they have positive charge or negative charge? Come on, you can tell me that, no? Which charge do electrons have? Negative charge, right? So if I take two electrons and bring them close, what should they do? Attract or repel? Repel, right? Like charges repel. But in this material, below the transition temperature, it turns out electrons can form pairs. And that's the quantum entanglement I was talking about. These electrons, normally which should repel each other, they form pairs called Cooper pairs. And that Cooper pair is a quantum entangled singlet pair. Okay? When that happens, these electrons, which are normally called fermions, and fermions obey the Pauli's exclusion principle. In chemistry, you have studied Pauli's exclusion principle. When you fill up electrons, you can fill only one box at a time. Okay? And when you want to put in another electron, you have to make an opposite arrow, right? The spin up and spin down. So it turns out electrons are naturally fermions, okay? But when they pair up, they become bosons, the other kind of particle that is found in nature. There are only two kinds of particles in nature, either fermions or bosons. And every particle in nature can be classified into one of the two. Electrons are naturally occurring fermions, but when they pair up, they become bosons. And those bosons condense to give you the fifth phase of matter, which is the Bose-Einstein condensate. Okay? And that is what a superconductor is. So this superconductor, this is what it looks like. Okay, it's totally unremarkable. If you hold it in your hand, it will seem like a stone. Okay, it's like a ceramic. Very bad conductor actually. At room temperature, it's a very bad conductor. But it becomes a superconductor when you cool it. Okay, this is what it can do, right? You see this? This is like floating in air, right? And what you see here is a magnet. This is not a superconductor. This is a magnet. This thing here, this disk that you're seeing here, that is a superconductor. Now, what is the smoke that is coming out? That smoke is just the vapor of liquid nitrogen which has been used to cool that superconductor. Okay? So what is happening is, when you have that superconductor actually acquires a special property called diamagnetism. Okay? The diamagnetism means it expels all magnetic field. If you try to take a magnet close to it, it will repel it. But it turns out some of the magnetic field lines can go through the superconductor. And what that does is, it creates a quantum lock. But that quantum lock is not a rigid lock. It allows the magnet to float above it, to move above it. Okay? And this principle, which is called the Meissner effect, was used to build that superconducting magnetic levitation train. I showed you that train, right? It's a kind of a bullet train. That train was built using this principle, that a superconductor does not allow magnetic field to penetrate through it completely, only partially. But that partial penetration of magnetic field creates a new kind of a lock called a quantum lock. Okay? And that quantum lock can be used to build the Maglev, magnetic levitation train. Right? And this is another demonstration of that. Let me see if this video works. You see this man is standing. So no wheels and just floating. Okay? All right, so it's now time for the demonstration. So let's go through these demonstrations one by one, and that will help you to understand superconductivity. Okay? ಕೆಲಸ ಮಾಡ್ತೀರಾ, ಇದನ್ನು ಓಪನ್ ಮಾಡಿ, ಹಾಂ, ಬಟ್ ಕೀಪ್ ಇಟ್ ದೇರ್. ತುಂಬ ಸ್ಟ್ರಾಂಗ್ ಅದು ಮ್ಯಾಗ್ನೆಟ್ ಅದು. Can I have 2 volunteers, please? Can you come? Please come. Huh? They will make it better. What's your name? Dhanush. Okay, Dhanush is here. What's your name? Kaveri. Okay, so Dhanush and Kaveri are here. Okay, and we are going to ask them to do a very simple experiment. So I have a pipe here. What do you think this pipe is made of? Copper. Okay, it's a copper pipe. Can you tell me whether it is made of copper or not? It looks like copper, right? It looks like copper? Good, okay. Now, is copper a metal or an insulator? It's a metal. Very good. Okay. So copper is a metal. Is copper magnetic or not? Does it get attracted to magnets? Huh? Yes or no? There can be only 2 answers, yes or no. Well, you can also have a grey answer. It may get feebly attracted or it may be weakly repelled. Overall, it is not magnetic, okay? And to show you it is not magnetic, I cannot call all of you here, but I am going to give a magnet and I am also going to give the copper pipe to each of these 2 people and they will validate for you, okay? So, why don't you take this magnet, okay? And try to see what is the interaction between the copper pipe and this. Is it getting attracted? It's getting attracted? No, right? Can you also check that? No? But is it a magnet? What you are holding, is it a magnet or not? Can you check? It's a magnet, right? Okay, good. So, we have just demonstrated that copper is not magnetic, okay? So, now we are going to do an experiment which will actually surprise you, okay? If it doesn't surprise you, you may know the answer already. But if you don't know the answer, it will surely surprise you, okay? So, the experiment is like this. Please come here. Hold this. You hold this, okay? Now, you have to hold it like this, right? And you have to put one hand down, right? What she will do is drop the magnet through this, right? Now, you have to hold below so that the others can see that it is falling down, right? ನೀವು ಹಾಕೋವಾಗ 1 2 3 ಹೇಳಿ ಹಾಕಿ, ಓಕೆ? ನೀವೆಲ್ಲ ಏನು ಮಾಡಬೇಕು, ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಅದನ್ನು ಅದು ಬೀಳಕ್ಕೆ, ಥ್ರೂ ದಿಸ್ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಫಾಲ್ ಫ್ರಮ್ ಹಿಯರ್ ಟು ಹಿಯರ್, ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಯು ಹ್ಯಾವ್ ಟು ಕೌಂಟ್, ಓಕೆ? ಆಲ್ ರೈಟ್. ಸೊ 1 2 3 ಹೇಳಿ ಮಾಡಿ.
1 2
ಕೇಳಿಸ್ತಲ್ಲ
1 2 3.
ಅವ್ರಿಗೆ ಕಾಣಿಸ್ಲಿಲ್ಲ. See, they have to see this. So, you have to see when it is coming out, okay? Drop. Again, 1 2 3.
1 2 3.
How much time did it take? Fraction of a second, right? All right. So instead of 1 magnet, we are going to drop 3 magnets now, okay? ಇನ್ನೂ ಸ್ವಲ್ಪ ಕೆಳಗಡೆ, okay, drop. Again, 1 2 3.
1 2 3.
How long did this take? About 3-4 seconds, right? Correct, right? Okay. Can you hold? Can he also drop? 1 2 3. ನೀವು ಕೆಳಗಡೆ, ಇನ್ನೂ ಕೆಳಗಡೆ.
1.
No, wait. Throw it like this so that it doesn't.
Okay, sir. 1 2 3.
Took a long time, right? Okay. Let's drop this. Hold. 1 2 3. Okay. Now, who will explain what is happening? Can you explain? Copper is not magnetic. There is no attraction, right? So, when I dropped this one, it took fraction of a second. When I dropped this, it took about 3 to 4 seconds. right? Let's do one more thing. Do you have a pen? Do you have a pen? Any object which can fall through this? Any pen? That pen should be able to fall through. All right. So let's take this pen now. Pen is not magnetic, right? We'll make it drop through this and then see how much time it takes. Okay, hold. When you say 1, 2, 3, I will drop.
1, 2, 3.
How long did it take? Exactly as this took. Okay, this one object. This also took this one, right? So the pen and this object took the same time. But this object. So this object here, okay, took lot more time. So I did not tell you something. This is a magnet and this is not a magnet. Okay, that's the first secret. So when I drop a non-magnetic object through the copper pipe, it took about 0.4 to 0.5 seconds, fraction of a second. But when I dropped a magnet, and this is a neodymium magnet, it took about 3 to 4 seconds. Okay? And copper is not magnetic. If copper is not magnetic, why should the magnet slow down if it is going through the copper pipe? Any idea? But you believe this, right? There's no magic in this. There's no trick in this. Correct? We dropped the magnet went through. When the magnet went through, it took almost 3 to 4 seconds. But when I dropped the non-magnetic object like a pen or an iron piece, it took maybe half a second. So why is that? What could have happened which is leading to this magnet taking so much more time than the non-magnetic object? Interestingly, the answer to this question is connected to how an induction cooktop works. It's also connected to wireless charging of your phone. The answer to this question. So now can you answer this question? It's a physics question. But the answer to this physics question holds the key to technology. Can you guess? No? Okay, go and sit. Sit down, I'll tell you the answer. So there is a phenomenon called electromagnetic induction. Okay? But even before that, there is a law which you may have studied called the Lenz's law. Right? So what is happening is this is a magnet which has lines of forces. Those lines of forces are cutting this metal. When I drop this magnet, those lines of forces cut this metal. Okay? They go through the metal. But if the magnetic field is changing, if the magnetic field is a function of time, it gives rise to a voltage. Okay? Now, what does voltage do to a metal? V equal to IR. So, when you apply voltage to a metal, it produces a current. That current is going around this metal pipe. So, when I am dropping this magnet, it produces a voltage. That voltage produces a current. What does that current do? It produces its own magnetic field. It becomes an electromagnet. That magnetic field opposes this magnetic field. When it is opposing this magnetic field, it does not allow this magnet to drop freely. Okay? This is electromagnetic induction. Because what did this magnet do? It induced a current. Okay? And that induced current produced its own magnetic field which opposed the dropping of this magnet. That is why it came down so slowly. Now you will ask, how is this connected to the induction cooktop? Okay? How many of you have seen the induction cooktop? These days, since LPG is in scarce supply in Bangalore, we have to use induction cooktops. Okay? So, the induction cooktop is basically a ceramic plate. But below that ceramic plate, there are coils. What those coils do is that they produce there is a current which is passed through those coils, which is sinusoidal, which is time dependent. that sinusoidal magnetic field, the current, produces an oscillating magnetic field. Okay? And when you keep a metallic container on that, then what happens? It produces currents in the metal container, in the bottom of the metal container. Those currents, okay, they create heating. That heat is what you use to cook your or boil your water or cook your food. Right? That is Joule heating. So it's basically electromagnetic induction. You're inducing currents in the metal container through a time-dependent magnetic field. But interestingly, this is all classical physics. This is all contained in the Maxwell's electromagnetism. One more application of electromagnetic induction. Okay? Let me just show you that. I'm not sure how many of you will be able to see this, but we will try to show. So what I have done here is that I have taken a battery, okay, and I have put two safety pins on the two sides. But not just that, I have not done only just that. What I have also done is I have placed magnets here, okay. So I have taken a battery, I have taken two safety pins, and I have placed here magnets. Now, why do I want to do that? Because what I want to do is, I want to produce a current through this battery. That current will have its own magnetic field. That magnetic field will interfere with this magnet's magnetic field and produce motion. That is something that all of you have studied in your 10th standard. This is a plain DC motor. Okay? See, this is the coil. Okay? This is a copper coil. And this copper coil is what will be used to pass the current. But when current passes through this coil will develop a magnetic field. That magnetic field and this magnetic field will interfere with each other. Okay? So let's see how that works. I'm going to try this now. Okay? You can already see that this is right. Can you all see this? This is the simplest DC motor possible. All the fans are based on AC motors, but the principle is the same, right? That what you're seeing here is that when current passes through a coil and a magnetic field is present around it, that magnetic field is going to apply a force on the coil, right? So you're seeing an interaction between current and magnetic field. That is what is giving rise to technology. How do we use this technology? In all the DC motors and AC motors, this technology is used, right? So basic physics going into technology. So now never ask, why am I studying physics? Why am I studying chemistry? Why am I studying biology? Because what use is there of this study? Everything that you study has gone into some technology or the other. That is why you are studying it, right? And this experiment that I showed you of this copper pipe, okay, and of the magnet dropping through it, this phenomenon is called diamagnetism. Because what is happening here is that this copper pipe was producing its own magnetic field and it became a diamagnet. It was opposing the falling of another magnet, right? So this exhibited diamagnetism, right? And the material that we have today, that is a superconductor, is a perfect diamagnet below a certain field, but above a certain field it becomes a mixed state. It allows some magnetic field to go through, so it is not a perfect diamagnet, okay? But that imperfect diamagnet is what we use to build the Maglev, okay, magnetic levitation train. So let's see how that works. I'll use this. So what I'll do is, I will first pour some liquid nitrogen into this, okay? I need 2 volunteers. Anyone willing to come? No one willing to come? That's surprising. No one wants to experience liquid nitrogen? Come on. Can you see what is going on there? Can you describe what is going on there?
Sublimating.
Huh.
Sublimation is going on.
Yes, go on, go ahead.
Sublimation is going on.
Why do you say sublimation?
So
It's just evaporation.
evaporation, sir. Sorry.
It's not solid going to a
Solid,
gas, right? It's just a liquid going to a gas. So what are you seeing there? Some liquid, right?
Yes.
Okay.
Nitrogen.
Liquid nitrogen. So this is actually liquid air. Okay, mostly liquid air, right? So what we want to do is we want to test out how cold it is, right? You want to put your finger into that? Okay. He doesn't want to put his finger, right? So we'll put this poor rose into it and then we will see what happens to the rose, right? Okay. So we are going to put this now to see how cold it is, yeah? So we have to keep it for more than 10 seconds and this causes a cold burn to the rose, okay? I hope the director will not scold me after this. All right. So what you have to do is you have to crush the rose after this, right? So why don't you go ahead and do this? Crush. Ah. Okay. So that's what happens to the rose, right? So this liquid nitrogen, right? Now I'm going to wet this because I want to use this for another experiment, okay? All right. So right now just stay aside. I will call you when I need, yeah? Just stay here. All right. So now what I'm going to do is, I'm going to take this material. This material is not a superconductor right now. It's just a ceramic. It's just a stone, okay? Come here, come. I didn't ask you to go that far. You can just stay here. Just hold this in your hand. Don't drop it. It's brittle. And describe what you feel.
It's very heavy.
It's very heavy. It's actually like a stone, right?
Yes, sir.
You can show it very much.
Same, sir.
Okay. So this material, okay, we are going to place it in this thermocol box, right? And now we are going to cool it. Now we don't have a refrigerator. We will actually pour liquid nitrogen on it to cool it, right? Since we need a lot more, I have to just pour it like this. Get me that magnet. Fast.
We did.
Fast. So while this is cooling, we will do something else. So we have built a track in JNC, okay? I showed you that magnetic levitation train, right? So this is a track that we have built, and in this track we have placed several magnets. But these magnets are actually pushed into a groove. We made a groove in the wooden thing, and then we pushed these magnets through it, and they were stuck to the wooden, the base using a particular glue. Now that glue has to be extremely strong because we were placing the magnets with opposite polarity. And these are very strong magnets, neodymium magnets. So can you guess which glue did we use for sticking these magnets? Fevicol? Super glue? No. Salman Khan glue. You won't believe it. The glue was actually called Salman Khan glue. Okay, so that is what we used to stick these magnets into this wooden base. Okay, but they are stuck very nicely now. But this is the track. Okay, this track is a magnetic track. Remember what happens to a superconductor? It expels magnetic field, right? So what we are going to do is, we are going to place the superconductor above this. Okay. So we have made a boat. This is a boat. This is an empty boat. And this thing inside it, we have placed a superconductor inside this. Okay. And above this, we have placed a small sponge. And the reason for the sponge is that it holds that liquid nitrogen for longer, right? So I'm going to place it in this, and we are going to cool this. How do we cool this? Again, pour liquid nitrogen into it, right? So we are going to place this here. Let me just remove all of this. We need more liquid nitrogen. Can you hold this? You know, in Udupi, we need a lot more liquid nitrogen to cool this. In Bangalore, it gets cooled with a much smaller amount because Bangalore is cooler. Okay, so this thing is, this is a very big superconductor. Okay, so it takes a lot more liquid nitrogen and a lot more time to bring it down below the transition temperature, right? So that is why we are just waiting for this. And you may wonder why liquid nitrogen is not boiling off immediately. After all, Udupi is so hot, right? So the outside temperature is so high, but the liquid nitrogen temperature is minus 200 degrees Celsius. So why is liquid nitrogen not immediately boiling off, right? It turns out there is a vapor layer. That vapor layer, it's like this, you know, when you take a hot dosa tawa and you throw water on it, what happens? Some water drops, they will form and they will float on it. So the tawa is extremely hot. So the water should immediately boil when it comes into contact with it, but it does not boil. It becomes a drop and it floats on the tawa, right? That's because there is a Leidenfrost effect. The water drop forms a water vapor layer. That water vapor layer protects that drop from evaporating immediately. That's what is happening here, okay? Okay, we have to wait for that. Let's see if this is ready. Yes, this is ready. Okay, so get ready to see the magnetic levitation train. Right, hold this, please. Can you all see this? It is floating. is a quantum lock. This is not just floating. Okay. Let me try what Dr. Vinayak Katta tries. Okay. I don't know whether it will work or not, but let me see. Do you see? This is a lock. Okay. This is a quantum lock. Right? And this is the principle of a magnetic levitation train. And the same material goes into the MRI machine. Right? Okay, now let's see if this thing also works. You have to wait for a long time. This is a, yes. Okay, this is almost ready now. That this remains in a superconducting state. You can try. Go ahead. Just push it a little bit. Check if it is. Get me a piece of paper, no? Quickly. Thin piece of paper. It gets hot very quickly actually. It gets hot very quickly. That's why you don't see it. But I should just remove this. Okay. You got the paper? No, make it just one sheet. Make it one sheet. Push it through that. Push it below this to show the audience that there is nothing below that. Push the paper through that. See, that's why you needed a good sheet of paper.
Sir, if you can make half, it will be enough.
We'll hold it like this, right? Push it. You're pushing it too hard. So we have actually placed the magnets in a very special way. Okay, these magnets are placed so that there are automatic brakes at the end. That's why this thing is not going off. There is nothing stopping that. It's just magnetic field again, right? So this magnetic track is actually holding the magnet in a quantum lock. The superconductor is there inside this, right? And this superconductor and this magnet, they were also holding each other. So they were both in a quantum lock, okay? And the same material here, people are now trying to figure out how to change the transition temperature of this superconductor so that we can get a superconductor at room temperature. Remember, there is no place on earth naturally occurring where this material, YbCO, becomes a superconductor, right? But what if we could get a superconductor at room temperature? What would happen? We would get a superconducting train right now. We would not have to cool the superconductor down to liquid nitrogen temperatures, right? We could have trains which move as fast as 600 kilometers per hour. Okay? The distance between Bangalore to Udupi, which I covered in about 8 hours, it can be covered within half an hour. Okay? That's the kind of power you will have. Okay? Plus, of course, there are lots of other benefits. A superconductor does not have resistance. So when you pass electricity through it, there is no dissipation. There is no heat dissipation. So you can pass electricity through a superconductor with 100% efficiency. Okay? So those are some of the things. Let me just see if this works again. Yeah, this will work again. Let's just try this. it gets this gets hot very quickly, so this doesn't work so well. But that is better. All right. All right. So I think we are done for today. If you have any questions, you are welcome to ask. And yeah, that's it. Thank you. Any questions you can ask on this, on these topics? You are welcome to ask. Okay, if you want to ask.
So any of you have any questions, you can ask now itself to Sir regarding the demonstration and the concepts he explained.
Sir, very good afternoon. Very good afternoon. I have a question. So, we can easily make the train move faster using the magnetic levitation. So, how can we actually stop it? Like while moving with such a high speed, so how can we stop it?
Okay. So I showed you that other experiment where I dropped the magnet, right? Now, when that magnet was dropping through the copper pipe, it was not dropping at its usual speed, right? In fact, if you could visualize it, and you can do that because you can actually tie a string to it and see how fast the string is going. It turns out that magnet was actually dropping at a constant speed. Now remember, when you drop an object, it actually accelerates because there is acceleration due to gravity, right? But when that magnet was falling, the acceleration due to gravity was zero, correct? So there was something which was stopping the magnet, but invisible, okay? This is exactly what we will use to stop the train. There are something called eddy currents. In fact, even now, when you want to stop the train, actual train in which you travel, right? You cannot use the brakes which we use in our automobiles. You cannot use friction-based brakes. You have to use non-friction-based brakes. So what you do is, you just bring a magnet close to the metallic wheel. What will happen? In the metallic wheel, there will be currents. Those currents are called eddy currents. But those currents will actually oppose the direction of the magnetic field, and they will slow down because you have just brought the magnet close to the wheel. So in trains, what they do is they keep the magnets far, right? But when you want to stop it, you take the magnet close to the wheel and it stops almost instantaneously. Okay? So within the train itself, you can place the magnets. In fact, you can also create orientation of the magnets. See, here I showed you the track, right? At the very end of the track, I had placed the magnets in a particular orientation. What I can do is, at any point on the track, I can create a polarity which is orthogonal to the train's polarity to create an automatic brake. Okay? So it's very easy to do that. Using electromagnetism itself, you can do that.
Thank you very much.
ಅದು ದೊಡ್ಡ ಮ್ಯಾಗ್ನೆಟ್ ಎಲ್ಲಿಟ್ರಿ ಅದು ತಂದ್ರೆ ಅವರು ದೊಡ್ಡ ಮ್ಯಾಗ್ನೆಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ ತರಲಿಲ್ಲ ಮ್ಯಾಗ್ನೆಟ್ Any other questions? No questions? All of you are hungry? You want to go for lunch? Tata, bye-bye.
Sir, you are kindly requested to take the seat in the auditorium itself. And thank you so much for your wonderful session. Your articulation of quantum physics concepts and the demonstration were just outstanding, mind-blowing and mesmerizing. Thank you so much. Now I invite Mrs. Pratibha C. Acharya ma'am to deliver the vote of thanks for this session.
Science is not just a collection of laws. It is an organized adventure of the human spirit. Seeking the divine blessings of Udupi Sri Krishna and Mukhya Prana, I offer my humble pranamas to the visionary lineage of our council, the founder president Sri Sri Vibhudesha Tirtha Swami Ji, and former president His Holiness Sri Sri Vishwapriya Tirtha Swami Ji, and our present president His Holiness Sri Ishapriya Tirtha Swami Ji, Udupi Sri Adamarmata Education Council, Bangalore. I, Pratibha C. Acharya, Head of the Department of Physics, feel deeply privileged to propose this vote of thanks on this intellectually vibrant occasion. Our President, His Holiness Sri Ishapriya Tirtha Swami Ji, may not be with us for this session, but his spiritual guidance and progressive vision for Poornaprajna are felt in every corner of this hall. We offer our sincere pranamas for his continuous blessings. We also remember with deep gratitude our Honorary Secretary, Dr. A.P. Bhatt sir. Though he is not present for this occasion, we remain indebted to his guide spirit. It is his relentless initiative that brings the world of high-level research to our students, making this symposium a reality. We are profoundly grateful to Professor N.S. Vidyadhi Raja sir from the Theoretical Science Unit, JNCSR. Professor, it has been a rare joy to witness your session. To see a researcher of your stature personally demonstrating the experiments has been a deeply enriching experience for all of us. You haven't just taught us physics today, you have shared your passion for discovery. On behalf of our college, we thank you from the bottom of our hearts for your time and for the inspiration you have provided. Thank you, sir. We offer our sincere thanks to Dr. Shivkumar sir and Dr. Amruta madam from Poornaprajna Institute of Scientific Research, Bangalore. Having you here reinforces the bond between our institutions and shows our students the path toward a future in research. Thank you. We also thank Sri C.K. Manjunath sir, Directorate of Academics, USAMEC, Udupi, for his constant presence and administrative guidance. We record our formal appreciation for our principal, Dr. Ramuel, and IQAC coordinator, Dr. Vinay Kumar D, for their support. My heartfelt thanks to Dr. Vijayalakshmi C. Bhatt, Member Secretary of Academic Council and HOD of Botany. Madam, we value your leadership and your presence here as a pillar of our academic family. Thank you, ma'am. We also thank Dr. Lakshmesh Rao, IQAC co-coordinator, for his guidance and support throughout this session. Thank you, sir. To the faculty and students from various schools and institutions, thank you for joining us. Your enthusiasm has truly made this a collective celebration of science. Thank you. I must thank the convener of Science Association, Dr. Karamchandra sir, for his meticulous planning behind this event. Thank you, sir. To our student coordinator, Mr. Abhay Kumar and Ms. Neha, and our volunteers, thank you for your hard work and for managing the session so gracefully. Our thanks also go to technical team for the flawless support led by Mr. Jagdish, and to our photographer, Mr. Krishna, and to the members of media for their vital role in sharing this event with the public. Thank you. Finally, I wish to thank every individual who has supported us directly or indirectly in making this session a grand success. Your contributions, big or small, are deeply appreciated. As we conclude, let us remember the scientist is not a person who gives the right answers, but the one who asks the right questions. May you all leave here today with many new questions. Thank you, one and all.
With this, we move forward into a day filled with learning, interaction, and exploration as we continue into the symposium, let us remember science is not just about answers, it's about questions, the courage to ask them and the patience to seek them. So let today not just be an event you attend, let it be an experience you carry, a thought that stays, a spark that grows, a curiosity that never fades. Because in the end, science is not just something we learn, it is something we become. Thank you. Have a truly inspiring day ahead. Within some few minutes, the arrangement for the lunch will be made in the Vibhudesha Tirtha Hall. So you're all requested to kindly proceed and be here exactly at 1:20 for the next session by Dr. B.R. Guru Prasad sir. Thank you.
Seeking the blessings of His Holiness and Sri Mukhyaprajna, I, Pratiksha, member of Science Association, welcome you all to the second session. I request our principal, Dr. Ramu L., Dr. A.P. Bhatt, Honorary Secretary, Udupi Sri Adamarmat Education Council, Bengaluru, and Dr. B.R. Guru Prasad kindly come to the stage and take the seat. Nothing in science has only value to the society if it is not communicated. Today, I am extremely honored to introduce our guest, Dr. B.R. Guru Prasad. Sir graduated in science in physics, chemistry, and mathematics, and master degree in communications and journalism. He obtained PhD degree from Mysore University for the thesis work, Contribution of External and Indigenous Technological Elements to India's Space Capabilities and Appraisal at the affiliated National Institute of Advanced Studies, Indian Institute of Science Campus, Bengaluru. Obtained proficiency certificate in the subject Principles of Flight and Aeronautics. Presently, he is serving as Director, Jawaharlal Nehru Planetarium, Bengaluru, and adjunct faculty member at National Institute of Advanced Studies, Bengaluru, and editorial board member of Journal of Aerospace Science and Technologies. He has worked in Indian Space Research Organization, ISRO, for nearly 37 years as a scientist, Associate Director, Office of Media and Public Relations, ISRO headquarters. As a satellite scientist, he has rich experience in satellite mission planning, analysis, and operations, and worked for over 25 Indian satellite missions at ISRO Satellite Center. worked at German Space Agency DLR and at NASA. He is invited to Japan in 2008 by Japanese Aerospace Exploration Agency as a member of panel on space education for young people and invited to France in 2010 for peer-related consultation. He had written and broadcasted extensively on space-related topics, including Indian space program in English and Kannada. He written more than 600 articles and 13 books on astronomy and space, broadcasted nearly 100 variety of science programs, including live phone-in program in All India Radio, Indira Gandhi National Open University FM station Gyanvani, Doordarshan, and private TV channels. Delivered more than 700 lectures on various science topics in educational and public service institutions and teachers' reorientation programs. Conducted more than 600 ISRO exhibitions in India as well as in abroad. Conducted more than 150 quiz programs in various institutions in many parts of India and in radio and TV channels. As a resource person on space and astronomy, he had taught the teachers community all over the Karnataka through SATCOM program. Extensively interviewed by radio and TV channels on India's space program Chandrayaan-3 and Aditya. He visited different countries like Austria, Dubai, France, Germany, Greece, Hong Kong, Japan, Qatar, Singapore, South Korea, Taiwan, Thailand, and United Nations. By this brief introduction, I welcome you, sir. I request Mrs. Pratibha C. Acharya, Head of the Department Physics, florally welcome Dr. Guru Prasad, sir, and Dr. Ramu L. and Dr. A.P. Bhatt, sir. Thank you, madam. Now, the stage is open to the session.
Please, sir, please. You have color mic. Hello. Respected Professor A.P. Bhatt, Professor Manjunath, Professor Ramu, Principal, as well as all others who have been responsible for my arrival here at Poornaprajna institutions in Udupi and Adamar. I thank all of them for having invited me here, as well as to enable me to speak to you people about a very exciting subject on the Indian space program. I don't know whether I can speak in English or Kannada. Okay. You want me to speak in both the languages, some sentences in English, some sentences in Kannada. But I don't want to speak in Konglish. Okay. Okay. Kannada is okay. Good. Thank you, sir. Okay. The topic of my talk today is Indian Space Research Organization. It is an inspiration to Indian students, no doubt about it. Why do I say ISRO is an inspiration? For the money which has been allocated to us, okay, it has done wonders in the domain of space science as well as space technology and space applications, in fact. So, obviously, it is not only what the country has got in terms of monetary returns, that is different. But ISRO has been able to inspire millions, hundreds of millions of students at different levels. Okay? ಭಾರತದಲ್ಲಿರುವಂತಹ ಕೋಟ್ಯಾಂತರ ವಿದ್ಯಾರ್ಥಿಗಳನ್ನು ವಿವಿಧ ಸ್ತರಗಳಲ್ಲಿ ವಿದ್ಯಾಭ್ಯಾಸ ಮಾಡ್ತಾ ಇರುವಂತಹ ವಿದ್ಯಾರ್ಥಿಗಳನ್ನು ಪ್ರೇರೇಪಿಸುವಲ್ಲಿ, ಅವರನ್ನು ಹುರಿದುಂಬಿಸುವಲ್ಲಿ ಇಸ್ರೋ ಪ್ರಮುಖವಾದ ಮಹತ್ತರವಾದ ಪಾತ್ರವನ್ನು ವಹಿಸಿದೆ. ಹಾಗಾಗಿ ಇದು ಒಂದು ವಿಶಿಷ್ಟವಾದ ಅನನ್ಯವಾದ ಸಂಸ್ಥೆ, ಯುನೀಕ್ ಇನ್ಸ್ಟಿಟ್ಯೂಷನ್ ಅಂತ ಹೇಳ್ಬೋದು. ದಟ್ ಈಸ್ ದ ರೀಸನ್. ವೈ ಡು ಐ ಸೇ ಲೈಕ್ ದಿಸ್? ವಿಚ್ ಆರ್ಗನೈಸೇಷನ್ ವಾಸ್ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಫಾರ್ making the world to turn towards India and say, very well done, because a spacecraft built and launched by ISRO in 2008 was responsible for conclusively discovering water on the moon for the first time. Conclusively means without any doubt. And ISRO was the organization which built and launched a spacecraft towards Mars, navigated it all the way for such a long distance over a period of 10 months, and enabled our country to become the first Asian country to reach Mars. And ISRO was the organization which made the country to hold its head high by landing a spacecraft for the first time in the difficult South Polar region of the moon. Which country was the first one to land in the South Polar region of the moon? Your India. ISRO built Chandrayaan 3 and launched by ISRO. So, I would not say ISRO, a great country called India, of which ISRO is only a small part, has made this possible. But ISRO has enabled India to become such a great country, in fact, through its achievements. That is why, let me take you on a journey of the origin and evolution of the Indian space program, the genesis and the evolution of the Indian space program. Next slide. It was coming, okay. You make it. Okay. Can you push the space bar? Space bar. Yeah, look at it. Look at the way in which this is a rocket built in India by ISRO. Look at that. This is a 15-story high rocket. Last year, it launched an American satellite weighing more than 5,000 kilograms. An American satellite weighing more than 5,000 kilograms. Look at that. This is the rocket, and this is Sriharikota, the only spaceport of India. Look at that. The rocket, what is the weight of that rocket? Can you tell me? The weight of that rocket is only 640,000 kilograms. 640,000 kilograms. Can you believe that 640,000 kilograms can go up? Even many a times I have seen. I didn't believe. But anyway, it's a fact. Next slide, please. Again, you press the space bar. Look at that. Yeah. Look at that. Yeah, our people are there. And this 15-story high rocket has lifted off, carrying an American satellite, in fact. And it was standing like a rock on its launch pad, and in about, let us say, 15 minutes or so, it achieved a speed in a particular direction. Speed in a particular direction is called what? Velocity. Okay? It achieved a velocity of only about 28,000 kilometers per hour. 28,000 kilometers per hour in a short span of 15 minutes. Look at that, the way in which the rocket is going. See, look at the rocket, the smoke and the fire which is coming out like anything. And, if a rocket has to work, it has to carry propellants, not fuel only. Propellant means fuel oxidizer combination. That is called as propellant. Okay? And that was the video of LVM-3 rocket, which is the LVM-3 is the largest and heaviest and the most powerful rocket built by India. Okay? Look at that, it is going up and up and up. And as far as rocket propellants are concerned, there are 3 types: solid, liquid, and cryogenic. You can ask me questions later what it is. And in all the 3, India excels today. My dear students, one thing let me tell you, giving a lecture like this is easy. Accomplishing something from engineering point of view, it is not easy. That is what India has done. Be proud of your country. That is what it has done. Okay? Look at that. And this is the way the rocket went up. I don't want to dwell upon that for a long time. Next slide. Okay, this is the man, perhaps one of the greatest sons of India, Vikram Ambalal Sarabhai, in fact. See, they are all very rich. He was very rich. He had an industrial empire. Why did he come to government? And why did he begin? Why did he begin the Indian space program? Destiny, I would say. He would have been content with his industrial empire, but he came to the government. Let me do something good for the country. Today, if we have achieved something and if we can hold our head high in the domain of space, okay, the man who is totally responsible, who is mainly responsible for this is Dr. Vikram Ambalal Sarabhai, because he was the man who actually conceived the Indian space program, okay, organized the Indian space program, and no doubt he was the architect of the Indian space program. Excuse me. Next. Sarabhai was a great dreamer, not daydreamer, great dreamer. He not only dreamt of something, he provided us, okay, he told us the way in which to achieve things. ಅಂತರಿಕ್ಷದಲ್ಲಿ ಭಾರತ ಸಾಧಿಸಬೇಕಾದ್ರೆ ಆ ಸಾಧಿಸಲು ನಾವು ಅನುಸರಿಸಬೇಕಾದ ಮಾರ್ಗ ಯಾವುದು ಅನ್ನೋದನ್ನು ತೋರಿಸಿಕೊಟ್ಟವರು ಡಾಕ್ಟರ್ ವಿಕ್ರಮ್ ಸಾರಾಭಾಯ್. ಹಾಗಾಗಿ ಆ್ಯಸ್ ಅರ್ಲಿ ಆಸ್ late 60s, he told one thing, please observe what I am telling. I am quoting Dr. Vikram Sarabhai. He said in 1960s, when we were not even, India was full of bullock carts and all those, snake charmers and all. At that time, he dreamt of building rockets. He said like this, there are some who question the relevance of space activities in a developing nation. To us, there is no ambiguity of purpose. We do not have the fantasy of competing with the advanced countries in the exploration of the moon, the planets, or even the manned space flight. At that time it was called as manned space flight. Now it is called as human space flight, because all you people will be angry only if we say manned space flight. Okay? So, but if we are to play a meaningful role nationally and in the Committee of Nations, we should be second to none in the application of advanced technologies to the real problems of man and society. Nodi, what a prophetic words they were. ಎಷ್ಟು ಚೆನ್ನಾಗಿ ಯೋಚನೆ ಮಾಡಿದ್ದಾರೆ ಅವತ್ತೇ ಅಂತ. ಆದರೆ 1962ರಲ್ಲಿ ಭಾರತೀಯ ಅಂತರಿಕ್ಷ ಕಾರ್ಯಕ್ರಮ ಪ್ರಾರಂಭ ಆದಮೇಲೆ 1971 ಡಿಸೆಂಬರ್ನಲ್ಲಿ ಸಾರಾಭಾಯಿ ಅವರು ನಿಧನರಾದರು. ಆದರೆ ಅವರು ಪ್ರಾರಂಭಿಸಿದ ಒಂದು ಸಂಸ್ಕೃತಿ ಏನಿದೆ ಅದನ್ನು ಇವತ್ತು ಇಸ್ರೋ ಮುಂದುವರಿಸ್ಕೊಂಡು ಹೋಗ್ತಾ ಇದೆ ಅಂತ ನನಗೆ ಭಾರತೀಯ ಅಂತರಿಕ್ಷ ಕಾರ್ಯಕ್ರಮವನ್ನು ಸುಮಾರು ಹತ್ತಿರ 5 ದಶಕಗಳಿಂದ ನೋಡಿರುವಂತಹ ನನಗೆ ಅನಿಸುತ್ತೆ. ನಾನೇನಿಲ್ಲಿ ಇಸ್ರೋ ಪರವಾಗಿ ಇಲ್ಲಿ ಬಂದು ನಿಂತಿಲ್ಲ, ಜವಾಹರ್ಲಾಲ್ ನೆಹರು ತಾರಾಲಯದ ಪರವಾಗಿ ನಿಂತಿಲ್ಲ. ನಾನು ನಿಮ್ಮೊಡನೆ ಇಂದು ಸಂಭಾಷಣೆ ಮಾಡ್ತಾ ಇರೋದು ಒಬ್ಬ ನುರಿತ ವಿಜ್ಞಾನ ಲೇಖಕನಾಗಿ. ಆ್ಯಸ್ ಎ ಪ್ಯಾಷನೈಟ್ ಸೈನ್ಸ್ ಕಮ್ಯುನಿಕೇಟರ್ ಐ ಆಮ್ ಟಾಕಿಂಗ್ ಟು ಯು. ಟೇಕ್ ಇಟ್ ಲೈಕ್ ದಟ್, ನಾಟ್ ಆಸ್ ಈಸ್ ಫಾರ್ಮರ್ ಇಸ್ರೋ ಸೈಂಟಿಸ್ಟ್ ಆರ್ ಆಸ್ ಡೈರೆಕ್ಟರ್ ಆಫ್ JNP. ಬಟ್ what I say, I feel honestly what I have observed, I am telling. Okay, Indian space program began, let's go quickly. It began on November 21st, 1963 with the launch of a sounding rocket. Sounding rocket is not a satellite launching rocket. It is only a small rocket capable of studying the Earth's upper atmosphere. ವಾತಾವರಣದ ಮೇಲ್ಭಾಗನ ಅನ್ವೇಷಣೆ ನಡೆಸೋದಕ್ಕೋಸ್ಕರ ಇದ್ದಂಥದ್ದು. ನೋಡಿ, ಅದು ಈ ರಾಕೆಟ್ನ ಕೊಟ್ಟಿದ್ದು ಅಮೇರಿಕಾ. ಆ ರಾಕೆಟ್ನಲ್ಲಿದ್ದಂತಹ ವೈಜ್ಞಾನಿಕ ಉಪಕರಣ ಅದು ಫ್ರಾನ್ಸ್ದು. ಆದರೆ ಅದನ್ನು ಉಡಾಯಿಸಿದವರು, ದ ಪೀಪಲ್ ಹೂ ಲಾಂಚ್ಡ್ ಇಟ್ ಎಂಥೂಸಿಯಾಸ್ಟಿಕಲಿ ವರ್ ಇಂಡಿಯನ್ಸ್. ಡೇಟ್ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, ಮುಂದೆ ಬರ್ತೀನಿ ತಿರ್ಗ. ನವಂಬರ್ 21, 1963 ಸಂಜೆ 6:25 ಈ ರಾಕೆಟು ಇಟ್ ವಾಸ್ ಲಾಂಚ್ಡ್. ಅಮೇರಿಕಾದ ರಾಕೆಟು, ಅದರಲ್ಲಿದ್ದಿದ್ದು ಫ್ರಾನ್ಸ್ನ ವೈಜ್ಞಾನಿಕ ಉಪಕರಣ, ಉಡಾಯಿಸಿದ್ದು ಭಾರತೀಯ ವಿಜ್ಞಾನಿಗಳು. ಪ್ಲೇಸ್ ಯಾವುದು, ಯಾವ ಸ್ಥಳದಿಂದ ಅಂದರೆ ತುಂಬಾ ಅಂತ. ತುಂಬಾ ಅನ್ನೋದು ಅವತ್ತು ತಿರುವನಂತಪುರದ ಹೊರಗಡೆ ಇತ್ತು. ಇವತ್ತು ಇಟ್ ಈಸ್ ಪಾರ್ಟ್ ಆಫ್ ಟ್ರಿವಾಂಡ್ರಮ್, ಇಟ್ಸ್ ತಿರುವನಂತಪುರಂ. ನೆಕ್ಸ್ಟ್ ಒನ್, ಲುಕ್ ಅಟ್ ದಟ್. ದಿಸ್ ಈಸ್ ದ ವೇ ರಾಕೆಟ್ಸ್ ವರ್ ಕ್ಯಾರಿಡ್ ಇನ್ ಇಂಡಿಯಾ ಅಟ್ ದಟ್ ಟೈಮ್. ಓಕೆ, ಯು ಲುಕ್ ಅಟ್ ಇಟ್, ದ ವೇ ಇನ್ ವಿಚ್ ದೇರ್ ವರ್ ನೋ ಕಾರ್ಸ್, ನೋ AC, no fans like this even, okay, though it is terribly hot there. ರಾಕೆಟ್, ಸೌಂಡಿಂಗ್ ರಾಕೆಟ್ ಪಾರ್ಟ್ ಕೂಡ ಒಂದು ಭಾಗವನ್ನು ಯಾವ ರೀತಿ ಬೈಸಿಕಲ್ ಮೇಲೆ ತಗೊಂಡು ಹೋಗ್ತಾ ಇದ್ದಾರೆ ನೋಡಿ. ನೆಕ್ಸ್ಟ್ ನೋಡಿ, ಇನ್ ದೋಸ್ ಡೇಸ್ ಇನ್ ಟ್ರಿವಾಂಡ್ರಮ್ ಇಟ್ ವಾಸ್ ನಾಟ್ ಈಸಿ ಟು ಗೆಟ್ ವೆಜಿಟೇರಿಯನ್ ಫುಡ್, ದ ಕೈಂಡ್ ಆಫ್ ಥಿಂಗ್ಸ್ ಮೆನಿ ಸೈಂಟಿಸ್ಟ್ ಲೈಕ್ಡ್. ದೇ ವರ್ ವೆಜಿಟೇರಿಯನ್ಸ್ ಅಟ್ ದಟ್ ಟೈಮ್. ಇನ್ ಟ್ರಿವಾಂಡ್ರಮ್ ಇಟ್ ವಾಸ್ ನಾಟ್ ಈಸಿ ಟು ಗೆಟ್ ವೆಜಿಟೇರಿಯನ್ ಫುಡ್ ಎವ್ರಿವೇರ್. At that time, I am telling, at that time, 60 years back. So, look at that, that's why they didn't have AC, they didn't have cars, okay, it was terribly hot like here, and they had to work, by eating whatever was available at least, sometimes even starve. By the time I entered ISRO, there were already many facilities. I entered ISRO in mid-80s, roughly. So, the sacrifices of these people are very important. Look at that one with banyan and squatting there. His name is Mr. Arva Mudan. Okay, Mr. Arva Mudan. Look at him. He has not eaten properly, I'm sure about it, at that time when the photo was taken. And, he is working on the part of a rocket. Look at that, the other person, no, look at him. Definitely he would not have eaten properly. Look at his face. ಓಕೆ, ಕನ್ನಡದಲ್ಲಿ ಹೇಳಬೇಕು ಅಂದರೆ ಸ್ವರ್ಗ ಹೋಗ್ಬಿಟ್ಟಿದೆ ಅವ್ರ ಮುಖ ಪಾಪ. ಇವರೆಲ್ಲ ಅರ್ವ ಮುದನ್, ಇವ್ರು ಯಾರು ಇವರು? ಓ, ಗೊತ್ತಾಯ್ತು ಇವ್ರು ಯಾರು ಅಂತ. ಇವ್ರ ಹೆಸರು APJ ಅಬ್ದುಲ್ ಕಲಾಂ ಅಂತ. ಇವರು ನೋಡಿ, ನಾ ತಮಾಷೆಗೆ ಹೇಳ್ತಲ್ಲ, ದಟ್ ಈಸ್ ಡಾಕ್ಟರ್ APJ ಅಬ್ದುಲ್ ಕಲಾಂ. ಡು ಯು ನೋ? APJ ಅಬ್ದುಲ್ ಕಲಾಂ ವಾಸ್ ಒನ್ ಆಫ್ ದ 7 people originally recruited for the Indian space program. First he was in ISRO only, okay, then he went to DRDO, okay. Yes, next one, okay. Then ಕಲಾಂ ಅವರೊಬ್ಬರೇನಾ ಗ್ರೇಟು? ಯಾಕೆ ನಿಮ್ಮ ಉಡುಪಿಗೆ ಏನಾಗಿದೆ? ಅನದರ್ ಗ್ರೇಟ್ ಸನ್ ಆಫ್ ಇಂಡಿಯಾ, ಹಿಸ್ ನೇಮ್ ಈಸ್ ಉಡುಪಿ ರಾಮಚಂದ್ರ ರಾವ್, UR Rao. Undoubtedly be proud of your city. He was born in Admar. But anyway, be proud. His name itself says Udupi Ramachandra Rao. That is Professor UR Rao. He is the architect of the Indian satellite program. Sarabhai is the architect of the Indian space program. Professor Rao is the architect of the Indian satellite program. Later, he became the chief of ISRO, and he had to take a lot of criticism because the Indian space program was evolving. Inevitably, there were many challenges and he was targeted for that. But still, he stood by. Okay? He had an unbridled belief that we would succeed one day. And today, if we have explored moon, explored Mars, and studying the sun today, thank Professor U.R. Rao. In fact, he was the man who built a solid edifice to the Indian space program. ಭಾರತೀಯ ಅಂತರಿಕ್ಷ ಕ್ಷಮಿಸಬೇಕು, ಭಾರತೀಯ ಉಪಗ್ರಹ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಭದ್ರವಾದ ಬುನಾದಿಯನ್ನು ಹಾಕಿದಂತಹ ಧೀಮಂತ ವ್ಯಕ್ತಿ ಎಂದರೆ ಉಡುಪಿ ರಾಮಚಂದ್ರ ರಾವ್, UR. ಓಕೆ, ಇವತ್ತು ಅವರು ಹುಟ್ಟಿದ ಸ್ಥಳ ಅದಮಾರು, ಅಲ್ಲೇ ಹೋಗ್ಬಿಟ್ಟು ಇದನ್ನು ಹೇಳ್ತಾ ಇದ್ದೆ ನಾನು. ಹಾಗಾಗಿ he is the man who is behind our satellite program. Next, of course, India's first satellite was Aryabhatta, named after famous Aryabhatta of the 5th century. He was a famous mathematician and astronomer. And do you know, we said, many people say we didn't know many things in the past. Aryabhatta very clearly says in a shloka, eclipses are due to shadows. Very clearly says, eclipses are due to shadows, and day and night are caused by the spin motion of the earth about its own axis. Look at that. Greatness is there. But don't say they were great. You have to become great and take India to a higher level. That is what I request you. Next. Look at that. This is where Professor U.R. Rao began the Indian satellite program. Can you believe? This is the industrial shed. These are the industrial sheds of Peenya. Peenya is an industrial estate which is in Bangalore now, at that time outside Bangalore in 1972. Here is the place where Aryabhatta was built. Next. Look at that. That is Aryabhatta. Aryabhatta, the satellite. It weighed only 358 kilograms and generated only 47 watts of power, electrical power. Next. What a bizarre picture it is. Look at that. A satellite being taken on a bullock cart. Is it a joke, practical joke or anything like that? No. At that time, there were no facilities to test the spacecraft, the satellite, Apple satellite, in a particular way, for a particular test. That is why they took it on a bullock cart. Today, my dear students, you should know, you take all the ingredients, okay, all the ingredients essential for building a satellite. There is a huge building near Marathahalli in Bangalore. Take it inside, at least there is space for building 8 to 10 satellites at the same time you can build. Such a big clean room is there, okay? And after that, one after the other, you can subject it to tests and directly take it to the launch center. This is where India is today. Okay? How many countries have these kind of things? Only a handful of them. That's all. Be proud, your country is one of them. Okay? How many countries have these kind of facilities? USA, Russia, China, Japan, France, okay? And India to a certain extent. Some European countries have this, that, and all those things. They are all part of the European space program, not entirely in a country, other than these 6 countries. Next. Look at that. This is what I told you about the infrastructure. Look at the people who have built this satellite. This satellite is called as AstroSat. You know about Hubble Space Telescope, you know about James Webb Space Telescope of NASA. But do you know our country has a satellite which has 4 different types of eyes, which is working for the past 10 years? Yes, we don't know. Look at the people who are building that satellite. Do you think they are scientists building the satellites or surgeons wearing a scalpel in the operation theater? That is the cleanliness which is required for building such a satellite. Next. Look at that. Having done a lot in the domain of artificial satellites, India has built communication satellites, weather monitoring satellites, that is meteorological satellites, earth observation satellites taking crystal clear pictures of the earth, navigation satellites, scientific satellites. And today, satellites are the backbone of India's economic infrastructure and even the comprehensive security. Okay? So they provide all these things. Without satellites, what kind of chaos you have today, it is unimaginable. Satellites have become an integral part of our life. But having done a lot in this domain, India set its sight on the nearest heavenly body to us, the moon. Moon is hardly about less than 4 lakh kilometers away, 3,84,000 kilometers away. Okay? So, India built and launched Chandrayaan 1 in 2008. Even I was thinking at the time, what do we do by launching Chandrayaan 1? Because 12 people had already walked on the moon, American astronauts, Apollo astronauts. Then, dozens of spacecraft had gone towards the moon. What a tiny Indian spacecraft will do. But it was for the tiny Indian spacecraft to discover that water is there on the moon conclusively. Don't get confused. Water is there on the moon means not seas, not oceans, and not like that. Small amount of water or small quantities of water are found attached to the lunar soil. But it is very significant, top layer of the lunar soil. So, anyway, Chandrayaan was launched on October 22nd, 2008. While it was orbiting the moon, this top part, a box kind of thing, got separated from it and hit the surface of the moon. And India became the 4th country to reach lunar surface. Not land, reach. That's all. Next. Then it discovered water on the moon. Look at that. This is a British newspaper, not ours. We are not trumpeting our. Now namde tuturi uttalla. Britishers, once upon a time they were supposed to be ruling us. They have told what India has done. Next. Mars. Look at that. See, we launched a spacecraft called Mars Orbiter Mission Spacecraft or Mars Orbiter Spacecraft, and popularly it is known as Mangalyaan. It was launched on November 5th, 2013, and in the following 10 months, it traveled 67 crore kilometers. 67 crore kilometers. 667 million kilometers. Then on September 24th, 2014, can you space bar? No. Look at that. It is approaching Mars. Then it approached Mars, having traveled for nearly 67 crore kilometers. When it was near Mars, look at that, what it did. See, this is the spacecraft, and it fired its engine and went into an orbit around Mars. Okay, look at that. And India became the first Asian country to reach Mars successfully. And later it became the first country to score 100% success in its very maiden attempt to explore Mars. How many countries have done? Next. Look at that. National Geographic, all of you know what a famous thing it is all over the world. I was working in the public relations of ISRO at that time. In 2016, we got a request from National Geographic. We are publishing an article on Mars, not on Indian space program, on Mars. Will you provide us one picture, good picture of Mars taken by your spacecraft? We'll give credit. We sent it. I still remember having sent. Then, when the November 2016 issue of National Geographic, when it came, I held it in my hand. My hand started trembling. I started crying, really. Look at that. The picture of Mars, which is printed there, is taken by your spacecraft, Indian spacecraft. You go inside. This is the picture of Mars taken from a height of 70,000 kilometers, courtesy Indian Space Research Organization. They have printed. What else you want? So this is the thing. Next. Of course, in Chandrayaan 1, we orbited the moon, took pictures, discovered water on the moon, etc. Then we thought, India thought it would make an attempt to gently land on the surface of the moon using Chandrayaan 2. But we were almost successful when we were less than a kilometer from the lunar soil. The landing attempt could not be accomplished. So what? Many people thought everything is gone. No. Other part of Chandrayaan 2 is circling the moon even today, and it has taken crystal clear pictures of the moon. In that, you can see features as small as less than 50 centimeters. How many countries have this kind of thing? Even today, even at this moment of time, it is taking pictures. And not only as other countries have also used it. Next. Look at that. This is the picture taken by Chandrayaan 2. Next. Next. Yeah. Chandrayaan 3 was launched on July 14th, 2023. Look at the LVM-3 rocket again. So this is the one, and look at that, how it can go up. And this rocket, as I told you, see, it is not child's play. It is not Deepavali rocket kind of thing. It is different. Okay, look at that. Even an inch this way, that way will cause disaster. So that is the rocket which is going up. Look at that, how beautifully it is going. Those two candlesticks kind of rockets which are firing, they eat the propellant, that is fuel and oxidizer, at such a high rate. I call them bakasuras. Okay? That is the kind of prodigal rate at which they consume the propellant. Within 2 minutes, 20 seconds, 4,14,000 kilograms of propellant will be washed out by both of them. Okay? Next. Of course, this is the way we went towards the moon first. Chandrayaan 3 was put into an orbit around the Earth. Then it was sent towards the moon. Next. Next. Space bar. Look at that. This is the way Chandrayaan 3 landed in the south polar region of the moon. After that, look at that, what happened. There was a rover inside that called Pragyan. Pragyan means wisdom. Okay? Chandrayaan 3 lander is called as Vikram, named after Vikram Sarabhai. Of course, look at that, the way in which the rover is coming out. You may say, hey, all these things, Leo tie sets also, it is there. Not like that. In space, it is not easy to make it to work. Okay, look at that, it is coming down. This is an animation. Shortly, you will see the real picture, how it went down. Real picture. Now, this is animation, of course, how it is coming down. And that car has traveled 100 meters on the surface of the moon, not on the surface of the earth. Okay, look at that. Real picture will come now. Yeah, you see how from the belly of that lander it came down. You can see. Very quickly we will go from now onwards. See, it is going down. This is the real picture as seen by the camera on Vikram. See, Pragyan has gone. See the sharp image, sharp shadow of Pragyan on the surface of the moon. Can you imagine why it is like that? Okay. See how it is going down. Yes, next. This is the picture of the century. This is the picture of Vikram taken by Pragyan. What else you want as proof that we have landed on this in the south polar region of the moon? Yes, this is the thing. Next. Look at that, how people are patriotically reacting like anything. In fact, in Planetarium, Bangalore, Jawaharlal Nehru Planetarium, when I was giving commentary in English and Kannada, people, including police constables, they became very, very emotional, in fact. Okay? Because I was telling them in Kannada. Next. Okay, so much so about the Indian space program, Moon, Mars, and though it is not telling here, we have launched a spacecraft not towards the sun. We have launched a spacecraft to study the sun for 24 hours a day. How do we do it? If you are very near to Earth, Earth shadow will be there. If you are elsewhere, it is not easy for you to look at the sun continuously. At the same time, send the information also continuously. It is not possible. Okay? That is why we have launched the spacecraft called Aditya L1, into a place which is about 1.5 million kilometers or 15 lakh kilometers from the earth in the direction of the sun. Believe me, even at this moment of time, it is taking a look at the sun like this 24 hours a day. Aditya L1. Aditya is another name for Surya, sun. Aditya Hrudaya is there, Anyway, morning many people will chant, that kind of thing. So, I have come back. Anyway, Dr. Prahalad sir has come and all others have come. Anyway, I am also coming to my end of my presentation. In the beginning itself, I told you about a date. Do you remember me, this sounding rocket launch? Okay. You have you have audio also, audio jack ಇಲ್ಲಿಯಾ? ಹಾಂ, ಇಲ್ಲಿ ಹಾಕಿ ನೋಡಿ, ಲೆಫ್ಟಲ್ಲಿದೆ ನೋಡಿ, ಅಲ್ಲಲ್ಲ, ಹಾಂ, ಓಕೆ, ಬರುತ್ತಾ? ಒಂದು ನಿಮಿಷ. ಓಕೆ, this was the launch of a sounding rocket on November 21st, 1963 from Tumba, which signified the formal beginning of the Indian space program. ನವಂಬರ್ 21, 1963 ಸಂಜೆ 6:25 ಈ ಸೌಂಡಿಂಗ್ ರಾಕೆಟ್ನ ಉಡಾವಣೆಯೊಂದಿಗೆ ಭಾರತದ ಅಂತರಿಕ್ಷ ಕಾರ್ಯಕ್ರಮ ವಿದ್ಯುಕ್ತವಾಗಿ ಪ್ರಾರಂಭವಾಯಿತು. ಡೇಟ್ ನವಂಬರ್ 21st, 1963. ನಮ್ಮ ಟಿ ವಿ ಸೀರಿಯಲ್ಸ್ ಥರ ಫಾಸ್ಟ್ ಫಾರ್ವರ್ಡ್ ಮಾಡೋಣ. ಟಿ ವಿ ಸೀರಿಯಲ್ಸ್ ಆದರೆ ಏನೋ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಮುಖ ತಿರುಗ್ಸೋಕ್ಕೆ 25 ನಿಮಿಷ ತೊಗೋಬೋದು, ಆದರೆ ಅಷ್ಟೊಂದು ಇದಿಲ್ಲ. ಇಲ್ಲಿ ನಾವು ಸುಮಾರು 50 ವರ್ಷಗಳ ಮುಂದೆ ಹೋಗೋಣ. ಅಂದರೆ 2017 ಫೆಬ್ರವರಿ 15ನೇ ತಾರೀಕು ಈ ನವಂಬರ್ 21st, 1963 ಸೌಂಡಿಂಗ್ ರಾಕೆಟ್ನ ಕೊಟ್ಟಿದ್ದು ಯಾರು ನಮಗೆ? ನಾಸಾ, ಅಮೆರಿಕದವರು. ಅದರಲ್ಲಿ ಇದ್ದಿದ್ದು ವೈಜ್ಞಾನಿಕ ಉಪಕರಣ, ದ ಸೈಂಟಿಫಿಕ್ ಪೇಲೋಡ್ ವಾಸ್ ಫ್ರಮ್ ಫ್ರಾನ್ಸ್. ದ ಪೀಪಲ್ ವಿ ಓನ್ಲಿ ನ್ಯೂ ಹೌ ಟು ಲಾಂಚ್. ಫಾಸ್ಟ್ ಫಾರ್ವರ್ಡ್ ಟು ಫೆಬ್ರವರಿ 15, 2017. ನೆಕ್ಸ್ಟ್, ಸ್ಪೇಸ್ ಬಾರ್ ಮಾಡಿ ನೋಡಿ. ಇಲ್ಲಿ ನಾವು ಹಾಕಿಲ್ಲ, ಇದು ಯಾರು ಹಾಕಿದ್ರು? ಇದು ಬರ್ತಾ ಇದೆಯಾ? ಬರ್ತಾ ಇಲ್ಲ. ನೋಡಿ, ಇದು ಅವತ್ತಿನ ದಿವಸ 15 ಮಹಡಿಗಳಷ್ಟು ಎತ್ತರ ಇದ್ದ ಒಂದು ರಾಕೆಟು ಶ್ರೀಹರಿಕೋಟಾದಲ್ಲಿ ನಿಂತಿತ್ತು, ಇಂಡಿಯಾದಾದರೆ. ಅದರಲ್ಲಿ ಇದ್ದಿದ್ದು 104 ಉಪಗ್ರಹಗಳು, 104 ಸ್ಯಾಟಲೈಟ್ಸ್. ದಟ್ ವಾಸ್ ದ ಲಾಂಚ್ ಆಫ್ PSLV. Look at the people who started dancing after the launch. They were Americans. They were Americans because this company's 88 satellites from their company was being carried by our launcher. Look at that, the way in which it is going. Look at the way in which they are clapping. Look at the way it is going. Then they are all working for those satellites. And ನೋಡಿ, 104 ಸ್ಯಾಟಲೈಟಲ್ಲಿ ಒಂದು ಸ್ಯಾಟಲೈಟ್ಗೂ ಏನು ತೊಂದರೆ ಆಗ್ದಂಗೆ ಒಂದೇ ಲಾಂಚಲ್ಲಿ 104 ಸ್ಯಾಟಲೈಟ್ ಲಾಂಚ್ ಮಾಡಿದ್ವಿ. ದಟ್ ವಾಸ್ ಎ ವರ್ಲ್ಡ್ ರೆಕಾರ್ಡ್ ಅಟ್ ದಟ್ ಟೈಮ್. ಯು ಕ್ಯಾನ್ ಸಿ, ಈ ಹುಡುಗರು, ಚಿಕ್ಕ ಹುಡುಗರು ಮಾವಿನ ತೋಟದ ಹತ್ರ ಹೋಗ್ತಾ ಮಾವಿನಕಾಯಿ ಕಲ್ಲು ಹೊಡಿತಾರಲ್ಲ, ಆ ರೀತಿ ಒಂದೊಂದೇ ಎಸಿತಾ ಇದೆ ನೋಡಿ ಅಲ್ಲಿ. ಇವಾಗ ನಾವು ಯು ಸಿ ರಾಕೆಟು ನೋಡಿ, ಇದೆಲ್ಲ ಈ ಥರ ಪಿಕ್ಚರ್ಸ್ ತೆಗೆಯೋ ಸಾಮರ್ಥ್ಯ ಇರುವಂತಹ, ಚಿತ್ರಗಳನ್ನು ತೆಗೆಯುವಂತಹ ಸಾಮರ್ಥ್ಯ ಇರುವಂತಹ ಉಪಗ್ರಹಗಳು ಇದು 88. ಈ ಕಂಪ್ನಿದು 88ನೂ ಲಾಂಚ್ ಮಾಡ್ತು PSLV. ಅದಲ್ಲದೆ ಇನ್ನೂ 16 ಸ್ಯಾಟಲೈಟ್ ನೋಡಿ ಹೆಂಗೆ ಎಸಿತಾ ಇದೆ ತೆಗೆದು ಲಾಂಚರ್ PSLV. ಒಂದಾದ್ಮೇಲೆ ಒಂದು ಎಸಿತಾ ಇದೆ. ಏನೂ ಆಗಲಿಲ್ಲ ಯಾವ ಸ್ಯಾಟಲೈಟ್ಗೂ. ನೋಡಿ ಹೆಂಗೆ ಹೋಗ್ತಾ ಇದೆ. 104 ಉಪಗ್ರಹಗಳಲ್ಲಿ 88. ನೋಡಿ 88 ಎಲ್ಲರೂ ಕ್ಲಾಪ್ಸ್ ಹೆಂಗೆ ಹೊಡಿತಾ ಇದ್ದಾರೆ ನೋಡಿ. ಇವತ್ತು ಇಂಡಿಯಾ ಎಲ್ಲಿದೆ, ಭಾರತ ಎಷ್ಟರ ಮಟ್ಟಿಗೆ ಬಂದಿದೆ. ನವಂಬರ್ 21, 1963ರಿಂದ ಫೆಬ್ರವರಿ 15, 2017ರವರೆಗೆ ಭಾರತ ಎಷ್ಟು ಬೆಳೆದಿದೆ, ಎಷ್ಟು ಮುಂದುವರೆದಿದೆ ಅನ್ನೋದಕ್ಕೆ ಈ ಒಂದು ಘಟನೆ ಅತ್ಯಂತ ಪರಿಣಾಮಕಾರಿಯಾದದ್ದು ನೋಡಿ. ಹೀಗಾಗಿ ಇವರು ಅಷ್ಟೇ. ಇವಾಗ ಕ್ಲೋಸ್ ಮಾಡಿಬಿಡಿ ಇದನ್ನು, ತೆಗೆದುಬಿಡಿ, ಅದು ತೆಗೀರಿ. ನೆಕ್ಸ್ಟ್, ಓಕೆ, ಗಗನಯಾನ ಅನ್ನುವಂಥ ಮತ್ತೊಂದು ಪ್ರೋಗ್ರಾಮ್ನ ಹಾಕ್ಕೊಂಡಿದ್ದೀವಿ ನಾವು. ಅಂದರೆ ಮಾನವ ಸಹಿತ ಅಂತರಿಕ್ಷ. ಅಂದರೆ ಟಿಲ್ ನಾವು ವಿ ಹ್ಯಾವ್ ಎಕ್ಸ್ಪ್ಲೋರ್ಡ್ ಸ್ಪೇಸ್ ವಿತ್ ಹೆಲ್ಪ್ ಆಫ್ ಸ್ಯಾಟಲೈಟ್ಸ್ ಆ್ಯಂಡ್ robotic spacecraft. Now Gaganyaan is the one which adds a new dimension to the Indian space program. Quickly, next one please. Okay, that is Shubhanshu Shukla, who went to space. We invited him to Jawaharlal Nehru Planetarium. There was a huge success and fantastic program it was. I'll share the videos. Next one. Look at that. India has the ambition, let me tell you, I'm not telling on behalf of anybody what I have read in newspapers and other things. Ambition to send our astronauts to moon by 2040 and to have a sustainable presence there by 2047. This is what the government has said. Okay, that has been published through various news channels. I am not telling on my own anything, but this is the aspiration of India. But that aspiration has to make it fulfill, you people have to work. Okay? Next one. So thank you very much. And before that, okay, India has explored the moon by discovering water on the moon in a pioneering way and taking crystal clear pictures of the moon through Chandrayaan 2 and making a pioneering landing in the South Polar region. Nobody else had done there, okay, in Chandrayaan 3, and became the first Asian country to reach Mars through Mars Orbiter mission and studying the sun continuously for more than 2 years through Aditya L1. Okay, having listened to me in the past 45-50 minutes, don't you feel proud about India or not? Proud about Bharat or not? Yes or no? I don't, all of you have not taken lunch? Are you proud of your country, great country called India or not? Yes or no? Yes. Okay, then why don't you give a big hand to a great country called India? That's all. Thank you very much. Thank you. Not only that, not only clapping, you have to study science, do maths, not study maths, do maths very well. And keep a little bit of your time and other resources for your country. A little bit, not 24 hours a day, a little bit of time. If you can do something on your own, within your limits, that is good for the country. We are more than 140 crores. So, good luck to all of you. Thank you once again. Bye. Close madbudi. Now, once again, I thank Professor A.P. Bhatt, Professor Manjunath, and Professor Ramu, and all others who have been responsible for this. And now I think we will have interactive session, and Dr. Prahlad sir also has come, and all others have come. Thank you very much. If you have any questions, no problem, you can ask later also. Okay, thank you. My pleasure. Thank you, sir. So, a laptop ಕೊಟ್ಬಿಡಿ. ಅಲ್ಲ ಕ್ಲೋಸ್ ಮಾಡಿಬಿಡಿ. ಅಲ್ಲ ಅದೇನು ಪರವಾಗಿಲ್ಲ, ನೀವು ಅಲ್ಲ ಕ್ಲೋಸ್ ಮಾಡಿಬಿಡಿ ಲ್ಯಾಪ್ಟಾಪು ಅಷ್ಟೇ. ದಟ್ ಈಸ್ ಓಕೆ. ಅದರದ್ದು ಪವರ್ ಇದಲ್ಲಿದೆ ಕಾರ್ಡ್, ಆಮೇಲೆ ಅದಿಲ್ದಿದ್ರೆ ಕಷ್ಟ. ಓಕೆ, ಇಫ್ ಯು ಹ್ಯಾವ್ ಎನಿ ಕ್ವಶನ್ಸ್ ನೆಕ್ಸ್ಟ್ 2-3 minutes, or maybe we will have questions in the formal interactive. Sir, ಕೊಡಿ ಸರ್, ನಾನು ಇಡ್ತೀನಿ. Lot of junk is there inside, so it is not easy to put there. Thank you.
The sky is not the limit is your vision. I profusely thank Dr. B.R. Guruprasad for enlightening our students by your extensive knowledge. I thank Dr. A.P. Bhatt sir for organizing such a wonderful program on science. May our students one day reach us, ISRO and NASA. I thank Dr. Ramu L. sir for supporting and organizing this program. Thank you one and all.
Can be called as a national scientific mission, exploratory mission dedicated to study the sun. After it safely reaches orbit, Aditya's orbit will be made to increase its most distant point.
Now. -4, 3, 2, 1. Now. Taken up.
And now, going past the saluting base, presenting a formidable combination of a long-range precision and overwhelming firepower, the Suryastra and the BrahMos weapon system. Lieutenant Mehak Bhati is leading the Suryastra Universal Rocket Launcher System. And following the Suryastra, the BrahMos weapon system led by Captain Animesh Rohela of the 344 Missile Regiment.
Rolling past the saluting days are two formidable pillars of India's air defense architecture, the Akash weapon system and the medium-range surface-to-air missile MR-SAM. The Akash weapon system led today by Captain Aniket Ocha of 128 Air Defense Missile Regiment. Following the Akash is MR-SAM, also known as Abhr weapon system, led today by Captain Tanik Sharma of 501 Air Defense Missile Regiment. The motto of the regiment, Agratah Abhr, Vijay Sarvatra. Ever ahead, victory everywhere.
See, when the project was sanctioned by Government of India with Dr. Kalam, he appointed me as the project director. So I had to build a team, project team.
ಚಂದ್ರಯಾನ 2 ಚಂದ್ರನ ಮೇಲೆ ಇಳಿಲಿಲ್ಲ, ಎಲ್ಲ ಹೋಯ್ತು ಅಂತ. ಇಲ್ಲ, ಇವತ್ತು ಕೂಡ ಒಂದು ಭಾಗ ಚಂದ್ರಯಾನ 2 ಸುತ್ತಾ ಇದೆ ಚಂದ್ರನ್. ಯಾವುದೇ ಉಪಗ್ರಹ ಆ ಎತ್ತರದಲ್ಲಿದ್ರೆ ಅಷ್ಟು ವರ್ಷ ಇರುತ್ತೆ ಬರುತ್ತೆ. ಭಾರತೀಯ ಅಂತರಿಕ್ಷ ಕಾರ್ಯಕ್ರಮದ ಒಂದು ಮೂಲ ಮಂತ್ರ ಅಂದ್ರೆ ವೈಫಲ್ಯ ಯಶಸ್ಸಿನ ಮೆಟ್ಟಿಲು.
Good afternoon, everyone. Shortly, Swami Ji will be arriving to this occasion. So we will be starting the program shortly.
Inside its nose cone, it carries a powerful warhead. The moment it receives a target, gas pressure launches it 15 meters into the air. Then, a top-mounted thruster quickly turns it 90 degrees midair, pushing it forward at incredible speed. Once the booster separates, the missile switches to its liquid ramjet engine, flying at nearly 3,000 kilometers per hour. At around 50 kilometers from the target, BrahMos locks in with deadly precision, and within seconds, it strikes.
To mention that all the distinguished scientists arrived, and in another 2-3 minutes, we'll be expecting our Poornaprajna Tirtha Swami Ji. Dear students, it's a special occasion for everyone. We have respected scientists who have done extraordinary work in the field of science and technology. And from morning we are witnessing that the scientists came from different parts of Karnataka, presented the work which they have done for the development of our country, for the development of our society. They have sacrificed their life. Whatever the work they have done, it is not for a short period. It is their time from their childhood till their retirement. They are sacrificed their life for the sake of our nation. You have to keep it in mind that scientists who are working at the back end, inside the laboratory, they are doing work, sacrificing their personal life. The scientists who are sitting in front of us for more than 30-40 years, they worked hard to bring out a missiles which is protecting our nation from the neighboring countries. Even though we have friendly neighboring countries, we too have our enemies. To protect the nation, it is important to develop the missiles like Agni, the missiles like Prithvi, the missiles like BrahMos, the missiles like Akash, which our Padmashri Praglad Ramarao sir has architected. In short period, we are going to witness the work, extraordinary work done by our Padmashri Dr. Praglad Ramarao sir, Dr. Guru Prasad sir, Dr. Vinayak sir. They have sacrificed their life. We are sitting peacefully today. It is all because of our scientists. Politicians, they are doing their part. But as a scientist, it is the duty of us to develop different equipment, different weapons which need to donated to or which need to given to the army, so that the army people will going to protect our nation from the neighboring countries and from the... Today we are witnessing what is happening in the Arab countries and what is happening in the Ukraine and Russian war. This Ukraine and Russian war, Iran, America, Israel war, completely dominated by missiles, completely dominated by the unmanned drones. These are all the architect of our scientists who are sitting in front of us. Dear students, if you have questions, keep it ready. Once we have the inauguration function, you can ask question to our scientist. We are media people here. We are already invited several media people, and they are here, and they will be having some questions for the scientist. Hope that whatever the question you will be asking, you will going to get an answer from our scientist. As a principal, it's my duty to provide the hospitality for the scientists and also for the students for this program. We have done our part. Now it's a duty of the scientists to answer your queries. Already our Poornaprajna Swami Ji arrived, and we'll be starting the program in another 2-3 minutes. Before that, we will have a video presentation. Kindly watch it and wait for our Swami Ji. We will start the program as early as possible. Thank you.
I humbly request our respected principal, Dr. Ramu L. Sir, to kindly escort the esteemed dignitaries onto the stage. Somewhere, something incredible is waiting to be known by Carl Sagan. I seek the divine blessings of Lord Sri Krishna and Mukhya and with the blessings of His Holiness Sri Vibhudesha Tirtha Swami Ji, Founder President, and His Holiness Sri Vishwapriya Tirtha Swami Ji, former President, and in the divine presence of His Holiness Sri Ishapriya Tirtha Swami Ji, the present President of Udupi Sri Adamarmat Education Council, Bengaluru, I extend a warm welcome to you all to this session of Scientists Meet 2026, organized by Science Association, Poornaprajna College, Udupi, under the guidance of IQAC. To begin this session, let us invoke the blessings of the Almighty. I request Ms. Chinmay Rao of 2nd BSc and Ms. Niharika of 2nd BBA to kindly come forward and lead us in the prayer.
वन्दिता शेषवन्द्योरुवृन्दारकं चन्दनाचर्चितोद्धारपीनांसकम् इन्दिरा चञ्चलापाङ्गनीराजितं मन्दरोद्धारिवृतोद्भुजभोगिनं प्रीणयामो वासुदेवं देवतामण्डलाखण्डमण्डलं प्रीणयामो वासुदेवं सृष्टिसंहारलीलाविलासाततं पुष्टषड्गुण्यसद्विग्रहोल्लासिनं दुष्टनिःशेषसंहारकर्मोद्यतं हृष्टपुष्टानुतिष्ठप्रजासंश्रयं प्रीणयामो वासुदेवं देवतामण्डलाखण्डमण्डलं प्रीणयामो वासुदेवं प्रीणयामो वासुदेवं प्रीणयामो वासुदेवं त्वमेव माता च पिता त्वमेव बन्धुश्च सखा त्वमेव विद्या द्रविणं त्वमेव सर्वं मम देवदेव ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः.
Thank you for that soulful prayer, Ms. Chinmay and Ms. Niharika. A warm welcome is the universal language of kindness, with every moment offering a new opportunity to learn and grow. I now humbly invite our principal, Dr. Ramuyal sir, to deliver the welcome address.
Seeking the grace of Lord Krishna and Mukhya, seeking the blessings of His Holiness Sri Vibhudesha Tirtha Swami Ji, Founder President, Udupi Sri Adamarmat Education Council, seeking the blessings of Paramapujya Sri Vishwapriya Tirtha Swami Ji, former President, Udupi Sri Adamarmat Education Council, seeking the blessings of Paramapujya Ishapriya Tirtha Swami Ji, President, Adamarmat Education Council, respected Chief Guest, Padma Shri Dr. Prahlad Ram Rao, distinguished scientist, Dr. B.R. Guru Prasad sir, Professor Vidyadiraj N.S., and Dr. Vinay K., esteemed guest, Honorable Secretary, Udupi Sri Adamarmat Education Council, Dr. A.P. Bhatt, Honorable Secretary, Poornaprajna College Managing Committee, Dr. G.S. Chandrasekhar Sir, Honorable Director for Academics and Director for Poornaprajna Institute of Management, Dr. P.S. Aital Sir, respected Principal, Poornaprajna PU College, respected Principal, Poornaprajna Union College, respected formal principals of Poornaprajna College, media personnels, teaching and non-teaching staff of Poornaprajna Degree College and PU College, dear guests and my dear students, I welcome you for the special event which was arranged under the supervision of Dr. A.P. Bhatt Sir, the Scientist Meet 2026. It's a special occasion for everyone, not only for the students, it is also a special occasion for the science community and other faculty members who gathered here. We are deeply grateful for the divine presence of Paramapuja Sri Isha Priyatirtha Swami Ji, President and the guiding force for all of us. We are doing the work assigned for us. It is a divine work. We are into the education sector, and it's a duty of us to develop the students' community who can lead the country in future. As we all know, today we have a special guest, respectful scientist who have sacrificed his life for the sake of science and technology. He is none other than the Padma Shri Dr. Prahlad Ramarao Sir, an eminent aerospace engineer and former director of Defense Research Development Laboratory, which is a wing of Defense Research and Development Organization. In short form, it is called as DRDO, doing extraordinary work in protecting our nation from other countries. Sir is known for his contribution to the Indian space program. He was known as the architect of Akash surface-to-air missile system, which has range of 2.5 kilometer to 30 kilometer, and the DRDO is planning for increasing the range of Akash, which was designed by our Prahlad Ramarao Sir. The range will be going to extend it to 50 kilometers. The short-range missiles are very important for our country because we have very close enemies to our nation, which are the boundaries of our nation. So we want to protect. So short-range missiles are very, very important. And SAR is actively participated and architected the Akash surface-to-air missile system. I am also proud to mention here, he was worked along with APJ Abdul Kalam, our former president. His excellent APJ Abdul Kalam was called as a missile man of India, and today we can also call our architect of Akash surface-to-air missile system, Padma Shri Dr. Prahlad Ramarao as missile man of India, and he is still involving in all the activities of DRDO. His role in the integrated guided missile development program, contributing to the development of Agni missile, which has a range of 1,000 to 8,000 kilometers. And keep it in mind that Agni missile, which was considered as Agni 1, 1,000 kilometer to 2,000 kilometer range, Agni 2, Agni 3, Agni 4, and now we have Agni 5. In all these projects are involved. So we are very proud that he is from our Karnataka, and we are really honored to mention that Sir is also part of Prithvi, which is a short-range missile developed by our country, which has a range of 50 to 150 kilometers. NOG, which is a very important one. NOG is dedicated to our Indian Army, which has a range of 4 km, 5 km, and usually in tanks they will use these NOG missiles. And keep it in mind, sir is also part of the Russian-Indian project, which we call it as a BrahMos missile. And it is an intercontinental missile, and keep it in mind, this intercontinental missile can reach the other continent also. He is an extraordinary person. He has done his work for the nation, and it is the younger generation who should get the inspire from his work, and you should see that you should also be like our Padma Shri Prahlad Ramarao sir in future. Sir has also worked as a Vice Chancellor for the Defense Institute of Advanced Technology from 2011 to 2014. He has done a remarkable contribution for the science and technologies. Sir, we are really honored to have you today, and we also salute you for the work, whatever you have done. And with this brief introduction, I'll welcome you, sir. It's honored to have another great scientist who has not only worked in the field of astrophysics, astronomy, he was part of ISRO, and he worked as associate director for the ISRO, and he worked nearly 37 years in ISRO and done a lot of work involved in many projects of ISRO. He carried out 25 satellite missions. Not only is in the astrophysics field, not only in the space research, sir is also kind enough to address our students. He was covered many schools and colleges in Karnataka by motivating the younger generations. Sir has written 600 articles in English and Kannada, and he has written 13 textbooks related to astronomy and space science. He has written books not only in English, he has also written books in Kannada. So he is keen to motivate younger generation of rural India, rural Karnataka. Sir, we are really honored to have you today as a chief guest. On behalf of management, on behalf of the students community, on behalf of my faculty member, I extend my warm welcome to you, sir. Today we have with us Professor Vidyadiraj, NS, Professor Theoretical Science, Jawaharlal Nehru Center for Advanced Scientific Research, extraordinary physicist. He has done his PhD from Indian Institute of Science, postdoctorate from University of Oxford. Later he joined Jawaharlal Nehru Center for Advanced Science Research. He is doing a lot of experimental work and also theoretical work, but his theoretical work was recognized around the globe. He was widely recognized for his extensive research in the field of quantum many-body theory. He is focusing his research related to strongly correlated materials and quantum phase transition. Phase transitions are important area of physics where sir is contributing. And keep it in mind that he is also an experimentalist. Morning we have witnessed, he has conducted experiment on this dais and he has inspired many students. This we are doing not for the sake of just as a program. This we are doing to motivate, to encourage the younger generation to take up the science as a career. Sir, we are really honored to have you as a guest today. On behalf of everyone gathered here, I welcome you, sir. Dr. Vinayak K. Patar, Program and Multimedia Coordinator, Education Technology Unit, CNR Rao, All of Science, Jawaharlal Nehru Center for Advanced Scientific Research, Bengaluru. You know that low temperature physics is very, very important, not only in the ISRO, not only in the field of space science. Everywhere, low temperature work is very, very important. And keep it in mind, Sir is one who is doing low temperature work, and he is a person who is specialist in optoelectronics. He is specialist in nanotechnology, thin films. He is specialist in nano ferrites. He is specialist in nano sensors. He is also doing a lot of work related to advanced materials. He has published more than 45 international research papers, conducted more than 100 science outreach programs. With over 15 years of experience, he is also known for developing innovative hands-on learning models for the schools and colleges. And sir is very kind. When we approach him, he eagerly accepts our invitation, and today he is here. Sir, we are really honored to have you as a guest today, and we expect your support and cooperation for our college in future also. I also extend my warm welcome to Honorable Secretary Dr. A.P. Bhatt sir. This program is possible only because of our Honorary Secretary, who is the man behind this program. And keep it in mind, he is also a physicist. He is doing a lot of work related to astronomy and astrophysics. He is a well-known person in Karnataka. Whenever something happens in outer space, media will approach him, and he will be addressing the media whenever there is a solar eclipse, lunar eclipse, or any event. And keep it in mind that he is also encouraging the younger generation, and I am also motivated by the work what our A.P. Bhatt sir has done, and he has covered 1,000 schools to promote the astronomical work in and around Udupi. Sir, we are really honored to have you as a guest today, and you are the main motivator, and we expect your blessings and guidance in future also. It's my privilege to welcome respected Dr. G.S. Chandrasekhar sir, a person who is working for 24 hours, not only for taking care of patient, but also he is giving time for the institution development. And even at 12:30, I can able to meet him, and I'll get the suggestions from sir to organize programs and also to maintain the academic standards in the college. Sir, we are really honored to have you today, and we are blessed that we have a person like Dr. G.S. Chandrasekhar sir in the Poornaprajna College Managing Committee. Respected P.S. Aital sir, Director, PMI, Director, Academic and Development of Poornaprajna Group of Institution. You all know that he worked as a VC, Vice Chancellor for Srinivasa University. Now he is in our team, and he is the guiding force for all of us. And I expect sir's support in future also to conduct several programs like this to motivate our students. Sir, thank you very much for your presence. I thank all our management committee members. I thank Mr. Krishna sir. He is not here, but in his absence, I want to thank him. He is honorary treasurer. I want to thank Mr. Gopal Sabraya sir, honorary secretary, VDPU College, and he is a man always motivating everyone in the team. So I want to thank him personally, and I want to thank on behalf of everyone gathered here. And I want to welcome him also. He was here. He was along with our Prahlad Ramarao sir. I hope that he will be continuing his support for us. I want to thank all the media personnel who gathered here. I want to welcome them, and also I want to thank them because every program they will be here. So I welcome one and all gathered here. I want to welcome the students community, faculty members, guests, the public who are gathered here to witness this program. I welcome one and all. I welcome the photographer. I welcome the media personnel. I welcome the technical supporters. I welcome the students, volunteers. I welcome one and all, and thank you. Special welcome to Director, PPISR, Dr. Anand Kulal sir. He is here. Morning also he called me, and he told that in future, whenever you are organizing the program, consider our institution also, and I really thank you, sir, and I welcome you for this program. Thank you, sir.
Thank you, sir, for your gracious welcome address. We now come to a sacred moment of offering. I humbly request Dr. A.P. Bhatt, sir, Honorary Secretary of Udupi Shri Adamarmat Education Council, Bengaluru, and Dr. G.S. Chandrasekhar, sir, Honorary Secretary of Poornaprajna College Managing Committee, Udupi, to kindly offer the Phalapushpa Samarpane at the lotus feet of Paramapujya Shri Isha Priya Tirtha Swami Ji. Thank you, Dr. A.P. Bhatt, sir, and Dr. G.S. Chandrasekhar, sir, for that reverential offering. I request Dr. P.S. Aital, sir, Director, Poornaprajna Institute of Management, Udupi, and Academic Advisor, Poornaprajna Group of Institutions, to kindly offer a floral welcome to our esteemed guests. Thank you, sir, for that warm floral welcome. I now request our beloved principal, Dr. Ramuyal, sir, to kindly offer a floral welcome to Dr. P.S. Aital, sir. Thank you, sir. Dream is not what you see in sleep, but something that does not let you sleep. With this quote from Dr. APJ Abdul Kalam, sir, it is my privilege to invite our chief guest, Padma Shri Dr. Prahlad Ramarao, sir, to deliver the keynote address.
ನಮಸ್ಕಾರ. ಈಗ ಆಗಲೇ ತಡ ಆಗಿದೆ. ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಡಾಕ್ಟರ್ ಭಟ್ 20 ಕ್ವಶನ್ ಇದೆ ಪರ್ ಹೆಡ್, ಅಂದರೆ 100 ಕ್ವಶನ್ ಇದೆ ಸುಮಾರು. ಅದು ನಾನು ಏನು ಕೀ ನೋಟ್ ಏನಿಲ್ಲ. ಒಂದು ಮುಖ್ಯ ವಿಷಯ ಅಂದರೆ ಇಷ್ಟು ಜನ ವಿದ್ಯಾರ್ಥಿಗಳು ಮಧ್ಯಾಹ್ನ 3 ಗಂಟೆಗೆ ಇಲ್ಲಿ ಬಂದು ಕೂತ್ಕೊಂಡು, ಏನು ಡ್ಯಾನ್ಸ್ ಅಲ್ಲ, ಮೂವಿ ಅಲ್ಲ, ಏನೂ ಇಲ್ಲ, ಸೈನ್ಸ್ಗೆ ಕೂತಿರೋದೇ ಒಂಥರ ಮಿರಾಕಲ್. ಅದು ಮಾಡಿದ್ದಾರೆ ಡಾಕ್ಟರ್ ಭಟ್ ಅವ್ರದ್ದು ಮೂಲಕ ಆಗಿದೆ. ಅದನ್ನು ನಂಗೆ ತುಂಬ ಸಂತೋಷ. ನೀವೆಲ್ಲರೂ ಐ ವಿಲ್ ವೆರಿ ಹ್ಯಾಪಿ. ನಿಮ್ಮ ಕ್ವಶನ್ಸ್ ಏನು, ಅದಕ್ಕೇನು ಕ್ಲಾರಿಫಿಕೇಷನ್ ಕೊಡೋದು, ಮುಂದೆ ಯಾವ ರೀತಿ ನಾವು ದಾರಿ ನೋಡಬೇಕು ಅದು ನೋಡೋದಕ್ಕೆ ನಾನು ಹೇಳ್ತೀನಿ. ನೋ ಕೀನೋಟ್ ಅಡ್ರೆಸ್, ಓನ್ಲಿ ಮೈ ಹ್ಯಾಪಿನೆಸ್ ದಟ್ ಆಲ್ ಆಫ್ ಯು ಆರ್ ಸೋ ಎನ್ಕರೇಜ್. ಅದು ಅಲ್ಲದೆ ಬೆಳಗ್ಗೆ ಎಕ್ಸಿಬಿಷನ್ ನೋಡಿದೆ, ಇಟ್ ಈಸ್ ಎ ರೆವಲ್ಯೂಷನ್. ಎಷ್ಟು ಒಳ್ಳೊಳ್ಳೆ ಎಕ್ಸಿಬಿಷನ್ ಇಟ್ಟಿದ್ದೀರಿ ಅನ್ನೋದು ತುಂಬ ಸಂತೋಷ ಆಯಿತು. ಸೊ ಲೆಟ್ ಅಸ್ ಸಿ ದಿಸ್ ಗ್ರೂಪ್ ಕಂಟಿನ್ಯೂ ಟು ಗ್ರೋ and contribute to Indian society, our Bharat Varsha, it will contribute. Namaskara.
Thank you, sir. Now we move into the most engaging segment of today's program, interaction with students. I request all students to actively participate and make the most of this valuable opportunity.
I am Vandana from 3rd BSc. My question is for Dr. Prahlad Rao, sir.
Your good name, please.
I am Vandana from 3rd BSc. My question is for Dr. Prahlad Rao, sir. It gives us goosebumps just by knowing the fact that you have worked with
ಕೇಳ್ತಿಲ್ಲ. ಇಲ್ಲಿ ಬನ್ನಿ.
Be slow and clear.
ಅದು ಬಾಗಿಲು ಹಾಕಿಸ್ಬಿಡ್ತೀರಾ ಆ ಕಡೆ? ಅಲ್ಲ, ಆ ಬಾಗಿಲು. ಹಾಂ, ಆ ಬಾಗಿಲು ಹಾಕ್ಬಿಡಿ. ಸೌಂಡ್ ಹಾಂ ಇದು ಬೆಟರ್.
It gives us goosebumps just by knowing the fact that you have worked with Dr. APJ Abdul Kalam, sir. How was your experience working with him? How did he inspire you throughout the journey?
How did he inspire you?
ಇನ್ಸ್ಪೈರ್ ಬೈ ಅಬ್ದುಲ್ ಕಲಾಂ. ಓಕೆ, ಅದಕ್ಕೆ ಏನು ಹೇಳ್ತಾರೆ, ವಾಕ್ ದಿ ಟಾಕ್ ಅಂತ ಕೇಳಿದ್ಯಾ? ವಾಕ್ ದಿ ಟಾಕ್ ಅಂತ. ಕಲಾಂ ವಾಸ್ ವಾಕ್ ದಿ ಟಾಕ್. ಅಂದರೆ ನಿನಗೆ ಬರೀ ಭಾಷಣ ಹೇಳೋಲ್ಲ, ಯಾವ ರೀತಿ ಮಾಡಬೇಕು ಅಂತ ಅವರೇ ಮುಂದೆ ಮಾಡಿ ತೋರಿಸ್ತಾರೆ. ಆದ್ದರಿಂದ ನಿಮ್ಗೆ ಗೊತ್ತು ಇವರು ಇದೇ ಮಾಡ್ತಾರೆ ಅಂದ್ಬಿಟ್ಟು. ಅವ್ರು ಯಾವ ರೀತಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದ್ದಾರೆ, ಯಾವ ರೀತಿ ಸಕ್ಸಸ್ ಮಾಡಿದ್ದಾರೆ. ಆ ಚಿಕ್ಕ ಫಸ್ಟ್ ರಾಕೆಟ್ ಲಾಂಚಿಂದ ಅವರಿದ್ದರು, ಫಸ್ಟ್ ರಾಕೆಟ್ ಲಾಂಚಿಂದ ಆವಾಗಿಂದ ಮಾಡಿದ್ರಿಂದ ನೀವು ಒಂದು ಸಲ ಅವ್ರ ಹತ್ರ ಮಾತಾಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ ಅವ್ರು ನಿಜವಾಗೂ ಕೆಲಸ ಮಾಡಿ ಕಲ್ತ್ಕೊಂಡು ಸಕ್ಸಸ್ ತಂದಿದ್ದಾರೆ ಅಂತ. ಆ ರೀತಿ ಬರುತ್ತೆ. ಆವಾಗ ಆಟೋಮೆಟಿಕ್ಲಿ ಯು ಗೆಟ್ ಎಕ್ಸ್ಪೈರ್ಡ್. ಇದು ಒಂದು. ಇನ್ನೊಂದು, ಅವರು ಯಾವ ರೀತಿ ಕಮಿಟ್ಮೆಂಟ್ ಇದೆ ಅಂದರೆ, ಇವಾಗ ಒಂದೇನೋ ಕೆಲಸ ಮಾಡ್ತಾಯಿರ್ತೀವಿ ನಾವು, ರಾತ್ರಿ 8 ಗಂಟೆ ಆಗುತ್ತೆ, ಮನೆಗೆ ಹೋಗಿರಲ್ಲ, ಏನೋ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ತಾಯಿರ್ತೀವಿ. ಅವ್ರಿಗೆ ಗೊತ್ತಾಯಿತು ಅಂದರೆ ಬಂದುಬಿಡ್ತಾರೆ. 1 ಗಂಟೆಗೆ ನಾವು ಇಲ್ಲಿ ಲ್ಯಾಬ್ ಬಂದ್ಬಿಟ್ಟು ಕೂತ್ಕೊಳ್ತಾರೆ. ನೀನೇನೋ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ತಾಯಿದ್ದೀನಿ ಅಂತ ನಾನು ನೋಡ್ತೀನಿ, ಅದು ರಿಸಲ್ಟ್ ಹೇಳು, ನೀನು ಹೆಂಗೆ ಮಾಡಿದೆ ಹೇಳು ಅಂತ ಕೂತ್ಕೋತಾರೆ. ದ್ಯಾಟ್ ಈಸ್ ಇನ್ಸ್ಪೈರಿಂಗ್. ಇಟ್ ಡಿಡ್ ನಾಟ್ ಗಿವ್ ಎನಿ ಸೊಲ್ಯೂಷನ್. ಸೊ ಅದಕ್ಕೆ ವಾಕ್ ದ ಟಾಕ್ ಅಂತಾರೆ. ಹಿ ವಾಸ್ ರಿಯಲಿ ಪರ್ಸನ್. ಅದು ಲೀಡರ್ಶಿಪ್ ಕ್ವಾಲಿಟೀಸ್ ತುಂಬ ಚೆನ್ನಾಗಿ. ಅವ್ರು ತುಂಬ ಕಥೆಗಳಿದೆ, ಒಂದು ದಿವಸ ಪೂರ್ತಿ ಅವ್ರ ಹತ್ರ ಮಾತಾಡ್ಬೋದು. ಅವರು ಎಲ್ಲ ಅದೇ ರೀತಿ ಮಾಡಿ ನಮಗೆಲ್ಲ ಮುಂದೆ ಏನೇ ತಪ್ಪು ಮಾಡಿದ್ರು ಅವ್ರು ಯಾವತ್ತೂ ಅದು ನೆಗೆಟಿವಾಗಿ ತೊಗೊಳ್ತಿರಲ್ಲ. ತಪ್ಪು ಮಾಡಿದ್ಯಾ, ಓಕೆ, ಫೈಂಡ್ ಔಟ್ ವೈ, ಹೌ, ಟೆಲ್ ಮಿ ಹೌ ಆರ್ ಯು ಗೋನ್ ಟು ಸಾಲ್ವ್. ಡೋಂಟ್ ಸೇ ಯು ಆರ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸ್ಟುಪಿಡ್ ಮಿಸ್ಟೇಕ್. ನೆವರ್ ಗೊತ್ತಾಯ್ತಾ? ಏನೇ ತಪ್ಪು ಮಾಡಿದ್ರು ಯಾಕೆ ಮಾಡಿದ್ವಿ ಕಂಡುಕೊಂಡು ಮುಂದಿನ ಸಲ ಕರೆಕ್ಟ್ ಮಾಡು. ನೀನು ತಪ್ಪು ಮಾಡಿದ್ದೀನಿ ಅಂತ ನಾನು ಯಾರು ಬೈಯಲ್ಲ. ನಾನು ಎಷ್ಟೋ ಮಿಸ್ಟೇಕ್ ಮಾಡಿದ್ದೀನಿ, ಎಷ್ಟೋ ತಪ್ಪು ಮಾಡಿದ್ದೀನಿ ನನ್ನ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ಲಿ. ಆದ್ದರಿಂದ ನಂಗೆ ಗೊತ್ತು. ಆ ರೀತಿ ಮಾಡ್ಕೊಂಡ್ರೆ ನಮಗೆ ಫುಲ್ಲಿ ಇನ್ಸ್ಪೈರಿಂಗ್ ಪರ್ಸನ್. ಓಕೆ,
ವೇದಿಕೆಯಲ್ಲಿ ಹೇಳಿದಾರಲ್ಲ, ಕೊನೆಗೆ ಅವರು ನಿಮ್ಮನ್ನು ಏನು ಕೇಳಿದರು ಅಂತ ಅದನ್ನು ಹೇಳಿ ಸರ್.
ಅದು ಇವರು ಬೆಳಗ್ಗೆ ಕತೆ ಹೇಳ್ತಾ ಇದ್ದೆ. ಏನಾಯಿತು, ಅವರು ನನ್ನ ಡೈರೆಕ್ಟರ್ ಆಗಿದ್ದರು. ನಾನು ಪ್ರಾಜೆಕ್ಟ್ ಆಕಾಶ್ ಮಾಡ್ತಾಯಿದ್ದೆ. ಆಮೇಲೆ ಅವರು ಇದು ಏನೋ ಒಂದು ಟಾರ್ಪೆಡೋ ಅದಕ್ಕೆ ಮಾಡು ಅಂದರು. ಆಮೇಲೆ ಅಗ್ನಿ ಲಾಂಚಿಗೆ ಹೋಗು ಅಂದರು, ಪೃಥ್ವಿಗೆ ಹೋಗು ಅಂದರು, ಎಲ್ಲ ಹೇಳ್ತಾಯಿದ್ರು. ಆಮೇಲೆ ಅವ್ರ ಪೊಸಿಷನ್ನು ಚೇರ್ಮನ್ ಮಿಸೈಲ್ ಪ್ರೋಗ್ರಾಮ್, IGMDP ಚೇರ್ಮನ್. ಅವರು ಅಲ್ಲಿಂದ ಬೆಂಗಳೂರು, ಹೈದರಾಬಾದಿಂದ ಡೆಲ್ಲಿಗೆ ಅವರು ಹೋದರು, ಪ್ರೆಸಿಡೆಂಟ್ ಆದರು. ನನಗೆ ಅವರ ಪೊಸಿಷನ್ ನನಗೆ ಕೊಟ್ಟರು. ನಾನು ಏನೇನು ಮಿಸೈಲ್ ಮಾಡ್ತಿದ್ದೋ ಎಲ್ಲ ನೀನು ಮಾಡು ಅಂತ ಹೇಳಿದ್ರು. ಸೊ ನಾನು ಅಲ್ಲೇ ಮುಂದುವರಿಸಿದೆ. ಬ್ರಹ್ಮೋಸ್ ಮಿಸೈಲ್, ಆಮೇಲೆ ಅಸ್ತ್ರ ಮಿಸೈಲ್, ಆಮೇಲೆ ಸಬ್ಮೆರೀನ್ ಲಾಂಚ್ಡ್ ಬ್ಯಾಲಿಸ್ಟಿಕ್ ಮಿಸೈಲ್ ಎಲ್ಲ ನನಗೆ ವಹಿಸ್ಬಿಟ್ಟು ಅವರು ಡೆಲ್ಲಿಗೆ ಹೋದರು. ನಾನು ಇವೆಲ್ಲ ನೋಡ್ಕೊತಿದ್ದೆ. ಸುಮಾರು 10 ವರ್ಷ ನಾನು ಹಾಗೆ ಮಾಡ್ತಾಯಿದ್ದೆ. ಆಮೇಲೆ ಕೊನೆಯಲ್ಲಿ 2012 ಆವಾಗ ನನಗೆ ಒಂದು ದಿವಸ ಬಾರಪ್ಪ ನೀನು ಆಫೀಸ್ಗೆ ಅಂದರು. ರಾಷ್ಟ್ರಪತಿ ಭವನ್ಗೆ ಹೋದರೆ ಅವರು ನೋಡೋ ಅವ್ರನ್ನ ಬಡಿ ಅನ್ನೋರು. ಸಿ ಬಡಿ, ಯು ಆರ್ ಡನ್ ಮಿಸೈಲ್, ಯು ಆರ್ ಡನ್ ರಾಕೆಟ್, ಯು ಆರ್ ಡನ್ ಗನ್, ಯು ಆರ್ ಡನ್ ಟಾರ್ಪೆಡೋ, ಫೈಟರ್ ಏರ್ಕ್ರಾಫ್ಟ್, ಬಾಂಬ್, ಎವ್ರಿಥಿಂಗ್ ಯು ಆರ್ ಡನ್, ಆಲ್ ಡಿಸ್ಟ್ರಕ್ಟಿವ್. ಡೂ ಸಮಥಿಂಗ್ ಗುಡ್ ಫಾರ್ ದಿ ಪೀಪಲ್, ಸೊಸೈಟಿ. ಹಂಗೆ ಮಾಡು. ಇವಾಗ ಇಟ್ ವಿಲ್ ಬಿ ಗುಡ್ ಬಿಕಾಸ್ ಆಕಾಶ್ ಓವರ್, ಬ್ರಹ್ಮೋಸ್ ಓವರ್, ನೋ ಯು ಡೂ ಸಮಥಿಂಗ್ ಗುಡ್ ಅಂತ ಹೇಳಿದರು. ಏನು ಮಾಡಬೇಕು ಹೇಳಿ ಗುರುಗಳೇ, ಮಾಡ್ತೀನಿ ಅಂದೆ. ಅದಕ್ಕೆ ಎನರ್ಜಿ ನಮ್ಮ ದೇಶಕ್ಕೆ ತುಂಬ ಇಂಪಾರ್ಟೆಂಟು. ನಾವು ಡಿಫೆನ್ಸ್ನವರು ಏನು ಎನರ್ಜಿ ವಿಷಯ ಮಾತಾಡಿಲ್ಲ. ಆದ್ದರಿಂದ ನೀನು ಎನರ್ಜಿ ವಿಷಯ ತಗೋ. ನಮ್ಮ ದೇಶಕ್ಕೆ ಎನರ್ಜಿ ಎಲ್ಲಿಂದ ಬರುತ್ತೆ? ಇವಾಗ ನಾವೆಲ್ಲ ಕೊಂಡ್ಕೊತೀವಿ ಪೆಟ್ರೋಲ್. ನಿಮಗೆಲ್ಲ ಗೊತ್ತಲ್ಲ ಕ್ರೂಡ್ ಆಯಿಲ್ ಎಷ್ಟು ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತಿದೆ ಅಂದ್ಬಿಟ್ಟು. ನಿಮಗೆ ಎಲ್ಲರ ಮನೇಲೂ ಗೊತ್ತಿದೆ. ಮನೆಗೆ ಗ್ಯಾಸ್ ಇಲ್ಲ, ಹೋಟೆಲ್ಗೆ ಹೋದರೆ ಹೋಟೆಲ್ ತಿಂಡಿ ಇಲ್ಲ, ಆಮೇಲೆ ಆಟೋ ಎಲ್ಲದಕ್ಕೂ ಗ್ಯಾಸ್ ಇಲ್ಲ. ನಮ್ಮ ಹತ್ರ ಗ್ಯಾಸೇ ಇಲ್ಲ. ಆಮೇಲೆ ನಮ್ಮ ಹತ್ರ ನ್ಯೂಕ್ಲಿಯರ್ ಮಾಡೋಣ ಅಂದರೆ ಯುರೇನಿಯಮ್ ಇಲ್ಲ. ಆಮೇಲೆ ಬರೀ ವಿ ಆರ್ ಡಿಪೆಂಡ್ ಆನ್ ಸನ್ ಆ್ಯಂಡ್ ವಿಂಡ್. ಅದು ಎಷ್ಟು ಎರಡೂ ಸೇರಿ 20-30% ನಮ್ಮ ಎನರ್ಜಿ ಆಗುತ್ತೆ, ಮೀಟ್ ಮಾಡೋಕ್ಕಾಗತ್ತೆ. ಮಿಕ್ಕಿದ ಎನರ್ಜಿ ಎಲ್ಲಿಂದ ಬರುತ್ತೆ ಅದು ಯೋಚನೆ ಮಾಡಿದ್ರು. ಆಮೇಲೆ ನನ್ನ ಅಲ್ಲಿ ಇಬ್ಬರು ಸೈಂಟಿಸ್ಟ್ಗೆ ಪರಿಚಯ ಮಾಡಿಸ್ಕೊಟ್ರು. ಶ್ರೀನಿವಾಸನ್ ಅಂತ ಒಬ್ಬರು ಬಾಬಾ ಅಟಾಮಿಕ್ ರಿಸರ್ಚ್ ಸೆಂಟರ್ ಡೆಪ್ಟಿ ಡೈರೆಕ್ಟರ್. ಇವ್ರ ಹತ್ರ ಕೂತ್ಕೊ ಮಾತಾಡು ಕಂಡಿಡಿ ಅಂತ ಹೇಳಿದ್ರು. ಆಮೇಲೆ ನಾನು ಅವ್ರ ಹತ್ರ ತುಂಬ ಮಾತಾಡಿದ ಮೇಲೆ ದೇರ್ ಇಸ್ ವಾಟ್ ಈಸ್ ನೋನ್ ಆ್ಯಸ್ ಕೋಲ್ಡ್ ಫ್ಯೂಷನ್ ಅಂತ ಕೇಳಿದರೆ, ಫಿಸಿಕ್ಸ್ ಯಾರ ಇದ್ದೀರಾ? BSc ಫಿಸಿಕ್ಸ್, MSc ಫಿಸಿಕ್ಸ್ ಯಾರು ಓದ್ತಿದ್ದೀರಾ? ಫಿಸಿಕ್ಸ್ ಯಾರು ಇಲ್ವಾ? PSc ಫಿಸಿಕ್ಸ್ ಇದ್ದರೆ ನೀವು ಓದಿ. ಕೋಲ್ಡ್ ಫ್ಯೂಷನ್ ಅಂತ ಇದೆ. ಅಂದರೆ ಇದ್ರ ಸೂರ್ಯನ ಜಾಗದಲ್ಲಿ, ಸೂರ್ಯನ ಇದರ ಹತ್ರ ಸೂರ್ಯನ ಮೇಲೆ 10⁻17 ಮಿಲಿಯನ್ ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್ ಇರುತ್ತೆ. ಆದ್ದರಿಂದ ಅಲ್ಲಿ ಏನಾಗ್ತಿದೆ, ಹೈಡ್ರೋಜನ್ನು ಹೀಲಿಯಮ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾಯಿದೆ. ಅಷ್ಟು ಹೈ ಟೆಂಪ್ರೇಚರು ಹೈ ಪ್ಲಾಸ್ಮಾದಲ್ಲಿ ಆಗ್ತಾಯಿದೆ. ಅದರಿಂದ ನಮಗೆ ಮಿಲಿಯನ್ಸ್ ಆಫ್ ಇಯರ್ಸಿಂದ ಶಕ್ತಿ ಬರ್ತಾಯಿದೆ. ಬೆಳಕು ಬರ್ತಾಯಿದೆ, ಹೀಟ್ ಬರ್ತಾಯಿದೆ, ಅಲ್ಟ್ರಾವೈಲೆಟ್ ಎಲ್ಲ ಬರ್ತಾಯಿದೆ. ಅದನ್ನು ನೀವು ಭೂಮಿ ಮೇಲೆ ಹೇಗೆ ಮಾಡೋದು ಅಂತ ಯೋಚನೆ ಮಾಡಿ. ಅದಕ್ಕೆ ಅದು ಅಷ್ಟು ಟೆಂಪ್ರೇಚರ್ ಮಾಡೋಕ್ಕೆ ತುಂಬ ಕಷ್ಟ. ಟ್ರೈ ಮಾಡ್ತಾಯಿದ್ದಾರೆ ಕೆಲವರೆಲ್ಲ, ಆ ಟೆಂಪ್ರೇಚರ್ ಸಾಧ್ಯವೇ ಇಲ್ಲ. ಅದಕ್ಕೆ 1000 ಡಿಗ್ರೀಸ್ 1000 ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡಲ್ಲಿ ಆ ಥರ ಮಾಡು ಅಂತ ಒಂದು ಸಲ ಒಂದು ಫ್ರೆಂಚ್ ಇಂಜಿನಿಯರು ಅವನು ಅಮೇರಿಕಾದಲ್ಲಿ ಕೂತ್ಕೊಂಡು ಏನೋ ಮಾಡಿ ಸಾಧ್ಯತೆ ಇದೆ ಅಂತ ಹೇಳಿದ್ದಾನೆ. ಅದನ್ನು ನೀವು ಯಾಕೆ ಪರ್ಸ್ಯೂ ಮಾಡಬಾರ್ದು? 1000 ಡಿಗ್ರಿ. ಅದನ್ನು ನಾನು ಲಾಸ್ಟು 2012 ಶುರು ಮಾಡಿದ ಮೇಲೆ ಇದುವರೆಗೆ ಮಾಡ್ತಾಯಿದ್ದೀವಿ ಒಂದು ಲ್ಯಾಬ್ರೇಟ್ರಿ ಇಟ್ಕೊಂಡು. ಅದೇ 1000 ಡಿಗ್ರೀಸ್ಗೆ ಎನರ್ಜಿ ಮಾಡೋಕ್ಕೆ ಕೊಟ್ಟರೆ ಅದು ಮೇ ಬಿ ಲೆಸ್ ಎಫಿಷಿಯೆಂಟ್ ದ್ಯಾನ್ ನ್ಯೂಕ್ಲಿಯರ್ ಫಿಷನ್, ನ್ಯೂಕ್ಲಿಯರ್ ಫ್ಯೂಷನ್, ಬಟ್ ಇಟ್ ವಿಲ್ ಗಿವ್ ಎನರ್ಜಿ. ಅದರಿಂದ ನಾನು ಮಾಡ್ತಾಯಿದ್ವಿ 14 ವರ್ಷದಿಂದ ಮಾಡ್ತಾಯಿದ್ವಿ. ಇಟ್ ಮೇ ಬಿ ದಿ ರಿಯಲ್ ಸೊಲ್ಯೂಷನ್ ಫಾರ್ ನಾಟ್ ಓನ್ಲಿ ಫಾರ್ ಇಂಡಿಯಾ, ನಾಟ್ ಓನ್ಲಿ ಫಾರ್ ಭಾರತ್, ಫಾರ್ ದಿ ಎಂಟೈರ್ ವರ್ಲ್ಡ್ ಅಂತ ಅಂದ್ಕೊಂಡಿದ್ದೀವಿ. ಅದು ಮಾಡ್ತಾಯಿದ್ವಿ. ಅದಕ್ಕೆ ತುಂಬ ಸಂತೋಷಪಟ್ಟು ಅದಕ್ಕೆ ಈ ವರ್ಷ ನಾವು ಅದರ ಒಂದು ರಿಸಲ್ಟು ಈ ವರ್ಷದ ಕೊನೆಯೊಳಗೆ ನಾವು ಮತ್ತೆ ರೆಡಿಯಾಗೆಲ್ಲ ಆದರೆ ನಾನು ಹೇಳಿದೆ ಸ್ವಾಮೀಜಿಯವರಿಗೆ, ನಾನು ಬಂದು ಒಂದು ಮಕ್ಕಳಿಗೆಲ್ಲ ಹೇಳ್ಕೊಡ್ತೀನಿ ಯಾವ ರೀತಿ ಮಾಡಿದ್ವಿ, ಅದರಿಂದ ಏನೇನು ಪ್ರಯೋಜನ ಆಗುತ್ತೆ ಅಂದ್ಬಿಟ್ಟು ಒಂದು ದಿವಸ ಬಂದು ಒಂದು ಪೂರ್ತಿ ದಿವಸ ಕೂತ್ಕೊಂಡು ನಾನು ಹೇಳ್ತೀನಿ. ಎನರ್ಜಿ ಕೋಲ್ಡ್ ಫ್ಯೂಷನ್ ಅಂತಾರೆ, ಲೋ ಎನರ್ಜಿ ನ್ಯೂಕ್ಲಿಯರ್ ರಿಯಾಕ್ಷನ್ ಅಂತಾರೆ. ಫಿಸಿಕ್ಸಲ್ಲಿ ಇರೋರು ಮೆಟೀರಿಯಲ್ ಸೈನ್ಸ್ ಎಲ್ಲ ಓದ್ಕೊಂಡಿರಿ. ಅದು ಯಾವಾಗ ಅದು ಪೂರ್ತಿ ಅದು ಪರಿಚಯ ಇದಾಗುತ್ತೋ, ಸಕ್ಸಸ್ ಆಗುತ್ತೋ, ಅವಾಗ ನಿಮಗೆಲ್ಲ ಕರೆಕ್ಟಾಗಿ ಗೊತ್ತಾಗುತ್ತೆ. ಅದನ್ನು ಅದೇ ನಿಮ್ಮ ಮುಂದಿನ ಚಾಲೆಂಜ್. ಅಂದರೆ ನಮ್ಮ ದೇಶಕ್ಕೆ ಆತ್ಮನಿರ್ಭರತ, ನಮ್ಮ ಎನರ್ಜಿಗಳಿಗೆ ನಮ್ಮ ಹತ್ರನೇ ಇರಬೇಕು. ವಿ ಶುಡ್ ನಾಟ್ ಗೆಟ್ ಆಯಿಲ್ ಫ್ರಮ್ ಮಿಡ್ಲ್ ಈಸ್ಟ್, ಆಯಿಲ್ ಫ್ರಮ್ ರಷ್ಯಾ, ಆಯಿಲ್ ಫ್ರಮ್ ಅಮೇರಿಕಾ, ಆರ್ ಯುರೇನಿಯಮ್ ವಿ ಆರ್ ಗೆಟಿಂಗ್ ಫ್ರಮ್ ಆಸ್ಟ್ರೇಲಿಯಾ, ಯುರೇನಿಯಮ್ ವಿ ಆರ್ ಗೆಟಿಂಗ್ ಫ್ರಮ್ ಕೆನಡಾ. ಇದೆಲ್ಲ ನಿಲ್ಲಿಸ್ಬಿಟ್ಟು ನಮ್ಮ ದೇಶದಲ್ಲಿ ನಾವೇ ಇರಬೇಕು. ಅದಕ್ಕೆ ಏನು ಬೇಡ, ಬರೀ ನೀರು, ಹೈಡ್ರೋಜನ್ನು ಎರಡೇ ಬೇಕು. ನೀರು ಬೇಕಾಷ್ಟಿದೆ ನಮ್ಮ ದೇಶದೊಳಗೆ. ಹೈಡ್ರೋಜನ್ ನೀರಿಂದ ತೊಗೋಬೋದು, ನೀರಿಂದ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಹೈಡ್ರೋಜನ್ ತೊಗೋಬೋದು, ಎರಡೂ ಇದೆ. ಆದ್ದರಿಂದ ಮಾಡೋದು ಬೇಕು ಅಂತ ಅಂದ್ಕೊಂಡಿದ್ದೀವಿ. ಎಲ್ಲ ದೈವಾನುಗ್ರಹ ಇದ್ದು ಸ್ವಾಮೀಜಿಯವರ ಆಶೀರ್ವಾದ ಅನುಗ್ರಹ ಬಂದರೆ ಅದು ಸಕ್ಸಸ್ ಆಗುತ್ತೆ ಅಂತ ಅಂದ್ಕೊಂಡಿದ್ದೀವಿ. ಅದು ಆದಾಗ ನೀವೆಲ್ರಿಗೂ ಹೇಳ್ಕೊಡ್ತೀವಿ. ಹೇಳಿ.
ಏನಿಲ್ಲ, ಭಾಳ ಸಂತೋಷ. ಡಾಕ್ಟರ್ ಪ್ರಹ್ಲಾದ್ ಅವರು ಹೇಳಿದ್ರು. ಅವರು ಕಲಾಂ ಅವ್ರ ಜೊತೆ ನೇರವಾಗಿ ಕೆಲಸ ಮಾಡಿರೋರು. ಅವರ ಜೊತೆ ಇದ್ದವರೇ ಒಂದು ಕಾಲದಲ್ಲಿ CR ಸತ್ಯ ಅಂತ. ಅವರು ಬದುಕಿದ್ದಾಗ ಈ ಒಂದು ಘಟನೆಯನ್ನು ಹೇಳಿದ್ರು. ಹೂ ಈಸ್ ಎ ಲೀಡರ್? ದ ಒನ್ ಹೂ ಇನ್ಸ್ಪೈರ್ಸ್. ಇವಾಗ ಯಾರೋ ಕೇಳಿದ್ರಿ ಅವ್ರು ಹೆಂಗೆ ಇನ್ಸ್ಪೈರ್ ಮಾಡಿದ್ರು ನೋಡಿ. ನಾನು ಒಂದು ಸೌಂಡಿಂಗ್ ರಾಕೆಟ್ದು ಒಂದು ಪಿಕ್ಚರ್ ತೋರಿಸ್ದೆ ನನ್ನ ಲೆಕ್ಚರ್ನಲ್ಲಿ. ಅದು ನವಂಬರ್ 21, 1963 ತುಂಬಾಯಿಂದ ಉಡಾಯಿಸಿದ್ದು ಅಂತ ಹೇಳಿದೆ. ದಟ್ ಇಟ್ ವಾಸ್ ಲಾಂಚ್ ಫ್ರಮ್ ತುಂಬಾ. ಅಲ್ಲಿ ತುಂಬಾ ಈಕ್ವೆಟೋರಿಯಲ್ ರಾಕೆಟ್ ಲಾಂಚಿಂಗ್ ಸ್ಟೇಷನ್ ಅಂತ ಒಂದು ಯುನೈಟೆಡ್ ನೇಷನ್ಸ್ ಫೆಸಿಲಿಟಿ ಶುರು ಆಯಿತು. ಇದು ಸಾರಾಭಾಯಿರವರ ದೂರದೃಷ್ಟಿ ಅದು ನಮಗೆ ತುಂಬ ಅಡ್ವಾಂಟೇಜ್ ಆಗೋಂಗೆ ಮಾಡ್ತು. ಆ ಸೆಂಟರ್ಗೆ ಒಬ್ಬರು HGS ಮೂರ್ತಿ ಅಂತ ಒಬ್ಬರು ಕರ್ನಾಟಕದವರೇ, ಹೊಳೆ ನರಸೀಪುರದವರು, ಅವರು ಡೈರೆಕ್ಟರ್ ಆಗಿದ್ದರು. ಅವರ ಸೆಂಟ್ರ್ ಅಲ್ಲಿ ಕಲಾಂ ಅವರು ಕೆಲಸ ಮಾಡ್ತಾಯಿದ್ರು. ಅಲ್ಲಿ ಅವ್ರ ಜೊತೆ ನೇರವಾಗೆಲ್ಲ ಅಂತೂ ಕೆಲಸ ಮಾಡ್ತಾಯಿದ್ರು. ಒಂದು ದಿವಸ ಕಲಾಂ ಅವರು ತಾವು ಕೆಲಸ ಮಾಡೋದಲ್ಲದೆ ಕಷ್ಟಪಟ್ಟು ತಮ್ಮ ಜೊತೆ ಇದ್ದಂಥವರನ್ನು ಯಾವ ರೀತಿ ಪ್ರೇರೇಪಿಸ್ತಾ ಇದ್ದರು ಅನ್ನೋದಕ್ಕೆ ಈ ಘಟನೆ CR ಸತ್ಯ ಅವರು ಹೇಳಿದ್ರು. ರಾತ್ರಿ 3 ಗಂಟೆಯಲ್ಲಿ ಅಥವಾ 3:15 ದೀಪ ಉರಿತಾ ಇತ್ತಂತೆ ತುಂಬ ಈಕ್ವೆಟೋರಿಯಲ್ ರಾಕೆಟ್ ಲಾಂಚಿಂಗ್ ಸ್ಟೇಷನ್ ತಿರುವನಂತಪುರದಲ್ಲಿ. HGS ಮೂರ್ತಿ ಯಾವುದೋ ಫಾರಿನ್ ಫ್ಲೈಟಿಗೆ ಹಿಡ್ಕೋಬೇಕು ಅಂತ 3:30 ಹೋಗ್ತಾ ಇದ್ದಾರೆ ಬೆಳಗ್ಗೆ. ಆವಾಗ ನೋಡಿದ್ರೆ ಇದೇನು ದೀಪ ಉರಿತಾ ಇದೆಯಲ್ಲ ಇಲ್ಲಿ ಅಂತ ಒಳಗೋಗಿ ನೋಡಿದ್ರೆ ಕಲಾಂ ಅವರು 3-4 ಜನ ಇನ್ನೂ ಯಂಗ್ ಇಂಜಿನಿಯರ್ಸು ಎಲ್ಲ ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ದಾರಂತೆ ಸೌಂಡಿಂಗ್ ರಾಕೆಟ್ ಮೇಲೆ. ಆವಾಗ HGS ಮೂರ್ತಿಗೆ ಸಿಕ್ಕಾಪಟ್ಟೆ ಕೋಪ ಬಂದ್ಬಿಡ್ತಂತೆ. ಕಲಾಂ, ಏನಿದು ನಿಮಗೆ, ನೀವು ದೇಶಾಭಿಮಾನಿ, ಕೆಲಸದ ಬಗ್ಗೆ ದೇವರು ಅಂತ ತಿಳ್ಕೊಂಡಿದ್ದೀರ, ಅದೆಲ್ಲ ಒಪ್ಕೋತೀನಿ. ಆದರೆ ನೀವು ಈ ಥರ ಕೆಲಸ ಮಾಡಿದ್ರೆ ಹಗಲು ರಾತ್ರಿ ನೋಡಿದೆ ನಿಮ್ಮ ಆರೋಗ್ಯದ ಗತಿ ಏನು? ಜೊತೆಗೆ ನಿಮ್ಮ ಜೊತೆ ಈ ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ದಾರಲ್ಲ ಚಿಕ್ಕ ಹುಡುಗರು, ಯಂಗ್ ಇಂಜಿನಿಯರ್ಸ್, ಅವ್ರ ಗತಿ ಏನು? ಸ್ವಲ್ಪ ಬುದ್ಧಿ ಬೇಡವಾ ನಿಮಗೆ? ಹ್ಞೂ ಅಂತಾರೆ, ರೇಗಾಡ್ಬಿಟ್ಟು ಹೊಟ್ಟೋದ್ರಂತ. ಇನ್ನು 15 ನಿಮಿಷದಲ್ಲಿ ಏನಾದರೂ ನೀವು ಆಚೆ ಹೋಗಲಿಲ್ಲ ಅಂದರೆ ಇಲ್ಲಿ ನಿಮ್ಮ ಕೆಲಸ ನಿಲ್ಲಿಸ್ಬಿಟ್ಟು ಈಗಲೇ ಸೆಕ್ಯೂರಿಟಿನವ್ರನ್ನ ಕರೆದು ಬಿಡ್ತೀನಿ ನಾನು ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ರೇಗಾಡಿ ಹೊಟ್ಟೋದ್ರಂತೆ. ಅವ್ರು ಆ ಕಡೆ ಹೋದ ತಕ್ಷಣ ಕಲಾಂ ಹೇಳಿದ್ರಂತೆ, 3:30 ಬೆಳಗಿನ ಜಾವ, ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, ಬೆಳಗಿನ ಜಾವ 3:30 ಕೆಲಸ ಮಾಡ್ತಾಯಿದ್ದಾರೆ. ಬೇರೆ ಅವ್ರಿಗೆ ಹೆಂಗೆ ಇಂಜಿನಿಯರ್ಸ್ ಕಡೆ ತಿರುಗಿಬಿಟ್ಟು ಹೇಳಿದ್ರಂತೆ, ಏನು ಮಾಡೋದು ನೋಡಿ, ಈ ಥರ ಹೇಳ್ಬಿಟ್ಟು ಹೊಟ್ಟೋದ್ರಲ್ಲ, ಇವಾಗ ಹೋಗದೆ ಇದ್ದರೆ ಸೆಕ್ಯೂರಿಟಿನವ್ರನ್ನ ಕರೆದು ಹೊರಗೆ ಹಾಕಿಸ್ತಾರೆ, ಹೊಟ್ಟೋಗೋಣ ಬನ್ನಿ, ಬೆಳಗ್ಗೆ 7 ಗಂಟೆಗೆ ಬಂದ್ಬಿಡೋಣ ತಿರ್ಗಾ ಅಂತ. 3:30 ಹೋಗ್ಬಿಟ್ಟು ಬೆಳಗ್ಗೆ 7 ಗಂಟೆಗೆ ತಿರ್ಗಾ ಬರೋದು ನೋಡಿ. ಇದು ಕಲಾಂ. ತಾನು ಕೆಲಸ ಮಾಡೋದಲ್ಲದೆ ನೋಡಿ ತನ್ನ ಜೊತೆ ಇದ್ದವ್ರನ್ನೂ ಕೂಡ ಹುರಿದುಂಬಿಸಿ ಅವರು ನೋಡಿ. ಇವರೆಲ್ಲ ಇವಾಗ ಕಲಾಂ ಅವರು ಯಾವುದು ಮೇಲ್ಪಂಕ್ತಿ ಹಾಕೊಟ್ರೋ ಅದನ್ನೇ ಅನುಸರಿಸ್ಕೊಂಡು ಹೋಗ್ತಾ ಇದ್ದಾರೆ. ಕಲಾಂ ಅವರು ಆ ರೀತಿ, ನಾನು 6 ಸಲ ಮೀಟ್ ಮಾಡಿದ್ದೀನಿ ಅವ್ರನ್ನ. ನಾನೇನು ಅವ್ರ ಜೊತೆ ಕೆಲಸ ಮಾಡಿದ್ದೀನಿ ಅನ್ನೋ ಸುಳ್ಳೆಲ್ಲ ಹೇಳಲ್ಲ, ದೂರದಿಂದ ನೋಡಿದ್ದೀನಿ, ಮಾತಾಡಿಸಿದ್ದೀನಿ ಸಾಕಷ್ಟು ಸಲ. ನಮ್ಮ ಒಂದು ಅಂತರಿಕ್ಷ ಕಾರ್ಯಕ್ರಮದ ಬಗ್ಗೆ ಅವರಿಗೆ ಮಾಹಿತಿ ನೀಡಿದ್ದೀನಿ, ಅದೆಲ್ಲ ಮಾಡಿದ್ದೀನಿ. ನಾನೇನು ಕೆಲಸ ಮಾಡಿದ್ದೀನಿ, ನಾನು ತುಂಬ ಚಿಕ್ಕವನು ಅವಾಗ. ಹಾಗಾಗಿ ನೋಡಿ, ಕಲಾಂ ಅವರು ಒಂದು ಅನನ್ಯವಾದ ವ್ಯಕ್ತಿ ಅನ್ನೋದು ಹೇಳೋಕ್ಕೆ ಇಷ್ಟಪಡ್ತೀನಿ. ಥ್ಯಾಂಕ್ ಯು.
ಓಕೆ, ನೆಕ್ಸ್ಟ್.
Good afternoon, everyone. I am Manaswini Rao. I am from 2nd BSc. My question is for Dr. Prahalada Ramarao, sir.
Go ahead.
In rocket design, we use differential equation to model motion. Why is it mathematically necessary to use differential equation rather than a simple linear formula?
ಹೇಳ್ತೀನಿ. ಇವಾಗ ರಾಕೆಟ್ ಪ್ರಪಲ್ಷನ್ ನೀವು ಆಗಲೇ ನೋಡಿದ್ರಿ ವಿಡಿಯೋಲಿ, ಅದರಲ್ಲಿ ಮಾಸ್ ಈಸ್ ನಾಟ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಕಂಟಿನ್ಯೂಸಾಗಿ ಪ್ರೊಪಲ್ಷನ್ನು ಬರ್ನ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಫ್ಯೂಯಲ್ ಬರ್ನ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಆ್ಯಸ್ ಎ ಫಂಕ್ಷನ್ ಆಫ್ ಟೈಮ್ d/dt ಎಲ್ಲಿಂದ ಬರುತ್ತೆ? ಬಿಕಾಸ್ ದಿ ಮಾಸ್ ಈಸ್ ಕಂಟಿನ್ಯೂಸ್ಲಿ ರಿಡ್ಯೂಸಿಂಗ್, ಥ್ರಸ್ಟ್ ಈಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್, ಡ್ರ್ಯಾಗ್ ಈಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್, ಲಿಫ್ಟ್ ಈಸ್ ಚೇಂಜಿಂಗ್, ಆಮೇಲೆ ವೈಬ್ರೇಷನ್ಸು ಎಲ್ಲನೂ ಡೈನಮಿಕ್ಕು. Everything is as a function of time. So that is why you have to take only the differential equations, because nothing is not a Newton's law where you can push a cart and find out the solution. Because here everything is burning, everything is consumed, and everything is highly dynamic and coupled. So you have to have not only differential equations, ಇದು ಈಕ್ವೇಷನ್ಸು ಆವಾಗ ಏನಾಗುತ್ತೆ, ಸಾಲ್ವ್ ಮಾಡೋಕ್ಕಾಗುತ್ತೆ. ಇಟ್ಸ್ ನಾಟ್ ಎ ಕಂಟಿನ್ಯೂಸ್ ಇಕ್ವೇಷನ್, ಇಸ್ ಎ ಸ್ಟೆಪ್ ಇಕ್ವೇಷನ್. ಅದನ್ನ ಬೇಕೇ ಬೇಕಾಗುತ್ತೆ. ಬಟ್ ಇಸ್ ನಾಟ್ ಎ ಹೈಲಿ ಮ್ಯಾಥಮೆಟಿಕಲ್, ದಿ ರಾಕೆಟ್ ಸೈನ್ಸ್. ಆಮೇಲೆ ನೋಡಿದ್ರೆ ನೀವು ಏನು ಸಿಗ್ನಲ್ ಪ್ರಾಸೆಸಿಂಗ್, ರೆಡಾರ್ ಸಿಗ್ನಲ್ ಪ್ರಾಸೆಸಿಂಗ್, ಕಮ್ಯುನಿಕೇಷನ್, ದಟ್ ಈಸ್ ಹೈಲಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅದೆಲ್ಲ. ಬಟ್ ದಿ ರಾಕೆಟ್ ಇಟ್ ಸೆಲ್ಫ್ is a simple differential equation. Amele it will become much more complex. When you go further studies, you will understand more complexity is with the signal processing than with rocketry. Got okay. Any other? Time. ಇವಾಗ ಸ್ವಾಮೀಜಿ 2 ಕ್ವಶನ್ ಕೇಳಿದ್ರು. ಟೈಮು ಒಂದು ಮುಹೂರ್ತ ಅಂತ ಇಡ್ತೀವಿ, ಅದು ಅಕಸ್ಮಾತ್ ಪೋಸ್ಟ್ಪೋನ್ ಆದರೆ ಹೇಗೆ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಒಂದು ಸಲ ಬಿಟ್ಬಿಟ್ಟು ನೆಕ್ಸ್ಟ್ ಡೇ ಹೋಗ್ತೀರಿ ಅಂತ. ಇವಾಗ ಟೈಮ್, ರಾಕೆಟ್ ಲಾಂಚಿಂಗ್ ಟೈಮು ಇವಾಗ ಒಂದು ದೊಡ್ಡ ಇವಾಗ 2 ಥರ ಮಿಸೈಲ್ ಇದೆ. ಒಂದು ಶಾರ್ಟ್ ರೇಂಜ್ ವಿತ್ 10 ಕಿಲೋಮೀಟ್ರು, 20 ಕಿಲೋಮೀಟ್ರು, 100 ಕಿಲೋಮೀಟ್ರು. ಅದು ನಮ್ಮ ದೇಶದೊಳಗೆ ಹಾರುತ್ತೆ, ನಮ್ಮ ದೇಶದೊಳಗೆ ಬಿದ್ದೋಗುತ್ತೆ. ಯಾಕೆಂದರೆ ಬೇ ಆಫ್ ಬೆಂಗಾಲಿಂದ ಹಾರಿಸ್ತೀವಿ, ಅದು ದೂರ ಹೋಗಲ್ಲ, ಪರದೇಶಕ್ಕೆ ಹೋಗಲ್ಲ. ಅದಕ್ಕೆಲ್ಲ ಈಸಿ, ನೀವು ಯಾವ ಬೇಕಾದ್ರೆ ಮಾಡ್ಬೋದು. ಅರ್ಧ ಗಂಟೆ ಲೈಟಾಗಿ, ಅರ್ಧ ಗಂಟೆ ಮೊದಲೇ ಮಾಡ್ಬೋದು. ಆದರೆ ಅಗ್ನಿ ಮಿಸೈಲು, ಪೃಥ್ವಿ ಮಿಸೈಲೆಲ್ಲ 100 ಕಿಲೋಮೀಟ್ರ್ 1000 ಕಿಲೋಮೀಟ್ರ್ ಹೋಗುತ್ತೆ. ಆವಾಗ ಬೇರೆ ದೇಶದ ಪ್ರಾಂತ್ಯಕ್ಕೆ ಹೋಗ್ತೀವಿ, ಅಲ್ಲಿ ಹಾರೋ ಏರೋಪ್ಲೇನ್ಗಳಿರ್ಬೋದು, ಅಲ್ಲಿ ಶಿಪ್ಗಳಿರ್ಬೋದು, ಅವ್ರಿಗೆ ಮೊದಲೇ ಇದು ಕೊಡ್ತೀವಿ, ನೋ ಟಮ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅಂದರೆ ಒಂದು ನೋಟಿಸ್ ಕೊಡ್ತೀವಿ, ಈ ಟೈಮ್ ಒಳಗೆ ಈ ಕಡೆ ಇಲ್ಲಿ ನಾವು ಈ ಆ್ಯಂಗಲ್ ಅಂದರೆ ಈ ಕಡೆ ನಾವು ಒಂದು ಅಗ್ನಿ ಮಿಸೈಲ್ ಹಾರಿಸ್ತೀವಿ ಅಥವಾ ಸಬ್ಮರೀನ್ ಲಾಂಚ್ ಮಿಸೈಲ್ ಹಾರಿಸ್ತೀವಿ. ಅಂದರೆ ಅದು 2000 ಕಿಲೋಮೀಟ್ರ್ ಹೋಗುತ್ತೆ. ಅದು ನಮ್ಮ ದೇಶದಲ್ಲೇ ಪರದೇಶದಲ್ಲೇ ಮುಖದ ದೇಶ ಎಲ್ಲ ದೇಶಕ್ಕೂ ಹೋಗುತ್ತೆ. ಇಷ್ಟು ಹೈಟ್ ಹೋಗುತ್ತೆ, ಇಷ್ಟು ಸ್ಪೀಡ್ ಹೋಗುತ್ತೆ, ಈ ಟೈಮಿಂದ ಈ ಟೈಮಿಗೆ ಹೋಗುತ್ತೆ. ದಯವಿಟ್ಟು ನೀವು ನಿಮ್ಮ ಏರ್ಕ್ರಾಫ್ಟ್ಗಳನ್ನು ಅಲ್ಲಿ ಬರದೇ ಇರೋ ಹಾಗೆ ನೋಡ್ಕೊಳ್ಳಿ. ನಿಮ್ಮ ಶಿಪ್ಗಳಿದ್ದರೆ ಆ ಶಿಪ್ ಅಲ್ಲಿ ಇರಬಾರ್ದು, ದೂರ ಹೋಗಬೇಕು ಅಂದ್ಬಿಟ್ಟು ನೋಟಮ್ ಅಂತ ಕೊಡಲೇಬೇಕು. ಅದು ಇಡೀ ಪ್ರಪಂಚದೊಳಗೆ ಅದು ಪ್ರತಿ ದೇಶದವರು ಯಾವಾಗ ಈ ರೀತಿ ಹಾರ್ತಾರೋ ಅದು ಮೊದಲೇ ನೋಟಿಸ್ ಕೊಡಬೇಕು, ನಾವು ಈ ಥರ ಹಾರಿಸ್ತೀವಿ ಅಂದ್ಬಿಟ್ಟು. ಆವಾಗ ಅಲ್ಲಿಂದ ಯಾವ ಶಿಪ್ಪು ಇರೋದಿಲ್ಲ, ಯಾವ ಏರ್ಕ್ರಾಫ್ಟ್ ಇರೋಲ್ಲ, ಯಾವುದು ಏನೂ ಆಗಲ್ಲ, ಆವಾಗಲೇ ಹೋಗಬೇಕು. ಅಕಸ್ಮಾತ್ ನಾವು ಲಾಂಚ್ ಮಾಡದೇ ಇದ್ದರೆ ಅದನ್ನು ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿ ಇನ್ನೊಂದು ದಿವಸ ಕೊಡಬೇಕು. ಅದಕ್ಕೆ ಮಿನಿಮಮ್ 3 ದಿವಸ 4 ದಿವಸ ಮೊದಲೇ ಹೇಳಬೇಕು. ಯು ಕ್ಯಾನ್ ಸೇ ಇವತ್ತಾಗಲ್ಲ ನಾಳೆ ಹೋಗ್ತೀವಿ ಅಂತ ಆಗೋದಿಲ್ಲ. ಆ ಥರ ಇರುತ್ತೆ. ಆ ಥರ ನೋಟಮ್ ಕೊಟ್ಟು ನಾವು ಮಾಡಬೇಕು. ದೊಡ್ಡ ಲಾಂಗ್ ರೇಂಜ್ಗೆ, ಸ್ಮಾಲ್ ರೇಂಜ್ ಅಪ್ ಟು 100 ಕಿಲೋಮೀಟರ್ಸ್ ವಿ ಕ್ಯಾನ್ ಲಾಂಚ್ ಎನಿ ಟೈಮ್ ವಿತಿನ್ ಅವರ್ ಬಾರ್ಡರ್. ನೋ ಬಡಿ ವಿಲ್ ವರಿ. ಬಟ್ ಓನ್ಲಿ ಇವರಿರ್ತಾರಲ್ಲ, ಮೀನುಗಾರಿಕೆ ಮಾಡಿರ್ತಾರಲ್ಲ, ಮೀನುಗಾರಿಕೆವರೆಗೂ ನಾವು ಹೇಳ್ತೀವಿ ದಯವಿಟ್ಟು ಫಿಶಿಂಗ್ ಮಾಡಬೇಡಿ ಅಂತ. ಅಂದರೆ ಸುತ್ತಮುತ್ತಲ ಹಳ್ಳಿ ಅದರೊಳಗೆ ಶ್ರೀಹರಿಕೋಟೆಯಲ್ಲೂ ಆಗುತ್ತೆ, ನಮ್ಮ ಬಾಲಸೂರು ಒರಿಸ್ಸಾದಲ್ಗೂ ಎಲ್ಲ ಹಳ್ಳಿಗಳಿಗೂ ನಾವು ಅನೌನ್ಸ್ ಮಾಡಿ ಕಳಿಸ್ತೀವಿ, ಸಾಯಂಕಾಲ 5ರಿಂದ 7ಕ್ಕೆ ಯಾರೂ ಫಿಶಿಂಗ್ ಮಾಡಬೇಡಿ ಅಂತ. ಯಾರು ಫಿಶಿಂಗ್ ಮಾಡೋಕ್ಕೂ ಬಿಡೋದು. ಯಾಕೆಂದರೆ ಅವ್ರು ಫಿಶಿಂಗ್ ಬಲೆ ಹಾಕ್ಕೊಂಡು ಹೋದರೆ, ಬೋಟಲ್ಲಿ ಹೋದರೆ ಅವ್ರ ಮೇಲೆ ಬೀಳ್ಬೋದು, ಹೆಚ್ಚು ಕಡಿಮೆ ಆಗ್ಬೋದು. ಅದಕ್ಕೆ ಅವ್ರ ಫಿಶರ್ಗೆಲ್ಲ ಅವ್ರ ಮನೇಲೇ ಇರ್ತಾರೆ ಅವರು. ಅದಲ್ಲದೆ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಅದೊಂದು ದೊಡ್ಡ ಈ ಲೋಕಲ್ ಡೆಪ್ಟಿ ಕಮಿಷನರ್ಗೆ ಒಂದು ದೊಡ್ಡ ಜವಾಬ್ದಾರಿ. ಅವರು ಫಿಶಿಂಗ್ ಮಾಡಿಬಿಡಿ ಅಂತೀವಿ, ಅವರು ಮನೇಲಿ ಕೂತ್ಕೊಂಡು ಏನು ಮಾಡ್ತಾರೆ. ಆದ್ದರಿಂದ ಅವರು ಸ್ವಲ್ಪ ಪೊಲಿಟಿಕಲ್ ಇಶ್ಯೂ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಆ ಡೆಪ್ಟಿ ಕಮಿಷನರು ಅವ್ರಿಗೆಲ್ಲನೂ ಅವ್ರ ಹಳ್ಳಿ ಒಳಗೆ ಏನೋ ಒಂದು ಕಾರ್ಯಕ್ರಮ ಇಡ್ತಾರೆ, ಹಾಡು ಡ್ಯಾನ್ಸ್ ಮಾಡೋದು ಅಥವಾ ಏನೋ ಒಂದು ಆ ಕಾರ್ಯಕ್ರಮ ಇಟ್ಬಿಟ್ಟು ಎಲ್ಲರಿಗೂ ಕರೆದು ಊಟ ಹಾಕಿಸ್ತಾರೆ. ನಾವೇ ಅದಕ್ಕೆ ನಮ್ಮ ಡಿಫೆನ್ಸ್ನವರೇ ಅದಕ್ಕೆ ಖರ್ಚೆಲ್ಲ ತೊಗೋತೀವಿ. ಅವರಿಗೆ ಊಟ ಹಾಕಿಸಿ ತಿಂಡಿ ಕೊಟ್ಟು ಇಟ್ಕೊಂಡಿರ್ತೀವಿ. ಆವಾಗ ಸಾಯಂಕಾಲ 5ರಿಂದ 6 ಅಂದರೆ ಸುಮಾರು 4ರಿಂದ 7 ಗಂಟೆ ತನಕ ನಾವು ಅವರಿಗೆಲ್ಲ ಖರ್ಚೆಲ್ಲ ನೋಡಿಕೊಂಡು ಮನೇಲೇ ಇರೋ ಹಾಗೆ ಮಾಡ್ತೀವಿ. ಆಮೇಲೆ ಹೋಗಲಿ ಫಿಶಿಂಗ್ಗೆ ಅಂತ ಮಾಡ್ತೀವಿ. ಅದಕ್ಕೂ ನಾವು ಮೊದಲೇ ನೋಟಿಸ್ ಕೊಡಬೇಕು. ಮೊದಲೇ ತಕ್ಷಣ ಬೇಗ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಆ ಥರ ಇದೆ. ಆದ್ದರಿಂದ ಬೋತ್ ಚಿಕ್ಕ ರೇಂಜ್ಗೂ ದೊಡ್ಡ ರೇಂಜ್ಗೂ, ಚಿಕ್ಕ ರೇಂಜ್ಗೆ ನಮ್ಮ ಸುತ್ತಮುತ್ತ ಹಳ್ಳಿರು ಕೊಡಲೇಬೇಕು, ದ್ವೀಪಕ್ಕೆ ಹಳ್ಳಿಗೆ. ದೊಡ್ಡ ರೇಂಜ್ಗೆ ಹೊರ ದೇಶಕ್ಕೆ ಕೊಡಬೇಕು. ಎರಡಕ್ಕೂ ಮೊದಲೇ ನೋಟಿಸ್ ಕೊಟ್ಟು ಆಮೇಲೆ ಲಾಂಚ್ ಮಾಡಿದ್ವಿ. ಮೊನ್ನೆ ಮಾಡಿದರು, ಪಾಕಿಸ್ತಾನ್ಗೂ ಕೊಟ್ಟಿದ್ದರು ನೋಟಿಸ್. ಅಂದರೆ ನಾವು ಯಾವುದೋ ದೊಡ್ಡ ಮಿಸೈಲ್ ಲಾಂಚ್ ಮಾಡ್ತಾಯಿದ್ದೀವಿ, ನೀವು ಈ ಹೈಟ್ ಒಳಗೆ ಈ ಟೈಮ್ ಒಳಗೆ ಏನು ನೀವು ಉಪಯೋಗಿಸ್ಬೇಡಿ. ಅಂದರೆ ಈವನ್ ಕಮರ್ಷಿಯಲ್ ಏರ್ಕ್ರಾಫ್ಟ್ ಯು ಶುಡ್ ನಾಟ್ ಅಲೋ ಅಂತ ಬರಿತೀವಿ. ಅದನ್ನು ಎಲ್ಲ ರೆಸ್ಪೆಕ್ಟ್ ಮಾಡಿ ಮಾಡ್ತಾರೆ, ಆವಾಗ ಕೊಡ್ತಾರೆ. ಆವಾಗ ಅವ್ರಿಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಇವ್ರು ಏನೋ ದೊಡ್ಡ ರಾಕೆಟ್ ಲಾಂಚ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂದ್ಬಿಟ್ಟು ಗೊತ್ತಾಗುತ್ತೆ ಅವ್ರಿಗೆ. ಅವರು ಅದನ್ನು ಟ್ರೈ ಟು ಫೈಂಡ್ ಔಟ್ ವಾಟ್ ಈಸ್ ದಟ್ ಅಂತ ಸ್ವಲ್ಪ ಸ್ಪೈಯಿಂಗು ಮಾಡ್ತಾರೆ, ಅದು ಮಾಡ್ತಾರೆ. ಆದರೆ ಅವ್ರು ಮಾಡಿದ್ರೆ ನಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ, ಪಾಕಿಸ್ತಾನ ಅನೌನ್ಸ್ ಮಾಡಿದ್ರೆ ನಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಅದರಿಂದ ಇದು ಎಲ್ಲ ದೇಶದೊಳಗೂ ಇದಾಗುತ್ತೆ. ಪ್ರಪಂಚದೊಳಗೆ ಈ ನೋಟಮ್ ಕೊಡೋದು, ಅದೆಲ್ಲ ಅಬ್ಸರ್ವ್ ಮಾಡೋದು. ಆಮೇಲೆ ಎಷ್ಟೋ ಸಲ ಅದು ಇದೇನಾಗುತ್ತೆ, ಮೊನ್ನೆ ನೋಡಿದ್ವಿ, ಸ್ಪೇಸ್ ಇದಾಯಿತು ಲಾಂಚ್ ಹೋಗ್ತಾ ಇರ್ಬೇಕಾದ್ರೆ ಏನು ಹೆಚ್ಚು ಕಡಿಮೆ ಆದರೆ ಅದು ದಾರಿ ತಪ್ಪಿಡುತ್ತೆ. ದಾರಿ ತಪ್ಪಿಟ್ರೆ ಅದು ಎಷ್ಟು ದೂರ ಹೋಗ್ಬೋದು, ದಾರಿ ತಪ್ಪಿ ತುಂಬ ದೂರ ಹೋದರೆ ಪರದೇಶಕ್ಕೆ ಹೋಗಿ ಬೀಳುತ್ತೆ. ಹತ್ತಿರ ಆದರೆ ಅದು ಏನು ಶಿಪ್ ಮೇಲೆ ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತಾರೆ, ಸೆಲ್ಫ್ ಡಿಸ್ಟ್ರಕ್ಟ್ ಮೆಕ್ಯಾನಿಸಮ್ ಅಂತ ಇರುತ್ತೆ. ಅಂದರೆ ಹಾರ್ತಾ ಇರುತ್ತೆ, ಅದು ನಮ್ಗೆ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ ಏನೋ ಒಳಗಡೆ ತಪ್ಪಾಗ್ತಾ ಇದೆ. ಆವಾಗೇನಾಗುತ್ತೆ, ಅದನ್ನು ಸೆಲ್ಫ್ ಡಿಸ್ಟ್ರಕ್ಟ್ ಅಂದರೆ ಒಳಗಡೆ ಒಂದು ಎಕ್ಸ್ಪ್ಲೋಷನ್ ಇಟ್ಟಿರ್ತೀವಿ, ಅದಕ್ಕೆ ಒಂದು ಕಮಾಂಡ್ ಕೊಟ್ಟರೆ ಢಮ್ ಅಂತ ಅಲ್ಲೇ ಇದಾಗ್ಬಿಡುತ್ತೆ, ಎಕ್ಸ್ಪ್ಲೋಡ್ ಆಗಿಬಿಟ್ಟು ಅಲ್ಲಿಂದನೇ ಎಲ್ಲ ಪುಡಿಯಾಗಿ ಬಿದ್ದೋಗುತ್ತೆ. ಆವಾಗ ಬೇರೆ ದೇಶಕ್ಕೆ ಹೋಗಲ್ಲ. ಅದಕ್ಕೂ ನಾವು ಇಟ್ಕೊಂಡಿರ್ಬೇಕು ರೆಡಿಯಾಗಿ. ಸೆಲ್ಫ್ ಡಿಸ್ಟ್ರಕ್ಟ್ ಅಂತ ಒಂದು, ಕಮಾಂಡ್ ಡಿಸ್ಟ್ರಕ್ಟ್ ಅಂದರು ಎರಡಿದೆ. ಒಂದು ಕಮಾಂಡ್ ಡಿಸ್ಟ್ರಕ್ಟ್, ಒಂದು ಸೆಲ್ಫ್ ಡಿಸ್ಟ್ರಕ್ಟ್. ಸೆಲ್ಫ್ ಅಂದರೆ ಅದೇನೇ ಆಟೋಮೆಟಿಕ್ಕಾಗಿ ಡಿಸೈಡ್ ಮಾಡುತ್ತೆ, ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೋಡ್ ಅಂತ. ಇನ್ನೊಂದು ಕಮಾಂಡ್ ಅಂದರೆ ನಮ್ಗೆ ಗೊತ್ತಾದ ತಕ್ಷಣ ಒಂದು ಕಮಾಂಡ್ ಕಳಿಸ್ತೀವಿ, ಅದು ಎಕ್ಸ್ಪ್ಲೋಡ್ ಆಗುತ್ತೆ. ಅದೆರಡೂ ಇರಲೇಬೇಕು. ಇವೆಲ್ಲ ಸೇಫ್ಟಿಗೆ ಇರಬೇಕು, ಇಲ್ಲಾಂದರೆ ಆಮೇಲೆ ಇದು ಇಂಟರ್ನ್ಯಾಷನಲ್ ರಿಲೇಷನ್ಶಿಪ್ಪಲ್ಲಿ ತುಂಬ ತೊಂದರೆ ಆಗುತ್ತೆ. ಅದೆಲ್ಲ ನಾವು ಮೊದಲೇ ತಯಾರು ಮಾಡ್ಕೊಂಡು ಹೋಗಿ ಅಲ್ಲಿ ತುಂಬ ಇನ್ಸ್ಟ್ರುಮೆಂಟೇಷನ್ ಇರುತ್ತೆ, ಶಿಪ್ ಇರುತ್ತೆ, ಟೆಲಿಮೀಟ್ರಿ ಇರುತ್ತೆ, ಟೆಲಿಕಮಾಂಡ್ ಇರುತ್ತೆ. ಆ ಮಿಸೈಲ್ ಒಂದೇ ಒಂದು ನೋಡೋಕ್ಕೆ ಇರೋದು, ಅದ್ರ ಗ್ರೌಂಡ್ ಸಿಸ್ಟಮ್ ಒಂದು 15 ಇರುತ್ತೆ, ಅದೆಲ್ಲ ಇರುತ್ತೆ, ಆ ಥರ ಇರುತ್ತೆ. ಬಟ್ ಅಲ್ಲೂ ಮಾಡಲೇಬೇಕು, ಅವರು ಮಾಡಲೇಬೇಕು.
ನೋಡಿ, ಇವಾಗೇನು ಅಂದರೆ ಒಂದು ಕಾಲದಲ್ಲಿ ಸ್ವಾಮೀಜಿ ಕೇಳ್ತಾ ಇದ್ದಾರೆ, ಸ್ಯಾಟಲೈಟ್ಲಲ್ಲಿ ಲಾಂಚ್ ಮಾಡ್ತಾ ಕೆಲವು ಸಲ ಡಿಲೇ ಇರುತ್ತೆ, ಒಂದು ಅರ್ಧ ನಿಮಿಷ 1 ನಿಮಿಷ. ಯಾಕೆ ಅಂತ ಈ ನಡುವೆ ಆಗ್ತಾಯಿದೆ. ಯಾಕಂದರೆ ಇವತ್ತು ಒಂದು 16,000ಕ್ಕೂ ಹೆಚ್ಚು ಉಪಗ್ರಹಗಳು ಭೂಮಿನ ಸುತ್ತುತ್ತಾ ಇದೆ. ಭೂಮಿಗೆ ನಿಸರ್ಗದತ್ತವಾದ ಉಪಗ್ರಹ ಇರೋದು ಒಂದೇ, ನಮ್ಮ ಚಂದ್ರ. ಇತ್ತೀಚೆಗೆ 1957ರಿಂದ ಆಚೆಗೆ ಸುಮಾರು 16,000ಕ್ಕೂ ಹೆಚ್ಚು ಸ್ಯಾಟಲೈಟ್ಗಳನ್ನ ಉಡಾಯಿಸಿದ್ದೀವಿ. ಆದರೆ ಅದರಲ್ಲಿ ಎಲ್ಲ ಎಷ್ಟೊಂದು ಕೆಲಸ ಮುಗಿದು ಕೆಳಗೆ ಬಿದ್ದು ಹೋಗಿದೆ. ಆದರೆ ಇವತ್ತು ದೊಡ್ಡ ಸಂಖ್ಯೆಯಲ್ಲಿ ಸಾವಿರಾರು ಉಪಗ್ರಹಗಳು ಸುತ್ತುತ್ತಾ ಇವೆ. ನಮ್ಮ ರಾಕೆಟು ಮೇಲೋಗಿ ಅದನ್ನು ಬೇಕಾದ ಕಕ್ಷೆಗೆ ಸೇರಿಸ್ಬೇಕಾಗತ್ತೆ. ಆ ವೇಳೆಯಲ್ಲಿ ಇನ್ನೊಂದು ಯಾವ್ದಾರ ಬಂದು ಅದಕ್ಕೆ ಘಾಸಿಗೊಳಿಸೋ ಸಾಧ್ಯತೆ ಇದೆ ಅಂತ ಗೊತ್ತಾದರೆ, ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ ನಾವು ಆ ನಮ್ಮ ಉಡಾವಣಾ ವೇಳೆ ಏನಿದೆ, ಉಡಾವಣಾ ಸಮಯ, ಅದನ್ನು ಆಚೀಚೆ ಸ್ವಲ್ಪ ಕೆಲವು ಸೆಕೆಂಡುಗಳು, ಅರ್ಧ ನಿಮಿಷ, ಆ ರೀತಿ ಅದನ್ನು ವಿಳಂಬ ಮಾಡ್ಬೋದು. ಆಮೇಲೆ ಇದೇ ಈ ರಾಕೆಟ್ನ ಉಡಾಯಿಸುವಾಗ ಯಾವ ರೀತಿ, ಮಿಸೈಲ್ಗಳನ್ನ ಉಡಾಯಿಸುವಾಗ ಯಾವ ರೀತಿ ಏನು ಜಾಗರೂಕತೆ ತೆಕ್ಕೋಬೇಕಾಗತ್ತೆ, ಯಾವ ರೀತಿ ಸಿದ್ಧತೆಗಳನ್ನು ಮಾಡ್ಕೋಬೇಕಾಗತ್ತೆ ಅಂತ ಡಾಕ್ಟರ್ ಪ್ರಹ್ಲಾದ್ ಅವರು ಹೇಳಿದರು. ಇವಾಗ ನೋಡಿ, ಚಂದ್ರನತ್ತ, ಮಂಗಳ ಗ್ರಹದ ಹತ್ರ, ಸೂರ್ಯನತ್ತ, ಆ ರೀತಿ ನಾವು ರೋಬೋಟ್ ನೌಕೆಗಳನ್ನು ಉಡಾಯಿಸಬೇಕಾದ್ರೆ ಲಾಂಚ್ ವಿಂಡೋ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಉಡಾವಣಾ ಗವಾಕ್ಷಿ ಅಂತ ಹೇಳ್ಬೋದು. ಅದೆಲ್ಲ ಕನ್ನಡದಲ್ಲಿ ಬಳಕೆ ಇಲ್ಲ, ಏನಿಲ್ಲ. ಲಾಂಚ್ ವಿಂಡೋ ಅನ್ನೋದೇ ಇದೆ. ಯಾಕೆ ಅಂದರೆ ನೀವು ಅತ್ಯಂತ ದಕ್ಷವಾಗಿ ಸುರಕ್ಷಿತವಾಗಿ ಒಂದು ನೌಕೆನ ಲಕ್ಷಾಂತರ ಕಿಲೋಮೀಟ್ರು ಇಲ್ಲ ಕೋಟ್ಯಾಂತರ ಕಿಲೋಮೀಟ್ರ್ ದೂರದಲ್ಲಿರೋ ಒಂದು ಆಕಾಶಕಾಯಕ್ಕೆ ಕಳಿಸ್ಬೇಕಾದ್ರೆ ಭೂಮಿಯ ಸ್ಥಾನ ಸೂರ್ಯನ ಸುತ್ತ ಎಲ್ಲಿದೆ, ಚಂದ್ರನತ್ತ ಕಳಿಸಿದ್ರೆ ಚಂದ್ರನ ಸ್ಥಾನ ಸೂರ್ಯನಿಗೆ ಭೂಮಿಗೆ ಹೋಲಿಸಿದ್ರೆ ಅದೆಲ್ಲಿದೆ, ಆಮೇಲೆ ಮೊದಲನೇದಾಗಿ ಯಾವ ಪ್ರಾಥಮಿಕ ಕಕ್ಷೆಗೆ ಹಾಕ್ತೀವಿ, ಪ್ರಿಲಿಮಿನರಿ ಆರ್ಬಿಟ್ಗೆ, ಅಲ್ಲಿಂದ ಯಾವ ರೀತಿ ಕಳಿಸ್ತೀವಿ, ಇದನ್ನೆಲ್ಲ ಗಣಿತಾತ್ಮಕವಾಗಿ ಮ್ಯಾಥಮ್ಯಾಟಿಕಲಿ ವಿ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್. ಒಂದೇ ಒಂದು ಸಂಗತಿ ಹೇಳ್ತೀನಿ ನೋಡಿ, ನಾನು ಗಮನಿಸಿರೋದು ಇದು. ಅಕ್ಟೋಬರ್ 22, 2008ರಂದು ನಮ್ಮ ಚಂದ್ರಯಾನ ಒಂದು ನೌಕೆ, ನಾ ಹೇಳಿದೆ ಚಂದ್ರನ ಮೇಲೆ ನೀರನ್ನು ಗುರುತಿಸ್ತು, ಅದನ್ನು ಉಡಾಯಿಸಬೇಕಾದಾಗ ಬೆಳಗ್ಗೆ 6:22 ಅಕ್ಟೋಬರ್ 22ನೇ ತಾರೀಕು 2008ರಂದು ಉಡಾಯಿಸಬೇಕಾಗಿತ್ತು. ನೋಡಿದ್ರೆ 2 ದಿವಸದ ಹಿಂದಿಂದ ಮಳೆ ಹುಯ್ತಾ ಇದೆ. ಯಾವ ರೀತಿ, ಇನ್ ಇಂಗ್ಲೀಷ್ ದೇ ಸೇ ರೈನಿಂಗ್ ಕ್ಯಾಟ್ಸ್ ಆ್ಯಂಡ್ ಡಾಗ್ಸ್ ಅಂತ, ಆ ರೀತಿ ಇಡೀ ಪೂರ್ವ ಕರಾವಳಿನಲ್ಲಿ, ಆಗ್ನೇಯ ಕರಾವಳಿನಲ್ಲಿ, ಸೌತ್ ಈಸ್ಟಲ್ಲಿ ಮಳೆ ಹುಯ್ತಾ ಇದೆ. ಆದರೂ ಜಗತ್ತಿನಿಂದ ಅನೇಕ ಕಡೆಗಳಿಂದ ಪತ್ರಿಕಾ ಬಾತ್ಮೀದಾರರು, ರೇಡಿಯೋದವರು, ಟಿ ವಿನವರೆಲ್ಲ ಬಂದುಬಿಟ್ಟಿದ್ದಾರೆ. ಬೆಳಗ್ಗೆ ಉಡಾವಣೆ ಇದ್ದಿದ್ದರಿಂದ 6:22 ನಾನು ಅವಾಗ ಅವ್ರನ್ನೆಲ್ಲ ಬಹುಶಃ 4 ಗಂಟೆಗಾದರೂ ಅಲ್ಲಿರೋ ಹಂಗೆ ಕರ್ಕೊಂಡು ಹೋಗ್ಬೇಕು. ಯಾಕಂದರೆ ಅವರು ಬೆಳಗ್ಗೆ ಫ್ರೆಶ್ ಅಪ್ ಆಗಬೇಕು, ಅಲ್ಲಿ ಎಲ್ಲ ಸಿದ್ಧತೆಗಳು ಮಾಡಿದ್ವಿ ಇಸ್ರೋಲಿ. ಆದರೆ ಹಾಗಾಗಿ ಚೆನ್ನೈಯಿಂದ 1 ಗಂಟೆಗೆ ಹೊರಡಬೇಕಾಯಿತು. ಮಳೆ ಹೆಂಗೆ ಹುಯ್ತಾ ಇದೆ ಅಂದರೆ, ಮಳೆ ಬರ್ತಾ ಇದೆ. ನಾವು ಶ್ರೀಹರಿಕೋಟ ಅನ್ನೋದು ಒಂದು ದ್ವೀಪ. ಆ ದ್ವೀಪಕ್ಕೆ ಮುಂಚೆ ನಮ್ಮ ಕರಾವಳಿ, ಆಗ್ನೇಯ ಕರಾವಳಿಲಿ ಸುಳ್ಳೂರುಪೇಟ ಅಂತ ಒಂದು ಪ್ಲೇಸ್ ಇದೆ ಆಂಧ್ರ ಪ್ರದೇಶಲ್ಲಿ. ಅಲ್ಲಿ ಹೋಗ್ಬಿಟ್ಟು ಅಲ್ಲಿಂದ ಒಂದು ಬ್ರಿಡ್ಜ್ ಮಾಡಿದ್ದಾರೆ, ಸುಳ್ಳೂರುಪೇಟನ ಕ್ರಾಸ್ ಮಾಡಿ ರೋಡೇ ಮಾಡಿದ್ದಾರೆ. ಅಲ್ಲಿ ಹೋಗಬೇಕು. ನೀವು ನಂಬ್ತಿರೋ ಬಿಡ್ತಿರೋ ಇದನ್ನು ನನಗೆ ಹೆಂಗೆ, ನಾನು ವಿಜ್ಞಾನದಲ್ಲಿ ಕೆಲಸ ಮಾಡೋದ್ರಿಂದ ನಂಗೆ ಇದನ್ನು ಹೆಂಗೆ ವಿವರಿಸಬೇಕು ಅಂತ ಗೊತ್ತಿಲ್ಲ, ಅರ್ಥೈಸಬೇಕು ಅಂತ ಗೊತ್ತಿಲ್ಲ. ಅವತ್ತು ಇಸ್ರೋದ ಮುಖ್ಯಸ್ಥರಾಗಿದ್ದವರು ಮಾಧವನ್ ನಾಯರ್ ಅವರು ಒಂದು ನಿರ್ಧಾರ ತಗೊಂಡು, ಏನೇ ಆದ್ರೂ ನಾವು ಉಡಾಯಿಸಲೇಬೇಕು. ಅಕ್ಟೋಬರ್ 22ನೇ ತಾರೀಕು ಬೆಳಗ್ಗೆ 6:20 ನೋಡಿ, 6:22 ಉಡಾಯಿಸಬೇಕು. ಎಲ್ಲಿ ಮಳೆ ಬರ್ತಾ ಇದೆ, ಹೆಂಗೆ ಉಡಾಯಿಸೋಣ? ಆದರೆ ಜೊತೆಗೆ ರಾಕೆಟಲ್ಲಿ ಬೇರೆ ತೊಂದರೆ ಬಂದುಬಿಟ್ಟಿದೆ. ಏನು ಮಾಡೋದು? ಆದರೆ ಅವರು ಅಚಲವಾದ ನಿರ್ಧಾರ ತಗೊಂಡು, ಇಲ್ಲ ನಾವು ಉಡಾಯಿಸಲೇಬೇಕು, ಏನೇ ಆಗಲಿ, ನೀವೇನು ಮಾಡ್ತೀರೋ ಗೊತ್ತಿಲ್ಲ, ಅದನ್ನು ಸರಿ ಮಾಡಿ. ನಾನು ಈ ಪತ್ರಿಕಾ ಬಾತ್ಮೀದಾರರು ಅವ್ರನ್ನೆಲ್ಲ 3 ಬಸ್ಸಲ್ಲಿ ಕರ್ಕೊಂಡು ಹೋಗ್ತಾಯಿದ್ದೀನಿ. ಸುಳ್ಳೂರುಪೇಟದ ಒಂದು ಕಡೆ ಹೋಗಿದ್ದೀನಿ. ಒಂದು 2-3 ಕಿಲೋಮೀಟ್ರ್ ಕ್ರಾಸ್ ಮಾಡಬೇಕಿತ್ತು. ಇಲ್ಲಿ ನಾನು ಸುಳ್ಳೂರುಪೇಟೆಗೆ ಈ ಕಡೆ ಬರ್ತಾ ಇದ್ದೀನಿ, ಯಾವ ರೀತಿ ಮಳೆ ಬರ್ತಾ ಇದೆ ಅಂದರೆ ನಂಬ್ತಿರೋ ಬಿಡ್ತಿರೋ, ಅಲ್ಲಿಂದ 3 ಕಿಲೋಮೀಟ್ರ್ ದಾರಿ ಅಷ್ಟೊತ್ತಿಗೆ ಇದ್ದಕ್ಕಿದ್ದಂಗೆ ಮಳೆ ನಿಂತೋಯ್ತು. 2 ದಿವಸದಿಂದ ಮಳೆ ಹೋಯ್ತಾ ಇದೆ, ನಿಂತೋಯ್ತು. ಸುಮಾರು 3:30-4 ಗಂಟೆಯಲ್ಲಿ ಸುಮಾರು, ಅಷ್ಟೇ ಜ್ಞಾಪಕ ಇಲ್ಲ, ಅಷ್ಟಾಗಿ 3:30-4ರಲ್ಲಿ ಆಯಿತು. 6:22ಕ್ಕೆ PSLV ರಾಕೆಟ್ 15 ಮಾಡಿ ಎತ್ತರದ್ದು ಹೋಯಿತು ಮೇಲೆ. ಹೋಗಿ ಚಂದ್ರಯಾನ ನೌಕೆನ ಪ್ರಾಥಮಿಕ ಕಕ್ಷೆಗೆ ಭೂಮಿ ಸುತ್ತ ಉಡಾಯಿಸ್ತು ಕೂಡ. ನಂಬ್ತಿರೋ ಬಿಡ್ತಿರೋ 7 ಗಂಟೆಗೆ ಕೆಲವು ನನ್ನ ಜರ್ನಲಿಸ್ಟ್ ಮಿತ್ರರ ಜೊತೆ ತಿಂಡಿ ತಿಂತಾ ಇದ್ದೆ. 7 ಗಂಟೆಗೆ ತಿರ್ಗಾ ಮಳೆ ಶುರುವಾಗಿದೆ, ರಾಕೆಟ್ ಮೇಲೆ ಹೋದ್. ಏನು ಹೇಳೋಣ ಇದಕ್ಕೆ, ಏನು ಅಂತ ಗೊತ್ತಿಲ್ಲ ನನಗೆ. ಅದು ಏನು ಅಂತ ನಾನೇನು ಹೇಳೋದಕ್ಕಾಗದ್ರೆ ಏನು ಹೇಳಿದ್ರು ತಪ್ಪಾಗತ್ತೆ. ಹಾಗಾಗಿ ನೋಡಿ ಯಾವ ರೀತಿ ಆಗುತ್ತೆ. ಅದೇ ರೀತಿ 2 ಗಂಟೆ 38 ನಿಮಿಷ ಇರಬೇಕು ಕರೆಕ್ಟಾಗಿ. ನಾವು ಇದೇ PSLVನ ನವಂಬರ್ 5, 2013ರಂದು ಮಂಗಳ ಗ್ರಹದತ್ತ ಕಳಿಸ್ಬೇಕಾದ್ರೆ ಪ್ರಾಥಮಿಕ ಕಕ್ಷೆಗೆ ನಾವು ಉಡಾಯಿಸ್ಬೇಕಾಯ್ತು. ನೋಡಿ ಆ ಥರ, ಅದಕ್ಕೇನು ತೊಂದರೆ ಬರಲಿಲ್ಲ, ಕರೆಕ್ಟಾಗಿ ಅಲ್ಲಿ ಹೋಗುತ್ತೆ. ಯಾಕಂದರೆ ಮಂಗಳ ಗ್ರಹದ ಸ್ಥಾನ, ಭೂಮಿ ಸ್ಥಾನ, ಸೂರ್ಯನ ಸ್ಥಾನ ಜಾಮಿತಿಯ ದೃಷ್ಟಿಯಿಂದ, ಜೊಮೆಟ್ರಿಕಲಿ ಸ್ಪೀಕಿಂಗ್ ಯಾವ ಥರ ಇದೆ ಅನ್ನೋದು ಬಹಳ ಬಹಳ ಮುಖ್ಯ. ಥ್ಯಾಂಕ್ ಯು.
ಇನ್ನೊಂದು ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್.
Good afternoon, sir. Myself, Prerana from second year BSc. And my question is for Professor Vidyagraj, sir. So why is theoretical physics important, even if it does not have immediate practical applications?
Sure. So, do you know how dosa is made? Do you know how dosa is made? You know? You have to soak, no? You have to soak rice and dal overnight. Right?
Yeah. Sir. Gottu.
Gottalva? So, you have to prepare for one night before to make the dosa.
Yes.
Correct, right?
Yes.
You can't make it immediately. Something similar is happening here. You have to do not just theoretical physics, you have to do science. And science converting to technology, sometimes it can take decades. In fact, one of the first discoverers of electricity, okay, for example, Michael Faraday, he was also asked, what is the use of all of this? Okay, he said, maybe one day you can tax it. Right? But today, our mobile phones, our electromagnetic devices, our, all the communication devices, they work on Maxwell's equations. Correct?
Yes.
If you use Newton's laws, when they were originally discovered, he discovered those laws for explaining the motion of certain small objects. Right? But today's engineering subjects, civil engineering, mechanical engineering, chemical engineering, in the form of other kinds of equations like Navier-Stokes equations, they are the basis of chemical engineering. Okay? So, if you combine Newton's laws and electromagnetism, again new kinds of devices come out. So, what I am trying to say is that theoretical physics alone or experimental physics or science is necessary if you want to bring out technology which is technology of the future. Today's science will become technology, but it will take time. In fact, in the morning I showed the journey from science to technology.
Yes.
And the journey from science to technology can take decades. Okay? In fact, now we are in the midst of quantum 2.0. Quantum mechanics itself is more than 100 years old. But some of the concepts of quantum mechanics have not been utilized and made into technology, right? Yes. It is almost 100 years, you can see. But now those devices are coming into picture, like a quantum computer, okay? Quantum encryption, quantum communication, these are just now coming into existence. So it takes a lot of time for science to become technology, okay? But if you don't do science, there is no hope for technology, right? So that is important and that is necessary, and it takes time for science to get converted to technology.
Thank you, sir.
Good afternoon all. I am Vyoma from 3rd BSc. My question is for Dr. B.R. Guruprasad sir. What role do planetarium play in inspiring the next generation of scientists?
Yeah. It's okay. What role planetariums, it is planetarium antare. It is not planetarium, okay, do play in inspiring students. No doubt about it. Yes, fantastic question. Give her a big hand. In fact, this is the kind of... See, planetaria, they no doubt play a very significant role. Because, education means it is not only learning in the class or something. Ultimately, what education? Education means samasye elle barli, challenge elle barli, how to face it. Annodana, whether in terms of physics, chemistry or mathematics or elsewhere. That is the thing. So whatever you learn in the class is not sufficient. In order to understand your subjects in a better way, in a more inspiring way, making education more meaningful and to inspire students, definitely planetariums will do a lot, because they conduct a lot of programs. Astronomy is one of the oldest scientific habits of human beings. For thousands of years, ಎಲ್ಲ ನಾಗರಿಕತೆಗಳಲ್ಲೂ ಅಂತರಿಕ್ಷದಲ್ಲಿ ಏನು ಕಾಣುತ್ತೆ, ಯಾವ ರೀತಿ ಆಕಾಶಕಾಯಗಳ ಚಲನೆ ಇದೆ ಅಂತ ಇದು ಮಾಡ್ತೀವಿ. ಅದನ್ನೇ ನಾವು ಭ್ರಮೆನ ಉತ್ಪಾದಿಸ್ತೀವಿ ನಮ್ಮ ಆಕಾಶ ಮಂದಿರದಲ್ಲಿ. ಹಾಗಾಗಿ by observing these things, you can better understand physics, chemistry and mathematics. For example, I'll give you an example. In the planetarium sky show, you see a spacecraft nearing a planet, and the gravity of the planet, how it deflects the path of the spacecraft itself. That you can understand. That is where Newton's law of gravitation comes into picture. This is just one example. Similarly, how to launch a satellite into orbit. Many other things can be taught by planetarium by projecting things in a very, very impressive way. So, by taking concepts in physics, taking concepts in space and astronomy, teachers can better teach physics, chemistry and mathematics, and students can better understand. ಆಮೇಲೆ ಪ್ಲಾನೆಟೇರಿಯಮ್ಸಲ್ಲಿ ಸರಿಯಾಗಿ ನಮ್ಮಲ್ಲಂತೂ ಸಾಕಷ್ಟು ಕಾರ್ಯಕ್ರಮಗಳಿದೆ. ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ ಪ್ರಯೋಗಗಳನ್ನು, ಚಟುವಟಿಕೆಗಳನ್ನು, ಅಂದರೆ ಆ್ಯಕ್ಟಿವಿಟಿ ಬೇಸ್ಡ್ ಟೀಚಿಂಗ್ ಇರುತ್ತಲ್ಲ, ಅದನ್ನು ನಡೆಸೋ ಮೂಲಕ ಎಜುಕೇಷನ್ ಅಂತ ನಾವೇನು ಹೇಳಿ ಶಿಕ್ಷಣವನ್ನು ಮತ್ತಷ್ಟು ಅರ್ಥಪೂರ್ಣವಾಗಿ ಮಾಡಬಹುದು. ಇದರಲ್ಲಿ ಏನೂ ಉತ್ಪ್ರೇಕ್ಷೆ ಇಲ್ಲ, ನೋ ಎಕ್ಸಾಜರೇಷನ್. ಹಾಗಾಗಿ from all these points of view, encouraging hands-on activities, teaching in an impressive way, and to provoke you to think more, definitely through conspicuous visuals in the sky theater and through programs, planetariums can inspire students in a better way. No doubt about it. You got your answer? Good.
Thank you, sir.
ಏನಂದರೆ ಪ್ಲಾನೆಟೇರಿಯಂ ದೇಶದಲ್ಲಿ ಹಲವು ಕಡೆ ಇದ್ರೂ ಬೆಂಗಳೂರಿನದ್ದು ತಾರಾಲಯವನ್ನು ಅತ್ಯುತ್ತಮವಾದ ತಾರಾಲಯ ಅಂತ ನಾನು ಹೇಳ್ತಾ ಇದ್ದೇನೆ. ಯಾಕೆಂದರೆ ಅಲ್ಲಿ ಬಂದಂಥ ಎಲ್ಲ ಡೈರೆಕ್ಟ್ರುಗಳು, ಇಡೀ ಬೆಂಗಳೂರಿನಲ್ಲಿ ಮಕ್ಕಳು ಅಲ್ಲಿ ಕಿಂಡರ್ ಗಾರ್ಡನ್ನಿಂದ MSc ಓದುವಂಥ ಮಕ್ಕಳಿಗೆ ಟ್ರೈನಿಂಗ್ ಕೊಡ್ತಾ ಇದ್ದಾರೆ. ಅಂದರೆ ಅಲ್ಲಿಯ ಸೈಂಟಿಸ್ಟ್ಗಳು. ಅಷ್ಟು ಮಾತ್ರ ಅಲ್ಲ, ಇಡೀ ಪ್ಲಾನೆಟೇರಿಯಂನ ಎದುರುಗಡೆ ಹಲವು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್ಗಳು, ಅದ್ಭುತವಾದ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್ಗಳು. ಇವರು ಮಾಡುವ ಕೆಲಸ ಎಷ್ಟು, ಬೇರೆ 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 ಪ್ರೋಗ್ರಾಮ್ಗಳು, ಯಾರ್ಯಾರಿಗೆ ಯಾವ್ಯಾವ ರೀತಿ ಆಕಾಶದ ಪ್ರೋಗ್ರಾಮ್ ಬೇಕು ಅಂತ ಮಾಡ್ತಾಯಿದ್ದಾರೆ. ತುಂಬ ಒಳ್ಳೆ ಕೆಲಸ ಮಾಡುವಂತಹ ಬೆಂಗಳೂರಿನ ತಾರಾಲಯದಲ್ಲಿ ನಮ್ಮ ಮಿತ್ರ ಗುರುಪ್ರಸಾದ್ ಸರು ಇದ್ದಾರೆ ಅಂತ ಹೇಳೋದು ಹೆಮ್ಮೆ. ನಮ್ಮ ಹೆಮ್ಮೆಯ ತಾರಾಲಯ ಬೆಂಗಳೂರಿನ ತಾರಾಲಯ.
ಖಂಡಿತ ದಯಮಾಡಿ ಬೆಂಗಳೂರಿಗೆ ಬಂದಾಗ ಎಲ್ಲರೂ ತಾರಾಲಯಕ್ಕೆ ಬನ್ನಿ. ಅಲ್ಲಿರುವಂತಹ ಕಾರ್ಯಕ್ರಮಗಳನ್ನು ಖಂಡಿತ ಪರಿಚಯ ಮಾಡಿಕೊಡ್ತೀವಿ. ತಾವು ಬಂದು ಕೆಲವುದರಲ್ಲಿ ಭಾಗವಹಿಸಿ ನೋಡಿ ಆನಂದಿಸಬಹುದು. ಇವತ್ತು ಕೂಡ ಪೂರ್ಣಪ್ರಜ್ಞಾ ಕಾಲೇಜಲ್ಲಿ ವಾಟರ್ ರಾಕೆಟ್ ಅನ್ನೋದನ್ನು, ನೀರಿನ ರಾಕೆಟ್ನ ತಂದುಬಿಟ್ಟು ಸ್ವಾಮೀಜಿ ಕೈಯಲ್ಲೇ ಒಂದು ಲಾಂಚ್ ಮಾಡಿಸಿದ್ವಿ. ಹಾಗಾಗಿ ನೋಡಿ, ಈ ರೀತಿ ಆ್ಯಕ್ಟಿವಿಟಿ ಬೇಸ್ಡ್ ಎಜುಕೇಷನ್ ಈಸ್ ಫಾರ್ ಮೋರ್ ಮೀನಿಂಗ್. ನ್ಯೂಟನ್ಸ್ ಫಸ್ಟ್ ಲಾ ಬೇಕಾ ಟೀಚ್ ಮಾಡ್ಬೋದು, ವಾಟರ್ ರಾಕೆಟ್ ಸೆಕೆಂಡ್ ಲಾ ಬೇಕಾ, ಥರ್ಡ್ ಲಾ ಬೇಕಾ ಮಾಡ್ಬೋದು. ಆ ರೀತಿ. ಥ್ಯಾಂಕ್ ಯು.
Good afternoon, sir. My name is Navya MR from first PSC. My question is for Dr. Vinayaka K. Pattar, sir. So, what are the exciting real-world applications of optoelectronics that we students should know about?
optoelectronics ಅಂತಂದರೆ ಇಲ್ಲಿ ಎಷ್ಟೋ ಜನ PU ಮಕ್ಕಳಿದ್ದೀರಾ, ನಿಮಗೆ ಅದ್ರ ಬಗ್ಗೆ ಗೊತ್ತಿರುತ್ತೆ. ಈ ಲೈಟಿಗೆ ಸಂಬಂಧಪಟ್ಟದ್ದು ಅಪ್ಟೋ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಈ ಸೆಮಿಕಂಡಕ್ಟರ್ ಸೈನ್ಸ್ನ ನೀವು ಕಲ್ತಿರ್ತೀರ, ಎಲಿಮೆಂಟಲ್ ಸೆಮಿಕಂಡಕ್ಟರ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಈ ಸಿಲಿಕಾನ್ ಆರ್ ಜರ್ಮೇನಿಯಮ್ ಅಂತ ಕೇಳಿರ್ತೀರಲ್ವಾ? ಅದೇ ಥರನೇ ಈ ಕಾಂಪೌಂಡ್ ಸೆಮಿಕಂಡಕ್ಟರ್ ಅಂತ ಇರುತ್ತೆ. ಕ್ಯಾಲ್ಮಿಯಂ ಸೆಲ್ನೈಡು, ಈ ಥರ ಗ್ಯಾಲಿಯಮ್ ನೈಟ್ರೇಟು, ಇದು ಕಾಂಪೌಂಡ್ ಸೆಮಿಕಂಡಕ್ಟರ್. ಅಪ್ಟೋ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಅಂದರೆ ಯು ಹ್ಯಾವ್ ಟು ಪ್ಲೇ ವಿತ್ ದ ಲೈಟ್ ಆ್ಯಂಡ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ. ಲೈಟಿಂದ ಎಲೆಕ್ಟ್ರಿಸಿಟಿನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ಬೋದು. ಸೋಲಾರ್ ಪ್ಯಾನಲ್ಸ್ ನಿಮ್ಮ ಮನೆ ಮೇಲ್ಗಡೆ ಇರುತ್ತಲ್ಲ, solar panel, you can generate the electricity. ಅದಕ್ಕೆ ಆಪ್ಟಿಕಲ್ ಎನರ್ಜಿ ಟು ದಿ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿಯಿಂದ ಆಪ್ಟಿಕಲ್ ಎನರ್ಜಿ ಮಾಡಬೇಕಂದ್ರೆ ಕ್ಯಾನ್ ಯು ಗಿವ್ ಮಿ ಎಕ್ಸಾಂಪಲ್? ಐಡಿಯಾ ಇದೆನಾ? ಇವಾಗ ನಿಮ್ಗೆ ಗೊತ್ತಾಯಿತು, ಲೈಟು ಸನ್ಲೈಟು ಪ್ಯಾನಲ್ ಮೇಲೆ ಬೀಳುತ್ತೆ, ಅಲ್ಲಿಂದ ನಿಮಗೆ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ಸೋಲಾರ್ ಸೆಲ್. ಇವಾಗ ಉಲ್ಟಾ ರಿವರ್ಸ್ ಆಗಬೇಕಲ್ವಾ? ಏನು? ಎಲೆಕ್ಟ್ರಿಸಿಟಿಯಿಂದ ಲೈಟ್ ಬರಬೇಕು ನನಗೆ. LED, light emitting diodes. These are semiconducting material, that is a gallium nitride thin film. ಓಕೆನಾ? ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ನಮ್ಮ ಪ್ರೀವಿಯಸ್ ಲ್ಯಾಬಲ್ಲಿ ನಾನು ವರ್ಕ್ ಮಾಡಬೇಕಾದ್ರೆ ಅಪ್ ಟು ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಮೇಲೆ ವರ್ಕ್ ಮಾಡ್ತಾಯಿದ್ದೆ. ಗ್ಯಾಲಿಯಮ್ ನೈಟ್ರೇಟ್, ಇಂಡಿಯಮ್ ಗ್ಯಾಲಿಯಮ್ ನೈಟ್ರೇಟ್, ಇವಾಗ ನಿಮ್ಮ ಮೊಬೈಲ್ ಫ್ಲ್ಯಾಶಲ್ಲಿರುತ್ತೆ, ಇವಾಗ LED ಬಲ್ಪ್ಗಳಿಗೆ ಬಂದಿದ್ದಾವೆ ಹೊಸದೆಲ್ಲ. ದೀಸ್ ಆರ್ ಆಲ್ ಅಪ್ ಟು ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಮಟೀರಿಯಲ್ ಇನ್ಕ್ಲೂಡಿಂಗ್ ಸೋಲಾರ್ ಸೆಲ್ಸ್. ಇದ್ರದ್ದು ಅಪ್ಲಿಕೇಶನ್ ನೀವು ಮೊಬೈಲ್ ಸ್ವಿಚ್ ಆನ್ ಮಾಡಿದ ತಕ್ಷಣ ಯು ಸ್ಟಾರ್ಟ್ ಸೀಯಿಂಗ್ ದ್ಯಾಟ್. ಓಕೆ, that is the application of up to electronics. ಆಮೇಲೆ ಮೇನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಈ ಅಪ್ ಟು ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ದು ಅಪ್ಲಿಕೇಶನ್ಸು. ಇವಾಗ ನಾನು ಏನು ಮಾತಾಡ್ತಾ ಇದ್ದೀನಿ, ಕಮ್ಯುನಿಕೇಷನ್ ಆಗ್ತಾ ಇದೆ. ಸಿ ದಟ್ ವೈರ್ಲೆಸ್ ಕಮ್ಯುನಿಕೇಷನ್ ವಿಚ್ ಈಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ದಿ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ ಕೇಬಲ್, ಆ್ಯಂಡ್ ವಾಟ್ ಎವರ್ ದ ಲೈಟ್ ಸಿಗ್ನಲ್ ವಿಲ್ ಬಿ ಟ್ರಾನ್ಸ್ಮಿಟೆಡ್, ವಾಟ್ ಎವರ್ ದ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸಿಗ್ನಲ್. ಈಗ ನಾನು ಮಾತಾಡ್ತಾ ಇರೋದು ಮೆಕ್ಯಾನಿಕಲ್ ಎನರ್ಜಿ, ಹೌದಲ್ವಾ? ಈ ಮೆಕ್ಯಾನಿಕಲ್ ಎನರ್ಜಿ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಡಿವೈಸಲ್ಲಿ ಡಿಜಿಟಲ್ ಫಾರ್ಮಾಗಿ, ಅಗೇನ್ ಇಟ್ ವಿಲ್ ಬಿ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಅದರ್ ಸಿಗ್ನಲ್. ಹೌದಾ? ದೆನ್ ಇಟ್ ವಿಲ್ ಗೋ ಆ್ಯಂಡ್ ರೀಚ್ ಟ್ರಾನ್ಸ್ ರಿಸೀವರ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಅಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ. ಅಲ್ಲಿಂದ ಏನು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ. ಸಿ ದಿಸ್ ಅ ಬ್ಯೂಟಿಫುಲ್ ಕಾನ್ಸೆಪ್ಟ್. ವಿತೌಟ್ ದಿಸ್ ಅಪ್ ಟು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಯು ಕೆನಾಟ್ ಡೂ ಇಟ್ ಅಟ್ ಪ್ರೆಸೆಂಟ್ ಫ್ಯೂಚರ್ ಅಲ್ಲಿ, ಇವಾಗ ಪ್ರೆಸೆಂಟಲ್ಲಿ. ಆಮೇಲೆ ಈಗ ಗೈಡೆಡ್, ಇವಾಗ ನಿಮ್ಗೇನಾದರೂ ಹೊಟ್ಟೆ ಒಳಗಡೆ ಏನಾದರೂ ಹುಣ್ಣಾಗಿತ್ತು ಅಂದರೆ ದೇ ವಿಲ್ ಸೆಂಡ್ ಒನ್ ಲೈಟ್, ದಟ್ ಈಸ್ ಅ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ ಕೇಬಲ್. ದೀಸ್ ಆರ್ ಆಲ್ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಅಪ್ ಟು ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್. ಇಟ್ಸ್ ಅ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಆಲ್ ದ ಮೊಬೈಲ್ ಫೋನ್, ಆಲ್ ಯುವರ್ ಯೂಟ್ಯೂಬ್ ವಿಡಿಯೋಸ್, ಆ್ಯಂಡ್ ಈ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ ಕೇಬಲ್ ಇದೆಯಲ್ಲ, ಒಂದು ಕಾಂಟಿನೆಂಟಿಂದ ಇನ್ನೊಂದು ಕಾಂಟಿನೆಂಟಿಗೆ ಇಟ್ ಈಸ್ ಇಂಟರ್ ಕನೆಕ್ಟೆಡ್. ನೀನು ಯೂಟ್ಯೂಬ್ ವಿಡಿಯೋ ಹೈ ಸ್ಪೀಡಲ್ಲಿ ಹಿಂಗೆ ಕ್ಲಿಕ್ ಮಾಡಿದ ತಕ್ಷಣ ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟಲ್ಲಿ ನಿಮ್ಮ ಮೊಬೈಲ್ ಒಳಗಡೆ ನೀವು ವಿಡಿಯೋನ ನೋಡ್ಬೋದು ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್ ಟೆಕ್ನಾಲಜಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.
I am Priya from first PSC. My question is for Vidya Dheeraj sir. Could you please share with us what are the unanswered questions in a physics that makes you most excited?
Yes, so what's your name?
Priya.
Priya. So Priya is asking what are the unanswered questions in physics which make us feel excited and which make us more curious to answer them, correct? So there are, Priya, so there are many websites that you can also see in every domain, whether you take astrophysics, whether you take nuclear physics, particle physics, materials physics, okay, every field of physics there are certain grand challenge problems. Okay, in my own field the grand challenge problem is that if you take a material which has very strong electron-electron interaction but it also has a large amount of disorder, okay, then how do you predict the behavior of that material? What kind of phase transitions will happen in that material? That is one of the grand challenge problems. Okay, this is the combination of interactions and disorder. That's what we say, right? But so that is one grand challenge problem. The second grand challenge problem is how do you make a material which is a very robust qubit? I was talking about a quantum computer in the morning, if you remember, right? Quantum computer is made out of qubits, quantum bits. Okay. Now these qubits are actually very delicate objects, extremely delicate objects. You have to cover them, you have to shield them from electromagnetic radiation, from vibration, from all kinds of interferences. Okay, and that's the reason why you have to store them at millikelvin temperature, and it's also very difficult to entangle them. Okay, so one of the grand challenges problems right now, which has an implication in the next 5 to 10 years, is how do you make qubits which are more robust towards interference, and how do you create protocols for entangling these qubits? Okay, so if you can entangle them very effectively, then you can make a quantum computer which is much bigger and which will also operate at higher temperatures. Okay, you don't have to go down to millikelvin temperatures. So similarly, there are other problems in particle physics, which is not something that I am working on, but some of my colleagues are working on that. So what they're trying to do is to unify different theories. Okay, like electromagnetism is a unification of electricity and magnetism, which is what Maxwell did. Then there was another unification that happened later, which was electromagnetism with weak interactions. Okay. So then there was another unification of quantum mechanics with relativity, which is quantum electrodynamics. So like this, physicists are basically trying to unify all theories and trying to arrive at something called a grand unified theory. Okay. So that is a very important question that is driving a lot of physicists worldwide. So like this, I can go on telling you different questions. You can write to me later on, and I will direct you to some information where you can find a lot of such grand challenge problems, very interesting problems. Okay?
Thank you, sir.
ಆ ಗ್ರ್ಯಾಂಡ್ ಚಾಲೆಂಜ್ ಬಗ್ಗೆ ಹೇಳಿದರು. ಇವಾಗ ನಾನು ಎನರ್ಜಿ ಬಗ್ಗೆ ಹೇಳ್ತಾ ಇದ್ದೆ. ಇವಾಗ ಏನಾಗಿದೆ ಅಂದರೆ ನಮಗೆ ನ್ಯೂಟನ್ಸ್ ಲಾಸ್, ಕ್ಲಾಸಿಕಲ್ ಫಿಸಿಕ್ಸು, ನ್ಯೂಕ್ಲಿಯರ್ ಫಿಸಿಕ್ಸು ತುಂಬ ಚೆನ್ನಾಗಿ ಅರ್ಥವಾಗಿದೆ. ಏನು ಅರ್ಥವಾಗಿಲ್ಲ ಅಂದರೆ ಸಬ್ ಅಟಾಮಿಕ್ ಲೆವೆಲ್, ಇವ್ರು ಹೇಳಿದ್ರೆ ಕ್ವಾಂಟಮ್, ಮೂಮೆಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್, ಮೂಮೆಂಟ್ ಆಫ್ ಪ್ರೋಟಾನ್, ಮೂಮೆಂಟ್ ಆಫ್ ನ್ಯೂಟ್ರಿನೋ, ಅದು ಯಾವ ರೀತಿ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದು ಇನ್ನೂ ಸ್ಟಿಲ್ ಚಾಲೆಂಜಸ್ ಆಗಿದೆ. ತುಂಬ ಜನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದು. ಇವಾಗ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ. ನೀವಲ್ಲಿ ಫಿಸಿಕ್ಸು, ಕೆಮಿಸ್ಟ್ರಿ, ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಎಲ್ಲ ಇದ್ದಾರೆ. ತುಂಬ ಜನ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದ್ದಾರೆ. ನಾವು ಮಾಡ್ತಿದ್ದೀವಿ ಎನರ್ಜಿ ಬಗ್ಗೆ. ಅಂದರೆ ಎರಡು ಹೈಡ್ರೋಜನ್ ಆಟಮು ಕಂಬೈನ್ ಆಗಿ ಹೀಲಿಯಮ್ ಆಟಮ್ ಆಗಬೇಕು. ಅದಕ್ಕೆ ನಮಗೆ ಗೊತ್ತಿರೋ ಸೈನ್ಸ್ ಫಿಸಿಕ್ಸ್ ಪ್ರಕಾರ ಸಾಧ್ಯ ಇಲ್ಲ. ಎರಡು ಆಗಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಬ್ರಿಂಗ್ ಎ ನ್ಯೂಟ್ರಾನ್, ಹೈ ಎನರ್ಜಿ ಬರಬೇಕು ಅಂತ ಎಲ್ಲ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿರೋ ಕ್ಲಾಸಿಕಲ್ ಫಿಸಿಕ್ಸ್, ನ್ಯೂಕ್ಲಿಯರ್ ಫಿಸಿಕ್ಸ್. ಬಟ್ ಆದರೆ ನಾವು ಮಾಡ್ತಿರೋ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ಲಿ ತುಂಬ ಜನ ಅಬ್ಸರ್ವ್ ಮಾಡಿರೋದು ಆ ರೀತಿ ಹೈಡ್ರೋಜನ್ ಬಿಕಮಿಂಗ್ ಹೀಲಿಯಮ್ ಈಸ್ ಪಾಸಿಬಲ್. ತೋರಿಸ್ತೀನಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ಲಿ ತೋರಿಸ್ತಾ ಇರೋದು. ಯಾಕೆ ಆಗ್ತಿದೆ ಅದು? ಸ್ಟಿಲ್ ಎ ಚಾಲೆಂಜ್. ಇಟ್ ಇಸ್ ಸ್ಟಿಲ್ ಎ ಚಾಲೆಂಜ್. ದಿ ಪರ್ಸನ್ ಹೂ ವಿಲ್ ಗಿವ್ ದಿ ಕರೆಕ್ಟ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ in the probably decade will get a Nobel Prize. Today it's a big challenge. They don't know how it's happening. How it's happening ಇನ್ನೂ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿಲ್ಲ. ಅದೇ ರೀತಿ ತುಂಬ ಜನ ಇವಾಗ ನಾವು ಇವ್ರು ಹೇಳಿದ್ರು ಯೂನಿಫಿಕೇಷನ್ ಅಂದ್ಬಿಟ್ಟು, ಫಿಸಿಕ್ಸು, ಕೆಮಿಸ್ಟ್ರಿ, ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಎಲ್ಲನೂ ಒಂದು ಯೂನಿಫಿಕೇಷನ್ ಅಟಾಮಿಕ್ ಲೆವೆಲ್. ಯಾಕೆಂದರೆ ನಮ್ಮ ದೇಹದಲ್ಲಿರೋದು ಎಲ್ಲ ಕಡೆ ಎಲ್ಲರೂ ನೀವು ಮೆಟೀರಿಯಲ್ ತೊಗೊಳ್ಳಿ, ಮೆಟಲ್ ತೊಗೊಳ್ಳಿ, ದೇಹದ ಹ್ಯೂಮನ್ ಬಾಡಿ, ಅನಿಮಲ್ ಬಾಡಿ, ಫಿಶ್ ತೊಗೊಳ್ಳಿ, ಎಲ್ಲರೂ ಹೈಡ್ರೋಜನ್, ಪ್ರೋಟಾನ್, ನ್ಯೂಟ್ರಾನ್, ಎಲೆಕ್ಟ್ರಾನ್ ಅಷ್ಟೇ ಇರೋದು. ಒಂದು ಕಾಂಬಿನೇಷನಿಂದ ಹೈಡ್ರೋಜನ್ ಬರುತ್ತೆ, ಒಂದು ಕಾಂಬಿನೇಷನಿಂದ ಯುರೇನಿಯಂ ಬರುತ್ತೆ, ಇನ್ನೊಂದು ಕಾಂಬಿನೇಷನಿಂದ ಕ್ಯಾಲ್ಸಿಯಂ ಬರುತ್ತೆ. ಇದು ಬಿಗ್ಗೆಸ್ಟ್ ವಂಡರ್. ಪೀಪಲ್ ಆರ್ ಟ್ರೈಂಗ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಹೌ ಇಟ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್. ಒಬ್ಬರು ತುಂಬ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದ್ದಾರೆ, ಒಬ್ಬರು ಸೈಂಟಿಸ್ಟು. ಅವ್ರೇನು ಮಾಡಿದ್ರು, ಇವಾಗ ನಿಮ್ಮ ಮನೆಯಲ್ಲಿ ಕೋಳಿ ಮೊಟ್ಟೆ ತುಂಬ ಜನ ಮನೆ ಇದೆಯಲ್ವ, ಕೋಳಿ ಅದು ಅವ್ರೇನು ಮಾಡಿದ್ರು, ಕೋಳಿ ಮೊಟ್ಟೆಗೆ ಎಗ್ಗಳಿಗೆ ಏನಿರುತ್ತೆ, ಕ್ಯಾಲ್ಸಿಯಮ್ ಇರುತ್ತೆ. ನೋಡಬೇಕು, ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿಬಿಟ್ಟು ಅವನು ಒಂದು ಕೋಳಿ ಮನೆ ಇಟ್ಕೊಂಡು ಅದಕ್ಕೆ ಕ್ಯಾಲ್ಸಿಯಮ್ ಯಾವ ರೀತಿಯೂ ದೇಹದೊಳಗೆ ಹೋಗಬಾರ್ದು. ಅಂದರೆ ಅದಕ್ಕೆ ಕೊಡೋ ಬೀಜ ಕೊಡಲಿ, ಏನೇ ಕೊಟ್ಟರು ಕ್ಯಾಲ್ಸಿಯಮ್ ಇರಬಾರ್ದು. ಕ್ಯಾಲ್ಸಿಯಮ್ ಇಲ್ಲದೇ ಇರೋವಂಥ ಆಹಾರ ಕೋಳಿ ಕೊಟ್ಟೆ ಅದು 1 ತಿಂಗಳಾದರೂ ಕೋಳಿ ಆರಾಮಾಗೆ ಅದು ಮೊಟ್ಟೆ ಇಡ್ತಲೇ ಇತ್ತು. ಆ ಮೊಟ್ಟೆಯಲ್ಲಿ ಕ್ಯಾಲ್ಸಿಯಮ್ ಇರೋದು. ಅವ್ರಿಗೆ ಆಶ್ಚರ್ಯ, ನಾನು ಯಾವ ರೀತಿ ಆಹಾರದೊಳಗೂ ಕ್ಯಾಲ್ಸಿಯಮ್ ಕೊಟ್ಟಿಲ್ಲ. ಈ ಕೋಳಿ ಹೆಣ್ಣು ಯಾವ ರೀತಿ ಕ್ಯಾಲ್ಸಿಯಮ್ ಉತ್ಪಾದನೆ ಮಾಡಿಕೊಂಡು ಅವರು ಎಗ್ಗಲ್ಲಿ ಕ್ಯಾಲ್ಸಿಯಮ್ ಬರುತ್ತೆ, ಅವ್ನಿಗೆ ಅರ್ಥವೇ ಆಗಿಲ್ಲ. ಇವನ್ ಟುಡೇ ಇಟ್ ಇಸ್ ಎ ಚಾಲೆಂಜ್. ಅದೇ ರೀತಿ ನಮ್ಮ ದೇಹದೊಳಗೆ ಏನೇನು ಆಗುತ್ತೆ ಕೆಲವೆಲ್ಲ ಇನ್ನೂ ಪೂರ್ತಿಯಾಗಿ ಅರ್ಥವಾಗಿಲ್ಲ. ಇನ್ನೂ ಬೇಕಾದಷ್ಟು ಚಾಲೆಂಜ್ಗಳಿದೆ. ಅವರು ಒಂದು ಗ್ರ್ಯಾಂಡ್ ಚಾಲೆಂಜ್ ಕ್ವಾಂಟಮ್ ಹೇಳಿದ್ರು, ಅದೇ ಥರ ನಾನು ಹೇಳ್ತೀನಿ ಸಬಾಟಾಮಿಕ್ ಪಾರ್ಟಿಕಲು ತುಂಬ ಚಾಲೆಂಜ್ ಇದೆ. ಅದೆಲ್ಲ ನೀವು ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು. ಆದ್ದರಿಂದ ಅಂದರೆ ದೈವ ಏನು ಶುರು ಮಾಡಿದ್ರು, ದೇವರು ಏನೇನು ಸೃಷ್ಟಿ ಮಾಡಿದ್ರು ಅದನ್ನು ಪೂರ್ತಿ ಅರ್ಥವಾಗಿಲ್ಲ. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಕ್ಕೆ ಅದೇ ಇವಾಗ ಸೂರ್ಯನ ಮೇಲೆ ಮಿಲಿಯನ್ಸ್ ಇಯರ್ಸಿಂದ ಹೈಡ್ರೋಜನ್ನು ಕಂಬೈನ್ ಆಗಿ ಹೀಲಿಯಮ್ ಆಗಿ ಹೀಟು ಎನರ್ಜಿ ಬರ್ತಾಯಿದೆ. ಅದು ಯಾಕೆ ಬರ್ತಿದೆ? ಮುಗಿದೋಗಲ್ವ ಒಂದು ದಿವಸ, 1 ವರ್ಷ, 10 ವರ್ಷ, 1000 ವರ್ಷ ಆದಮೇಲೆ ಮುಗಿದೋಗ್ಬೇಕಲ್ಲ ಹೈಡ್ರೋಜನ್ನು. ಎಲ್ಲಿಂದ ಬರ್ತಾ ಹೈಡ್ರೋಜನ್ನು? ಬಿಗ್ ಕ್ವಶನ್. ಎವ್ರಿಬಡಿ ಥಿಂಕಿಂಗ್ ಫ್ರಮ್ ವೇರ್ ಇಟ್ ಈಸ್ ಗೆಟಿಂಗ್. ಇದೊಂಥರ ಈ ಕೋಳಿ ಕ್ವಶನ್ ಥರ. ಸೊ ದೇರ್ ಆರ್ ಸ್ಟಿಲ್ ಎನಫ್ ಗ್ರ್ಯಾಂಡ್ ಚಾಲೆಂಜಸ್ ವಾಟ್ ಯು ಆಲ್ ವಿಲ್ ಹ್ಯಾವ್ ಟು ಸಾಲ್ವ್. You may take, as you say, sometimes 1 year, sometimes 100 years, sometimes 20 years. Please, there is no end to scientific sort of a surprises. So, science ಬಿಡಬೇಡಿ. ಅದು ಯಾವತ್ತೋ ಒಂದು ದಿವಸ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟರು ಕ್ವಾಂಟಮ್. ನಾನು ಹೇಳ್ತೀವಿ ಲೇಸರು ಕಂಡಿಡಿದ್ರು ಯಾರೋ ಒಬ್ಬರು, ಅವಾಗೆಲ್ಲರೂ ಲೇಸರಿಂದ ಏನಾಗುತ್ತೆ, ಏನೋ ಆಟ ಆಡ್ಬೋದು, ಲೇಸರ್ ಏನು ವಾಟ್ಸ್ ದಿ ಪರ್ಪಸ್, ಸೊಸೈಟಿಗೆ ಏನು ಯೂಸ್ ಆಗುತ್ತೆ ಲೇಸರಿಂದ, ಏನೋ ಒಂದು ಲೈಟ್ ವಿತ್ ಎ ಸಿಂಗಲ್ ವೇವ್ ಲೆಂತ್ ಮಾಡಿ ಸರಿನಪ್ಪ ಮಾಡ್ಬೋದು, ಅದು ಜನಕ್ಕೆ ಏನು ಯೂಸ್ ಆಗುತ್ತೆ ಅಂದರು. ಇವಾಗ ಲೇಸರ್ ಇಲ್ಲದೆ ಏನೂ ಆಗಲ್ಲ. ವೆಲ್ಡಿಂಗ್ ಮಾಡ್ತಾರೆ, ಕಟ್ಟಿಂಗ್ ಮಾಡ್ತಾರೆ, ಬ್ಯೂಟಿಫಿಕೇಷನ್ ಮಾಡ್ತಾರೆ, ಲೇಸರ್ ಟ್ರೀಟ್ಮೆಂಟ್ ಮಾಡ್ತಾರೆ, ಬೇಕಷ್ಟು ಲೇಸರ್ ಸರ್ಜರಿ ಮಾಡ್ತಾರೆ, ಐ ಸರ್ಜರಿ ಮಾಡ್ತಾರೆ ಲೇಸರಿಂದ. ಫಸ್ಟ್ ಟೈಮ್ ಲೇಸರ್ ಕಂಡಿಡಿದಾಗ ಎವ್ರಿಬಡಿ ವಂಡ್ರಿಂಗ್ ಈ ಲೇಸರ್ ಯಾಕಪ್ಪ ಉಪಯೋಗಿಸ್ತದೆ, ಅದು ವೇಸ್ಟ್ ಅದು ಅಂತ ಹೇಳ್ತಿರು. ಅದೇ ಥರ ಫಸ್ಟ್ ಕಂಪ್ಯೂಟರ್ ಮಾಡಿದಾಗ ಕಂಪ್ಯೂಟರ್ ಇದು ದೊಡ್ಡದು ಒಂದು ಅಲ್ಮೇರಾ ಸೈಜ್ ಇತ್ತು, ಒಂದು ಕಂಪ್ಯೂಟರ್ ಅಲ್ಮೇರಾ ಸೈಜು. ಇದು ದೊಡ್ಡ ಕಂಪ್ಯೂಟ್ರಿಂದ ಏನು ಮಾಡೋದು, ಪ್ರಪಂಚಕ್ಕೆ ವೇಸ್ಟು ಅಂತ ಹೇಳಿದ್ಬಿಟ್ರು. ಒಂದು ಸಲ ಈ ಕಂಪ್ಯೂಟ್ರಿಂದ ಜನಸಾಮಾನ್ಯರಿಗೆ ಏನೂ ಪ್ರಯೋಜನ ಇಲ್ಲ. ಆಮೇಲೆ ಫಸ್ಟ್ ಡೆಸ್ಕ್ಟಾಪ್ ಕಂಪ್ಯೂಟ್ರ್ PC ಪರ್ಸ್ನಲ್ ಕಂಪ್ಯೂಟ್ರ್ ಮಾಡಿದಾಗ ಜನಗಳು ಆಶ್ಚರ್ಯ, ಓ ಇದು ಮಾಡ್ಬೋದಾ ಅಂತ. ಅದೇ ರೀತಿ ನೀವು ಏನು ಸೈನ್ಸ್ ಮಾಡಿದ್ರೂ ಮೊದಲು ನಿಮಗೆ ಗೊತ್ತಾಗಲ್ಲ, ಅದರ ಏನು ಆಳವಾಗಿ ಏನಾಗುತ್ತೆ ಅಂದರೂ ಅರ್ಥವಾಗಲ್ಲ. ಮಾಡ್ತಾ ಮಾಡ್ತಾ ಇವಾಗ ನೀವು ಮಾಡ್ತೀರಿ, ಇನ್ನೊವ್ರು ಮಾಡ್ತಾರೆ, ಮತ್ತೊವ್ರು ಮಾಡ್ತಾರೆ, ಪ್ರಪಂಚದಲ್ಲಿ ಬೇರೆ ಕಡೆ ಮಾಡ್ತಾರೆ, ಆವಾಗ ಏನಾಗುತ್ತೆ, ಇಟ್ ಬಿಕಮ್ಸ್ ಸಿನರ್ಜಿಸ್ಟಿಕ್. ಆದ್ದರಿಂದ ಸೈನ್ಸ್ ಈಸ್ ಸ್ಟಿಲ್ ಪಝಲ್, ನೇಚರ್ ಈಸ್ ಸ್ಟಿಲ್ ಪಝಲ್. We go on doing it. I've been doing for 50 years. You will do maybe another 500 years. ಯಾರು ಬಿಡಬೇಡಿ, ಸೈನ್ಸನ್ನ ಬಿಡಬೇಡಿ. ಅದು ಇಸ್ ದ ಬಿಗ್ಗೆಸ್ಟ್ ಏನಂತಾರೆ, ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದು, ನೇಚರ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಕ್ಕೆ ಸಾಧ್ಯ ಆಗ್ತಿಲ್ಲ. ಥ್ಯಾಂಕ್ ಯು.
Good afternoon, everyone. Myself, Swati Joshi from 2nd BSc. And my question is for Dr. B.R. Guguprasad sir. And my question is, how do aerospace engineers actually control the speed and direction of the rocket so that it enters in elliptical orbit instead of a circular orbit?
I saw this question. She is asking, how do the space scientists or rocket engineers, let us say, how do they control the flight speed of the rockets, its direction? Okay, that is your question, isn't it? Okay. One thing is, speed of the rocket, there are 3 different kinds of rockets, roughly, let us say. One is the one that burns solid propellants. Propellant andre fuel oxidizer combination. A rocket has to carry along with fuel oxidizer also, because it has to work in the upper atmosphere and space where there is no air for all practical purposes. So propellant, if it is rocket propellant, is in the form of solid, it is called as a solid rocket. In the case of liquid, it is a liquid rocket. Cryogenic means using chemicals or using atoms which are normally at normal temperature and pressure, they are gases. But you liquefy them carefully, forcibly, and will bring them to liquid state. Today morning, Vinayak was showing liquid nitrogen ಕೆಳಗಡೆ ಹಾಕಿದ ತಕ್ಷಣ ಅದು ಆವಿ ಆಗೋಕ್ಕೆ ಶುರುವಾಗೋಯ್ತು. -178 ಅಲ್ಲಿ ಇರುತ್ತದೆ. How do you store such propellants? That is a different kind of technology. Now, how do we control the speed of a rocket? Okay, if you burn more propellant per time, okay, the thrust, that is the pushing force generated by the rocket, will be more. So that is how you increase or decrease the speed of a rocket. Okay, you got it, just like accelerator kodange. In the case of, okay, when you give in two-wheeler accelerator like this, more of fuel, that is petrol air mixture in the carburetor, that goes inside. Similarly, by burning more propellant, you can enhance the speed of the rocket if it is liquid or cryogenic. But solid means you burn in such a way the area will be more. Okay, that is the thing. How do we control the direction? Okay, controlling direction is a little bit difficult. But anyway, if you want to tilt the rocket like this, you have to provide a turning moment like that. There are different methods for that. Abdul Kalam sir, okay, for SLV-3, they had a different kind of thing. Just like in aeroplane, wings are there, Okay, fins anta heltivi, F-I and fins. ಆ ಥರದ್ದು ಯೂಸ್ ಮಾಡಿಬಿಟ್ಟು by tilting them, you can control the direction of the rocket when it is in the atmosphere. How do we control when it is in space? You use smaller rocket engines around that. If you fire rocket engines in this direction only, not from the back, in this direction, there will be a turning moment like this. Similarly, if you fire only this side, it will be like this. So, and at the same time, here and here, if you fire, there will be a spinning. This is the way we do that. I hope you have understood. These are the different methods. Thank you.
Next question.
Yes, I saw this question earlier also.
A very good afternoon to all. I am Sanidhi from first BSc, and my question is to Padma Shri Dr. Prahlad Ramarao. My question is that, sir, what were your biggest challenges while designing the Akash missile, and how did you overcome them?
ಬಿಗ್ಗೆಸ್ಟ್ ಅಂತ ಏನಿಲ್ಲ, ಫುಲ್ ಆಫ್ ಚಾಲೆಂಜಸ್, ಫುಲ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ಸೇ. ಮೊದಲು ಎ ಟು ಝಡ್ ಪ್ರಾಬ್ಲಮ್ಮೇ. ಯಾಕೆಂದರೆ ನಮಗೇನೋ ಹೇಳಿದರು ಕಲಾಂ ಸಾಹೇಬರು, ನೀವೊಂದು ಆಕಾಶ್ ಮಿಸೈಲ್ ಸಿಸ್ಟಮ್ ಮಾಡಪ್ಪ ಅಂತ. ಆಮೇಲೆ ಆರ್ಮಿನ ಏರ್ಫೋರ್ಸ್ ಕೇಳಿದ್ವಿ ನಿಮ್ಗೆ ಏನಪ್ಪ ಬೇಕು ಅಂತ. ಅವರು ದೊಡ್ಡದಾಗಿ ಒಂದು ಡಾಕ್ಯುಮೆಂಟ್ ಕೊಟ್ಟರು, ಐ ವಾಂಟ್ ಆಕಾಶ್ ಮಿಸೈಲ್ ಲೈಕ್ ದಿಸ್ ಅಂತೆಲ್ಲ ಕೊಟ್ಟರು. ಅದೆಲ್ಲ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ಮೇಲೆ ಕೂತ್ಕೊಂಡು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಅದಕ್ಕೆ ಯಾವ ರೀತಿ ಪ್ರೊಪಲ್ಷನ್ ಅಂತ ಹೇಳಿದ್ರಲ್ಲ, ಆ ರೀತಿ ಪ್ರೊಪಲ್ಷನ್ ನಮ್ಮ ದೇಶದಲ್ಲೇ ಇಲ್ಲ ಒಂದು. ಆಮೇಲೆ ಯಾವ ರೀತಿ ರೆಡಾರ್ ಬೇಕು ಆ ರೀತಿ ಮಾಡೋಕ್ಕೆ ನಮ್ಮ ದೇಶದಲ್ಲಿ ರೆಡಾರೇ ಇಲ್ಲ. ಪ್ರೊಪಲ್ಷನ್ ಇಲ್ಲ, ರೆಡಾರ್ ಇಲ್ಲ, ಮಿಸೈಲ್ ಯಾರು ಮಾಡೋದು? ಆಮೇಲೆ ಏನು ಎಲ್ಲರಿಗೂ ಯೋಚನೆ, ಏನಪ್ಪ ಇವು ಆರ್ಮಿ ಏರ್ಫೋರ್ಸ್ ಕೊಡೋ ಪ್ರಕಾರ ನಮ್ಮ ಕೈಲಿ ಇದೂ ಇಲ್ಲ ಅದೂ ಇಲ್ಲ, ಯಾವ ರೀತಿ ಮಿಸೈಲ್ ಮಾಡಬೇಕು ಅಂತ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಆವಾಗ ಕಲಾಂ ಹೇಳಿದರು, ನೋ ಸಿ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, everybody got project 5 years, 6 years, 7 years. You are project director for 15 years. ಯಾಕೆ ನಂಗೆ ಗೊತ್ತು ನಿಂದು ವಿಲ್ ಟೇಕ್ ಮೋರ್ ಟೈಮ್. ಆದ್ದರಿಂದ ಐ ಹ್ಯಾವ್ ಗಿವನ್ ಯು 15 years. ಸೊ ನೀನು ಪ್ರೊಪಲ್ಷನ್ ಇಲ್ಲ, ಪ್ರೊಪಲ್ಷನ್ ಹೊಸದಾಗಿ ಕಂಡಿಡಿ. ಆದರೆ ಏನು ಕೆಮಿಸ್ಟ್ರಿ, ಏನು ಫಿಸಿಕ್ಸು, ಏನು ಇಂಜಿನಿಯರಿಂಗ್ ಕಡಿ. ರೆಡಾರ್ ಇಲ್ಲ, ಅದು ಹೊಸ ರೆಡಾರ್ ಮಾಡು. ಏನು ರೆಡಾರ್ ಬೇಕು, ಯಾವ ಲ್ಯಾಬ್ರೇಟ್ರಿ ಮಾಡ್ತಾರೆ, ಯಾವ ರೀತಿ ರೆಡಾರ್ ಬೇಕು, ಯಾವ ರೀತಿ ಅದನ್ನು ಉಪಯೋಗಿಸ್ಬೋದು, ಅದು ಮಾಡು. ಅದಕ್ಕೆ 10 ವರ್ಷ ಆಯಿತು. ಹೊಸ ರೆಡಾರ್ ಮಾಡೋಕ್ಕೆ, ಹೊಸ ಪ್ರೊಪಲ್ಷನ್ ಮಾಡೋಕ್ಕೆ 10 ವರ್ಷ ಆಯಿತು. ಆ 10 ವರ್ಷದೊಳಗೆ ನಾವೊಂದು 100 ಫ್ಲೈಟ್ ಮಾಡಿದ್ವಿ. 100 ಒಳಗೆ 30 ಡಮಾರ್ ಫೇಲ್. ಡಾಗ್ 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 ಅದು 3, 2, 1, 0 ಅಂತ ಪ್ರೆಸ್ ಮಾಡಿದ್ರೆ ಕಣ್ಮುಂದೆನೇ ಅದು ಎಕ್ಸ್ಪ್ಲೋಡು. ಆದ್ದರಿಂದ ಅದು ನಮಗೆ ಗೊತ್ತು ಏನೋ ಮಿಸ್ಟೇಕ್ ಆಗಿದೆ, ಕಂಡುಹಿಡಬೇಕು ಅಂತ. ಸೊ ಎಲ್ಲ ಫೇಲ್ಯೂರಲ್ಲಿ ಕಲ್ತ್ಕೊಂಡು ಮಾಡಿದ್ವಿ. ಆಮೇಲೆ 10 ವರ್ಷ ಒಳಗೆ ಎಲ್ಲ ರೆಡಿ ಆಯಿತು. ಮಿಸೈಲ್ ರೆಡಿ, ರೆಡಾರ್ ರೆಡಿ, ವಾರ್ ಹೆಡ್ ರೆಡಿ, ಲಾಂಚರ್ ರೆಡಿ. ಆಮೇಲೆ ಆರ್ಮಿ ಏರ್ಫೋರ್ಸ್ ಹೇಳಿದ್ವಿ, ನೋಡಿಯಪ್ಪ ನೀವು ಹೇಳಿದಂಗೆ ಮಾಡಿದ್ವಿ. ಅಂದರೆ ಸೈನ್ಸ್ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ಮಾಡಿದ್ವಿ, ಇಂಜಿನಿಯರಿಂಗ್ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ಮಾಡಿದ್ವಿ, ಇವಾಗ ತೊಗೊಳ್ಳಿ ನೀವು ಅಂತ. ಅವರು ಹೇಳಿದರು, ನಾನು ನೋಗೋತೀವಪ್ಪ, ಫಸ್ಟ್ you have to convert into usable product. I am the user. I will go to the fight and fight the war. ನನಗೆ ಈ ರೀತಿ ಬೇಕು, ಮಿಸೈಲ್ ಹಿಂಗಿರಬೇಕು, ರೆಡಾರ್ ಹಿಂಗಿರಬೇಕು, ವಾರೆಂಟ್ ಹಿಂಗಿರಬೇಕು, ಹಿಂಗಿರಬೇಕು ವೆಹಿಕಲ್ಲು, ಆ ಥರ ಮಾಡಿಕೊಡು. ಅಂದರೆ ಯು ಹ್ಯಾವ್ ಟು ಕಸ್ಟಮೈಸ್ ಇಟ್ ಫಾರ್ ಇಂಡಿಯನ್ ಆರ್ಮಿ, ಇಂಡಿಯನ್ ಏರ್ಫೋರ್ಸ್. ನೀನು R&D ನೀವು ಲ್ಯಾಬ್ರೇಟ್ರಿಲಿ ಮಾಡಿಕೊಟ್ರೆ ಸರ್ ನಂಗೆ ಒಪ್ಕೊಳ್ಳಲ್ಲ. ನೀವು ಕಸ್ಟಮೈಸ್ ಫಾರ್ ಇಂಡಿಯನ್ ಆರ್ಮಿ, ಇಂಡಿಯನ್ ಏರ್ಫೋರ್ಸ್, ಆವಾಗ ನಾವು ತೊಗೋತಿದ್ರು. ಅದಕ್ಕೆ ನಾವು 3 ವರ್ಷ ತೊಗೊಂಡ್ವಿ. 3 ವರ್ಷ ಯಾವ ರೀತಿ ರೆಡಾರ್ ಯಾವ ರೀತಿ ಪ್ಯಾಕೇಜ್ ಮಾಡಬೇಕು, ಯಾವ ಗಾಡಿ ಒಳಗೆ ಹಾಕಬೇಕು, ಎಷ್ಟು ಅದಕ್ಕೆ ಫಿನಿಶ್ ಹೆಂಗೆ ಕೊಡಬೇಕು, ಡಿಸ್ಪ್ಲೇ ಯಾವುದು, ಕಂಪ್ಯೂಟರ್ ಯಾವುದು, ಸಾಫ್ಟ್ವೇರ್ ಯಾವುದು, ಎಲ್ಲ ಮಾಡಿದ್ಮೇಲೆ ಕೊಟ್ವಿ. ಆವಾಗ ಓಕೆ. ನಾವು ಎಲ್ಲಿಂದ ಯಾರು ಮಾಡಿಕೊಡ್ತಾರೆ, DRDO ಮಾಡಲ್ಲ, ಯಾವುದೋ BDL ಮಾಡ್ತಾರೆ, ಬೆಲ್ ಮಾಡ್ತಾರೆ, ಅಲ್ಲಿಂದ ಕೊಂಡ್ಕೊತೀನಿ, ಕೊಂಡ್ಕೊಂಡು ಟೆಸ್ಟ್ ಮಾಡ್ತೀನಿ. ಅದೆಲ್ಲ ಟೆಸ್ಟ್ ಆದರೆ ನಾನು ಆರ್ಡ್ರ್ ಕೊಡ್ತೀನಿ ಅಂತ. ಆಮೇಲೆ ಮಾಡಿ ಒಟ್ಟಿನೊಳಗೆ 12-13 ವರ್ಷ ಆದಮೇಲೆ ಆರ್ಡ್ರ್ ಕೊಟ್ಟರು. ಆದ್ದರಿಂದ ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಎ ಚಾಲೆಂಜ್. ಅಂಡ್ ನನಗೆ 1500 ಮಂದಿ ಸೈಂಟಿಸ್ಟ್ ವರ್ಕ್ ಮಾಡ್ತಿದ್ರು. 1500 ಇಡೀ ದೇಶದೊಳಗೆ. ಹೈದ್ರಾಬಾದ್, ಬೆಂಗಳೂರು, ಚೆನ್ನೈ, ಚಂಡೀಗಢ, ಕಲ್ಕಟ್ಟ, ಮುಂಬೈ, ಆಮೇಲೆ ಎವ್ರಿ ಸಿಟಿ, ಡೆಲ್ಲಿ, ಸೈಂಟಿಸ್ಟ್ ಆರ್ ದೇರ್ ಎವ್ರಿವೇರ್. ಎಲ್ಲ ಮೋಸ್ಟ್ಲಿ ಯಂಗ್ ಪೀಪಲ್ ಇನ್ ದೇರ್ ಅರ್ಲಿ 20, ಅರ್ಲಿ 30s. ಅವರೆಲ್ಲ ಫ್ರೆಶ್ ಆಗಿ ತೊಗೊಂಡಿದ್ದವರು. ಫುಲ್ ಚಾಲೆಂಜ್. ಅವರು ಮನೇಲಿ ಎವ್ರಿ ಫ್ಯಾಮಿಲಿ ಹ್ಯಾಡ್ ಎ ಚಾಲೆಂಜ್ ಬಿಕಾಸ್ ಆಫ್ ಫ್ಯಾಮಿಲಿ ಪ್ರೆಷರ್ಸ್, ಪ್ಲಸ್ ವಿ ಹ್ಯಾಡ್ ಎ ಟೆಕ್ನಿಕಲ್ ಚಾಲೆಂಜ್. ಬಾಲಾಸೂರು ಹೋಗಿ ಲಾಂಚ್ ಮಾಡಬೇಕು. ಒಂದು ಸಲ ಹೋದರೆ 15 ದಿವಸ 20 ದಿವಸ ಅಲ್ಲೇ ಇರಬೇಕು. ಅದು ಲಾಂಚ್ ಆಗೋ ತನಕ ಬರೋ ಹಾಗಿಲ್ಲ. ಲಾಂಚ್ ಆಗಿ ಏನೋ ಟೆಕ್ನಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಮು, ಮ್ಯಾನೇಜರಲ್ ಪ್ರಾಬ್ಲಮ್ಮು ಕಾಯಬೇಕು. 15 ದಿವಸ ಎಲ್ಲರೂ ಮನೆ ಬಿಟ್ಟು ಬರಬೇಕಲ್ಲೆಲ್ಲೋ. ಆವಾಗ ಮನೆಯಲ್ಲಿ ಏನೋ ಪ್ರಾಬ್ಲಮ್ ಇರ್ಬೋದು, ಮಕ್ಕಳ ಪ್ರಾಬ್ಲಮ್ಮು, ಹೆಂಡತಿ ಪ್ರಾಬ್ಲಮ್ಮು, ಬಂಧು ಬಳಗ ಏನೋ ಇರ್ಬೋದು. ಆದ್ದರಿಂದ ವಾಟ್ ವಿ ಫೌಂಡ್ ಈಸ್, ಇಫ್ ಯು ವಾಂಟ್ ಟು ಅಚೀವ್ ಎಕ್ಸ್ಟ್ರಾ ಆರ್ಡಿನರಿ ರಿಸಲ್ಟ್, ಯು ಹ್ಯಾವ್ ಟು ಪುಟ್ ಇನ್ ಎಕ್ಸ್ಟ್ರಾ ಆರ್ಡಿನರಿ ಇನ್ಪುಟ್. ಯು ಕೆನಾಟ್ ಪುಟ್ ಆರ್ಡಿನರಿ ಇನ್ಪುಟ್ ಆ್ಯಂಡ್ ಟೇಕ್ ಗೆಟ್ ಎಕ್ಸ್ಟ್ರಾ ಆರ್ಡಿನರಿ ಔಟ್ಪುಟ್. ಇಟ್ಸ್ ನಾಟ್ ಪಾಸಿಬಲ್. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ವರ್ಕ್. ಅದು ಹೇಳಿದಲ್ಲ, ಕಲಾಂ ಸಾಹೇಬರು 3 ಗಂಟೆ ಕೂತ್ಕೊಂಡು ಹೇಗೆ ಮಾಡೋದು ಅಂತ ಯೋಚನೆ ಮಾಡಿ ಆ ಥರ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ಯು ಹ್ಯಾವ್ ಟು ಸ್ಯಾಕ್ರಿಫೈಸ್ ಮೆನಿ ಥಿಂಗ್ಸ್. ನೀವೆಲ್ಲ ಸ್ಯಾಕ್ರಿಫೈಸ್ ಮಾಡಿ ಕೂತ್ಕೊಂಡಿದ್ದೀರಲ್ಲ ಸೈನ್ಸ್ ಕೇಳೋಕ್ಕಿರ್ತಾನೆ. ಯು ಆರ್ ಸ್ಯಾಕ್ರಿಫೈಸ್ ಯುವರ್ ಟೈಮ್, ಕಮ್ ಹಿಯರ್ ಫಾರ್ 2 hours 3 hours, ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಸೈನ್ಸ್. ಯು ಆರ್ ಡನ್ ಎ ಗ್ರೇಟ್ ಸ್ಯಾಕ್ರಿಫೈಸ್. ಐ ವಾಂಟ್ ಅಪ್ರಿಷಿಯೇಟ್. ಅದೇ ರೀತಿ ವಿ ವೆಂಟ್ ಆನ್. ನಮ್ಮ ಮನೆಯವ್ರನ್ನ ಕೇಳಿ ಹೇಳ್ತಾರೆ ಅವರು ಕಲಾಂ ಸಾಹೇಬರ ಕಥೆನ ಅವ್ರು ಹೇಳ್ತಾರೆ. ಒಂದು ಏನಾಯಿತು ಮನೆಯೊಳಗೆ, ಇವ್ರು ಹೇಳಿದ್ರಲ್ಲ ಮನೆಯಲ್ಲಿ ಹೆಂಡತಿ ಮಕ್ಕಳು ಇರ್ತಾರೆ. ಕಲಾಂ ಏನೋ ಬ್ಯಾಚುಲರು, ಅವ್ರಿಗೆ ಹೆಂಡತಿ ಇಲ್ಲ ಮಕ್ಕಳಿಲ್ಲ. ಅವರು ಬೇಕಾದ್ರೆ 3 ಗಂಟೆ ತನಕ ಇರ್ತಾರೆ, 8 ಗಂಟೆ ತನಕ ಇರ್ತಾರೆ, ಭಾನುವಾರ ಇರ್ತಾರೆ, ಸೋಮವಾರ ಇರ್ತಾರೆ. ನಮಗೆಲ್ಲ ಈ ರೀತಿ ಬಂಧನಗಳು ಇರೋದ್ರಿಂದ ಯಾವ ರೀತಿ ಅದಕ್ಕೆ ಅವರು ಕಥೆ ಹೇಳ್ತಾ ಅವ್ರಿಗೆ ಗೊತ್ತು, ಎಕ್ಸ್ಪೀರಿಯೆನ್ಸು. ಆದ್ದರಿಂದ ಕಷ್ಟಪಡೋದು ಪಟ್ಟೆ ನಿಮಗೆ ರಿಸಲ್ಟ್ ಬರುತ್ತೆ. ಕೈ ಕೆಸರಾದರೆ ಬಾಯಿ ಮೊಸರು ಅಂತ, ಇಲ್ಲೇ ಇದ್ದರೆ ಬಾಯಿ ಮೊಸರಾಗಲ್ಲ, ಬಾಯಿ ಕೆಸರೇ ಆಗಿರುತ್ತೆ.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
In another 10 minutes, we are conducting the experiment, live experiment here. So questions from PUC students. Rather, PU Makal question ಕೇಳೋದಾದರೆ ನೀವು we can stand up. We'll pass on the mic. You can ask the question.
Yeah.
Let it be crazy question, difficult question, simple question. Don't worry. Ask question.
I think the first question has to come, then domino effect will be there. People will start. Anyway, anybody is there? Before that, I would like to say something. In a way, some kind of counter to Dr. Prahalad. See, not counter. Again, I'm coming back to Kalam. He was mentioning about each and everyone having challenges in the family while doing office work. What did Dr. Kalam do actually? There is one more incident which, Kalam sir was Kalam always. That is, again, this is what I have heard from my reliable source. It went like that. One day, the same HGS Murthy, his PA came to him in Tumba and told, it seems, sir, there is a gentleman who looks like a villager. ಲುಂಗಿ ಉಟ್ಕೊಂಡಿದ್ದಾರೆ, ಬಂದಿದ್ದಾರೆ, ಪಾಪ ಆಲ್ಮೋಸ್ಟ್ ಅಳ್ತಾ ಇದ್ದಾರೆ, ಕಣ್ಣೆಲ್ಲ ತೇವ ಆಗೋಗ್ಬಿಟ್ಟಿದೆ, ನೀರು ಬರ್ತಾ ಇದೆ. ಯಾಕಪ್ಪ ಏನಾಯ್ತು? ಅದು ನನ್ನ ಆಫೀಸ್ಗೆ ಯಾಕೆ ಬಂದು ಅಳ್ತಾ ಇದ್ದಾರೆ ಅಂತ ಕೇಳಿದ್ರು. ಆವಾಗೆಲ್ಲ ಇಸ್ರೋ ಒಳಗಡೆ ಹೋಗೋದು ಈಸಿ ಆಗಿತ್ತು. ಇಸ್ರೋ ಅನ್ನೋದೇ ಇರಲಿಲ್ಲ ಅವಾಗ, ಇನ್ನೊಂದು ಇಟ್ಕೊಳ್ಳಿ. ಆಮೇಲೆ ನೋಡಿದ್ರೆ ಅವರು ಹೇಳಿದ್ರಂತೆ, ಅವರು ಕರಿ ಒಳಗೆ ಅಂತ ಹೇಳಿಬಿಟ್ಟು ಕರೆದ್ರಂತೆ. ಯಾರಪ್ಪ ನೀವು? ಸರ್, ನಾನು ತಮಿಳ್ನಾಡಲ್ಲಿ ರಾಮೇಶ್ವರಮಿಂದ ಬಂದಿದ್ದೀನಿ ಸರ್ ಅಂತ. ಏನು ಅಂದರೆ, ನನ್ನ ಮಗ ಇಲ್ಲಿ ಕೆಲಸ ಮಾಡ್ತಾಯಿದ್ದಾನೆ ಸರ್, 6 ತಿಂಗಳಿಂದ ಮನೆಗೆ ಬಂದಿಲ್ಲ. ಮನೇಲಿ ತಾಯಿ, ನಾನು, ಆಮೇಲೆ ತಮ್ಮಂದರು, ತಂಗಿರು ಎಲ್ರಿಗೂ ಗಾಬರಿ ಆಗೋಗ್ಬಿಟ್ಟಿದೆ. ಏನು ಅಂತ ಗೊತ್ತಿಲ್ಲ. ಬರ್ತಾನೆ ಇಲ್ಲ ಮನೆಗೆ, ಏನು ಲೆಟ್ರು ಬರೆಯಲ್ಲ, ಏನೂ ಬರ್ತಾ ಇಲ್ಲ. ಬರ್ತೀನಿ ಅಂತ ಹೇಳ್ತಾರೆ ಯಾವಾಗಲೂ, ಬರೋದೇ ಇಲ್ಲ. ಯಾಕಪ್ಪ, ಯಾರು ನಿಮ್ಮ ಮಗ? ಅಷ್ಟೊಂದು ನಾವು ಕೆಲಸ ಕೊಟ್ಬಿಟ್ಟಿರೋ ಅಂಥ ಮನುಷ್ಯ ಯಾರು? ರಜಾ ತೊಗೋಬೇಡ ಅಂತ ನಾವೇನು ಹೇಳಲ್ಲ, ಫ್ಯಾಮಿಲಿನಲ್ಲಿ ಚಾಲೆಂಜಸ್ ಇದ್ದರೆ ಬೇಡ ಅಂತ ಹೇಳಲ್ಲ. ಯಾರು ನಿಮ್ಮ ಮಗ? ನಿಮ್ಮ ಹೆಸರೇನು ಮೊದಲು ಅಂತ ಕೇಳಿ. ನನ್ನ ಹೆಸರು ಅವುಲ್ ಫಕೀರ್ ಜೈನುಲ್ ಅಬ್ದೀನ್ ಅಂತ ಹೇಳಿದ್ರಂತ. ಆಯ್ತಪ್ಪ, ಆಯಿತು, ನಿಮ್ಮ ಹೆಸರು ಅವುಲ್ ಫಕೀರ್ ಜೈನುಲ್ ಅಬ್ದೀನ್ ಅಂತ. ತಮ್ಮ ಮಗನ ಹೆಸರೇನು ಅಂತ ಕೇಳಿದ್ರು. ಅವ್ರ ಹೆಸರು ಅಬ್ದುಲ್ ಕಲಾಂ ಅಂತ ಸಾರ್. ಅಯ್ಯೋ, ಇದೇ ಅಬ್ದುಲ್ ಕಲಾಮ, ತಿರ್ಗಾ ಕರೀರಿ ಅವ್ರನ್ನ ಅಂತ ಕರೆದ್ರಂತೆ ಅಬ್ದುಲ್ ಕಲಾಂನ. ತಿರ್ಗಾ ಬಂದರೆ ಅಬ್ದುಲ್ ಕಲಾಂ ಅವ್ರಿಗೆ, ಕಲಾಂ ಸಾರ್ಗೆ ಅವ್ರ ತಂದೆ ನೋಡಿ ಗಾಬರಿ ಆಗೋಯ್ತಂತೆ. ಅದು ಡೈರೆಕ್ಟರ್ ಚೇಂಬರಲ್ಲಿ ಕೇಳಿದ್ರಂತೆ, ಬಂದು ಸುಮ್ಮನೆ ನಿಂತ್ಕೊಡ್ರಂತೆ. ತಿರ್ಗಾ ಹೇಳಿದ್ರಂತೆ HGS ಮೂರ್ತಿ, ಕಲಾಂ, ಯು ಸಿ ರಿಯಲಿ ಯು ಹ್ಯಾವ್ ಡನ್ ದಿಸ್, ಯು ಆರ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಹೋಮ್. ವಾಟ್ ಅಬೌಟ್ ಯುವರ್ ಮದರ್? ಶಿ ಈಸ್ ಸೋ ವರಿಡ್. ನಿಮ್ಮ ತಾಯಿಗೆ, ನಿಮ್ಮ ತಂದೆ ನೋಡಿ ಅಳೋ ಥರನೇ ಆಗೋಗ್ಬಿಟ್ಟಿದೆ ಅವ್ರಿಗೆ. ನಿಮ್ಮನ್ನು ನೋಡಿದೆ, ತಮ್ಮಂದರು ತಂಗಿಯರು ಗಾಬರಿ ಆಗೋಗ್ಬಿಟ್ಟಿದ್ದಾರೆ. ಈ ಥರ ಮಾಡಬಾರ್ದು ನೀವು. ನಿಮಗೆ ಕೆಲಸದ ಬಗ್ಗೆ ತುಂಬ ಗೌರವ ಇದೆ, ಕೆಲಸ ಇದ್ದರೆ ನೀವು ಯಾವುದು ದೇಶಕ್ಕೆ ಹೋಲಿಸಿದ್ರೆ ನೀವು ಯಾವುದೂ ಕೇರ್ ಮಾಡಲ್ಲ, ಕುಟುಂಬನೂ ಕೇರ್ ಮಾಡಲ್ಲ. ಆದರೆ ನಿಮಗೂ ಒಂದು ಕುಟುಂಬ ಅಂತಿದೆ, ಅವರು ನಿಮ್ಮನ್ನು ಪ್ರೀತಿಸ್ತಾರೆ ಅಲ್ವಾ? ದಯಮಾಡಿ ಆ ಥರ ಮಾಡಬೇಡಿ. ನೋಡಿ, ಇವಾಗ ಅದೇನು ತಲೆ ಮೇಲೆ ತಲೆ ಬೀಳೋ ಕೆಲಸ ಇದ್ರೂ ಪರವಾಗಿಲ್ಲ, ನಿಲ್ಲಿಸಿ. ಇವತ್ತು ನಿಮ್ಮ ತಂದೆ ತಿರುವನಂತಪುರಮ್ಗೆ ಬಂದಿದ್ದಾರೆ. ಬೆಳಗ್ಗಿಂದ ಸಂಜೆವರೆಗೂ ಅವರನ್ನು ಸುತ್ತಾಡಿಸ್ಬಿಟ್ಟು ರಾತ್ರಿ ರಾಮೇಶ್ವರಂ ಬಸ್ಸಿಗೆ ಇಬ್ಬರು ಕೂತ್ಕೊಳ್ಳಿ, ಒಂದಷ್ಟು ದಿವಸ ರಜಾ ತಗೊಳ್ಳಿ, ವಾಪಸ್ ಬನ್ನಿ. ಏನೇ ಕಷ್ಟ ಇದ್ದರೂ ನಾನು ನೋಡ್ಕೋತೀನಿ, ಇವಾಗ ನನ್ನ ಮುಂದೆ ನಿಂತ್ಕೊಬೇಡಿ, ಹೋಗಿ ತಿರ್ಗ ಅಂತ. ಸರಿ, ಕಲಾಂ ಅವರು ಆಯಿತು ಅಂತ ತಲೆ ಆಡಿಸಿದ್ರಂತೆ. ಹೋಗ್ಬಿಟ್ಟು ಅವ್ರ ತಂದೆನ ಇಡೀ ತಿರುವನಂತಪುರಂನಲ್ಲಿ ಸುತ್ತಿಸ್ಬಿಟ್ಟು ಎಲ್ಲ ತೋರಿಸಿ ಒಳ್ಳೆ ಊಟ ಹಾಕಿಸಿ ಅವ್ರನ್ನ ರಾಮೇಶ್ವರಂ ಬಸ್ಗೆ ಹತ್ತಿಸಿ ಕಳಿಸಿ ತಾವು ತಿರ್ಗಾ ಕೆಲಸಕ್ಕೆ ಬಂದರು. ಅದೇ ಅಬ್ದುಲ್ ಕಲಾಂ. ಅದಕ್ಕೆ ನಾನು ಹೇಳಿದ್ದು, ಕೆಲವರು ಇರ್ತಾರೆ, ಅದು ಡೆಸ್ಟಿನಿ, ಅವರು ಯಾವುದು ಕೇರ್ ಮಾಡಲ್ಲ. ನೋಡಿ, ಕಲಾಂ ಅವರು ಕಡೆಗೆ ದೇಹತ್ಯಾಗ ಮಾಡಿದ್ದು ಯಾವ ರೀತಿ, ಇದೇ ರೀತಿ ಒಂದು ಸ್ಟೇಜ್ ಮೇಲೆ ಲೆಕ್ಚರ್ ಕೊಡ್ತಿದ್ದಾಗ ಹೋದರು. ತಾವು ಏನು ಕಲ್ಪನಾ ಚಾವ್ಲಾ ಇನ್ನೇನು ಹಾರಬೇಕು ಅನ್ನೋದು ಅವರ ಕನಸು. ಅದು ವಾಪಸ್ ಬರ್ತಾ ಇದ್ದಾರೆ ಅಂತರಿಕ್ಷ ಶಟಲ್ನಲ್ಲಿ, ಗಂಟೆಗೆ ಸುಮಾರು 20,000 ಕಿಲೋಮೀಟ್ರ್ ವೇಗದಲ್ಲಿ, ಅದು 60 ಕಿಲೋಮೀಟ್ರ್ ಎತ್ತರದಲ್ಲಿದೆ. ಆವಾಗ ಅಲ್ಲಿ ಆ ಸ್ಪೇಸ್ ಶಟಲ್ ಅಂತ ವಾಹನ ಏನು ಹೇಳ್ತೀವಿ, ಆ ವಿಮಾನದ ರೆಕ್ಕೆನಲ್ಲಾಗಿದ್ದ ಒಂದು ತೂತು ಒಳಗೆ ಪ್ಲಾಸ್ಮಾ ಅಂತ, ವಿದ್ಯಾಧಿರಾಜ ಅವ್ರಿಗೆ, ಪ್ರೊಫೆಸರ್ ವಿದ್ಯಾಧಿರಾಜ ಇವರಿಗೆಲ್ಲ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರುತ್ತೆ, ಪ್ಲಾಸ್ಮಾ ಒಳಗಡೆ ಹೋಗಿ ಆ ರೆಕ್ಕೆನೇ ಮುರಿದ್ಬಿಡ್ತು. ಕಲ್ಪನಾ ಚಾವ್ಲಾ ಅವರು ಕೂತಿದ್ದ ಹಾಗೆ ತಮಗೇನು ಇಷ್ಟ ಆಯಿತೋ ಆ ಕೆಲಸ ಮಾಡ್ತಿದ್ದಾಗಲೇ ಗತಿಸಿದ್ರು. ಕಲಾಂ ಅವರು ಅಷ್ಟೇ, ತಮಗೇನು ಇಷ್ಟ ಆಯಿತೋ ಅದು ಮಾಡ್ತಾ ಇದ್ದಾಗ ದೇಹತ್ಯಾಗ ಆಯಿತು. ಹಾಗಾಗಿ ಕೆಲವರು ಇರ್ತಾರೆ ಪ್ರಪಂಚದಲ್ಲಿ, ಯಾಕೆ ಅವರು ಇದು ಮಾಡಬೇಕು. ವಿಕ್ರಮ್ ಸಾರಾಭಾಯಿ ಯಾಕೆ ಬರಬೇಕಿತ್ತು? ಬಾಬಾ ಅವರು ಅಷ್ಟೇ, ಎಂಥ ಶ್ರೀಮಂತರವರೆಲ್ಲ ಯಾಕೆ ಬರಬೇಕಿತ್ತು? ದೇಶಕ್ಕೆ ಏನಾರು ಮಾಡಬೇಕು ಅಂತ ಬಂದರು. ಇವತ್ತು ನಾನಂತೂ ಊಟ ಮಾಡ್ತಾ ವಿಕ್ರಮ್ ಸಾರಾಭಾಯಿ ಅವ್ರನ್ನ ನೆನೆಸ್ಕೊಂಡೇ ಊಟ ಮಾಡಿ. ಇವತ್ತು ಈ ಬಗೆಯ ನಾವು ಭಾರತದಲ್ಲಿ ಈ ಬಗೆಯ ಸಾಧನೆಯನ್ನು ಮಾಡಿರೋದಕ್ಕೆ ಮೂಲ ಕಾರಣ, ನಾನು ಹೇಳಿದೆ ಅವರೆಲ್ಲ ಏನು ಹೇಳಿದ್ರು ಅಂತ ಪುರಾಣ ಅಲ್ಲಿ, ಅವರೇ ಕಾರಣ. ಹಾಗಾಗಿ ನಮ್ಮಲ್ಲಿರುವಂತಹ ಕಲಾಂ ಅವ್ರನ್ನ, ನಮ್ಮಲ್ಲಿರುವಂತಹ ಬಾಬಾ ಅವ್ರನ್ನ, ನಮ್ಮಲ್ಲಿರುವಂತಹ ಬೇರೆ ಸತೀಶ್ ಧಾವನ್ ಅನ್ನುವಂತಹ ವಿಜ್ಞಾನಿ, ಅಪ್ರತಿಮ ವಿಜ್ಞಾನಿ, ಅವರು ಅಷ್ಟೇ, ನಮ್ಮಲ್ಲಿರುವಂತಹ ಪ್ರೊಫೆಸರ್ ರಾವ್ ಅವ್ರನ್ನ, ಎಲ್ಲರಲ್ಲೂ ಇರ್ತಾರೆ ಇವರು, ಹೆಚ್ಚು ಕಡಿಮೆ ಇರುತ್ತೆ. ಆದರೆ ಅವರನ್ನು ಹೊರ ತೆಗೆದು ಕಿಂಚಿತ್ತಾದರೂ ದೇಶಕ್ಕೋಸ್ಕರ ಸ್ವಲ್ಪ ಸಮಯವನ್ನು ಮುಡಿಪಾಗಿಡೋಣ ಅಂತ ಹೇಳಿದೆ. ಇವಾಗ ನಾನು ಬಂದಿರೋದು ಅದಕ್ಕೋಸ್ಕರನೇ. ಇಲ್ಲಿ ನನಗೂ ಕೆಲಸ ಇದೆ ಅಲ್ಲಿ. ಆದರೆ AP ಭಟ್ರು ಕರೆದ್ರು, ಸ್ವಾಮೀಜಿ ಕರೆದಿದ್ದಾರೆ ಅಂದರೆ ಬಹಳ ಗೌರವದಿಂದ ಬಂದಿದ್ದೀನಿ. ನಿಮ್ಮಂಥ ಮಕ್ಕಳ ಜೊತೆ ಮಾತಾಡಿದ್ರೆ ನಿಮಗೂ ಏನಾದ್ರು ಉಪಯೋಗ ಆಗಬಹುದೇನೋ, ನನಗಂತೂ ಒಳ್ಳೆಯ ಉಪಯೋಗ ಆಗಿದೆ ನಿಮ್ಮ ಜೊತೆ ಮಾತಾಡಿ. ಹಾಗಾಗಿ ಎಲ್ರಿಗೂ ಒಳ್ಳೆಯದಾಗಲಿ ಅಂತ ಹೇಳಿ ನನ್ನ ಮಾತು ಮುಗಿಸ್ತೀನಿ.
ಕೇಳಿದ್ದು ಆನ್ಸರ್ ಬಂದಿದೆ ಎಲ್ಲರಿಗೂ. ಸುಮಾರು 48 ಕ್ವಶನ್ಸ್ಗಳು ಇನ್ನೂ ಬಾಕಿ ಉಂಟು. ಅದನ್ನೆಲ್ಲ ನಾವು ಮೇಲ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಮೇಲ್ ಆಲ್ರೆಡಿ ಮಾಡಿದ್ದೀವಿ 4 ಪ್ರೊಫೆಸರ್ಸ್ಗೆ. ಇನ್ನೂ ಕ್ವಶನ್ಸ್ PU ಅವ್ರದ್ದಿದ್ದರೆ ನೀವು ಕಳಿಸ್ಕೊಡ್ಬೋದು ನಮಗೆ, ಅದನ್ನು ನಾವು ಸೈಂಟಿಸ್ಟ್ಗಳಿಗೆ ಕಳಿಸ್ತೀವಿ. ನಿಮಗೆ ರಿಟರ್ನ್ ಫಾರ್ಮೇಟಲ್ಲಿ ಅದಕ್ಕೆ ಬೇಕಾಗಿರೋ ಆನ್ಸರ್ಸು ಸಿಗುತ್ತೆ. ಸೊ ವಿ ಥ್ಯಾಂಕ್ ಆಲ್ ದ ಸ್ಟೂಡೆಂಟ್ಸ್ ಫಾರ್ participating in the question and answer session. Now we'll start the experimental demonstration, live experimental demonstration. I request Dr. Vinay sir and Vidyadhiraja sir to conduct the experiment, live experiment to the PU students, and also morning itself we have conducted the experiment for degree students. Especially this one is arranged for PU students.
So actually there have been many questions that we have seen where people have asked, why are we doing basic science? What is the use of, what is the practical application of basic science? And so on. And there are some people who have asked the question, how should we study science so that it is easily understandable? What are the techniques for absorbing scientific concepts more easily? So this is one answer to that. Okay, when you do experiments, when you do practical things, then it is much easier to understand science than to just read in the textbook. Okay, in fact, Professor Guru Prasad also mentioned, right, when you go to the planetarium and when you see the things in action, or when you do those experiments by yourself, that is when you absorb things much more easily. That is how educators can also explain concepts to children much more easily. Okay, so we will show you some concepts here, and we will also show you how those concepts get converted to technology as time progresses. Okay, most of the concepts, when they are first discovered, they are hardly useful for technology. Most scientists don't even realize how important these effects can become. One very famous thing is Raman effect. When Professor C.V. Raman found out his effect and he was awarded the Nobel Prize subsequently, he had no idea of the uses. But today, if you go to any diagnostic laboratory for testing your blood and other things, you're actually using Raman effect there. If you go to an airport where there is a bomb detection or a drug detection going on, that is Raman effect. Okay? Raman effect has found thousands of uses in all domains of science, in pure chemistry also, in pure physics also, in industrial chemistry. Lots of uses have been found for the Raman effect. So when people do science, they don't directly go for technology. You go for discovering nature. You go for understanding nature. Okay? So technology comes much later, maybe a few decades later. This is science. But science is magic. Huh? Okay, so
ಬಿಫೋರ್ ದ್ಯಾಟ್ ಸೈನ್ಸ್ ಸಬ್ಜೆಕ್ಟ್ ಹೆಂಗಂತಂದರೆ ಒಂಥರ ಯು ಹ್ಯಾವ್ ಟು ಎಂಜಾಯ್ ದ್ಯಾಟ್. ನಿಮ್ಮ ಮುಖದ ಮೇಲೆ ಸ್ಮೈಲ್ ಇರಬೇಕು. ನಮ್ಮ ಮುಖದ ಮೇಲೆ ಸ್ಮೈಲೇ ಇರೋಲ್ಲ, ಹೌದಲ್ವಾ? ಈ ಫಿಸಿಕ್ಸು, ಮ್ಯಾಥಮೆಟಿಕ್ಸು, ಕೆಮಿಸ್ಟ್ರಿ ಕಲಿಬೇಕಾದ್ರೆ ಅಯ್ಯೋ ಹೆಂಗೆ ಮಾಡೋದು, ಬಯಾಟ್ ಮಾಡಿಬಿಡ್ತೀವಿ. ನಾವು ಕಾನ್ಸೆಪ್ಟನ್ನ ಸರಿಯಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಲ್ಲ. ನಾನು ಇವತ್ತು ಬೆಳಿಗ್ಗೆ ಅಲ್ಲಿ ತುಂಬ ಟೈಮ್ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ತುಂಬ ಶಾರ್ಟ್ ಮಾಡಿ ಹೇಳಿದೆ, ನಾನು ಸರಿಯಾಗಿ ಹೇಳೋಕ್ಕಾಗಲಿಲ್ಲ. ನೀವು ಅದನ್ನು ಹೇಗೆ ಎಂಜಾಯ್ ಮಾಡಬೇಕಂದ್ರೆ ಒಬ್ಬ ಫಿಲ್ಮ್ ಸ್ಟಾರ್ ಬಗ್ಗೆ ಈಗ ನಿಮ್ಗೆ ಯಾರಾದರೂ ನಿಮ್ಮ ಫೇವ್ರೇಟ್ ಮೂವಿ ಹೀರೋ ಯಾರು ಅಂದ ತಕ್ಷಣ ನಿಮ್ಗೆ ಹೀರೋ ಪಟ್ನ ಬರ್ತಾರೆ. ಅಕಸ್ಮಾತ್ ಅವ್ನ ಮೂವಿ ನೀವು ನೋಡಿದ್ರಿ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಆಫ್ಟರ್ ಫ್ಯೂ ಇಯರ್ಸ್ ಯು ವಿಲ್ ರಿಮೆಂಬರ್ ದಟ್ ಮೂವಿ ಸ್ಟೋರಿ ಕಂಪ್ಲೀಟ್ಲಿ. ಅದೇ ಹೋದ ವರ್ಷ ಓದಿದ್ದು ನಿಮಗೆ ನೆನಪಿರೋದಿಲ್ಲ, ಹೌದಲ್ವಾ? ಆದರೆ ಮೂವಿ ಮಾತ್ರ ಫುಲ್ಲು 3 hours ಮೂವಿ ಕಂಪ್ಲೀಟ್ಲಿ ನೆನಪಿರುತ್ತೆ. ಇವನ್ ಹಾಡು ಕೂಡ ನೆನಪಿರುತ್ತೆ. ಯಾಕೆ? ಬಿಕಾಸ್ ಅವ್ರ ಬಗ್ಗೆ ನಿಮಗೆ ಗೊತ್ತಿರುತ್ತೆ. ಅದಕ್ಕೆ ನೀವು ಯಾವುದಾದ್ರೂ ಒಂದು ಕಾನ್ಸೆಪ್ಟನ್ನ ಕಲಿಯೋಕ್ಕಿಂತ ಮುಂಚೆ ಆ ಸೈಂಟಿಸ್ಟ್ ಯಾವ ಟಾಪಿಕ್ನ ಓದ್ತಾ ಇದ್ದೀರಾ, ಅದ್ರ ಬಿಹೈಂಡ್ ಯಾರಿದ್ದಾರೆ. ಎಕ್ಸಾಂಪಲ್ ಪ್ರೊಫೆಸರ್ ವಿದ್ಯಾರಾಜ ಹಿ ಡಿಡ್ ಥಿಯರಿಟಿಕಲ್ ಸೈನ್ಸ್, ದ ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಮೇಲೆ ಸ್ಟ್ರಾಂಗ್ಲಿ ಕೋರಿಲೇಟೆಡ್ ಥಿಯರಿ ಮೇಲೆ ವರ್ಕ್ ಮಾಡಿದ್ದಾರೆ. ಫ್ರಾಂಕ್ ಕಾಂಡನ್ ಪ್ರಿನ್ಸಿಪಲ್ಸ್ ಮೇಲೆ ವರ್ಕ್ ಮಾಡಿದ್ದಾರೆ. ಅಷ್ಟೊಂದು ಈ ಪರ್ಟರ್ಬೇಷನ್ ಥಿಯರಿ, ಈ ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಮೇಲೆ ವರ್ಕ್ ಮಾಡಿದ್ದಾರೆ. ಈಗ ಅವ್ರ ಬಗ್ಗೆ ನಾವು ತಿಳ್ಕೊಂಡಾಗ, ಬಿಕಾಸ್ ಪ್ರೊಫೆಸರ್ ವಿದ್ಯಾಧಿರಾಜ ಅವಾಗ ಹೋಗಿ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ಕಲ್ಲಿ ಅವ್ರ ಬಗ್ಗೆ ಅವ್ರು ಬರೆದಿರ್ತಕ್ಕಂಥ ಇದನ್ನು ಓದಿ ಆಫ್ಟರ್ ನೀವು ಎಷ್ಟು ಬೇಕಾದಷ್ಟು ವರ್ಷ ಬಿಟ್ಟು ಬನ್ನಿ, ನಿಮಗೆ ಇನ್ನೂ ನೆನಪಿರುತ್ತೆ. ಬಿಕಾಸ್ ಯು ನೋ ಅಬೌಟ್ ಹಿಮ್, ಯು ಲರ್ನ್ಟ್ ಅಬೌಟ್ ಹಿಮ್, ಹೌದಲ್ವಾ? ಅದೇ ಥರನೇ ಮೂವಿ ಯಾವ ಥರ ನೀವು ಹೀರೋಗೆ ಯಾವ ಥರ ಇದನ್ನು ಮಾಡ್ತೀರ, ಅದೇ ಥರನೇ ಲರ್ನ್ ಅಬೌಟ್ ಸೈಂಟಿಸ್ಟ್. ಆಗಲೇ ಹೇಳ್ತಾ ಇದ್ರು ಪ್ರೊಫೆಸರ್ ವಿದ್ಯಾಧಿರಾಜ, ವಾಟ್ ಇಸ್ ದ ನ್ಯೂ ಬಾರ್ನ್ ಬೇಬಿ ವಿಲ್ ಡೂ. ಮುಂದೆ ಒಂದು ದಿವಸ ನೀವು ಟ್ಯಾಕ್ಸ್ ಕಟ್ತೀರಾ, ನೀವು ಇದು ಎದಕ್ಕೆ ಯೂಸ್ ಆಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಿಸಿಟಿ. ಮೈಕಲ್ ಫ್ಯಾರಡೆ, ಹಿ ಈಸ್ ದ ಮ್ಯಾನ್ ಬಿಹೈಂಡ್ ಆಲ್ ದ ವೈರ್ಲೆಸ್ ಕಮ್ಯುನಿಕೇಷನ್ ರೈಟ್ ನೌ. Wireless communication with the Maxwell's he solved many problems. And law of electrolysis, now we are using the battery and everything because of Michael Faraday. He did only 3 years schooling. Learn about the scientist and go and learn about that unification of forces, electricity, magnetism, electrodynamics and many things. ನಿಮ್ಮ ಕಣ್ಣು ಮುಂದೆ ಬಂದ್ಬಿಡುತ್ತೆ ಅದು ಆಟೋಮೆಟಿಕ್ಕಾಗೆ. ಫಸ್ಟ್ ಅವ್ರ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳಿ. ದಿಸ್ ಇಸ್ ಹೌ. ಈಗ ಯಾಕೆ ಇದನ್ನ ಇಲ್ಲ ಇಷ್ಟೆಲ್ಲ ಹೇಳಿದೆ ಅಂತಂದರೆ, ಬಿಕಾಸ್ ನಾವು ಒಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ಬೇಕು, ಅದಕ್ಕೋಸ್ಕರ ಅದನ್ನೆಲ್ಲ ಹೇಳಿದೆ. ನನಗೆ ಬ್ಯಾಕ್ಗ್ರೌಂಡ್ ಬೇಕಲ್ಲ, ಅದಕ್ಕೆ. ಓಕೆ, ಇದು ಏನಂತಂದರೆ, ಈಗ ಒಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ತೀನಿ. ಈ ಜಾನ್ ಟಿಂಡಲ್ ಅಂತ, ನೀವು ಮನೆಯಲ್ಲಿ ಈಗ ಈ ಸನ್ಸೆಟ್ಟು ಸನ್ರೈಸ್ ಆಗಬೇಕಾದ್ರೆ ಕಿಟಕಿಲಿ ಬಿಸಿಲು ಬಿದ್ದಿರತ್ತೆ, ನೋಡಿದ್ದೀರಾ? ಒಂಥರ ಛಾಯ ಬಿದ್ದಿರತ್ತೆ, ರೇಸ್ ಬಂದಿರತ್ತೆ, ನೋಡಿದ್ದೀರಾ ಯಾವತ್ತಾದರೂ? ಡೈಲಿ ನೋಡ್ತೀವಿ. ಟೆಲ್ ಮಿ ಎಸ್ ಆರ್ ನೋ. ಏನ್ರಿ? ಆ್ಯಂಡ್ ರಿಮೆಂಬರ್ ಒನ್ ಥಿಂಗ್, ನಿಮ್ಮ ಜೀವನದಲ್ಲಿ ಏನಾದರೂ, ಬಿಕಾಸ್ ಯು ಆರ್ ಆಲ್ ಸೈನ್ಸ್ ಸ್ಟೂಡೆಂಟ್ಸಿಗೆ ಒಂಥರ ಎನರ್ಜಿ ಹೇಗಿರಬೇಕು ಅಂತಂದರೆ, ಬಿಕಾಸ್ ಯು ಆರ್ ದ ಪರ್ಸನ್, ದ ಫ್ಯೂಚರ್ ಇಂಡಿಯಾ. ರಿಮೆಂಬರ್, ಯು ಆರ್ ದ ಬ್ಯಾಕ್ ಬೋನ್ ಆಫ್ ದ ಕಂಟ್ರಿ. BSc ಜನ ಎಷ್ಟು ಜನ ಇದ್ದೀರಾ? ಕೈ ಎತ್ತಿರಿ ನೋಡೋಣ. ಏನ್ರಿ ಎಷ್ಟು ಸ್ಲೋಗೆ ಕೈ ರೇಸ್ ಮಾಡ್ತೀರಾ? ಯು ಆರ್ ದ ಬ್ಯಾಕ್ ಬೋನ್ ಫಾರ್ ದ ಫ್ಯೂಚರ್ ಇಂಡಿಯಾ. ರಿಮೆಂಬರ್, ಯಾರು BSc, MSc, PhD, ದಿಸ್ ಇಸ್ ದ ಫಂಡಮೆಂಟಲ್. ಎಕ್ಸಾಂಪಲ್ PUC ಸೈನ್ಸ್ ಮಾಡ್ತಾರೆ, ಯು ವಿಲ್ ಕಮ್ ಟು ದ BSc ಲೇಟರ್, ದಟ್ ಈಸ್ ಡಿಫ್ರೆಂಟ್ ಕೇಸ್. But these BSc students, they will rule the science because they are very curious. That's why they did BSc. Be proud of yourself. See, nanu BSc madidini, PhD madidini. Take any scientist, the top scientist in the world. They did a BSc, MSc and PhD. And of course, engineers also become a scientist like Thomas Alva Edison, the APJ Abdul Kalam sir. And sir, he is a scientist and he was an engineer. And like that, ರಿಮೆಂಬರ್, ಎಕ್ಸೆಪ್ಷನಲ್ ಇಂಜಿನಿಯರ್ ಆಗಬೇಕು. ದಿಸ್ ಇಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. BSc ದವರಿಗೆ ಒನ್ ಮೋರ್ ಟೈಮ್ ಬಿಗ್ ರೌಂಡ್ ಅಪ್ಲಾಸ್ ಫಾರ್ BSc ಸ್ಟೂಡೆಂಟ್ಸ್. ಈ BSc ಸ್ಟೂಡೆಂಟ್ ಏನಿದಾರಲ್ಲ, ಯಾಕೆ ಅವ್ರಿಗೆ ಕ್ಲಾಪ್ಸ್ ಹಾಕಿದೆ ಅಂತಂದರೆ, ನಮ್ಮ JNCSR ಅಲ್ಲಿ BS ಪ್ರೋಗ್ರಾಮ್ ಅಂತ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. MSc ಇಂಟಿಗ್ರೇಟೆಡ್ MSc ಆ್ಯಂಡ್ PhD ಪ್ರೋಗ್ರಾಮ್. ಇವ್ರ ಹತ್ರ ಆಪ್ರೇಟರಾಗಿ ಯಾರಿದ್ದಾರೆ ಹೇಳಿ? ME MTech ಮಾಡಿದವರು ಇದ್ದಾರೆ, ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಆಪ್ರೇಟರ್ಸ್. ಯಾರು ವರ್ಕ್ ತೊಗೊತಾರೆ? BSc ಸ್ಟೂಡೆಂಟ್ಸ್. ನಾನು ಹಾಗಾದರೆ ಅವ್ರನ್ನ ಇನ್ಫಿನಿಟಿ ಅಂತ ಅವ್ರನ್ನ ಸಪ್ರೆಸ್ ಮಾಡ್ತಾ ಇಲ್ಲ, ಬಟ್ ದಟ್ ಇಸ್ ದ ಪವರ್ ಆಫ್ ಬ್ಯೂಟಿ ಆಫ್ ದಟ್ BSc ಕೋರ್ಸ್. ರಿಮೆಂಬರ್, ಯು ನೆವರ್ ನೋ ದ್ಯಾಟ್. ನೀವು PUC ಸೈನ್ಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇದಿರಲ್ಲ, ನೀವು ಕೇಳಿ ಇಲ್ಲಿ ಇಷ್ಟು ಟಾಪ್ ಸೈಂಟಿಸ್ಟ್ಗಳೆಲ್ಲರೂ ಇದ್ದಾರೆ, ಈ ಸೇಮ್ ಸಿಲೆಬಸ್ಸೇ ಯೂಸ್ ಮಾಡೋದವರು. ವಿತೌಟ್ ದಟ್ ಸಿಲೆಬಸ್ ನೋ ರಾಕೆಟ್ ಲಾಂಚ್, ನಥಿಂಗ್. ನ್ಯೂಟನ್ಸ್ ಲಾಸ್, ನಥಿಂಗ್. ಇಸ್ರೋ ವರ್ಕೇ ಆಗಲ್ಲ. PUC 10th 11th 12th ವಿತೌಟ್ ದೀಸ್ 3 years ಯಾವುದು ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಲೇ ರಾಕೆಟ್ ಲಾಂಚ್ ಮಾಡಿ ಅಂತ ಹೇಳಿ ಇಸ್ರೋಗೆ ಆಗಲ್ಲ ಅಂತ ಹೇಳ್ತಾರೆ ಅವರು. ನೀವು ಕಲಿತಾ ಇರೋದು ಇಂತಿಂಥ ದೊಡ್ಡ ದೊಡ್ಡ ಸಿಲೆಬಸ್ನ ಕಲಿತಾ ಇದ್ದೀರ. ರಿಮೆಂಬರ್ ಆ್ಯಂಡ್ ಫೀಲ್ ದ್ಯಾಟ್. ಎಂಜಾಯ್ ಮಾಡಿ. ನಿಮ್ಮ ಮುಖದ ಮೇಲೆ ಖುಷಿ ಇರಬೇಕು. ಸುಮ್ಮನೆ ಬಾಯಾಟ್ ಮಾಡಿ ಏನೋ ಮಾಡಿ ಆ ಥರ ಮಾಡೋಕ್ಕೆ ಹೋಗ್ಬೇಡಿ. ಯು ಆರ್ ದ ಫ್ಯೂಚರ್ ಇಂಡಿಯಾ. ರಿಮೆಂಬರ್, ನೀವು ಹ್ಯಾವ್ ಲಾಟ್ ಆಫ್ ರೆಸ್ಪಾನ್ಸಿಬಿಲಿಟಿ. ನಮ್ಮ ಅಪ್ಪ ಹೇಳಿದ್ರು, ನಮ್ಮಮ್ಮ ಹೇಳಿದ್ರು, ನನ್ನ ಫ್ರೆಂಡ್ ಹೇಳಿದ್ರು, ಅದಕ್ಕೆ ನಾನು ಸೈನ್ಸ್ ಮಾಡಿದೆ ಅಂತ ಅನ್ಕೊಳಕ್ಕೆ ಹೋಗ್ಬೇಡಿ. ನೆವರ್ ಡೂ ದ್ಯಾಟ್ ಮಿಸ್ಟೇಕ್. ಥ್ಯಾಂಕ್ ಯು. ಆ್ಯಂಡ್ ಸೈಂಟಿಸ್ಟ್ ಬಗ್ಗೆ ಹೇಳಬೇಕಂತ ಅಂದ್ಕೊಂಡಿದ್ದೆ, ಸುಮ್ಮನೆ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಟೈಮ್ ವೇಸ್ಟ್ ಅಲ್ಲಿ ದಿಸ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಮೆಸೇಜ್ ಫಾರ್ ಯು. ಥ್ಯಾಂಕ್ ಯು. ಆ್ಯಂಡ್ ನನಗೆ ಈ ಲೈಟ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಮಾಡ್ತಾ ಇದ್ದಾರಲ್ಲ ಇಲ್ಲಿ ಅವರು, ಆ ರೇಸ್ ಬೀಳ್ತಾ ಇತ್ತಲ್ಲ, ಲೈಟ್ ರೇಸ್ ಬೆಳಿಗ್ಗೆ, ಅದು ಹೇಗೆ ಬೀಳುತ್ತೆ, ಅದಕ್ಕೆ ಟಿಂಡಲ್ ಎಫೆಕ್ಟ್ ಅಂತ ಕರೀತಾರೆ. ಈ ಟಿಂಡಲ್ ಎಫೆಕ್ಟ್ ಬಗ್ಗೆ ಬರೀ ನಿಮ್ಮ ಸ್ಕೂಲಲ್ಲಿ, ಕಾಲೇಜಲ್ಲಿ ವಾಟ್ ಇಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ಟಿಂಡಲ್ ಎಫೆಕ್ಟ್ ಅಂತ ನೀವು ಕಲ್ತಿದ್ದೀರಾ, ಹೌದಲ್ವಾ? ಟಿಂಡಲ್ ಎಫೆಕ್ಟ್ ಯಾರು ಹೇಳಿದ್ದು? ಯಾರಾದ್ರೂ ಗೊತ್ತಾ ನಿಮಗೆ? ಫಸ್ಟ್ ಅವ್ರ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳಿ, ಯಾವುದಾದ್ರು ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ನ ತಿಳ್ಕೊಳ್ಳೋಕ್ಕಿಂತ ಮುಂಚೆ. ಅದಕ್ಕೋಸ್ಕರ ಜಾನ್ ಟಿಂಡಲ್, ಹೀಸ್ ನೇಮ್ ಈಸ್ ಜಾನ್ ಟಿಂಡಲ್. ಇವತ್ತು ನೀವೆಲ್ಲ ಈ ಯೂಟ್ಯೂಬಲ್ಲಿ ಹಿಂಗೆ ಕ್ಲಿಕ್ ಮಾಡಿದ ತಕ್ಷಣ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ ಕೇಬಲಲ್ಲಿ ಒಂದು ದೇಶದಿಂದ ಇನ್ನೊಂದು ದೇಶಕ್ಕೆ ಬರ್ತಾ ಇದೆಯಲ್ಲ ಸಿಗ್ನಲ್ಸು, ಒಂದೆಲ್ಲೋ ಒಂದು ಕಡೆ ಹಾರ್ಡ್ ಡ್ರೈವಲ್ಲಿ ಒಂದು ವಿಡಿಯೋ ಸ್ಟೋರ್ ಮಾಡಿಟ್ಟಿದ್ದಾರೆ, ಅದಕ್ಕೊಂದು ಅಡ್ರೆಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ನೀವೇನು ಮಾಡ್ತೀರಾ, ಒಂದು ವಿಡಿಯೋನ ಸರ್ಚ್ ಮಾಡ್ತಾರೆ. ಸರ್ಚ್ ಮಾಡಿದ ತಕ್ಷಣ ಅಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಒಂದು ಫ್ರಾಕ್ಷನ್ ಆಫ್ ಸೆಕೆಂಡಲ್ಲಿ ಬರುತ್ತೆ. ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟಲ್ಲಿ. ವಾಟ್ ಇಸ್ ದ ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್? 3 lakh km/s. ಹೌದಲ್ವಾ? ಅಷ್ಟು ಸ್ಪೀಡಲ್ಲಿ ನೀವು ವಿಡಿಯೋ ನೋಡ್ತಾ ಇದ್ದೀರಾ. ಇದನ್ನು ಫಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟಲ್ಲಿ ಮಾಡಿದ್ದು ಯಾರು ಗೊತ್ತಾ? ಒಂದು ವಾಟ್ರಲ್ಲಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿ ಜಾನ್ ಟಿಂಡಲ್. ಓಕೆ ಫೈನ್. ಜಾನ್ ಟಿಂಡಲ್ ಏನು ಹೇಳಿದ್ರು ಅಂತಂದರೆ, ನಿಮ್ಗೆ ಏನಾದರೂ ಈ ಸ್ಕ್ಯಾಟ್ರಿಂಗ್, ಈ ಫೆನಾಮಿನ ನೋಡಬೇಕಂದ್ರೆ ಅವ್ರು ಕಂಡೀಷನ್ ಹಾಕಿದ್ರು, ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ಏನು 85 nanometer 900 nanometer ಇರಬೇಕು. ಅಂದಾಗ ಮಾತ್ರ ನೀವು ಈ ಟಿಂಡಲ್ ಎಫೆಕ್ಟ್ ನೋಡ್ತೀರಾ, ಅದರ್ವೈಸ್ ಯು ವಿಲ್ ನಾಟ್ ಸಿ ಅ ಟಿಂಡಲ್ ಎಫೆಕ್ಟ್. ರಿಮೆಂಬರ್. ಓಕೆ.
Actually, this is also seeing the invisible. Light itself is invisible, but it helps you to see things. But if you want to see light itself, then you need to do something. You need to scatter light. Okay, that's what he's talking about. You need to turn off these lights.
Can you turn off the light? ಓಕೆ. ವಾಟ್ ಜಾನ್ ಟಿಂಡಲ್ ಸೆಡ್, ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ಇಷ್ಟೇ ಇರಬೇಕು ಅಂತ. ಇಲ್ಲ ಅಂದರೆ ನಿಮಗೆ ಟಿಂಡಲ್ ಎಫೆಕ್ಟ್ ಕಾಣಿಸಲ್ಲ. ಓಕೆನಾ? ನಾನೀಗ ನನ್ನ ಹತ್ರ ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ಆಲ್ಮೋಸ್ಟ್ ಆಲ್ ಎಲ್ಲ ಸೈಜಸ್ ಇದು ಪಾರ್ಟಿಕಲ್ಸ್ ಇದೆ. ಯಾಕಂದರೆ ಏನು ಯೂಸ್ ಮಾಡಿದ್ದೀನಿ? ಚಾಕ್ ಪೌಡ್ರು. ಓಕೆ, ಲೋ ಕಾಸ್ಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಇದು. ಚಾಕ್ ಪೌಡ್ರು ಇದಕ್ಕೆ 300 rupees. ಈ ಲೇಸರ್ಗೆ 300 rupees. ಯು ಕ್ಯಾನ್ ಸಿ ದಟ್ ಟಿಂಡಲ್ ಎಫೆಕ್ಟ್, ಆರ್ ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ಸೇ ದಟ್ ಸ್ಕ್ಯಾಟ್ರಿಂಗ್ ಆಫ್ ಲೈಟ್. ಸ್ಕ್ಯಾಟ್ರಿಂಗ್ ಆಫ್ ಲೈಟ್ ಅಂತ ನೀವು ಕೇಳಿದ್ದೀರಾ ನೋಡಿ. Can you see that? This is a Tyndall effect. John Tyndall ಹೇಳಿದ್ದನ್ನ ಇಲ್ಲಿ ತೋರಿಸ್ತೀವಲ್ಲ ನೋಡಿ. ಇಲ್ಲ, ಅದು ಪ್ಲೇ ಮಾಡಬೇಕಾದ್ರೆ ಲೈನ್ ಕ್ಯಾನ್ಸಲ್ ಆಗಲ್ಲ. ಓಕೆ ಫೈನ್. ಆ್ಯಂಡ್ ಡಿಫ್ರಾಕ್ಷನ್ ಆಫ್ ಲೈಟ್ ಕ್ವಿಕ್ ಮಾಡ್ಬೇಕು, ಯಾಕಂದರೆ ಬಿಕಾಸ್ ವಿ ಡೋಂಟ್ ಹ್ಯಾವ್ ಟೈಮ್, ಓನ್ಲಿ 10 minutes. ಡಿಫ್ರಾಕ್ಷನ್ ಆಫ್ ಲೈಟ್ ಅಂತಂದರೆ, ಇವಾಗ ನೀವು ಸ್ಕ್ಯಾಟ್ರಿಂಗ್ ಆಫ್ ಲೈಟ್ ನೋಡಿದ್ರಿ, ಇದಕ್ಕೆ ಟಿಂಡಲ್ ಎಫೆಕ್ಟ್ ಅಂತಲೂ ಕರೆದ್ರಿ, ಹೌದಲ್ವಾ? ಓಕೆ, ನಾವು ವಾಟ್ ಐಲ್ ಡೂ, ಇಲ್ಲಿ ನನ್ನ ಹತ್ರ CD ಇದೆ, ಇದಕ್ಕೆ ಕಾನ್ಸೆಂಟ್ರಿಕ್ ರಿಂಗ್ಸ್ ಇದೆ, ಹೌದಾ? ಎಷ್ಟು ಸೈಜಲ್ಲಿದೆ ಗೊತ್ತಾ? ಆಲ್ಮೋಸ್ಟ್ 1/2 micrometer. 1/2 micrometer ಅಂದರೆ ಒಂದು 500 nanometer. 1 nanometer ಅಂದರೆ ಗೊತ್ತಾ ನಿಮಗೆ? You can visualize my hair thickness is about some 50 micrometer, and cut that 50 micrometer into 50 times. Take one part, that part, what is the thickness of this part? 1 micrometer. Cut this into 1000 times. Take one part, that is called 1 nanometer. Now we have a 500 nanometer ಈ ಕಾನ್ಸೆಂಟ್ರಿಕ್ ರಿಂಗ್ಸ್ ಇದೆ ಇದರಲ್ಲಿ. ನಾನು ಯೂಸ್ ಮಾಡ್ತಾ ಇರೋ ಲೇಸರ್ ಗ್ರೀನ್ ಕಲರ್ ಲೇಸರು, ದಟ್ ಈಸ್ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 532 ನ್ಯಾನೋಮೀಟರ್. ಓಕೆ, 532 ನ್ಯಾನೋಮೀಟರ್ ಲೈಟ್ ಲೇಸರು, ರಿಂಗ್ಸ್ ಇದೆ, ಸ್ಮಾಲ್ ಅಬ್ಸ್ಟ್ಯಾಕಲ್ಲು. ರೂಲ್ ಏನು, ಯಾವುದೇ ಒಂದು ಲೈಟ್ ಬಂದು ಒಂದು ಅಬ್ಸ್ಟ್ರಾಕ್ಷನ್ನಿಗೆ ಏನ್ರಿ ಅಬ್ಸ್ಟ್ರಕ್ಷನ್ನಿಗೆ ಹಿಟ್ ಆಯಿತು ಅಂದರೆ ಇಟ್ ವಿಲ್ ಡೈವರ್ಜ್, ಅದು ಚೇಂಜ್ ಆಗುತ್ತೆ ಅದರ ಡೈರೆಕ್ಷನ್ನು. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಅ ಡಿಫ್ರಾಕ್ಷನ್ ಆಫ್ ಲೈಟ್. ಇದು ನೇಚರಲ್ಲಿ ತುಂಬ ಕಡೆ ನೋಡ್ತೀವಿ ನಾವು. ಓಕೆ, ಸೊ ಸರ್ ವಿಲ್ ಶೈನ್ ದ ಲೈಟ್. Okay, you can see the diffraction spots on the ceiling if you want. And sir, this is green color laser. ನಾನು green color laser ಬಗ್ಗೆ ಹೇಳ್ಬಿಟ್ಟೆ already. 532 nanometer. Okay, you can see here. Can you see now? These rays. You know, you can exactly know where exactly diffraction, because you know the wavelength of the light, and you can make out what is the size of the abstraction. Okay. Those obstructions are to make you to see. Okay, this is called a diffraction of light. Many experiments we have. Okay, not only that, and sir will explain about the superconductor, and will finish it off, and will create the cloud at the end of the session. Okay.
This sunlight you don't want.
Sunlight the camera focus ಮಾಡಬೇಕು. ಬೇಡ ಬಿಡಿ. Sunlight ಆಮೇಲೆ. Okay, and this one. Okay, ಇದನ್ನ ಹೇಳಿಲ್ಲ.
So there is one more, this optical fiber that Dr. Vinayak was talking about. So this optical fiber is based on the principle called total internal reflection. So basically the idea is that if I pass light like this, then you can see it is passing through the glass. Okay, but what will happen if I change the angle? At some angle you will see that the light will not come out. Can you please put some chalk powder on this? I want to show the path of light. So you will see light is coming out of the other side. Okay, but at some point light will stop coming out of the other side. Okay, so now you see, gotaito nan shirt hoytu ivattu. So you will see now, you see light is now completely inside. Can you see? Okay. So light is completely reflected inside the system beyond a critical angle, and this is the principle we use for telecommunications. This is the optical fiber principle. Okay, without using a mirror, you can reflect light inside a fiber. Okay, just by using different refractive index materials.
Yeah, I have an example of this optical fiber cable. You can see here. I rolled it like this. And sir will hold at the different end, and he will show you that how light will move in that fiber. Okay, I'll show. Explain my point.
So you see, this is the optical fiber. This is a very high quality optical fiber. Okay, so what we are doing is we are actually shining light from one end, and the principle that you study in your class, light travels in a straight line, that is not violated here. Light is still traveling in a straight line. Okay. Whose phone is that? Okay. Yeah. So light is still traveling in a straight line, but then reflecting back and forth, and then going in a zigzag way to come out of the other end. Okay. In fact, this fiber is so good that you can actually fold it multiple times. Can you please fold it multiple times?
I'm already folded.
He's already folded it.
You can see it.
See, even after folding so many times, you can still see light is coming out of the other end and not leaking out anywhere. Okay, so this is optical fiber effect, and this is how information is coded into light, and that information travels at the speed of light from one end to the other end.
Stage light, yeah.
Okay, stage lights please. On mabidi, ella on mabidi.
Ella lights on mabidi.
So this is the last one, and again this is also going to illustrate how basic science becomes technology. So those who were in the morning session, we already discussed it, that we can make MRI machines, we can make this quantum computers, superconducting qubits, and we can also make superconducting magnetic levitation trains using this superconductivity principle. Okay, so this principle is now being demonstrated here, that the superconductor actually displays Meissner effect, something called diamagnetism. Okay. But it is more than diamagnetism, this is a quantum locking effect. So what happens is that there is a track here, the track is made out of magnets, and there is a superconductor which is present inside this both. That material becomes a superconductor only at very low temperatures. Somebody has asked the question, why are we not having room temperature superconductors? That's because Udupi is hot or Earth is hot. Okay? The problem is that the coldest temperature on Earth is just about minus 80 degrees Celsius. Today we have superconductors like this YBCO, which works at about 90 Kelvin, minus 180 degrees Celsius. Okay? There is no place on Earth which is minus 180 degrees Celsius, but there are places on the moon. So if some of you go and live on the moon, on a colony in the moon, you will have a room temperature superconductor. Okay? And there is a quest worldwide. In fact, that is one of the grand challenges, as one of the children asked. That is one of the grand challenges. Can we make a room temperature superconductor? Okay? So what we are showing here is that there is a quantum locking effect, and because of the quantum locking effect, you can make a train run on a track which is floating, okay? And you also don't need walls to hold it. It's floating on its own, okay? So let's see how that works. No, Agilala. You need more, yeah.
Because here very, very hot.
Yeah, Udupi is hot. So this is all for cooling the superconductor, okay? And you have to cool it below about 90 Kelvin, right? If you cool it below 90 Kelvin, it becomes superconducting, which means inside that material, something very special happens. I was telling in the morning, you get a fifth phase of matter, which is the Bose-Einstein condensate, okay? That's what is born inside this material.
Okay, fine.
Aita?
10 seconds more. And remember, this, meanwhile, what I'll do, let it cool some more. And it's so very, very cold. Properties of liquid nitrogen, you know, if you talk about, it uses everywhere, you know, especially in cryogenic experiments and all.
In agriculture.
Agriculture, and to store some biological samples. And MRI machines, all the MRI machines has this LN2.
Liquid helium.
Yeah, liquid helium. That liquid helium, which is, you know, the liquid nitrogen, they use to encapsulate liquid helium. They need a liquid helium as well as. Thank you very much, sir. Sorry, I apologize to the flower because it's a beautiful flower. Sorry,
what is the temperature of LN2? We had discussed in the morning. 77 Kelvin.
Or minus 196 degrees Celsius.
So actually, this liquid nitrogen is even colder than that, because 77 Kelvin is the boiling temperature of liquid nitrogen. It's like water's boiling temperature, right? Water's boiling temperature is 100 degrees Celsius. But at room temperature, water is a liquid. So this liquid is colder than 77 Kelvin. Okay? It's roughly about 50 or even 40 Kelvin. Very, very cold.
Now you can see now, it is levitating on the track. And they are going to, you know, the project over there. I have a 2 train here that is a magnetically levitating, because this magnet is there, you know, this is a magnetic track. And what this magnet is doing, it is penetrating that superconductor. But superconductor is a diamagnet, as sir said. Camera illi focus maglilla. Okay, here. Idu kanista ide nodi. Levitate aagta ide. You can see the levitation. Okay. Ee Maglev train idu telta untu adra mele. Idralli Japan amele idralli ಚೈನಾದಲ್ಲಿ ಈ ಟ್ರೈನು ಟ್ರ್ಯಾಕ್ ಮೇಲೆ ಹೋಗೋದಿಲ್ಲ, ಟ್ರ್ಯಾಕ್ ಮೇಲೆ ಸ್ವಲ್ಪ ಲಿಮಿಟೆಡ್ ಆಗಿ ಹೋಗುತ್ತೆ. ಓಕೆ, ಸೊ ದೇ ಅಚೀವ್ ಸಮ್ 500 kilometer per hour, more than 500 kilometer per hour.
I showed the train in the morning.
Okay. But the PU students, sir, PU students ನೋಡಿಲ್ಲ ಪಾಪ. ಪಾಪ ಅಂದ್ಬಿಟ್ಟೆ ಸರ್ ಅವ್ರಿಗೆ, ಬಿಕಾಸ್ ಅವ್ರು ನೋಡಿಲ್ಲಂತೆ. So it is levitating.
I showed an actual video of an actual train in the morning.
ಈ ಮ್ಯಾಗ್ನೆಟ್ ಇದೆಯಲ್ಲ, ಈ ಸ್ಟ್ರಾಂಗ್ ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್ನ ಅದಕ್ಕೆ ಬಿಡುತ್ತೆ. ಬಟ್ ಈ ಸೂಪರ್ ಕಂಡಕ್ಟರ್ ಏನು ಮಾಡುತ್ತೆ, ನನಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಬೇಡ ಅಂತ ಪುಷ್ ಮಾಡುತ್ತೆ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಮೈಸರ್ ಎಫೆಕ್ಟ್, ಆಸ್ ಸರ್ ಸೆಡ್. ಓಕೆ, ಮೆನಿ ಥಿಂಗ್ಸ್ ಆರ್ ದೇರ್ ಇನ್ಸೈಡ್, there is a,
Can you show the quantum lock?
Yeah, I'll show the quantum lock, but some of the flux too. ಸಮ್ ಆಫ್ ದ ಫ್ಲಕ್ಸ್ ಟ್ಯೂಬ್, ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಇದೆಯಲ್ಲ, ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸು, ಆ ಫ್ಲಕ್ಸ್ ಟ್ಯೂಬ್ ಈ ಸೂಪರ್ ಕಂಡಕ್ಟರ್ ಒಳಗಡೆ ಪೆನೆಟ್ರೇಟ್ ಮಾಡಿ, ಅದು ಫ್ಲಕ್ಸ್ ಸ್ಪಿನ್ನಿಂಗ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಲಾಕ್ ಮಾಡುತ್ತೆ. ಲಾಕ್ ಮಾಡಿದ ತಕ್ಷಣ ಸೂಪರ್ ಕಂಡಕ್ಟರ್ ಆ ಕಡೆ ಈ ಕಡೆ ಅಲ್ಲಾಡೋದೇ ಇಲ್ಲ. It will be always on the track. You can see if I shake it, it will not fall.
One of them.
That is the old one. Okay. This is the new one. You can see now. If I do upside down, it will not fall. Can you see now? See, it is still levitating.
That's a quantum lock. Yeah. Okay.
Yeah. No, it will work, sir. It will work. See, still it is working. Yeah. You will do.
See, it's still working.
This is called a quantum locking.
And that is the principle.
Application of the superconductor is MRI machines, Maglev train, quantum computers. In future, ನೀವೆಲ್ಲ quantum computers ಮನೆಯಲ್ಲೇನೆ ಯೂಸ್ ಮಾಡ್ತಾರಾ ಈ ತರ.
In fact, even to read your signal, brain signal. Suppose I want to read your mind. What are you thinking about? Maybe some movie, maybe some physics concept, maybe something else. If I want to read your brain, I need sensors which can pick up magnetic field from your brain. There I can use something called SQUID, superconducting quantum interference device. Okay? So superconductors can also be used to read your mind.
ಸುಮ್ಮನೆ ನಿಮ್ಮ ಪಕ್ಕ ಹಿಂಗೆ ಸೂಪರ್ ಕಂಡಕ್ಟರ್ ಇಟ್ಕೊಂಡು ಹೋದ್ರೆ ಬಂದ್ಬಿಡುತ್ತೆ ಸರ್? ಹಂಗಿಲ್ಲ, ಇಂಪ್ಲಾಂಟ್ ಮಾಡಬೇಕು.
That is only for picking up the magnetic fields. Yes. Once you pick them up, then you have to analyze them.
And it's very, very cold. Last one, the small experiment ಮಾಡ್ತೀನಿ. If you keep your hand more than 10 seconds, what will happen? ಬ್ರಿಟಲ್ ಆಗುತ್ತೆ. ಸ್ವಲ್ಪ ಕೈ ಹೊರಗಡೆ ತೊಗೊಂಡು ಹಿಂಗೆ ಮಾಡಿಬಿಟ್ರೆ ಕೆಳಗಡೆ ಬಿದ್ದೋಗ್ಬಿಡುತ್ತೆ. ಗೊತ್ತಾ? PUC ಸ್ಟೂಡೆಂಟ್ಸು. You want to see that experiment? Hey, what is this? ಅಲ್ಲ, ನನ್ನ ಕೈನ ಟೆಸ್ಟ್ ಮಾಡ್ಬೇಕಂತಾರೆ. ಓಕೆ, ಸೊ ಇದು ಫ್ಲವರ್ನ. ಓಕೆ, ಸಾರಿ ಫ್ಲವರ್. ಚೆಕ್ ಮಾಡಿ ನೋಡೋಣ. ಒಂದು 10 ಕೌಂಟ್ ಮಾಡೋಣ. Tell me yes or no? Okay, start counting 10. Okay, start. 2. Oh, ulta. 4. Okay, you can see here. It happens because it is very, very cold, very cold. ಐಸ್ ಕ್ರೀಮ್ ಎಲ್ಲ 0 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ತಿಂತೀರಾ ನೀವು? ಇದು -196 ಬಿಯಾಂಡ್ ದ್ಯಾಟ್. ಐಸ್ ಕ್ರೀಮ್ ಆಗಿಬಿಡುತ್ತೆ ಕೈ. ಡೋಂಟ್ ಕೀಪ್ ಯುವರ್ ಹ್ಯಾಂಡ್ ಇನ್. ಇಟ್ ಈಸ್ ವೆರಿ ವೆರಿ ಡೇಂಜರಸ್. ಸಿ, ಸ್ಟಿಲ್ ಇಟ್ ಈಸ್ ಲೆವಿಟೇಟಿಂಗ್. ಅದು ಕೂಲ್ ಆಯಿತು ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ರೂಮ್ ಟೆಂಪರೇಚರ್ಗೆ ಬಂತು ಅಂದರೆ ಇಟ್ ಇಸ್ ಲೈಕ್ ಅ ಸಿರಾಮಿಕ್ ಡಿಸ್ಕ್. ಇಟ್ ಈಸ್ ನಥಿಂಗ್. Yttrium, barium, copper oxide. It is a compound material. It works only in that particular temperature because scientists have achieved that particular temperature. Room temperature superconductor, worldwide there are many scientists, hundreds of scientists, thousands of scientists, they are working on it because there is no loss in the energy, zero resistance material. Okay, that is very, very important. Last, I'll finish it with the cloud, sir, with your permission, because I'm wasting everything. Yeah. ಇಲ್ಲೇ ಮಾಡ್ಬೋದಾ? ಇಲ್ಲಿ ಬೇಡಲ್ಲ, ನೀರು ಬೀಳುತ್ತೆ ಇಲ್ಲಿ, ನಡೆಯೋದಲ್ಲ. ನೋ ಪ್ರಾಬ್ಲಮ್, ಎಲ್ಲ ಆಗಲ್ಲ. ಅಲ್ಲ, ಇಷ್ಟೇ ನೀರು ಬೀಳೋದು. ನಿಮ್ಮ ಜವಾಬ್ದಾರಿ ಸರ್ ಇದು. ಇನ್ನು ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನ್ ಬೇಕಾ? ಚೆನ್ನಾಗಿ ಕಾಣಿಸುತ್ತೆ. ಆ್ಯಂಡ್ ರಿಮೆಂಬರ್, ಇದು ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನ್ ಟೆಂಪರೇಚರ್. ಇದರಲ್ಲಿಲ್ಲ, ಹಾಕಿ ಅದು ಇದೆ, ಫುಲ್ ಇದೆ. ಲಿಕ್ವಿಡ್ ಹೀಲಿಯಂ ಟೆಂಪರೇಚರ್ ಎಷ್ಟು ಜನಕ್ಕೆ ಗೊತ್ತು? ನೋಡಿ ಯಾವ್ಯಾವ ಮೆಟಲ್ಲು. ಆ್ಯಂಡ್ ರಿಮೆಂಬರ್, ದೆರ್ ಈಸ್ ಒನ್ ಆ್ಯಪ್ ದಟ್ ಈಸ್ ಅ ವೆರಿ ಇಂಟ್ರಾಕ್ಟಿವ್ ಆ್ಯಪ್. ಈ ಕೆಮಿಸ್ಟ್ರಿದು ಪಿರಿಯಾಡಿಕ್ ಟೇಬಲ್ ಅದು RSC ಪಿರಿಯಾಡಿಕ್ ಟೇಬಲ್, RSC ಪಿರಿಯಾಡಿಕ್ ಟೇಬಲ್. ನೀವು ಅದನ್ನು ಸರ್ಚ್ ಮಾಡಿ. ಯಾವುದರಲ್ಲಿ? ಗೂಗಲ್ ಕ್ರೋಮಲ್ಲಿ. ಅದನ್ನು ಆ್ಯಪ್ನ ಇನ್ಸ್ಟಾಲ್ ಮಾಡಿ. ಯು ಕ್ಯಾನ್ ಪ್ಲೇ ವಿತ್ ದ ಪಿರಿಯಾಡಿಕ್ ಟೇಬಲ್. ತುಂಬ ಚೆನ್ನಾಗಿದೆ. ಯಾರಿಗೆ ಪಿರಿಯಾಡಿಕ್ ಟೇಬಲ್ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರುತ್ತೆ, ಹಿಲ್ ಬಿಕಮ್ ಅ ಬಿಗ್ಗೆಸ್ಟ್ ಸೈಂಟಿಸ್ಟ್. He will understand better. He can synthesize many materials because he knows each and every corner of the elements. So he can do a better science. So, and play with that. Aitala sir? Okay, fine. This is a hot body. And remember, ಏನಾಗುತ್ತೆ ಅಂದರೆ because that is in liquid form, this is also in liquid form, that is a minus 196 degrees Celsius boiling point. This boiling point is 100 degrees Celsius. This is a water, hot water. When you bring immediately together, what will happen? It expands rapidly. So you will see nitrogen gas form ಆಗೋದನ್ನು ನೋಡ್ತೀರಾ, ಅದು ವೆರಿ ಹೈ ರೇಟಲ್ಲಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ನಿಮಗೆ ಹೇಸ್ ಥರ, ಮಿಸ್ ಥರ, ಕ್ಲೌಡ್ ಥರ ಕಾಣಿಸುತ್ತೆ. ಓಕೆನಾ? ಓಕೆ, ಐ ವಿಲ್ ಜಸ್ಟ್ ಫಿನಿಶ್ ಇಟ್. ಓಕೆ, ಸ್ಟಾರ್ಟ್ ಕೌಂಟಿಂಗ್. 4, 3, 2, 1. ವಾಟ್ ಇಸ್ ದ ಲಿಕ್ವಿಡ್ ಹೀಲಿಯಂ ಟೆಂಪರೇಚರ್? minus 260? 269. ಓಕೆನಾ? ವಾಟ್ ಅಬೌಟ್ ಲಿಕ್ವಿಡ್ ಆಕ್ಸಿಜನ್? ಅದಕ್ಕೆ ತಿಳ್ಕೊಳ್ಳಿ, ಯಾವ ಎಲಿಮೆಂಟ್ ಯಾವ ಟೆಂಪರೇಚರಿಗೆ ಗ್ಯಾಸ್ ಆಗುತ್ತೆ, ಯಾವ ಎಲಿಮೆಂಟ್ ಯಾವ ಟೆಂಪರೇಚರ್ಗೆ ಲಿಕ್ವಿಡ್ ಆಗುತ್ತೆ. ಯು ಶುಡ್ ಹ್ಯಾವ್ ಸಮ್ ದಿಸ್ ಜನರಲ್ ಅವೇರ್ನೆಸ್ ಅಬೌಟ್ ದ periodic table. Install that RSC, Royal Society Chemistry periodic table, interactive periodic table. I asked already to your teachers and they will make you to install. Okay, 4, 3, wait. It actually costumes hakolde enu madangilla. Okay, start counting. Thank you very much. Thank you.
ಹಲೋ, ಒಂದೇ ಒಂದು ವಿಚಾರ ನೋಡಿ ಇಲ್ಲಿ minus 196 ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್, ಅದು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನ್ಗೆ. ಇದು ಇವರು ನಿಮಗೆ ತೋರಿಸಿದ್ರು ಚೆನ್ನಾಗಿದೆ ಎಲ್ಲ ಸರಿ. ನೀವು ಒಂದು ರಾಕೆಟ್ ಸ್ಟೇಜಲ್ಲಿ ಲಿಕ್ವಿಡ್ ಯಾರೋ ಕೇಳಿದ್ರು, ಅದು ಬೇರೆ ಥರ ರಾಕೆಟ್ಸ್ ಯಾವುದಿರುತ್ತೆ ಅಂದಾಗ ಸಾಲಿಡ್, ಲಿಕ್ವಿಡ್, ಕ್ರಯೋಜೆನಿಕ್ ಅಂತ ಹೇಳಿದೆ. ದಿಸ್ ಈಸ್ ಅ ಕ್ರಯೋಜೆನಿಕ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಕ್ರಯೋಜೆನಿಕ್ಸ್. We have 2 types of cryogenic technology at hand in India. Mind it, 2 types of cryogenic technologies. We use liquid hydrogen. You know at what temperature it boils? Minus 253 degrees centigrade. And we have liquid oxygen which boils at minus 183 degrees centigrade. And you have to supply them through turbopumps to the engine combustion chamber, where the temperature will be 2000 degrees centigrade plus. How do we make it to work? That is what is India today. Many a times this kind of rocket engines built in India have worked. So this is one demonstration there. The rocket itself has worked. I showed one slide in which we launched 5,600 kg American satellite. At that time also our Bahubali rocket's 3rd stage uses cryogenic propellants. Mind it, be proud of India. That's why I'm telling.
BSc ವಿದ್ಯಾರ್ಥಿನಿಯರು ಇಲ್ಲಿದ್ದೀರಾ. ಕ್ರಿಯೋಜೆನಿಕ್ ಸೆಟಪ್ ನಮ್ಮ ಥಿನ್ ಫಿಲ್ಮ್ ಲ್ಯಾಬಲ್ಲಿ ಇನ್ನು 1 ಮಂತಲ್ಲಿ ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನ್ ಲೆವೆಲ್ಗೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡುವ ಸೆಟಪ್ನ ಇಲ್ಲಿ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಅದನ್ನು ಪ್ರಯೋಜನವನ್ನು ನೀವು ಪಡಿಬೇಕು. ನೀವು ಬಂದು ರಿಸರ್ಚ್ ಮಾಡಿ. ದಿಸ್ ಫೆಸಿಲಿಟಿ ವಿಲ್ ಬಿ ಡೆವಲಪ್ಡ್ ಇನ್ ಅವರ್ ಲ್ಯಾಬಾರೆಟ್ರಿ. ಥಿನ್ ಫಿಲ್ಮ್ ಲ್ಯಾಬಲ್ಲಿ ಇದನ್ನು ತರ್ತಾ ಇದ್ದೀವಿ. 77 ಕೆಲ್ವಿನ್ವರೆಗೆ ನೀವು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ಬೋದು. ಹೀಲಿಯಂ ನಾವು ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಹೀಲಿಯಂ ಫೆಸಿಲಿಟೀಸ್ ನಮ್ಮಲ್ಲಿಲ್ಲ. 4 ಕೆಲ್ವಿನ್ವರೆಗೆ ಆಗುತ್ತೆ. ಅದು 77 ಕೆಲ್ವಿನ್ವರೆಗೆ ಮಾಡುವ ಫೆಸಿಲಿಟೀಸ್ನ ನಾವು ಇಲ್ಲಿ ತರ್ತಾ ಇದ್ದೀವಿ ಮುಂದೆ. ಥ್ಯಾಂಕ್ ಯು.
Thank you, Dr. Vinayak K. Patar, sir, and Professor Vidyadhiraja N.S., sir, for those exciting live experiment. I am truly grateful to all esteemed scientists for igniting curiosity and sparking our students' minds with knowledge. Thank you all the students for actively participating in the interaction section. We know that many of you are disappointed. You had lot of questions. As sir said, principal said, we will be mailing your questions, and we will request our scientists to please answer their questions. Thank you. I request Dr. A.P. Bhatt, sir, Honorary Secretary of Udupi Sri Adamaramata Education Council, Bengaluru, for the conclusion remark on Scientist Meet 2026.
ಇಷ್ಟು ಹತ್ರ ಬೇಡಿತ್ತು. ಪೂಜ್ಯರಿಗೆ ನಮಸ್ಕಾರ ಮಾಡಿಸ್ತಾ ವೇದಿಕೆಯಲ್ಲಿರುವಂಥ ಗಣ್ಯರೇ, ಮುದ್ದು ಮಕ್ಕಳೇ, ಒಂದೂವರೆ ನಿಮಿಷದಲ್ಲಿ ಮುಗಿಸ್ತೇನೆ ಅಂತ ನಿಮಗೆ ಎಶ್ಯೂರೆನ್ಸ್ ಕೊಡ್ತಾ ನನ್ನ ಮಾತನ್ನು ಪ್ರಾರಂಭಿಸ್ತೇನೆ. ಇಬ್ಬರು ಮಹಾನ್ ಚೇತನಗಳ ಶಿಷ್ಯರಿಲ್ಲಿದ್ದಾರೆ. ಒಬ್ಬರು ಭಾರತ ರತ್ನ ನಮ್ಮ ನೆಚ್ಚಿನ ಅಬ್ದುಲ್ ಕಲಾಂ ಸರ್ನ ಇಬ್ಬರು ಸ್ಟೂಡೆಂಟ್ಸ್ ಅಲ್ಲಿದ್ದಾರೆ. ಹಾಗೆಯೇ ನಮ್ಮ ಭಾರತ ರತ್ನ CNR ಅವರ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ ಇದ್ದಾರೆ. ಎರಡು ಮಹಾನ್ ಚೇತನಗಳ ವಿದ್ಯಾರ್ಥಿಗಳು ನಮ್ಮ ಮುಂದಿದ್ದಾರೆ ಅಂತ ಹೇಳೋದು ತುಂಬ ತುಂಬ ಹೆಮ್ಮೆ. ಅದು ನಮ್ಮ ಭಾಗ್ಯ. ಇವತ್ತು ಇಂಥ ಒಂದು ಒಳ್ಳೆಯ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಅವರು ಇಲ್ಲಿ ಬಂದದ್ದು ನಮ್ಮ ಭಾಗ್ಯ ಅಂತ ತಿಳಿತೇನೆ. ಒಂದು ಆಸೆ ನನಗೆ ಏನಂದರೆ, ಸರ್ ಕೋಲ್ಡ್ ಫ್ಯೂಷನ್ ಬಗ್ಗೆ ಹೇಳಿದರು. ಎಷ್ಟೋ ಸಾರಿ ಫ್ಯೂಷನ್ ಬಗ್ಗೆ, ಸೂರ್ಯನ ಒಳಗಡೆ ನಕ್ಷತ್ರಗಳ ಒಳಗಡೆ ಹೈಡ್ರೋಜನ್ ಫ್ಯೂಸ್ ಆಗಿ ಹೀಲಿಯಂ ಆಗಿ ಶಕ್ತಿ ಚಿಮ್ಮತ್ತಲ್ವೇ, ಇದು ಹಾಟ್ ಫ್ಯೂಷನ್. ಸರ್ ಇವತ್ತು ಕೋಲ್ಡ್ ಫ್ಯೂಷನ್. ಅಬ್ದುಲ್ ಕಲಾಂ ಅವರು ಕೇಳಿದ್ರಂತೆ, ನೀನು ಬಾಂಬ್ಗಳನ್ನೆಲ್ಲ ಮಾಡಿದ್ದಿ ಸಿಡಿಸುವಂಥದ್ದು, ದೇಶಕ್ಕೆ ಒಳ್ಳೆ ಮಾಡುವಂಥದ್ದು ಏನಾದರೂ ಎನರ್ಜಿ ಬಗ್ಗೆ ಮಾಡು ಅಂತ ಹೇಳಿದಾಗ, ಸರ್ ಈಗ ಸರ್ 75 ವರ್ಷ ಸರಿಗೆ ಅವರು ಈ ದೇಶಕ್ಕೆ ಈ ವಿಶ್ವಕ್ಕೆ ಅನುಕೂಲ ಆಗುವಂತಹ ಶಕ್ತಿಯನ್ನು ಹೇಗೆ ಪಡಿಬೇಕು ಅಂತ ಹೇಳುವಂತಹ ಕೋಲ್ಡ್ ಫ್ಯೂಷನ್ನಲ್ಲಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂತ ಹೇಳಿದರು. ಒಂದು ಆಸೆ ಸರ್, ತಮಗೆ ನೊಬೆಲ್ ಪ್ರೈಸ್ ಬರಲಿ, ಭಾರತಕ್ಕೆ ನೊಬೆಲ್ ಪ್ರೈಸ್ ಬರಲಿ, ಕೋಲ್ಡ್ ಫ್ಯೂಷನ್ನಲ್ಲಿ ಸರ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಸಕ್ಸಸ್ ಆಗಲಿ, ಇಡೀ ಜನಾಂಗಕ್ಕೆ ಅತ್ಯಂತ ಸುಲಭವಾಗಿ ಶಕ್ತಿ ಸಿಗೋದಾಗಲಿ ಅಂತ ನಾನು ಪ್ರಾರ್ಥಿಸ್ತೇನೆ ಸರ್. ಯಾಕಂದರೆ ಒಬ್ಬ ಎಕ್ಸ್ಪೆರಿಮೆಂಟು ಈ ಏಜಲ್ಲೂ ಇಷ್ಟು ಒಳ್ಳೆಯ ಎಕ್ಸ್ಪೆರಿಮೆಂಟನ್ನು ಸರ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಹಾಗೆಯೇ 4 ಜನ ಸೈಂಟಿಸ್ಟ್ಗಳು ಏನು ಒಂದು ಇತ್ತೀಚೆಗೆ ಪರಮ ಪೂಜ್ಯರ ಒಟ್ಟಿಗೆ ನನಗೆ ಶ್ರೀಹರಿಕೋಟೆಗೆ ಹೋಗಿ ನೋಡುವಂಥ ಭಾಗ್ಯ ಸಿಕ್ಕಿತ್ತು. ನಾವು ಮಾತಾಡ್ತೀವಿ ಮಕ್ಕಳೇ, ಅವರ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ನ ಎಂಜಾಯ್ಮೆಂಟನ್ನು ನೀವು ನೋಡಿದ್ರಿ. ಅವರ ಲ್ಯಾಬ್ಗಳಿಗೆ ಹೋಗಬೇಕು. ನಮ್ಮ ವಿದ್ಯಾಜರಾಜ ಸರ್ ಹಾಗೂ ವಿನಾಯಕ್ ಸರ್ಗೆ ಅಲ್ಲಿ JNC ಕಾರ್ನಲ್ಲಿ ಹಾಗೇನೆ CNR ಲ್ಯಾಬ್ನಲ್ಲಿ ನಿರಂತರ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ತಾ ಇರ್ತಾರೆ ಅವರು. ಪ್ಲಾನೆಟೋರಿಯಂನಲ್ಲಿ ಗುರುಪ್ರಸಾದ್ ಸರ್ ಇರ್ಬೋದು, ಶೈಲಜಾ ಮೇಡಮ್ ಹಿಡಿದು ಎಲ್ಲರೂ ನಿರಂತರ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಇರುತ್ತೆ. ಬೆಂಗಳೂರಿಗೆ ಹೋದರೆ ದಯವಿಟ್ಟು ನೀವು ಅಲ್ಲಿಗೆ ಹೋಗಿ ನೋಡಿ, ಅಲ್ಲಿಯ ಆ ಭವ್ಯತೆಯನ್ನು ನೋಡಿ ಎಂಜಾಯ್ ಮಾಡ್ಬೋದು ಅಂತ ಹೇಳ್ತಾ ಸರ್, ಬಹುಶಃ ಚಂದ್ರಶೇಖರ್ ಸರ್ ಮಾತಾಡ್ತಾರೆ. ನಾನೇನು ಹೇಳ್ತಾ ಅಂದರೆ, ಇಂಥ ಒಂದು ಸದ್ವಿನಿಯೋಗ ನಮಗೆ ಮಾಡಲಿಕ್ಕೆ ಅವಕಾಶ ಮಾಡಿಕೊಟ್ಟಂತಹ 4 ಜನ ಮಹನೀಯರಿಗೆ ಪೂರ್ಣಪ್ರಜ್ಞಾ ಸಂಸ್ಥೆಗಳ ಪರವಾಗಿ ಹೃತ್ಪೂರ್ವಕವಾದಂತಹ ವಂದನೆಗಳನ್ನು ಅರ್ಪಿಸ್ತೇನೆ. ನಮಸ್ತೆ ಸರ್, ನಮಸ್ತೆ.
Thank you, sir. May I now invite Dr. G.S. Chandrasekhar, sir, Honorary Secretary of Poornaprajna College Managing Committee, Udupi, to address the gathering and to graciously lead the felicitation of our esteemed guests.
Good evening, everybody. At the outset, I would like to seek the blessings of Sri Lord Krishna. And of course, I pay my humble pranamas to Sri Ishabhriti Swami Ji, the present President of Admarmat Education Council. And of course, pay humble pranamas to Founder President Udupi Swami Ji. In fact, really very, very exciting day for us. In fact, I am really wordless as a doctor. Because I have been seeing the scientists from morning, the amount of involvement they are having the students, it is something amazing. Because they are not only teaching the students, they try to attract you to the basic science. That is really, that's what I told Vidyadhar and of course Vinayak, this one. So probably if they visit the Poornaprajna college in a year, once or twice, probably our all basic science departments will be extremely full. Am I right? Ramu, am I right? I think, okay. So of course, as you all know, the Poornaprajna is really very, very happy to host this type of scientist. In fact, way back in the year 2003, Ubudi is the Chief Swami Ji, the founder president of the college. That time during the Pariya for the Marmat, this one, he called all scientists of national importance, including CNR Rao, UR Rao and Kasturi Rangan and Radhakrishnan, and so many people were there. And they sat on the same stage that delivered the lecture for more than 2 to 3 hours. So probably at that time it was coordination done by Dr. N.A. Madhyastha. If I'm right, I think I'm right. N.A. Madhyastha one was taken the lead at particular time. He was a retired principal then. But today, so probably the day has come again with the blessings of our President Swami Ji and of course the great effort by our Honorary Secretary, that is Professor A.P. Bhatt. So probably that's the reason we are really today. In fact, really I'm wordless what exactly speak to the great people. In fact, I'm very, very happy that Prahlad Rao is doing a lot of work on preparation, that is energy production. So probably the Udupi Lord Krishna is definitely going to bless you in the presence of our Swami Ji. Definitely you're going to succeed in the experiment. I think is already seen because our Vibhuti Chatri Swamiji, only one dream was there. Our students should get Nobel Prize. So probably even if we get a Nobel Prize, we are very extremely happy. We are close to our heart from so many years. So with this brief introduction, I request our Swamiji to felicitate Dr. Prahlad Rao. He is a Padma Shri. Prahlad Rao. Of course, it's a great moment for us. And in fact, the way as they interact with the students is something extremely amazing. I've been seeing they are not only just simply delivering the talk to give the talk, they are attracting the students, they are involving with the students, especially the Guru Prasad. So probably he is just unimaginable. He has served ISRO for more than 37 years. Now he is a director of Jawaharlal Nehru Research Institute. And of course, probably many of our students are there. From the Poornaprajna, many of the students have gone there. So with this brief, I request Dr. Guru Prasad to receive the presentation from our Swami Ji. Yeah, I request the madam, Indira madam, if I am right, I think Mrs. Indira Prahlad that is to come and get the blessing from the Swamiji. In fact, so probably I can only say he has sacrificed more for the country than Prahlad Rao. So I request Dr. Guru Prasad to get presented by Swamiji. Very, very dynamic man. He has brought all Jawaharlal Nehru planetarium here. That is a planetarium, and showed to our students in Adamaru. It was something, so probably we would not able to venture to Bangalore and see there. He has brought from Bangalore because he is having so much of affection to Dr. Professor U.R. Rao. He is a Udupi Baran from Adamar. That's why he remembers his teachers. He remembers his teachers well, seniors well, and he traveled all night to reach Adamaru from all night and landed in Adamaru and really involved with the students. Thank you, sir. Thank you very much for gracing the occasion and deliver and ignited our students, especially regarding the space. Now I request Professor N.S. Vidyadhiraja, and of course he is an Indian physicist who earned his PhD from the Indian Institute of Science. He has been in our college from the morning 9:30. Probably is having a lot of interaction with our students from the morning. And of course, he is widely recognized for his extensive research in the quantum many-body theory, and of course, focusing strongly on covalent materials and quantum phase transitions. Now I request Dr. Vinayak K. Pathar, and of course you have been seeing from the morning, very, very dynamic scientist. is a researcher, educator, and science communicator working at JN CSR, Bangalore. His research focuses on optoelectronics, nanostructured thin films, nanoperides. In fact, I remember the days where the Professor C.N. Rao, after his Bharat Ratna award, he was visited our Admarmat, and of course he came to the degree college and took the same session way back in maybe about, as soon as he awarded the Bharat Ratna, visited our college and addressed our students and visited the mat. So, last, of course, Dr. N.A. Madhyastha. He was a former principal of the degree college. And of course, those are the times I've seen the two great scientists in the college. That is Dr. N.A. Madhyastha and of course K.G. Bhatt is no more. But N.A. Madhyastha one is worked as a principal in the college, and of course he served as a secretary of the PUC college. He is a distinguished environmental biologist and a former principal and professor of zoology, Poornaprajna College, Udupi. Of course, he has 25 years of research experience, a gold medalist from the Mysore University. He has made a significant contribution to the study and conservation of biodiversity in the Western Ghats, particularly in the fields of freshwater molluscs and land snails and bird ecology. His research has led to the documentation of endemic species and ecologically sensitive regions with contribution to global conservations. An accomplished academic, he has authored over 40 research papers and numerous books and 400 popular science articles. And of course, his contribution to the Poornaprajna Degree College and also PUC College, extraordinary. Even though he's a very dynamic man, at his old age also he is doing a lot of work. So thank you very much, sir, accepting our invitation and this one. So with this brief introduction, of course, I can only tell the Swami Ji has blessed us today to see all the great scientists on the stage. So probably over the course of years, at least once in 2 years, once in 3 years, we'll have this type of sessions other than inviting the individual science. So with this, I really thanks all the students. Even if the 1 or 2 students out of this crowd become either the Vidyadhir or the Vinayak, we are extremely happy. So probably our basic science, we have to improve a lot, because it is not only the doctors and the engineers required for the country, it is the basic scientists which are very much required. Thank you, one and all.
Thank you, sir. We would be privileged to hear from you, sir, Dr. N.A. Madhyastha, sir. May I request you to kindly share your reflections with us on this special occasion.
ಶ್ರೀ ಗುರುಭ್ಯೋ ನಮಃ. ಶಾರ್ಗೆ ಸಾಮಾನ್ಯ ನಾನು ಇಂಥ ಕಾರ್ಯಕ್ರಮ ಮಾತಾಡೋದು ಕಡಿಮೆ. ಕಾರಣ ಇಷ್ಟೇ, ನಾನು ಹೇಳಿ ಕೇಳಿ ನಿವೃತ್ತ ಪ್ರಾಧ್ಯಾಪಕ. ಒಮ್ಮೆ ಮೈಕ್ ಮೇಲೆ ನಿಂತರೆ 1 ಗಂಟೆ ಮಾತಾಡಬೇಕು. ಸೊ ಅಷ್ಟಕ್ಕೆಲ್ಲ ಅವಕಾಶ ಇಲ್ಲ. 2 ವಿಷಯವನ್ನು ಮಾತ್ರ ಪ್ರಸ್ತಾಪಿಸ್ತೇನೆ. ಒಂದು, ನನ್ನೆಲ್ಲ ಅದೇನು ಹೇಳಿದರು ಅದೆಲ್ಲಕ್ಕೆಲ್ಲ ಕಾರಣ ನಮ್ಮ ಹಿರಿಯ ಶ್ರೀ ವಿದೇಶ ತೀರ್ಥರು ನನ್ನ ಎಲ್ಲ ಚಟುವಟಿಕೆಗೆ ಬೆನ್ನು ತಟ್ಟಿ ಆಶೀರ್ವಾದ ಮಾಡಿದವರು ಶ್ರೀ ವಿದೇಶ ತೀರ್ಥರು. ಆದ್ದರಿಂದ ನಾನು ಅವರನ್ನು ಮನಃಪೂರ್ವಕವಾಗಿ ಈಗ ನೆನಪಿಸ್ಕೊಳ್ತೇನೆ. ಎರಡನೇದು, ಈಗ 2005ರಲ್ಲಿ ಇಂತಹದ್ದೇ ಒಂದು ಕಾರ್ಯಕ್ರಮ ನಡೀತು. ವಿದೇಶ ತೀರ್ಥರು ದೇಶದ ಪ್ರತಿಷ್ಠಿತ 8-9 ಜನ ವಿಜ್ಞಾನಿಗಳನ್ನು ಇಲ್ಲಿ ಕರೆಸಿದರು. ನಾನು ಅವಾಗ ನಿವೃತ್ತರಾಗಿದ್ದೆ. ಈ ವಿಜ್ಞಾನಿಗಳನ್ನು ನೀವೇ ಮ್ಯಾನೇಜ್ ಮಾಡಬೇಕು ಅಂತ ನನಗೆ ಕಳಿಸಿದ್ರು. 2 ಗಂಟೆ ಕಾಲ 9 ಜನ ವಿಜ್ಞಾನಿಗಳು ಏನು ಮಾಡೋದು? ಮತ್ತು ಹೇಳಿದರು, ನೀವು ವಿಜ್ಞಾನಿಯಾಗಿ ಅದನ್ನು ನಿರ್ವಹಿಸಬೇಕಿನ ಈ ಬೇರೆ ಏನು ಬೇಡ, ಹೂ ಕೊಡೋದು ಭಾಷಣ ಮಾಡೋದು ಯಾವುದು ಬೇಡ, ವಿಜ್ಞಾನಿಗಳನ್ನು ಮಾತ್ರ ನೀವು ನಿರ್ವಹಿಸಿ ಅಂದರು. ಅವರು ಎದುರುಗಡೆ ಕೂತರು, ಮೇಲ್ಗಡೆ ಮಾತ್ರ 9 ಜನ ವಿಜ್ಞಾನಿಗಳು. ನಾನು ಒಬ್ಬೊಬ್ಬರಿಗೆ 5-5 ನಿಮಿಷ ಅಂತ ಹೇಳಿದೆ. ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ 2 ಪ್ರಶ್ನೆ ಕೇಳುವ ಅವಕಾಶ, ಸಾರ್ವಜನಿಕರಿಗೆ ಪ್ರಶ್ನೆ ಕೇಳುವ ಅವಕಾಶ ಇಲ್ಲ. ಹಾಗೆ ಮಾಡಿ ಒಬ್ಬೊಬ್ಬ ವಿಜ್ಞಾನಿನ 5 ನಿಮಿಷ ನಾನೇ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿ ಅವರಿಗೆ 5 ನಿಮಿಷ ಮಾತಾಡಲು ಅವಕಾಶ ಕೊಟ್ಟು, ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಬ್ಬರಿಗೆ ಮತ್ತೆ 2 ನಿಮಿಷ ಪ್ರಶ್ನೆಗೆ ಅವಕಾಶ ಕೊಟ್ಟು, ಹೀಗೆ 2 ಗಂಟೆಯಲ್ಲಿ 9 ಜನ ವಿಜ್ಞಾನಿಗಳನ್ನು ನಿರ್ವಹಿಸಿದ್ದೇನೆ. ವಿದೇಶಿ ತೀರ್ಥರಿಗೆ ತುಂಬ ಖುಷಿಯಾಯಿತು. ಯು ಆರ್ ಎ ರಿಯಲ್ ಸೈಂಟಿಸ್ಟ್ ಅಂತ ನಾನು ಹೇಳ್ತಿದ್ರು. ಕೊನೆಯದಾಗಿ ಒಂದು ಮಾತು ಹೇಳ್ತೀನಿ. ನಾನು ಇದೆಲ್ಲದಕ್ಕೆ ವಿದೇಶಿತರ ಕಾರಣ. ಮತ್ತು ಒಂದು ಮಾತು ಹೇಳಿದರು, ನನ್ನನ್ನು ಬೀಳ್ಕೊಡುಗೆ ಸಮಾರಂಭದಲ್ಲಿ ವಿದೇಶಿ ತೀರ್ಥರು ಒಂದು ಮಾತು ಹೇಳಿದರು, ಆಫ್ಟರ್ ಇನಾಮ್ದಾರ್ ಮಧ್ಯೆ ದ ಬೆಸ್ಟ್ ಪ್ರಿನ್ಸಿಪಾಲ್ ಆಫ್ ದ ಕಾಲೇಜ್ ಅಂತ. ಅದು ನನಗೆ ಸಂದ ಅತ್ಯಂತ ದೊಡ್ಡ ಗೌರವ. ಇದನ್ನು ನೆನೆಸ್ಕೊಳ್ತಾ ಈಶತೀರ್ಥ ಶ್ರೀಪಾದರಿಗೆ ಮತ್ತೊಮ್ಮೆ ಒಂದು ಮಾತು ಮುಗಿಸ್ತೀನಿ. ನಮಸ್ಕಾರ.
Thank you, sir. Your journey stands as an inspiration to generations to come. We feel truly blessed to be in the divine presence of Paramapujya Sri Ishapriya Tirtha Swami Ji. With folded hands, I humbly pray Swami Ji to kindly bestow his blessings upon us.
Hare Krishna, Shri Guru Bhyo Namaha, Hari Om. I'm very happy today because eminent scientists are here, and already Vidyadhiraja and Shri Vinayak came and they showed us, they threw light on some of the things, I think 2 years back, 2 or 3 years back, or maybe 5 years back, 23, okay. ಅಂತೂ ಎಲ್ಲ ತುಂಬ ಸೈಂಟಿಸ್ಟ್ಗಳ ಹತ್ರ ನಾವು ಮಾತಾಡೋ ಒಂದು ಅವಕಾಶ ಇತ್ತೀಚಿನ ದಿನಗಳಲ್ಲಿ ವಿದೇಶಿ ತೀರ್ಥರ ಒಂದು ಕೃಪೆಯಿಂದ ಸಿಗ್ತಾ ಇದೆ. ಒಂದು 6 ತಿಂಗಳ ಹಿಂದೆ ನಮಗೆ ಶ್ರೀಹರಿಕೋಟಕ್ಕೆ ಹೋಗಲಿಕ್ಕೆ ಅವಕಾಶ ಆಗಿತ್ತು. ಅಲ್ಲಿ ವಿಕ್ರಮ್ ಸಾರಾಭಾಯಿ ಅವರ, ಸತೀಶ್ ಧವನ್ ಅವರ ಒಂದು ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಟು ದ ಭಾರತ್, ಅದು ನಮಗೆ ನೋಡಲಿಕ್ಕೆ ಸಿಕ್ತು. ಅದನ್ನು ವಿಜುವಲೈಸ್ ಮಾಡಲಿಕ್ಕೆ ಒಂದು ಅವಕಾಶ ಆಯಿತು. ಇವತ್ತು ಇಂಥವ್ರ ಹತ್ರ ಮಾತಾಡುವಾಗ ನಮ್ಮ ಪ್ರಹ್ಲಾದ್ ರಾಮರಾವ್ ಇರ್ಬೋದು, ಬಹಳ ತಿಳ್ಕೊಳ್ಳುವ ವಿಷಯ ಏನಂದರೆ, ನಾವು ವಿ ಆರ್ ವೆರಿ 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 ಸ್ಮಾಲ್ ಪಾರ್ಟಿಕಲ್ ಆನ್ ದ ಅರ್ತ್, ತುಂಬ ಚಿಕ್ಕವರು. ಯಾಕೆಂದರೆ ನಮ್ಮ ಕಾಲವು ಕೂಡ ಬಹಳ ಸೀಮಿತವಾದ್ದು. 100 ವರ್ಷ ಇರ್ತೀವಿ ನಾವು, ಆದರೆ ಲಕ್ಷಾಂತರ ವರ್ಷದಿಂದ ಈ ಭೂಮಿ ಇದೆ ಮತ್ತು ಕೋಟ್ಯಂತರ ವರ್ಷಗಳು ಇರಲಿಕ್ಕಿದೆ. ಹೀಗೆ ಇರುವಾಗ ನಮ್ಮ ಕಾಲದ ಮಿತಿಯೂ ತುಂಬ ಚಿಕ್ಕದು, ಬುದ್ಧಿಯ ಮಿತಿಯೂ ಕೂಡ ತುಂಬ ಚಿಕ್ಕದಾಗಿರ್ತದೆ. ಪ್ಲಾನೆಟೇರಿಯಮ್ಮಿಗೆ ಹೋದಾಗ ಪ್ರಾಯ ನಾನು ಕಂಡುಕೊಂಡದ್ದು ಏನು ಅಂದರೆ ಇದೆ, ಈಗ ಹೇಳಿದ ವಿಷಯವನ್ನು. ನಾವು ತುಂಬ ಚಿಕ್ಕವರು, ಏನು ದೊಡ್ಡ ಸಾಧನೆ ಮಾಡಿದರೂ ಕೂಡ ಪ್ರಪಂಚದ ವಿಸ್ತಾರದ ಎದುರಿನಲ್ಲಿ ಬಹಳ ಬಹಳ ಚಿಕ್ಕದಾಗಿರ್ತದೆ. ಮತ್ತು ಇದನ್ನೆಲ್ಲ ಹಿಂದೆ ಕಂಡುಹಿಡಿದಿಲ್ಲ ಅಂತ ಹೇಳಲಿಕ್ಕೂ ಆಗೋದಿಲ್ಲ. ಕಾಲಾಂತರದಲ್ಲಿ ಮರ್ತು ಹೋಗಿರ್ಬೋದು, ಮತ್ತು ಈಗ ಕಂಡುಹಿಡದೇ ಇರ್ಬೋದು. ಹಾಗಾಗಿ ಒಂದಷ್ಟು ವಿಷಯಗಳು ನಮಗೆ ಇಂತಹ ಒಂದು ಜನರೊಟ್ಟಿಗೆ ಸೇರಿದಾಗ ಸ್ಫೂರ್ತಿ, ಜೀವನದಲ್ಲಿ ಏನಾದರೂ ಒಂದು ನಾಲೆಡ್ಜ್ ಅನ್ನೋದೇ ನಿಜವಾಗಿ ಆನಂದವನ್ನು ತರುವಂಥದ್ದು. ಬೇರೆ ಎಲ್ಲವೂ ಕೂಡ ಏನಾಗ್ತದೆ, ಹೊಸದನ್ನು ತಿಳಿತಾ ಹೋದಾಗ ನಮಗೆ ಆನಂದ ಬರ್ತದೆ ಹೊರತು ಯಾವುದೋ ಒಂದು ವ್ಯಕ್ತಿಯಿಂದ, ವಸ್ತುವಿನಿಂದ ಆನಂದ ಬರುವುದಿಲ್ಲ. ಯಾಕೆಂದರೆ ಅದು ನಮ್ಮ ಹತ್ರ ಇದ್ದಾಗ 4 ದಿನ ಆದಮೇಲೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದು ಫೋನ್ ಇದೆ, ಐಫೋನ್ ನೀವು ತೊಗೊಳ್ತೀರಿ, 4 ದಿವಸ ಆದಮೇಲೆ ಹೊಸ ವರ್ಷನ್ ಬಂದ ಕೂಡಲೇ ಅದರ ಬಗ್ಗೆ ನಿಮಗೆ ಕಾಳಜಿ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಒಂದು ವ್ಯಕ್ತಿ ಆದರೂ ಅಷ್ಟೇ, ನೀವು ತುಂಬ ಪ್ರೀತಿಸಿದ ಹುಡುಗ ಅಥವಾ ಹುಡುಗಿ ಇದ್ದರೂ ಕೂಡ ಅಷ್ಟೇ, 4 ದಿವಸ ಮುಖ ನೋಡಿದ ಮೇಲೆ. ಹಾಗಾಗಿ ಇಂಥ ಒಂದು ಭ್ರಮೆಗೆ ನಾವು ಬೀಳದೆ ನಮ್ಮ ಜ್ಞಾನವನ್ನು ಹೇಗೆ ಹೆಚ್ಚಿಸ್ಕೊಳ್ಬೇಕು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ನೀವು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ. ನಾನು ನಿಮ್ಮ ಸಂಸಾರದ ವಿಷಯಗಳನ್ನು ನಿರಾಕರಿಸ್ತಾ ಇಲ್ಲ, ಅದು ಬೇಕು. ಆದರೆ ಅದರೊಟ್ಟಿಗೆ ಇರುವಾಗಲೇ ಹೊಸತನ್ನು ತಿಳ್ಕೊಳ್ಬೇಕು. ಪ್ರಪಂಚದ ಹೊಸ ವಿಷಯಗಳನ್ನು ತಿಳ್ಕೊಳ್ಳಿಕ್ಕೋಸ್ಕರ ನಾವು ಸ್ವಲ್ಪ ಪ್ರಯತ್ನ ಪಟ್ಟಾಗ ನಿರಂತರ ಆನಂದ ಪ್ರಾಪ್ತಿ ಅನ್ನೋದು ಅದು ಸಿದ್ಧಿ ಆಗ್ತದೆ. ಹಾಗಾಗಿ ಆ ನಿಟ್ಟಿನಲ್ಲಿ ನಿಮ್ಮ ಪ್ರಯತ್ನ ಇದ್ದರೆ ಆವಾಗ ನಿಮ್ಮ ಜೀವನ ಸುಖಕರ ಆಗಲಿಕ್ಕೆ ಸಾಧ್ಯ. ಇವತ್ತಿನ ದಿನಗಳಲ್ಲಿ ಹೇಗೆ ಯಂಗರ್ ಜನ್ರೇಷನ್ ಅನ್ನೋದು ಭಾರತದ ಶಕ್ತಿ ಹೌದೋ ಅದೇ ರೀತಿ ಇನ್ನೊಂದು ಬದಿಯಿಂದ ನೋಡಿದರೆ ಈ ಯಂಗರ್ ಜನ್ರೇಷನ್ ಅನ್ನೋದು ಇಡೀ ಭಾರತದ ನಾಶಕ್ಕೂ ಕೂಡ ಕಾರಣ ಆಗಬಹುದು, ಸರಿಯಾದ ತಿಳುವಳಿಕೆ ಇಲ್ಲದೆ ಹೋದಲ್ಲಿ. ಯಾಕಂದರೆ ನಮ್ಮ ಮೇಲೆ ಅಷ್ಟು ಏನು ಭಾರತ ತುಂಬ ಮೇಲೆ ಬರ್ತಿದೆ ಅನ್ನುವಾಗ ಇಲ್ಲಿಗಲ್ ವೇಸ್ ಅದರ ಮುಖಾಂತರವಾಗಿ ಒಂದಷ್ಟು ಡ್ರಗ್ಸ್ ಕಳಿಸೋದು ಈ ಥರ ಒಂದು ಪ್ರಯತ್ನಗಳು ಕೂಡ ನಮ್ಮ ದೇಶದಲ್ಲಿ ನಡೀತಾ ಇದೆ, ನಮ್ಮ ಸುತ್ತಮುತ್ತಲಲ್ಲಿ ನಡೀತಾ ಇದೆ. ಇದನ್ನೆಲ್ಲ ನಾವು ಮನಗಂಡು ನಾವು ಅದಕ್ಕೆಲ್ಲ ಸಿಲುಕದೆ ನಾವು ಸಾಧನೆಯ ದಿಕ್ಕಿನಲ್ಲಿ ಹೋಗಬೇಕು. ಅದಕ್ಕೋಸ್ಕರ ಪೂರ್ಣಪ್ರಜ್ಞಾ ಸಂಸ್ಥೆಗಳು ಖಂಡಿತವಾಗಿ ಪ್ರಯತ್ನ ಮಾಡ್ತಿದೆ. ನಿಮ್ಮೆಲ್ಲರ ಸಹಕಾರ ಇದ್ದಾಗ ದೇಶ ಕಟ್ಟಲಿಕ್ಕೆ ಅದು ಸಾಧ್ಯ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಇಂಥ ಯಾವುದೇ ಆಪರ್ಚುನಿಟಿ ಬಂದರೆ ಯು ಡೋಂಟ್ ಮಿಸ್ ಆ್ಯಂಡ್ ಯು ಶುಡ್ ದೇ ಆರ್ ವೆರಿ ಜನರಸ್. ಅವ್ರು ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ನೀವು ಮೇಲ್ ಕಳಿಸಿ, ನಾವು ಇಂಟ್ರ್ಯಾಕ್ಟ್ ಮಾಡ್ತೀವಿ, ನೀವು ಪ್ರಶ್ನೆ ಕಳಿಸಿ, ಅದಕ್ಕೆ ಉತ್ತರ ಕೊಡ್ತೀವಿ, ಅಥವಾ ನಿಮ್ಮದೇನಾದರೂ ಒಂದು ಸೈಂಟಿಫಿಕ್ ರಿಸರ್ಚ್ ಮಾಡಬೇಕು ಅಂತ ನಿಮಗೆ ಅನಿಸಿದರೆ ಅದಕ್ಕೆ ಸಪೋರ್ಟ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳ್ತಾ ಇರುವಂಥ ಸೈಂಟಿಸ್ಟ್ ನಮ್ಮಲ್ಲಿ ಇದ್ದಾರೆ ಅಂದರೆ ನಾವು ಪ್ರೌಡ್ ಅಂತ ಹೇಳಿ ನಾವು ತುಂಬ ಹೆಮ್ಮೆ ಪಡುವಂಥ ವಿಷಯ. ಯಾಕೆ ಅಂದರೆ ಒಂದು ಹಂತಕ್ಕೆ ಹೋದ್ಮೇಲೆ ನನ್ನಷ್ಟು ದೊಡ್ಡವನು ಯಾರಿದ್ದಾನೆ ಅಂತ ಬರೋದು ಮನುಷ್ಯನಿಗೆ ಸಹಜವಾಗಿ ಬರುತ್ತೆ, ಸಾಧಾರಣವಾಗಿ ಬರುತ್ತೆ. ಆದರೆ ನಮ್ಮ ಪ್ರಹ್ಲಾದ್ ರಾಮರಾವ್ ಅವ್ರನ್ನ, ಗುರುಪ್ರಸಾದ್ ಅವ್ರನ್ನೆಲ್ಲ ನೋಡುವಾಗ ಅಷ್ಟು ದೊಡ್ಡ ದೊಡ್ಡ ವ್ಯಕ್ತಿಗಳೊಟ್ಟಿಗೆ, ಅಷ್ಟು ಸಾಧನೆ ಮಾಡಿದ ವ್ಯಕ್ತಿಗಳೊಟ್ಟಿಗೆ ಅವರು ಮಾತಾಡಿ ಅವರೊಟ್ಟಿಗೆ ಅವರ ಸಮಯವನ್ನು ಕಳೆದು ಅವರಿಂದ ಒಂದಷ್ಟು ಪಡ್ಕೊಂಡು ನಮ್ಮ JNCSRಲ್ಲಿ ಕೂಡ ಯಾವಾಗಲೂ ವಿನಾಯಕ್ ಅವರು CNR ಅವರೊಟ್ಟಿಗೆ ಇರ್ತಾರೆ, ವಿದ್ಯಾಧಿರಾಜ್ ಅವರು CNR ಒಟ್ಟಿಗೆ ಇರ್ತಾರೆ, ಅವ್ರ ಹತ್ರ ಎಲ್ಲ ಮಾತಾಡ್ತಾರೆ. ಅಷ್ಟು ದೊಡ್ಡ ವ್ಯಕ್ತಿಗಳೊಟ್ಟಿಗೆ ಇದ್ದರೂ ಕೂಡ ಅವರು ಮಕ್ಕಳಿಗೆ ಏನಾದರೂ ಕೊಡಬೇಕು ಅಂತ ಇಷ್ಟು ದೂರ ಬರ್ತಾರೆ ಒಂದು ಕಾಲಿಗೆ ಅಂತ ಹೇಳಿದರೆ ಅವರ ತುಡಿತ ಎಷ್ಟಿದೆ ಅಂತ ನಾವು ತಿಳ್ಕೊಳ್ಬೇಕು. ಭಾರತ ಕಟ್ಟುವಲ್ಲಿ ಅವರೆಲ್ಲರ ತುಡಿತ ಎಷ್ಟಿದೆ ಅಂತ ನಾವು ತಿಳ್ಕೊಳ್ಬೇಕು. ಇಂತಹ ವ್ಯಕ್ತಿಗಳಾಗಿ ನೀವು ಹೊರಬಂದರೆ ಅದು ಪೂರ್ಣಪ್ರಜ್ಞಾ ಸಂಸ್ಥೆಗೆ ನೀವು ಕೊಡಬಹುದಾದ ದೊಡ್ಡ ಗಿಫ್ಟ್. ಹಾಗಾಗಿ ನೀವು ದೇಶಕ್ಕೆ ಸಂಪತ್ತಾಗಿ ಅನ್ನೋ ಮಾತನ್ನು ಹೇಳ್ತಾ ನಮ್ಮ ಹಿರಿಯರಾದ ಮಧ್ಯಸ್ಥರು ತುಂಬ ಈ ಇನ್ಸ್ಟಿಟ್ಯೂಷನಲ್ಲಿ ಕಟ್ಟುವಲ್ಲಿ ಅವರ ಪಾತ್ರವು ಕೂಡ ತುಂಬ ದೊಡ್ಡದಿದೆ. ಈಗ ಅವರ ನಂತರದಲ್ಲಿ ನಮ್ಮ ಎಪಿ ಭಟ್ರು ಕೂಡ ಆ ಹುದ್ದೆಗಳನ್ನು ಅಲಂಕರಿಸಿದ್ದಾರೆ. ಅದೇ ರೀತಿ ನಮ್ಮ ಶ್ರೀರಾಮಣ್ಣ ಐತಾಳ್ರು ಕೂಡ ಸ್ಟೇಜಲ್ಲಿದ್ದಾರೆ, ರಾಮು ಅವರಿದ್ದಾರೆ. ಇವರೆಲ್ಲ ಫೇಸ್ ಅಷ್ಟೇ. ಇದರ ಹಿಂದೆ ನಮ್ಮ ಇಡೀ ಅಧ್ಯಾಪಕ ವರ್ಗ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮ ಆಯೋಜನೆ ಮಾಡುವಲ್ಲಿ ತುಂಬ ಕೆಲಸ ಮಾಡಿದೆ. ಯಾಕಂದರೆ ಎಲ್ಲರೂ ಕೂಡ ಅಂತಹ ಒಂದು ತುಡಿತ ಉಳ್ಳವರಾಗಿದ್ದಾರೆ. ಅದೇ ರೀತಿ ನಮ್ಮ PPISR ಸಂಸ್ಥೆಯಿಂದಲೂ ಕೂಡ ನಮ್ಮ ಡೈರೆಕ್ಟರ್ ಅವರು ಆನಂದ್ ಅವರು ಬಂದಿದ್ದಾರೆ, ಮತ್ತು ಶಿವ ಅವರು ಬಂದಿದ್ದಾರೆ, ಅವರ ಮನೆಯವರು ಬಂದಿದ್ದಾರೆ. ಹೀಗೆ ಅವರೆಲ್ಲರೂ ಕೂಡ ವಿಶೇಷವಾದ ವಿಜ್ಞಾನದಲ್ಲಿ ತುಡಿತ ಉಳ್ಳವರು. ನೀವು ಕೂಡ ಒಳ್ಳೆಯ ಒಂದು ಮಾರ್ಗವನ್ನು ನೀವು ಕಂಡುಕೊಂಡಿದ್ದೀರಿ. ಇದರಲ್ಲಿ ಮುಂದುವರಿಯಿರಿ. ದೇಶಕ್ಕೆ ಹೆಮ್ಮೆ ತರುವ ಕೆಲಸಗಳು ನಿಮ್ಮಿಂದ ಆಗಲಿ ಅಂತ ಹಾರೈಸ್ತಾ ಎಲ್ಲರಿಗೂ ಕೂಡ ಶ್ರೇಯಸ್ಸಾಗಲಿ ಅಂತ ಹೇಳ್ತಾ, ನಮ್ಮ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ರೆಪ್ರೆಸೆಂಟೇಟಿವ್ ಆಗಿ ಒಬ್ಬರು ನಮಗೆ ಕಾಣಿಸ್ತಾ ಸ್ಟೇಜಲ್ಲಿ ಚಂದ್ರಶೇಖರ್ ಅವರು ಬೆಳಿಗ್ಗೆ 8:00 ಅವರ ಆಸ್ಪತ್ರೆಗೆ ಹೋದರೆ ರಾತ್ರಿ 2:30, 2:45 ಮತ್ತೆ ಮನೆಗೆ ಹೋಗ್ತಾರೆ. ದಿನ 2-3 ಗಂಟೆ ಮಾತ್ರ ನಿದ್ರೆ ಅವರದ್ದು. ಇವತ್ತು ಸೈನ್ಸ್ ಪ್ರೋಗ್ರಾಮ್ ನಮ್ಮ ವಿಭುದೇಶ್ ತೀರ್ಥರಿಗೆ ತುಂಬ ಇಷ್ಟದ ಕಾರ್ಯಕ್ರಮ, ಮತ್ತು ಅವರ ಒಂದು ಮಾರ್ಗದರ್ಶನದಲ್ಲಿ ಸಾಕಷ್ಟು ವರ್ಷಗಳು ಅವರು ಕೆಲಸ ಮಾಡಿರೋದ್ರಿಂದ ಈ ಶಾಲೆ ಕೆಲಸ ಅದು ವಿಭುದೇಶ ತೀರ್ಥರ ಕೆಲಸ ಅಂತ ಹೇಳಿ ಅವರು ಕೂಡ ಮಧ್ಯಾಹ್ನ ಪೂರ್ತಿ ಬೆಳಿಗ್ಗೆನೂ ಕೂಡ ನಮಗೆ ಅಲ್ಲಿಗೆ ಬಂದಿದ್ದಾರೆ, ಅದಮಾರಿಗೆ ಬಂದಿದ್ದಾರೆ. ಹಾಗಾಗಿ ಎಂಟೈರ್ ಡೇ ಹಿ ಸ್ಪೆಂಡ್ ಫಾರ್ ಪೂರ್ಣಪ್ರಜ್ಞಾ. ಈ ರೀತಿ ಅವರು ಆವಾಗವಾಗ ನಮ್ಮ ಎಲ್ಲ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಸ್ಟಾಫ್ ಅವರ ಟೈಮ್ ಕೊಡ್ತಾ ಇದ್ದಾರೆ. ಅವರಿಗೆಲ್ಲರಿಗೂ ಕೂಡ ಅಭಿನಂದನೆಗಳನ್ನು ಹೇಳ್ತಾ, ಎಲ್ಲ ಅಧ್ಯಾಪಕರ ವರ್ಗದವರಿಗೆ ವಿಶೇಷವಾಗಿ ಅಭಿನಂದನೆಗಳನ್ನು ಹೇಳ್ತಾ, ಎಲ್ಲದಕ್ಕಿಂತ ಮುಖ್ಯವಾಗಿ ನೀವು ವಿದ್ಯಾರ್ಥಿಗಳು ಇಲ್ಲಿ ಕೂತಾಗ ಇದು ಸಾರ್ಥಕ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ನೀವು ಇಂಟ್ರೆಸ್ಟ್ ತೋರಿಸಿ ಎಲ್ಲ ಸಮಯವನ್ನು ಇಲ್ಲಿ ಕೊಟ್ಟು ನೀವು ಎಂಜಾಯ್ ಮಾಡಿದರೆ ಅದು ತುಂಬ ಸಂತೋಷ ಕೊಡುವಂಥ ವಿಷಯ. ಇದು ಮುಂದುವರಿಲಿ ಅಂತ ಹೇಳ್ತಾ, ಇವತ್ತು ಇದನ್ನು 75ನೇ ವರ್ಷದ ಸಂಭ್ರಮ ನಮ್ಮ ಅದಮಾರನ ಶಾಲೆಗೆ. ಇವಾಗ ನಾವೊಂದು ನಮ್ಮ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಒಂದು ಹೊಸ ಸಂಕಲ್ಪ ಮಾಡಿದೆ. ಇಂಥ ಕಾರ್ಯಕ್ರಮಗಳನ್ನ ಫ್ರೀಕ್ವೆಂಟಾಗಿ ಮಾಡಬೇಕು, ನಮ್ಮ ಹುಡುಗರಿಗೆ ಎಷ್ಟು ಸಾಧ್ಯವೋ ಅಷ್ಟು ಜಾಸ್ತಿ ವಿಷಯಗಳನ್ನು ಕೊಡಬೇಕು ಅಂತ. ಆ ಒಂದು ಸಂಕಲ್ಪ ಸಿದ್ಧಿಯಾಗಲಿ ಅಂತ ಪ್ರಾರ್ಥನೆ ದೇವರಲ್ಲಿ ಮಾಡ್ತಾ 2 ಮಾತನ್ನು ಮುಗಿಸ್ತೇನೆ. ಕೃಷ್ಣಾರ್ಪಣ ವಸ್ತು.
We are truly blessed and grateful for those divine words of guidance and wisdom, Swami Ji. As this session draws to a graceful close, it is time to extend our heartfelt gratitude. Now invite Dr. Vinay Kumar sir, our IQAC coordinator, to propose the vote of thanks.
I place my humble pranamas to Lord Sri Krishna and Mukhya Prana, and I seek the divine blessings of His Holiness Sri Vibhudesha Tirtha Swami Ji, His Holiness Sri Vishwapriya Tirtha Swami Ji, and His Holiness Sri Ishapriya Tirtha Swami Ji, the present President of Udupi Sri Adamarmat Education Council, Bengaluru. Respected scientists, chief guests, invitees, staff, students, good evening to all. It gives me immense pleasure to extend a deep sense of gratitude to all who made this event, the Scientist Meets, a memorable one. I offer my humble pranamas to the holy feet of His Holiness Sri Ishapriya Tirtha Swami Ji for His divine blessings and for gracing this occasion. Pranama Swami Ji. I express my heartfelt thanks to our Honorable Chief Guest, Padma Shri Dr. Prahlada Ram Rao, the former Director of DRDL, for gracing this occasion and delivering such an inspiring address. Your remarkable contribution to the nation and your valuable insights have truly motivated all of us. We are privileged to have you here, sir. Thank you very much. I also thank Mrs. Prahalada Ram Rao, Madam, for gracing this occasion. Thank you, Madam. I extend my sincere thanks to our distinguished scientist, Dr. B. Guru Prasad, the Director of Jawaharlal Nehru Planetarium, for enlightening us with his vast knowledge and for motivating our students in the field of astrophysics and astronomy. Thank you, sir. My heartfelt thanks to Professor Vidyadhiraj NS, the Professor of Theoretical Science Unit, JNCASR, for enlightening us with his profound insights and the exciting experiments which have been done here. Thank you, sir. And I also thank his family for gracing the occasion. I also extend my sincere gratitude to Dr. Vinay K. Pattar, researcher, educator, and scientific communicator of JNCASR Bangalore, for sharing his valuable knowledge, also showing of some interesting and exciting demonstration. Thank you, sir. His family is also with us. I thank them also. A deep sense of gratitude goes to Dr. A.P. Bhatt, sir, Honorary Honorary Secretary Udupi Sri Adamarmat Education Council, for always guiding us and motivating us to do all of such academic and research activities. Thank you very much, sir. I extend my sincere gratitude to Dr. G.S. Chandrasekhar, sir, Honorary Secretary of Poornaprajna College Managing Committee, for his constant support and guidance and motivation. Thank you very much, sir. I extend my sincere thanks to Dr. P. Sri Ramana Aital, sir, Director of Academics and Development, Poornaprajna Group of Institutions, for his constant support. Thank you, sir. Our special thanks goes to Dr. N.A. Madhyastha, sir, for accepting our honor and come over here and enlightening us. Thank you, sir. My special thanks goes to Dr. G.V. Krishna, sir, Honorary Treasurer of Udupi Sri Adamarmat Education Council, and Dr. Sri Gopal Shabraya, sir, Honorary Secretary of Vidya PU College, for their support and motivation. Thank you. My special thanks goes to the Director of PPISR, Anand Kulal, sir, and the staff of PPISR for gracing this occasion. I also thank the Secretary of PU College, PPC, for their constant support. My special thanks goes to our respected Principal, Dr. Ramu, sir, for his leadership and creating this platform to organize such a meaningful program. Thank you very much, sir. My sincere thanks to all the principals of sister institutions, the principal of PU College, the principal of Evening College, and all the staff members of those institutions for involving with this event and graciously presenting this event. I thank the Honorable Administrative Officer of Adamarmat Education Council, Udupi, Dr. C.K. Manjunath, sir, and all the members of the council for supporting us in creating this event a successful one. My sincere appreciation goes to the convener and members of Science Association of Poornaprajna College and all the subcommittees who have contributed thoroughly for the success of this program. Thank you. Yes. My special thanks goes to all teaching and non-teaching staff of the college, Poornaprajna College, for their dedicated effort in making this event a grand success. I thank Dr. Anand Acharya sir for his support in facilitating food from Krishna Mata for all of us. Thank you all teachers and Anand sir. I would also like to thank the media personnel for their coverage, the technical team for their seamless support, photographer Krishna sir and his team who are live streaming this program, and all the student volunteers who are continuously supporting to make this event a successful one. Thank you one and all. Finally, I thank all the participants, students from different colleges and schools, students of our college, PU College, for active presentation and making this program lively and engaging. Thank you one and all. I thank everyone who are directly or indirectly contributed to the success of this success of this event. Thank you one and all.
Students, there's a special announcement by Dr. Vinayak sir. Sorry, Professor Vidyadhiraj sir.
Yeah. So I'll just take 1 or 2 minutes. Basically, we wanted to tell you that our institution, JNCSR, is open to several visiting student programs. So please visit the JNCSR's website, especially the Fellowships and Extensions Program website. There you will find that there is a program called the Long-Term Visiting Student Program. There is also a graduate research internship program where students can write to the faculty members and do an internship there for 6 months to 1 year. There are also summer research fellowship programs. Then there is something called a project-oriented chemistry education and project-oriented biology education programs. So please visit our website. You will get to know all the information. And those of you who are interested in research can always pursue your dreams through these programs. Okay? Visit the website, then find out the faculty member whose research interests you, write to them, write an email to them with your CV and ask them if you can spend some time in their place. Okay? That will help you to spend some time and get to know about the research. Okay? And there are many such programs. In fact, many other institutions in India also offer such programs. For example, the Indian Academy of Sciences offers 1,000 summer research fellowships. Okay? So please make use of such facilities so that you can explore a research career before you actually embark on it. Thank you.
Thank you, madam.
Thank you, sir. A special thanks to Krishnapataya sir for his presence here, and thanks to professors from PPISR Bengaluru. Before we conclude, nothing can move rewarding to a scientist than achieving a state where doing science becomes a way of life, by Dr. C.N.R. Rao. Let us carry this inspiration forward. Thank you all. Let us all rise for national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभाशिष मागे गाहे तव जय गाता जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Students, refreshment has been arranged. Please accept it. I request all the faculty